water.
Have you ever used a sodium lamp? If you've ever used a sodium lamp before, you're seeing the yellow spectral of sodium, dude. That's
in a lab, bro.
Again,
That's comparing a lab to.
No, you can use a sodium lamp anywhere.
You're seeing an effect. You're seeing an effect, okay? Hold on. You're seeing the effect. You don't see an individual atom. You don't see the parts of an atom. You believe that effect is caused by atoms. So there's a big difference between the observation of effect, like electrolysis, the popping of hydrogen and the quote unquote, right? That's the observation of effect. Now, when you say that effect happens because the cause, that's not what you have. That comes from inside of you.
Oh, man.
I have
this conversation is going to come to a grinding halt thinking like that.
Yeah, it's just
When was the last time you took a chemistry course?
Instruments in our lab that take pictures of atoms, dude.
Okay, hold on. But when you say takes a picture of, right, it's not a direct line of sight visual, quote unquote, picture, right?
We scatter electrons off of atoms.
Okay, so now you've assumed the electron, which is part of the atom, to prove the atom that you're trying to prove with the electron that you've already assumed. That seems very circular. That seems very circular logic.
Atoms we're looking at. Just because you don't know
how you know,
and doesn't mean that it's wrong, right? The electrons we use aren't part of
the atom. Doesn't mean it's right.
The electrons we use are not part of the atoms we are looking at.
But again, you've never seen the electron. You've never seen the electron to confirm it. You've seen the effect. You've seen objects, like you see a rock, you touch the rock, that's the effect. You explain that effect with electrons, right? So electrons are not the effect, right? They're not what you have.
They haven't even seen an atom, dude. They see crystal structures. It's about one every 50 pictures they get a crystal structure, three-dimensional. It's pretty cool what they do, bro.
Yeah, that's what I do.
But it's not atoms.
I do crystal structures, and we can resolve down to the hydrogen atom in proteins.
No, that's not what you're doing. Is you're not looking at it like if you looked at a baseball, you're like, that's a baseball, right? Now, if you closed your eyes and somebody put the baseball in the box and shook it, right? You're trying to gather visual information from non-visual information. So you've never seen a hydrogen atom. You just get these effects from these machines. And this is why I brought it back to you're trying to measure what you've never sensed. So you've never seen an atom, but you can somehow build a machine that can sense it, but you can never verify it because you can never see the electron yourself. So you just have
pretty amazing, isn't it? Right there.
You're telling me what I do.
Like
that's pretty fake.
We literally take fucking pictures of atoms, dude.
No, you're getting a glimpse of the structure. You're getting a glimpse of the structure of a bunch of atoms. You're getting a little glimpse of the structure that they form. And it's a stretch, but it's pretty cool what they do, but it doesn't prove atoms. It proves like a crystal. I said crystal like because it looks kind of like a crystal structure, but they're not seeing no atoms. They're
Let me ask a question.
He's
claiming they see atoms.
Down to the hydrogen atom in a freaking crystallograph, dude.
Let me
how
ask
can you see a hydrogen atom, bro?
Hold on, guys. If you could see atoms, then how come when I was in like grade school, the model of an atom looked like a solar system with the nucleus looking like the sun and other planets orbiting it, being the electrons, protons, neutrons, right? But now the model of an atom looks more like fields around the nucleus. So if you could see it this whole time, then how come it looks different now?
Yeah.
Because you're not there. It's never a visual inspection.
I'm sorry that technology advances and we can see smaller and smaller. They couldn't see bacteria. Does that mean it doesn't exist? What is your point?
You can see bacteria, dude.
Guys were incorrect.
Yeah, with a microscope that didn't always.
Now you guys got it done, right?
You ever see a sandwich that's furry or green that has mold on? That's bacteria that you can literally see with your eye. Bro, you're insane. Yeah. Oh God, he proved me wrong. Yes, you can see bacteria with your eye. You don't need a microscope. Okay. If you saw the microscope just lets you see the bacteria closer, right? You've never seen an electron, but you think you've seen it closer. That's the craziest part.
So
you think you've seen something closer that you've never seen, period.
You should get your kingdom straight there before you try to tell someone that they don't do their actual job.
Hey, Jace,
You've never seen an electron. You've seen these patterns.
I'll say it's pretty cool what y'all do. What y'all do is pretty cool. I'll give y'all that. What y'all do is pretty fucking amazing. But as far as like proving electrons and shit, come on, let's be honest, man.
Yeah, we use electrons off the atoms in a crystal, and the higher the energy, the higher the velocity of the electron, the smaller size we can resolve. And right now, with the cryo-yens that we have, we can resolve down to the hydrogen atom.
See, the problem is that
the time when you explain things I don't understand. Can you post a link of what you talking about?
Yeah, sure.
Bro, the atomic, just because you get
Google
this like
but I'll post
you get this pattern, and you can explain that pattern with what you believe is the atom. But you can explain that pattern with many different things, dude.
No,
That's
you
not
really
what
can't.
I'm not talking
Yes,
about.
you can.
No, you can't. You
You
make
can't
shit up.
explain it with
I'm
electrons.
not
Yes, you
talking
can, actually.
about diffraction. I'm not fucking talking about
I'm
that.
talking. Yeah, I mean,
images.
It's not an image. It's a readout from a scanning, electron, a quote unquote electron scanning. You've never seen it with your eye, okay? The computer builds an image.
Sorry, man. Reality isn't what you're saying.
Do you realize that your cell phone does the same thing? Basically, it's not a real piece. It's a computer image.
How can you get image from something you can't isolate? Vibrating so fast, it won't let you isolate it. But you're getting a picture of the electrons that make up this thing. We can't focus in on something that's vibrating so fast. It won't even let us isolate it. We get the structure that the shit makes up. We'd act like we're getting electrons. I mean, they're churching everything up, bro.
We've made cathode ray tubes for.
You call spin? What's spin? It's vibration, right? Right.
We cryogenically cool them down to temperatures to almost absolute zero, so that their thermal energy is basically zero. Thus, we
and when
can
you're lucky,
solve them.
And when you do everything just right, you get a picture of the structure.
Actually, not that.
Anything moving around in that structure? Is there anything moving around in that structure, please?
Grad students do it. It's really not that hard.
It's an honest question. Anything moving around?
You know, the cathode ray tubes have been around for a long time, right? That the old TVs were basically electron beams.
What the fuck does that have to do with the question I just asked?
This is not new technology. He's basically.
You're white. I didn't say it was white knighting for him, bro. Is there anything moving around?
I'm not white knighting for him. I'm telling you that you guys are like denying stuff that's been done for hundreds of years now. We know about.
Just made a fucking tube last night. What are you talking about? Denying it?
Let them talk.
We got better shit than cathode tubes, bro. We got semiconductor transistor.
Come on, I'm on your side, but let the guy talk. I want to learn something. If he's true, then I want to learn.
Just because you have a cathode tube, right? That's the effect. Again, this is where you're trying to manifest. Hang on. A ray cathode tube is not an electron. It's a cathode ray tube.
Electron generator.
No, it's not. When you're trying to assert that something is real, you have to have that particular thing, right? This is how people get to God.
Gives off this beam of electrons that we can steer with magnets.
Let him speak, and you can go next and have your time to respond.
So a Christian will never have God. You don't have an electron, but you have the cathode ray tube. Now, you turn the cathode ray tube, which is not an electron, into proof of an electron. The Christian does the same thing. He takes life, which is not God, but then he says that's proof of God, and then God becomes real. It's the same religious step.
I think it's interesting.
No,
I think it's interesting.
I think
it's interesting.
Yeah, let Paid respond.
Paid was going to respond, but yeah, then go next.
No, this is not religion. This is science. There's a big difference between the two. Huge.
All right, so can you explain how a cathode ray tube is showing electrons? Is that what you were saying?
It heats up and shoots out a beam of electrons. We steer them with magnets. They're negatively charged. We know that.
Gio, they have to assign a number.
What?
If they don't assign a number, they can't put it in their computer and make these devices. They have to give a value to everything, including photons.
cathode ray tubes predate computers.
But how have you isolated it as an electron versus just a charge, a spark of something? How are you isolating that into what you're calling an electron?
You dismiss electrons.
No, I'm asking you to validate that to verify that that's an electron rather than just a charged piece of material.
Charged piece of material, right? It is. That's what an electron is. A negatively charged piece of material.
But we have detectors that can detect specific properties, and you can do experiments checking what direction the spin is, depending on sending it through a magnet, and where it hits your detector gives the value for what its spin is. You can get the value for its electric charge. You can get the value for its mass, and these are what we call an electron. This collection of properties that show up on a detector as a point-like object.
To make these detectors, you had to have the values first, though, right?
No.
They didn't even.
You didn't need the values to make devices.
How do you make a device to measure something you have no idea is even there? Right? You've never sent
the whole point of the device is to measure.
You've never said. You just said we have electrons before the ray tubes.
Use just regular film to detect electrons, and film was made long before electrons were fucking.
This is the photoelectric effect, right?
No, it's
you
just
jump from. It's really crazy how you'll take 7 things that are not an electron, right? And that you somehow stack them around and they become an electron. The cathode ray tube, not an electron, but becomes one. My cell phone is an electron, but becomes electrons. It's so crazy how you don't see that you do the exact same thing that religious people do when they make God real.
This is not a religion because actual particles coming out, we know it's negatively charged and we can see it and measure
it's
it.
just your silly
No such thing as negative charge, but
now we're denying negative charge. How far did we go?
What is that? What is negative charge?
You're fucking insane if you think there's a negative charge.
Yes,
there ain't no negative charge. Every charge is an actual positive charge.
There are no negative charges.
There are no negative charges. Reality, man.
There are charge potential differences. Get it straight, dude. There are
no. And when you talk about charge, all you really mean is the spin, right? You mean which way it's spinning.
Which is
that's a different attribute.
So what's charge then?
Dude,
so what's charge? You're asking what is charge, and you're sitting here having this discussion. You don't know what charge.
I'm asking you used it in this context. Like how? What do you picture it is?
He thinks these electrons are carrying negative flags around. They're carrying flags with a negative sign on them. All the electrons have negative signs, and all the other ones, all the neutrons have what?
The positive. It's the boy bathroom and the girl bathroom.
No, electrons are negative.
Neutrons are neutral. Neutrons.
That's what I was trying to say before you interrupted me.
Protons, positive, pro.
What's the difference between?
That's what I was trying to say before you interrupted me. So he sees these flags.
Hold on, man. Let's stop the rhetoric, dude. Waste so much time.
Okay, what's the difference between a neutral particle, a positively charged particle, and a negatively charged particle? How are they physically different?
Same difference between a positive number, a negative number, and zero.
Well, there's no difference between numbers. They're imaginary.
Difference.
So I said, hold on.
Properties are different.
I asked for a physical difference, right? If there's no physical difference, then they're not different. You can't differentiate. You can't. Okay.
It's different.
How do you know the property? What is the property of neutral that you can show that it's different from positive? That you can show that it's different from negative? You can't just say 1, 2, 3, 4.
It's not attracted to positive or negative. It's neutral.
Okay. So hold on. Let me work. So when you put two things next to each other and they don't attract, you call that neutral charge, right?
It's an error bar.
Give off electromagnetic radiation when they are accelerated. Neutral particles do not. That's one very big difference between the two. Also, the way they will deflect in a magnetic field can give you the indication of if it's a positive or negatively charged particle. The mass
charge or a north charge, dude, right? It's not a negative or a positive.
Why am I
positive? Electric.
Hold on, guys. Let's let Jace respond to Grimm's thing that he's saying now, and we gotta let people finish their responses.
I still don't understand what charge is. Like nobody's articulated.
Let Jace finish what he's saying.
Understandably.
Well, I can give you an explanation, right, of what charge really is. Do you want me to? It's complex.
I'd like. Oh, here. Let me just real quick. If I was to explain, hey, I hit somebody in the face. I reeled my fist. I punched him. You would understand. You could see that in your head. Give me that with charge. I want to be able to see why this one's negative, why this one's positive, so I can understand it.
Yeah. So if you get something like a Stern-Gerlach device, right? You can just get two magnets, basically two long magnets, and place them on top of each other with a gap in between. And you can send a positively charged particle through that gap, and it will hit your detector at a specific location. Then you can send a negatively charged particle, and it will hit the detector at another different location, right? So you know where positive and negative charges will hit the detector. Then you can have particles that you don't know what their charge is, but you just send them through.
Yeah, and we're going to call that the dimensional unit, right? Call that the dimensional unit of charge, right?
The detector will tell you if it was positively charged or negatively charged because you have the controls, right? This is what an experiment is.
Okay, so remember I was like, I want to picture it. So now all I understand is you're sitting, you put two magnets, you're saying the way to tell that a thing is positive is by sending a positive. Do you not see that? You're like, oh, I know it's positive because I take a positive. How do you know it's positive if the way to send so you're saying I know that it's positive before I sent it through the machine, which tells us if it's positive or negative, which is crazy.
When you can just arbitrarily,
there we got to it. It's arbitrary.
Shut up, man. What the fuck? You can just arbitrarily say that, okay, this one hit at the top, so we're going to call this positive, and this one hit at the bottom, we're going to call this negative. And that's really what humans did back in the day, and everyone just agreed to follow that convention, that the particles that act in this manner are negatively charged, and particles that act in this manner are positively charged.
Okay, if that's true, then when they say, sorry, real fast, if that's true, then they say that electrons move from negative to positive, then that's arbitrary. Then it would make more sense that I could say, maybe that's arbitrary, and maybe you guys got it wrong and it's the other way, and electrons actually flow from positive to negative, which is what we witness in nature, and that's what Witsit was talking about earlier about the electrical gradient.
Well, positive and negative aren't. It just matters that there's two different things and they're different. And it doesn't matter which is which.
The problem.
Yeah, I know that, but I'm just saying if you switch it around, it makes sense now. Because I don't think electrons could flow from negative to positive. It would make sense that they would flow from positive to negative.
Well, you could call the negative positive and the positive negative, right? Like, because there is.
Holy shit. The problem arises that you can detect the mass of the particles that are traveling in different directions, as you say. And the one that we've defined as negative will always travel in that direction, and that's what
can't have negative mass, bro.
No one said it.
Hold on. So negative and positive have nothing to do with the particle itself, but it has to do where it shows up on the medium.
They're property of the particle.
Hold on, wait. No, it's not a property, because you can have the same. Hang on, you could have the same particle that goes into different places because of the magnets, not because of the particle, right?
No, because of the charge and how that charge.
No, hold on. But when you say charge, you're referencing a location on the magnet.
No.
You know how they got
Hold on, wait. When you said, hang on, wait, listen. You said we take two magnets, we put them together, then we send a particle through. It ends up in the detector. Field, right? The detector will sense it at X location. Then we take a different particle or whatever, and it senses it at Y location, right?
He's saying no because it's in the magnetic field, not an actual magnet.
The reason that's even delineated, and he's not telling you this.
Okay, hold on. You're
property of electric.
You stated what I asked.
Because of the property of electric charge that they have. That's the second
magnetic inclination, dude.
They always
north is negative, south is positive.
They always have
if it goes towards the north side of the magnet, then they say it's opposite, and then that makes it positive. If it goes towards the south side of the magnet,
so it's the location.
they say it's opposite, and then it's negative. That's right. It's only
So it's location. It's location. It has nothing to do with the. It's a location.
The particles have a property called charge, and based on the sign of that charge, they will hit on one location or another on the on the detector. Then we can define. Then we can define which one we're going to call negative and which one we're going to call positive. So the particles that hit at the bottom of the detector, we're going to say their electric charge property they had as they traveled through the magnet and interacted with it. We're going to call those negatively charged.
Tell them
Then
how
we're
it
going to call
interacted
the
with the
ones
magnet.
at the top.
Describe how it interacts with the magnet, though, so that you can get a better, clear understanding.
His property is not, he's trying to say the property is the negative electrical charge when it's not. The property is the south side of the magnet or the north side of the magnet. The property is not the electrical charge. The property is which side of the magnet you detect it on. That is your property.
If you remove the electric charge,
which is due to the charge on the particle.
No, that's your belief. That's your personal belief.
No, that's how
if you remove.
We just shown it.
If you
you've shown north or south on the magnet. You have not shown the charge.
Why did it hit
if you remove,
why? You believe electrical charge. That's the answer to your why that goes to north and south.
If you remove the electric charge,
don't talk. The property that you're talking about is not.
Guys,
I haven't been able to finish a fucking
The property you're talking about is not the electrical charge. It's the location on the magnet that it's been detected.
If you remove the property of electric charge, i.e. send a neutron to the magnets, it will just hit because it won't be affected by the magnets because it doesn't have an electric charge.
You're manifesting electrical charge.
Exactly
You
what
don't have.
In the
You don't have electrical charge, right? So this is what they, again, remember I was just saying when he takes a cathode ray tube and turns it into electrons, he's doing the exact same thing, and he's taking the north side of a magnet and turning that into a negative electrical charge. This is what they always do. They take A, they run it through their system of beliefs, and it comes out as B.
Reality disagrees.
This guy's literally an astrophysicist and a quantum physicist all at once, man. He knows everything.
Brian.
He's a Google hero.
I'm a biochemist.
That's a bullshit, dude. Just a parrot for the copy and paste Wikipedia.
Did you say you're a biologist?
I'm a biochemist.
Oh, okay. So you're an actual scientist.
That explains why you didn't know what a parsec was.
You said earlier that you're looking at this and you called it an experiment. What does it have to do with the cause and effect relationship? You're just shooting photons and electrons and protons and neutrons.
Yeah, the sign of the electric charge on the particle will cause to hit the detector at one of two locations, which is the effect.
Can't have one without the other, bro.
It's just simple stuff, guys. Come on.
Hey guys, can I show you how a perturbation medium could behave as a particle?
Hell yeah.
Go ahead, man.
They have to make everything a particle, or they can't put it in their computer. Even a photon, they call it a discrete chunk of energy. It's the littlest speck of light they can show. But if you keep doing it, it's going to produce a wave because light is a wave. But if they don't make it if they don't give it an amount and give it a discrete chunk and call it a particle, then they can't simulate it and they can't put it in their computer or make devices. So I understand why they have to do it. But when they get caught up into thinking that electron is this and is that, dude, it's a convention. Okay,
it's just detected reality, Brian. I'm sorry you don't like that. But that's not going.
I didn't say I don't like it. I just said, dude, it's not proof of reality. If you don't give a number to it, how are you going to compute it? How can you compute it and put it in software if it has no value?
Photons exist whether we can compute them or not.
Dude, you think you just say it's reality, it becomes you think if you just keep saying it with your little arrogant tone that somehow you're better than all of us and it becomes reality?
We can show
a photon is conceptualization. Just because you have a discrete chunk of quote unquote impact doesn't prove it's a physical spherical particle. That's a model. Thanks for playing. Stop
No
pretending
one
that you're
says it's
over everyone.
spherical, and of course it proves that it
It's
exists.
so
We
hard to
can
listen to
detect
for the
it.
last 10 minutes. Oh my god.
Yeah,
You're
you can
talking
just
down to everyone with
poison the well and celebrate.
So
Thank you
it's
all.
the lenses. Hold on. So then it
Thank
must
you.
be the lenses, the polarized
Detectable
lenses.
reality. Detectable
So
reality
polarized
is
lenses.
reality.
Hold on. So polarized lenses
Detectable
distribute the
reality.
momentum
Yes.
of these photons, right? Because I can
Detectable
take
reality.
a lens and let the light
Check out
through,
my
and then
gift.
put another polarized lens and block it, and then I could get it racing off again with the third polarized lens. So you're saying it's the
Detectable
polarized
reality.
lens that's giving these photons momentum, pal?
No, you're trying to tell me detectable reality isn't actually reality. And I'm evidence for
I did not say that. I said if you don't quantify it, you can't make devices and put it in your computers and make simulations and software. You have to give it a quantification, or you can't put it in your software and devices. That doesn't mean that it's actual particles, bro. How can we have a particle with no mass that stops and speeds up and stops and speeds up?
They exist whether or not we put it in software, Brian.
Okay, but the part that it's a physical spherical particle is a model, okay?
No.
And that's, yes, actually, that's why you have your nonsense of massless particle, wave-like
That's just wrong. Not a spherical particle.
Okay, you don't know exactly
check out the
what
gift I
a
posted.
photon is. Stop pretending that you do.
Yeah, so we say it's what we can detect rather than.
Are there radio waves? Are there any waves at all? Are there radio waves, or are they particles
you can
too?
know that you detected, then you have known it.
Are radio waves
favorite thing that they say? My favorite thing they say is refraction. So a photon can be manipulated by gravitation. They actually call it gravitational lensing, but I like to call it diffraction because the funniest thing they say. Go ahead and tell us about gravitational lensing, guys. It's the funniest thing. Get ready for the stand up.
All right. Well, I got to go for a bit, so you guys can.
Come on, you could be a star. You'd be a great comedian.
Like
Tell us about diffraction, bro.
While you accomplish.
Tell us about diffraction.
See ya.
Tell us about gravity-induced diffraction on a massless particle. Come on, bro. It's gonna be great.
Yeah, particle
Quantum
physics got
it's not very
destroyed
often we get a
again
quantum.
today.
We get a quantum cosmologist. That's very rare. We get a quantum cosmologist.
Well, anyway, the point is, this is what they think, okay? People think that if they just regurgitate the current consensus and they say it real snide, that, like,
that was weak
they're
as fuck,
smarter than
dude.
everyone. It's super annoying, bro. It's super annoying.
Like, terribly weak. I was trying to, I'm like, well, I mean, it seems like the only real difference is the direction of the spin and how they meet up with each other at that, because they both have a charge. I mean, you're calling it a negative charge. That just means that it has a southward spin.
No, they call it a spin. It's a vibration, bro. It's not even technically a spin. They can't see it because it's vibrating so fast, and they can't even isolate it.
Well, that's why I don't even have. That's why the rest
there
of
is a
mass of the
rotation
electron
at all
is just
to
a
the.
theory.
Yeah, I'm saying if there is a rotation at all to the magnetic field, itself, due to whatever little electric charge or whatever it is that it's holding, I mean, there is a magnetic, motion. Well, I mean, we do detect spiraling motion towards the center on either end, coming in opposite directions.
Right. But look up spin and look at videos of what it really is, and you'll see the best that they actually have on through their devices. It's but they can't even isolate it. They have to see the structure. Like he was right about the crystalline tree. It's awesome what they do, to be honest.
Right. It might
I will
not
give
be
them that.
at all.
The technology they have is fucking fascinating, but it
just be
doesn't
like an
show
inside-out
electrons and
hole,
fucking prove photons or particles and shit. That's like where they just step over the line of reality. It's like why did they don't have to do that? What they do is cool enough, man.
I want a Glober to tell us about gravitational lensing of a massless particle. Can anybody do that?
It's so weird how they got the massless particle, the spin of a ball, like the electron, but it's not a physical thing that spins, right? So it's so funny they use these words to describe these things, and you're like, oh, so it's spinning end over end like a basketball. Like, no, not like that. And you're like, well, that's what spin is. So I don't. Why are you? It's just It's a bastardization of the language to push police.
You're right about that. You're right about that. But very quickly, just to clear up two things. You're right about that, right? The hand that is bastardization, but that's a known bastardization. They know that that's not actual spin. It's just the use of the word. It's just what do you call it? It's just so it doesn't have it does. It's not actually spinning. That's true. And
because you can't describe it any other way.
Hank, what you said about gravitational lensing and refraction. In both cases, you have gravity affecting either the medium in the case of refraction and the space-time field in the case of gravitational lensing, and the light traveling through that medium or that field. That's it's not the gravity actually affecting light. So it doesn't matter.
That sounds like why ain't gravity affecting the particles?
Hold on. Sounds like
and you keep attributing the first one.
Because the background medium.
I'm sorry, dude.
Right, Kosho? Since the background medium that causes it.
Yeah, they can't say that it's the particles because there's no gravity properties to particles. And here's the thing: if they say it's shit spinning electrons and protons spinning around, then we should be able to take something real small and just chop a piece off real quick, right? And isolate a few electrons that are in that position of the spin and a few protons, right? They can't do that because you can't fucking isolate the fucking things. You can't see them to do it, for one. They say it's spinning, it's vibrating, and it's profusely, and you can't separate the shit with physically, like with a cup, like just slam a cup over a miniature teeny microscopic cup. You should be able to cut off a portion of that orbit, right? No, you can't. And there's no gravity.
Another bastardization of the language is the word theory. I think when people hear the theory of gravity, they think it's a scientific theory, that could be proven. But if you can't put space-time in a jar and manipulate it, see things rise and fall, or at least fall, right? Or heavenly bodies orbiting each other, not manipulating space-time, then it's just a cool story.
That's what I was going to say. Yeah. That's kind of what I was going to touch on earlier. It was like, he agreed that, it's the first thing of refraction where, there's material in the way causing, and then the second one, is gravitational lensing, where you're assuming there's no material in the way between you and all of those billions of different galaxy clusters that you're getting gravitational lensing off of, or in the solar plasma limb of the sun, where you're getting your only gravitational lensing is through these materials. I mean, obviously you're forgetting something. You're just like,
that's funny, bro. That's simple. Hey, that's funny. That's simple Snell's law, right?
Well, that and the way plasma and electric fields actually will reflect light in shells and stuff too. It does all kinds of interesting stuff. Not only that, it redshifts the light, so it could give them the idea that the universe is expanding at relativistic speeds nearly. Instead of just saying, oh, well, I guess that indicates the level of charge and the direction of ion flow underneath the plasma, because that's what it does.
Instead of just saying we were wrong, guys, the galaxies aren't what we thought they were. Sorry, we were wrong. We're way off. Let's start over. Yeah. They'll never do that. They'll never be honest.
Yeah, they might be a lot smaller. I mean, not tiny, but still a lot smaller and a lot closer.
Yeah, when they, like I said, when they give that extra, when you give an extra dimension, you're in essence making it smaller on accident without even doing it on purpose, like something squared and cubed. You give it an extra dimension, you're shrinking it.
So I don't think squaring or cubing makes it smaller. But
within 2 years, here's my prediction, and I'll shut up. Dark energy will be the fifth dimension within 2 years.
Okay, could you just cut out the middleman and do the second part of what you were going to say? Because the refraction thing and the gravitational lensing thing, and I'm sorry, Grim, but I know because I've heard Chronic talk to you about this, and that's actually the only reason why I understand the argument. I forget the term, but it's like monochromatic. The monochromatic nature of gravitational lensing. The monochromatic nature of the gravitational lensing, meaning that it doesn't matter what wavelength of light, it's going to be lensed the same way, whereas refraction doesn't behave. It does entirely depend on the wavelength of the light. So you can see these two things are not.
Yeah, but they're talking in terms of new tired light, not the old tired light, but the new tired light, where it's loss of the energy of the photon itself across all wavelengths. And why are Einstein rings always blue? If that's true. I mean, if it's not chromatic aberration,
I didn't know that they're always blue. I didn't know that.
Yeah, unless they're getting colored enhanced and all of that. If you're looking at the actual frequency of light coming through, it's blue.
Yeah, I wouldn't know. I wouldn't be able to speak on that.
Next, they're going to tell us about, virtual particles and beer bubble universes that pop in and out of existence, and all kinds of other weird shit about multiverses that nobody can verify. I mean, if you got to make shit up to make your model work, I mean, you might as well make up the most fanciful shit you can fucking make up, right?
Why are Einstein rings blue, or shouldn't they be redshifting?
No, I mean, like I said, I don't know that they are always blue. That's what I'm saying. I can't speak on it. I mean, Greg might have a theory about that. I'm not sure though.
I think the most infuriating aspect of this entire cosmic paradigm is that it is so highfalutin and sophisticated and complex and convoluted that the vast majority of the human race doesn't even have access to it. And even if they did have access to the information, you have to go through years of curricula and indoctrination just to begin to understand it and appreciate it.
Exactly, Gregory. Can you imagine something more convoluted than time? Or something as misunderstood as light? And people think they have a solid grasp on this shit?
So that makes it false, right?
And then in the end, it doesn't inform you at all.
I didn't say that. That's a straw man, sir. If you don't mind, all I was saying, I was adding on to Gregory's point, and forgive me for interrupting, Mr. Gregory, but I was adding on to the point that the average person can't really understand this, right? Because it's so convoluted. And then you said, so that means it's wrong, right? Is that what I said? Or is that what you said?
He's very confrontational, and he doesn't understand a lot of times when people are trying to support him. So give him a break. Anyway, I got this.
I was going to say, in addition, the greatest point is that in the end, it does not answer the question, how then shall we live? And how do I have hope, guaranteed hope for my utter blessedness in the midst of this world where the problem of evil is oh so real?
That's true. That's because all this information has nothing to do with wisdom, and only wisdom deals with morality. So good point, Gregory.
Remember, very good point. Yeah. So back to the Kosho conversation that we were actually just having. Here's the Einstein rings. Why they're blue? This explanation, and this mainstream explanation, is clearly ad hocery, because they're blue because it's chromatic aberration, right? Because that's why it would be blue in a normal situation if you're just looking through dusty plasma, right? But see, with all of this extra, it's blue because dark matter and extra stuff that they don't have any evidence for, again, to support their other things. So they're using both of their solely dogmatically touted theories to support each other and accentuate each other when neither one of them can be proven.
A two birds with one stone technique makes it look like they're making up less shit.
Yeah, I'll prove
But
that
they're
thing that
still making up.
other
Go
thing
ahead.
that I can't prove. Therefore, it's proven. And they're both the same thing, right? I mean, one of them is, it's like literally conjecture. It's like, okay, so I'm assuming there's no material out there in space, the dusty plasmas and electrical connections, so therefore it has to be these other things no matter what. But the assumption could be obviously wrong, because the further we get out into space, the more electrical dusty plasmas we interact with.
Has to.
Not only that, you guys are about to find out some relatively awesome news. I mean, I don't know if whatever you believe the Earth is doing, and if you believe it's spinning, or if somehow if some motion to it at all, or any of that. I don't know if you that, but there's a rift in the mainstream right now because the Earth is actually speeding up, right? And there's no physical model for that. The first mistake they made was try to say, "Oh, the polar ice caps are melting, therefore the water going out." I was like, really? Is that how an ice skater speeds up with her already going momentum? She puts her arms out. Yeah. No, she puts them in.
No.
That would be like you take your weight and you put it out towards a ring of mass. It takes more momentum. It takes more force to move that same amount of mass unless you pull it in towards the poles, and then it takes less amount of force to move that amount of mass. And the melting ice caps is the opposite daisy. Whoopsie.
Yeah,
so that's not gonna work.
I don't think it's because the melting ice caps themselves. I heard that explanation for the climate change being one of the results. It is a likely result or consequence of it because not just that the ice caps are melting, but that the migration of the ice and the water, like the mass movement, because that
Your mic is horrible.
what changes speed. The primary change of speed is due to the migration of
like I was saying,
mass.
though, we're about to find out really soon that it's externally driven electrically. The spin of the earth, the winds, the jet streams, all of that business. And not only that, and I think it was in 1997, they said, wow, the core of the earth seems to be spinning faster than the planet itself. I mean, obviously, after billions of years, that shit wouldn't still be happening. Had it not still be electrically driven right now, to this very moment, still electrically driven. Obviously, I mean, you guys need to wake up to this shit. This is not something I've been sitting here for fucking 4 billion years, and my core is still spinning faster than the surface of this big giant fucking retarded. No way, dude.
So 1.59 milliseconds. Yeah, that's a ton.
Yeah, I heard
sometimes it spins slower than the Earth. Sometimes the core spins slower, and then sometimes it's
really worried that
over and over again.
What am I going to do?
So
what am I going to do with that?
Keeps driving the spin. That's my point.
What am I doing?
You can't just
what am I going to
lose
do
all
with
this
that extra
momentum and then gain it all back 10 years later, and then lose it all again, and then gain it all back cyclically,
I don't know,
unless you're in an electrically driven system.
I don't know what I'm going to do with that.
Oscillating moments.
I don't know what I'm going to do with that extra
sun cycle.
I don't know what I'm going to do with that 1.59 microseconds that I lost, milliseconds, whatever.
Yeah, you should probably explain where the force came from and what energy drove that force.
Yeah, that's the funny thing. Picture I threw a baseball and it's at its peak speed after it left my hand was 86 miles an hour. But then somehow we've detected it going faster. Everybody be like, wait a minute. How did it magically start going faster midway through its throw? That's impossible.
Leave it
right. Like
leave it to Page to church up a millisecond. Leave it to Page NASA Shield to church up a millisecond to a fucking microsecond.
1.59. I don't know. What is a millisecond?
No, this case is microseconds. Still extremely small, but regardless, on a rotating sphere like our paradigm, I think the Earth is, you can speed up or slow down the speed of the rotation just by changing the distribution of mass. So that's all. That's
Dude,
all.
it's supposedly been we've supposedly been losing seconds or microseconds all these years. Like for 40 years in a row, we've been losing a microsecond. Now we're gaining. What the fuck is that? Dude, same thing as they're saying that the atmosphere extends out past the moon. Yeah, we know that because the moon's local, and then it just goes away. Then during the 2017 eclipse. Hold on, they said during the 2017 eclipse, the timing was wrong. It was too long. They said, well, come to find out, the sun is 105 million miles away, and then that went away. It's just fucking news. It's crap.
Okay, I got a news headline to read for you guys.
The moon is local.
97.
The moon is local, but that's compared to everything else.
And more energy is coming into our system, driving the current, just like the world's simplest battery. It's the same exact thing. And we're all talking about how things spin and how the right hand rule and everything. It should be very clearly obvious that now that we've detected the electric currents that go in and out of the north and south poles, it should be clearly obvious why the fucking planet actually spins faster and then slower, because we are electrically driven.
It's any proof of that? Any evidence for that?
Yeah, every single fucking thing you ever look at is basically evidence for that. The anomaly of the Earth spinning faster and slower. The anomaly of the core having a jet stream. The Earth's core has 2 jet streams, bro.
Have you written it up? And
Earth's core has 2 jet streams. That's a brand new. I don't know why you keep trying to. You asked me for evidence. I'm giving it to you, and you keep on talking through it like a little wussy. Now listen to your evidence and take your little butt spanking. Don't ask me for evidence if you don't have the time to listen to the answers.
Well, why don't you just give me the evidence rather than pontificating?
Well, I can make a LED. I can make an LED the same color as the sun, like 3,000 Kelvin, and grow fucking plants. Okay, I can make it look just like the sun, same fucking temperature, okay, in Kelvin, and fucking grow plants. Okay, it's not a fucking gas. Okay, drop it. It's electric. For fuck's sake.
It is gas. We have the spectrum of it.
Just look at the motherfucker, Paige. It's fucking electric. Are you kidding me?
Look through a spectrometer. You can make one of those.
Well, it's an electrified gas. I mean, you know, plasma, and I'm imagining that there's probably a surface to it underneath there. Otherwise, how are you getting all
It's
of
not
that?
a gas, dude. It's a transformer. It's a fucking LED, bro. It's a big ass fucking bright ass LED, which is not a gas. It's not a fucking fluorescent tube of gas. That's our atmosphere. Okay?
No.
It's a fucking transformer.
I know,
Okay?
'cause
It's
we
electric.
have satellites. We have satellites above
You
the
can't grow
atmosphere.
plants with fire.
Whatever. It's not fire, by the way, but that's another issue.
Bro, I could make a little miniature sun, 100 little miniature suns, the same temperature. I can make little sun replicas and grow my plants. My plants won't know that it ain't the sun. I plug them into the wall, get the electricity with my LEDs, and they're identical. I could take a picture of it. You wouldn't know the difference between the little LED, the same temperature, and the sun.
You understand?
We will know the difference between a fire for fusion or fucking gases in a tube.
You understand when you understand when they say temperature, that doesn't mean like
right. That's Kelvin. That's why I specified the Kelvin of the fucking the frequency.
Yeah, I'm not
Kelvin
talking
is a temperature
at you. I'm
scale.
talking to this dumb over here.
That's why I expressed it in Kelvin.
But that's I mean that doesn't mean that your LED is at the temperature in Kelvin, right?
It is expressed as a temperature in Kelvin. Okay, you want to express it in other ways. Okay, the sun is a fucking. Hold on, the sun is a continuous spectrum. You can't get a continuous spectrum from gas.
Yeah.
Drop it. It's not. No, you can't fucking do it. Oh my god, I gotta shut up. Nobody can get continuous spectrum from gas. Drop it. That shit's fucking 18th century.
Well,
go away.
It's electrified. Only when it's electrified. Otherwise, they can't.
It still won't give continuous spectrum, bro. Are you fucking kidding me?
Yeah, no.
Graphite will give a continuous spectrum.
Calm down, dude. I mean, I'm sitting here trying to.
You're speaking out of ignorance, bro.
Well, you're just screaming. I mean, that's not helping anything.
You're right. I am screaming, but I'm gonna back off and let somebody else take over who knows about this. There's no gases that give off continuous spectrum. Okay, not even in plasma form.
Brian, look at your screen when you're talking so that you realize which green circle is lighting up.
You guys, check out the Sapphire project where they get a continuous, steady spectrum off of a.
That's where I learned it from, bro. That's where I learned it.
Well, that's what they did achieve that though with electrified plasma.
Right, with
ionized
fucking
gas.
graphite. It's obviously plasma, Grim. I'm not arguing that. I'm just saying you don't get.
Yeah. It's a strange lattice structure you get to it.
It doesn't matter. Anything you plasmize is gonna turn into a gas anyway. But I'm just saying you can't just take just the gas. You got to have the electrodes and shit. You're not gonna get continuous spectrum from just a gas. That's what I'm saying. Look at Sapphire, dude. They had graphite electrodes.
Yeah, you weren't listening. That's what I was saying. Yeah, we're not arguing then. Same page.
Dude, they did some good work, bro. I'll give it hands down on that. And I feel like y'all are like half awake, bro. You're like sleepwalking, bro. You're up on your feet, man. Just got to shake you a little bit, man.
No, I like him. I like Grim thinks for himself. He thinks outside the box.
Yeah, me too. I do. I'm just fucking with Grim.
But
it's all love, dude. And
yeah, I'm trying to make sense of then. Sorry, I was just going to respond to what Brian had just said though. About the sun not having a continuous spectrum. If that were the case, how would you be able to get spectral lines from it?
Say that again.
The spectral lines that we get, that we've always gotten from observations of the sun. How would that be possible if what you said was true?
We get the whole spectrum of white light, don't we, Kosho? What do we call that? And you got to call it a black body, and then say it's not a black body, right? Let's talk about it in depth. Is it a black body or is it not a black body?
Sorry, I can't tell when my thing's on or off. But yeah, we clearly don't get the whole spectrum. Otherwise, we wouldn't get any.
Really? It's not white light? We don't get the continuous visible spectrum? It's not white light?
Those two ideas aren't consistent. They're actually the exact opposite of one another. So you can't get you can't get a continuous spectrum and also get distinct spectral lines. Those are two.
What color is the sun's light?
You look at the spectral lines of the sun.
I'm not saying physically. What color is it? What color do they call it?
It's white.
White. And what is white?
White is all the color. I mean, is all the colors added together.
It's all the colors. It's a continuous spectrum.
Right. Yeah, but it's not a continuous spectrum. If you actually break down the light itself, it's not a continuum. There's breaks in it.
I didn't say it's a continuum. What the fuck is a continuum? I said it's a continuous spectrum.
Well, a continuous spectrum would be all the lines.
There's no gas alone that creates that, bro. Listen. Okay, is it a black body? Let's go in depth. Is it a black body?
All stars are used as black bodies. I mean,
is the sun a black body?
They're not actual black bodies.
How you bouncing shit off a black body, pal?
Okay, Brian, you're gonna have to just be quiet for a second because you're gonna learn something if you listen. Which stars, they emit light, they also absorb light. Okay, if you add both those together, if you add both those together, you're gonna get the reason why they use them as black bodies. Okay, but they're not actual black bodies.
Right, so they're black bodies that aren't black bodies. That's what I wanted you to get to. I rest my case.
Yeah, and I just explained that. I just explained why they're used as black bodies.
They're black bodies, guys, until they want to bounce fucking signals off of it. Then they're not black bodies. So they're black bodies that aren't black bodies. And he's saying that with a serious face, guys.
Well, he doesn't.
I'm they're emitting lines and they're absorbing lines, and those lines added together equal the full spectrum. So you can, for practical purposes, consider them black bodies, but they are not perfect black bodies.
Well, now that we know,
so they're black body, not black bodies, right? That's all I was trying to get to.
Oh God, did you listen to them? They're not perfect black bodies. That's the problem.
They're just enough out of a black body to let your fucking shit bounce off of them, right? Paid.
Bouncing it off has.
Do y'all think we're retarded, dude? Do y'all really think we're fucking retarded?
Yes. Actually.
Listen to yourself. Rewind it and listen to what you just said.
No, actually, no. Yeah, I do think you're retarded, actually. But yes, since you asked the question.
Y'all, these people will believe anything. Well, it's a black body, but yeah. Well, how did we shine? How did we bounce the radar? Well, it's not a black body. It's a black body, but no. When we bounce the radar, it's like not a black body. They'll believe any fucking crap shit they fucking are told because they have to. These people, I don't know if they're even fucking real people, dude. I got love for all these guys, man. But listen to them, dude. They will contradict themselves in the exact same sentence and not even question it. Is that weird? I mean, am I fucking weird? I mean, I'm sorry to be loud and a dick, but just talking to these guys, it's fucking crazy.
Seriously, they're like a walking contradictionary. They speak out of both sides of their mouth, just like the serpent's tongue, right?
And they think they're smart, right?
I can't help but
it's like The Walking Dead, guys. It's like The Walking Dead. And we're the
Oh, thank you.
Listen, guys, we're the alive people. They're the Walking Dead, and they need brains. They need like brains to think, and they're like everything.
Let's see. You guys.
Hank was in the middle.
How much rhetoric is going to happen?
What's the proof of
the you're not going to talk right now. NASA, you're not talking right now. Hank was in the middle of talking.
Yeah, the three guys. You're just saying more things to I don't know, insulting my position for whatever reason.
Again. I think you misunderstood me. But Hank was speaking and got interrupted, so we're going to let Hank speak like we let everyone speak. Thank you.
Go ahead,
I don't speak very much, and when I do, I usually make a point and go on mute pretty quickly. So yeah, I just want to point out that there's lots of contradictions that you guys make, like his light coming like 90 degrees parallel from the sun, except for on eclipse days. But luckily Eratosthenes didn't measure the sun on eclipse days, right? It's like one of those things where you can't have your cake and eat it too, and you guys do that all the time. Like you guys eat your cake, and then instead of it becoming a turd, like your cake is sitting on your desk like you never ate it. It's like, wait a minute, that's not reality, bro. You can't do that.
So what's the proof of the?
I'm going to respond to the first criticism, which wasn't that one, which is far different from the other ones. I don't know what contradictions or two sides of the mouths people are speaking on when they're telling you clearly what's meant by the continuous spectrum which clearly something that has spectral lines that you can see distinctly is not a continuous spectrum. That's one, not the other. Okay, so it's not two sides of the mouth. In the case of the black body, they're used as black bodies because stars the light that they absorb is the exact complement of the light that it's going to be emitting, and they're not perfect black bodies for the reason I just explained, that they have distinct spectral lines. So these aren't two sides of the mouths. This is one point, and it's not contradictory in any way whatsoever. So you just have to clearly understand it.
Guys, pray for Kosho. He's a smart guy, y'all. Everybody pray for Kosho tonight, man. He's a smart guy, man. He's a decent guy.
I wasn't addressing this argument. I was just noticing that he was saying that you were being contradictory with your speech, and I'm noticing that in my experience with you guys, it's been the same way in the past. Like, it's like one way or the other. Like, it can't be both. So let me ask a question: does the light from the eclipse, does it like travel at 90 degrees until it hits the Earth?
So
the light from the sun during a solar eclipse.
Yeah, I got what you're saying. Nobody who's speaking accurately or correctly or carefully will tell you that the light is coming in perfectly parallel. As a matter of fact, if they say the words perfectly parallel, light is coming in and hitting the Earth, they're undoubtedly wrong. So people don't say that. If they do, they're wrong.
Since the sun is like 100-something times bigger than the Earth, what degree is the sun actually like off by 90?
For it to be 1 degree, it would need to be as far as maybe I've seen like maybe 500,000 miles or something like that for it to be 1 degree different. It's much smaller than 1 degree from either end of the Earth. So you have to. I've done the math before. I don't have the numbers on top of my head. You just have to reverse you'd have to reverse with the angles. The angle would have to be from both ends of the Earth, and where the parallel line would be.
All right, so I'm just going to post something real fast, and I'll let everybody kind of make up their own minds on, what they're seeing. But from what I can tell, it looks like the way that you guys describe like a solar eclipse is the moon is acting like a magnifying glass, but it's not magnifying the sun, it's magnifying the shadow. And I say that because the moon is 1/4 the size of the Earth, allegedly, but the shadow that it leaves from the sun, the one that's in totality, where you can see like the whole sun is blocked out, so you're right in the right spot where the whole shadow is like completely blocked out the sun. That spot's only like 70 to 100 miles in diameter, which that's not 1/4 the size of the Earth. So I'll just post this little bit of information here and let everybody make up their mind. Because if light's coming down at 90 degrees, like Aristophanes says, then you got a small moon.
What's the other name for that? Oh, go ahead.
You can't have it both ways. You either got a spherical Earth because of Aristophanes, or you got a small moon. But
No,
you can't have it both ways.
We can't have it both ways because we're talking about two different phenomena.
Yeah, aren't there two different?
Right, but the light is one phenomenon, right?
Yeah, but the shadow.
The shadows are two different phenomena.
Yeah, there's two different components of this shadow, and you're referring to the wrong one.
Okay, so what's the right one?
The other one.
The one where it's partially blocked? So you think...
No, there's an umbra and the penumbra, right? You're talking about the
penumbra. Right, the penumbra is where it's partially blocked, right?
No, no.
That's not the totality of the shadow. The totality is actually a very small, like 100 miles in diameter. But where you can see where it's partially blocked, that takes up like, I don't know, like most of the United States, right?
No, hold on. Hold on a second.
So are you guys saying, and this is a question, not a straw man, are you guys saying where you can see on the Earth where the sun is partially blocked out, that's what you're going to measure the size of the moon where it's partially blocked out instead of measuring the size of the moon where it's in totality?
Hold on 1 second. You can pay that show. You can talk about. I'm talking to somebody. Hold on.
by the way, I posted that so everybody could see. If Eratosthenes is true, light was coming at 90 degrees, which would be the very first thing you see. Right? Science says sun rays reach the Earth parallel. Right? That would be a good example for Eratosthenes, except on an eclipse day, when they converge into a cone and make a small path to totality. See, this is what we're talking about, contradictionary. Like, you can't have it both ways. Either the light's going straight, like railroad tracks, or it's converging. So which one is it? Because the way I see it, it's a failure both ways, because if it is that Eratosthenes correctly measured the Earth, right, then you got a moon the size of like 100 miles across in diameter. So if you got a moon that size, then gravity doesn't work at the solar system level, which what creates the shape of the Earth, how our Spaceball's made? Gravity. So this is like not a winning situation for you guys.
I think the crazy part is in moments like this, they'll just all agree to get completely quiet and not respond at all. And then they'll just kind of wait it out. And then they'll jump back in to talk about how stupid anyone is that questions it. So, like, in the moments where they don't have a rebuttal, they literally just all get quiet. Think about, like, the psychology of, like, knowing you literally can't respond and, like, you have no idea what the answer is, and it contradicts and falsifies your model. So just choosing to go on mute and be quiet and hope it passes, and then coming back in after that like it never happened. I'm just like the psychology of it.
You might not have been present, but a second ago I just said, "Hold on a second, I'm talking to somebody." I was talking to my girl for a second. I don't even know what. What were you saying? We're talking about the eclipses, right? So what about the eclipses?
Yo, calm down, man. I'm just making a bigger point. It happens all the time.
You're making a down point. I'm saying that
it happens all the time.
It's not true.
Yeah, it is true. It happens all the time. Like, I do it to Glovers all the time. Like Kosha, do you agree that Einstein said that if there was actually movement outside of the Earth, that the Coriolis and centrifugal force would happen on a stationary Earth as well?
Listen, no offense, but I'm trying to focus on whatever point we were just talking about.
See, that's my point. Yeah,
we're on a point. We're talking about the eclipse and stuff. I'm not trying to change.
Okay.
I was trying to respond.
I don't want to change the subject either. I'm just showing it. Yeah, whenever you guys get refuted. Well, my talking point was simple. It was just quiet in here, so I decided to say something. Then you decided to come back when you said you were leaving. But all I said was, when you offer them something that they don't really know a rebuttal to, like the question I just asked, or they don't like the answer, they just avoid it, but then they skate past it. It's a generalization. I'm not saying every single one of them do it every single time, but it is very interesting. It's very fun.
In the specific case that we're on right now about the moon, but what was the something about the penumbra and umbra?
The question is, does the light travel at 90 degrees parallel, or does it not?
First of all, no. 90 degrees parallel doesn't make sense.
How does Eratosthenes work? If you don't
90 degrees parallel doesn't make sense, first of all. Second of all, as I told you earlier, nobody who's correctly explaining anything about the light coming from the sun would say it comes in perfectly parallel, because it doesn't.
So how did Eratosthenes make an accurate measurement with diverging light?
Because, as I told you before, the distance between two ends of Earth, the farthest ends, 8,000 miles apart from each other, in reference to the distance apart from each other, that is not going to be a big enough distance for there to be a huge discrepancy between that angle. That angle is going to be far small enough to easily make a measurement which would fit into any other, like the error margin for your measurement device, or your the way you're doing it. It's probably going to have a bigger error than the error that would be caused by that. It's not. It's not very big. It's much
So
smaller than a half
basically, what
degree.
you're saying is that it's negligible enough to work both ways.
No, it's not negligible. It's not negligible to work both ways. It's negligible to not be a problem in this case. In this case, it's not an issue because the amount of air that you would get from that is not enough to make any sort of something that would wildly change your model. Like I did this test with 22 other people, whatever, and I allowed for a big enough error, but I think a half a degree or something like that. Nobody got anything near that because that's not expected from that difference. It's a very small difference.
So if we're talking about like half a degree worth of convergence, is that it? Because if you look at the eclipse, it's converging. The light is converging around the moon, almost like the moon is magnifying it. Is that half a degree?
What? No, I'm not saying. I'm saying I allowed for half a degree. I'm not saying that that's the actual.
Right, but we're talking about the eclipse too, right? Because the light
Sure.
is the main thing we're talking about. The light from the sun,
Okay.
and you're saying it's converging a half a degree.
No, I'm
from
not.
the
I'm
sun
specifically
to
saying I'm not saying that.
What is the visual diameter of the sun?
It's supposed to be fucking 0.54 degrees, and
Yeah,
but in
half a
reality, it's
degree.
supposed to be
Wait a minute,
865,000
that's
fucking
the
miles.
apparent. That's the apparent size, right?
That's
What's
correct.
the
He's just
actual
trying to ask you a
size?
question to get a win, bro. That's my answer because he's trying to get a win on you, bro.
All we
He's
care,
a snake.
all we care about for the phenomena we're talking about is its visual size.
Oh, so we're going to go with the apparent size, not its actual size, because if
That's
we did
correct.
the actual
Whatever
numbers,
works.
it wouldn't
Whatever
be.
works for
It
the
wouldn't
argument,
be
right, Paige?
negligible.
Excuse me,
Yeah.
are we talking about an optical phenomena or not?
No, we're talking about
What
actual
difference would it make if he'd have
phenomena.
said fucking
Light
it's 1
traveling
degree?
at 90 degrees. Is
So
light traveling at 90 degrees or is it not?
it's traveling. The light rays coming to the Earth are not, once again, as I said, not perfectly parallel. They are almost parallel within, well, guess what? Half a degree. Why? Because the sun is a half a degree wide.
All right, so
the difference.
during a solar eclipse, is that a half a degree where the sun like bends around the moon like it's a
It
magnifying
doesn't
glass,
bend. It's not
magnifying the
bending.
shadow?
It's not bending.
Okay, so
Those are
it's not
straight
bending. Is
lines.
it like a degree? Okay, so is it like half a degree?
Excuse me, did you see the diagrams there? Those are straight lines. They're nothing bends.
Right, I understand that. I misspoke. Right, so is it half a degree from the top of the sun to the bottom of the moon, and from the
The
bottom
sun
of the
and moon
sun to
are
the top of the
both
moon?
the sun and moon are both the same apparent size, which is why it works in the first place.
What are the actual sizes? Because the
cares?
apparent is different. Well, see, like
gives
if I'm trying to spear the fish, hold on. If I'm trying to spear the fish, don't I want to spear the actual location and not the apparent
No,
location?
no, you.
Oh, really? So I'm hungry. I want to feed my family.
Okay,
I
I
want
know
to
what you're
spear the
saying, but
fish
no,
in its apparent location.
I got you now. I understand what you're saying. That's not a great analogy for this phenomena.
Really? So we
Yes,
want to get the actual information, but you want to spear the apparent
we're not going to spear
location.
anything. We're just looking. See, if you look at these
Well,
lines, they're
doesn't a
straight
spear
lines.
travel in a straight line? Does the spear travel in a straight line?
Is it going through a medium? But no. Okay, no. Anyway, so where you get this magnifying effect.
Right. I'm saying that when you magnify light with a magnifying glass, that's the kind of angle that the shadow is taking from around the moon.
It's
So
similar, but it's different.
what is
No,
causing
it's
the
not.
light to do that when it's normally traveling at 90 degrees?
The light doesn't bend around the moon. This is the half degree. The half degree becomes important when you're looking at the penumbra and umbra.
Right, but when we're talking about the totality shadow, right, that's the actual size of the moon. For everybody who can see a partial eclipse, that's not the actual size of the moon. They're just getting a piece of it, which would be a much larger area than someone who's actually in totality, because the totality is going to be the actual shadow. Everybody who's seeing a piece of it is going to be seeing a partial shadow. So in reality, that would be a much larger area if you could see it partially blocked out.
Hank, I don't think you're thinking about
your analogy. Your analogy of the moon being a magnifying glass is incorrect. It doesn't work that way. These are
Okay,
straight
so
lines.
I would ask you to go up to where I posted at 7:49 p.m. I got that off of the Metabunk website. So when you click on that video and you watch it, what does it look like to you?
I don't know. I mean, see, you're telling me so far you tell me it's looking like a magnifying glass, but it's not. What you're seeing there is the difference between the edges. So the half degree becomes important.
So what is the actual like mechanical? What's the mechanism that causes the light to like, go around in those angles to cause that path of totality? And it's such a small path of totality.
Because it's not perfectly
Because
parallel.
what?
Because they're not.
Oh, then how's Aristosthenes work?
Because
how does Aristosthenes work?
Eratosthenes between the shadow and the ground had maybe I don't know, a meter, maybe a meter and a half.
So it's negligible, huh?
Yeah, exactly.
Yeah, your double speak is negligible.
No, actually, it's not. See, the moon is not. The moon is like 288,000 miles away. It's a ways out there, so you have to worry about this.
So wait, hold on. So who's making this argument? Who's making this argument that it's not whatever? Who's the guy who was talking earlier? Like the guy that was flat earther, the flat eurther dude.
This is Hank.
No, they have to put it out. They have to put it out to get it right. They have to put it out a little extra far. That's why he said 288. Because it doesn't
what is it? I don't know.
But the math is it's close, man.
I'll
give you that.
I'll have this shit memorized,
Okay. Yeah. Anyway. Yeah. So I mean, yeah, Hank. I mean, if you really want to like look into this, you should just either maybe do the math or actually look into it, because right now it's just your guess. You know what I'm saying? Like I get where you're getting at, but like if you actually look into it, it checks out. All right. So I don't know what to tell you.
I was going to tell you, Hank, that you're thinking about it. If you think about it in a different way, it may become clear, because you're thinking about it in a way that is describing the penumbra and umbra as the partial eclipse versus where people can see the totality, right? However, if you think about it in a way of what's actually happening, of what the shadow is actually expressing onto the earth, you think about where the moon is that's blocked by the sun, and where the shadow is as it's moving across the earth. The shadow is going to have a range, right? It doesn't matter what the people can see from that position; it just matters what's the shadow doing, and that range is going to be, like I said, not the umbra, but the penumbra is going to be more defined by the size of the moon itself.
No, it doesn't make sense when you say that, because if you think about it, the totality, the shadow, that's totality, that's the actual size of the moon. Because when you look up in the sky, it's completely blocking the sun, right? But when you're like, sorry, hold on. Yeah, the shadow of the moon blocks the sun in your model, right? So when you're talking about the larger shadow, right? That's people that can see a partial eclipse, and that's not the whole size of the moon, right? That doesn't make any sense. See that thing partially blocking that thing out there? That's how big the moon is.
Yeah, I know.
No,
that's
that
what I'm
doesn't
saying.
make any sense whatsoever.
From that perspective, but it may not make sense to you, but from a perspective of actually standing outside of the whole thing and actually thinking about what's actually occurring and seeing what you'd be seeing from that perspective, from standing outside and looking at the actual shadow on the earth, the shadow created from the moon, you would see that actual shadow that's created by the moon is actually very much close to the actual size of the moon. Not what people are experiencing on Earth, but what the actual shadow on Earth looks at that given moment.
All right, so you're telling me if something's partially blocking a light, right, that whole area that's partially blocking the light, I can determine how big this object is, and that's going to be a better determining factor than, hey, see this little area right here where it's completely blocked out? We're not going to measure that. We're not going to count that. We're going to measure this much larger area that's partially blocked out, and that's how we're going to determine the size of an object. You got to be kidding me.
I'm not saying
you
to
really
use
believe
that to
that?
determine the size of the object at all. I never said to use that to determine it. I'm saying that the reason why I'm saying that you do not use the other one to determine it. You would not use the umbra to determine the size of the moon. It's going to be more reflective of what the penumbra is doing. But I mean, like I said, I wouldn't even use that. If you could stand outside of the Earth and watch it happen, you could maybe approximate it that way. But that would involve you having to actually see the entire shadow at one moment.
Yeah, that's the shadow that's going to give you the actual size, when you can see the whole object being blocked out That's the entire moon, right? And you can look at that shadow on the Earth and say, okay, I see the whole sun's blocked out. That's the moon, right? Not a piece of the moon, but that's the whole moon. And this is the actual size of that object.
Say that again. You said, I mean, I kind of I think I kind of got what you're saying. I mean, I don't know. It's you really have to like look at the angles and shit and whatnot. I mean, like really just work it out, yourself.
Look at the video I posted. What is the mechanism that magnifies the shadow to that degree? And I say magnify because I don't have a better word to describe that, because I've only seen those kind of angles with the magnifying glass.
I mean, the weird screen recording one? So screen recording 202.
It's like a 15-second video that I posted at 49 minutes after that.
Okay. I mean, really, I'm trying to think because, like, with how light works, I know if the light source is bigger than the object, then yeah, you get the smaller thing going on. But it's smaller than it goes outwards.
So if the angle is converging at that degree around the moon, that's nowhere near 90 degrees. Nowhere's fucking near it.
Yeah, I'm not trying to get out and bust your chops or anything, but you keep on using 90 degrees, and I kind of know what you're getting at, but I'm just saying it doesn't make sense to say that the 90
Well,
degrees.
I'm rounding it up. We know that you mean.
No,
89,
I'm saying that number doesn't make sense in this aspect at all. Like it's not.
I
I
know. That's
think
what
you're saying is the actual
the Aristophanes thing and the eclipse thing. They don't go together at all. What's bad?
You're talking about the actual point where the moon would be at its zenith. That's 90 degrees, and then everywhere from there, the angles being parallel, or whatever. But if angles are parallel, you wouldn't describe them as being 90 degrees. Anything close to it.
So are railroad tracks parallel?
Yeah, they're not in any way 90 degrees. They'd be more like 0 degrees or 180.
Okay, so let's call it 0 degrees. So what's the deviation from, the sun to the Earth?
I mean, I put my diagram because I found the picture I made, and I don't know if my number is correct, but the way I think about it is much closer to that, which is let me see what I put. It's much, yeah, there it is. It's like more like 5/1000ths of a degree, based on
really. So you're telling
parallel
me
lines coming from the sun and where they would be at when they reach the Earth.
So you're telling me, right? And let's be clear. Let's make it to scale of the solar system. The sun is like 109 times the diameter of the Earth, right? Isn't that right?
Something like that. Yeah, 18. Yeah.
Right. So if the moon is 1/4 the size of the Earth, that would be like 427. No, 400 and.
It's about 409.
Okay, so the sun is 409 times, let's say, roughly, bigger than the moon. At what angle would, the sunlight have to be coming from the top of the sun to cross the bottom of the moon in that diagram? I'd say that's a pretty steep angle, because if we're talking like 400 times the size of the Earth, I'm sorry, 400 times the size of the moon. I mean, that's a pretty steep angle. That's not anywhere near 0.
Yeah, but that's not exactly that. It doesn't perfectly represent what's happening with the Umbra and the Penumbra. It's just if you were to take the magnitude of the light that is reaching the Earth from any point, and you have this spherical object that's creating the shadow, you would not have a crisp, circular shadow on the Earth, for the reason that even though there may be a region inside of that shadowed point that's not receiving sunlight, it still is receiving some radiant sunlight, and it's still receiving some parts that aren't eclipsed by the moon sunlight. So it's darker than the regions outside of that, but it's not exactly the darkest. And if you have this going around the entire circle of that shadow, then it stands to reason that the very center of that shadow is going to be the darkest point, because that's the place where that radiant light is not going to be able to get into. So it's just basically differing degrees of the shadow.
So this shadow, right, the one that's the darkest, the boundary between it and the other shadow, the penumbra, is it a blurry boundary or is it pretty cut and dry?
I mean, it's I would think it's pretty blurry, but I mean, I think when you're standing there, that's where you can see the.
When you're standing there, it's very cut and dried because the little bit of the, as soon as you see just just the smallest bit of the sun, you can you no longer see the corona.
Right. That's what I'm saying.
So it's kind of weird that light is doing all this, crazy, refracting through the atmosphere, and it's converging in all directions around the moon. But that shadow from the moon is crisp. That's weird, right?
No. Again, it's crisp from what as he just described it, as viewing it as where you can be, as the positions you have to be to view the total eclipse. Those are crisp lines. However, viewing the shadow from outside the Earth, it would be it would appear like a hazy gradient of where it's the darkest and where it's lighter and lighter as you get to the edges.
No, but I've experienced it on the Earth. If you're outside of the path of totality, like I was when the annular eclipse happened, if you're outside of that path of totality, you don't get to see the whole sun. So I saw it in what was it, about 2012 era? There was
I think it was 2013 after.
Maybe it was 2013. That sounds about right. Okay, so when I saw it setting, because it happened in West Texas and California, real clear. But what I saw was a partial annular eclipse, and it should have been a perfect ring like Lord of the Rings. It should have been the Ring of Fire eclipse, but it wasn't, right? Because I was just outside. I was just on the wrong side of Dallas to be able to see it. And that's how crisp those lines are. It's a perfect boundary. Either you're in it or you're out it. And if this is caused by light converging, and there was obviously a little bit of refraction because we got atmosphere, then it wouldn't be such a crisp line because light would be going all over the place, bending at 8 inches per mile squared and all sorts of weird shit, right?
Visually, I'll give you that it looks very crisp, but like Kosha said, if you see the pictures of the shadow from like Himawari or one of those, it doesn't look that crisp. I think what you're seeing because.
Can you show me a picture from Himawari?
Yeah, they have pictures of stuff.
I'd love to see that.
Damn it!
I've got it now. So hold on. Actually, I have it right here with NASA. Just give me 1 second. But there's a diagram for where a future eclipse is going to appear to be, right? And you can see how it gradiates. You can also see how the size is comparable to the size of the moon, except for the darkest point with the center, which is going to be significantly smaller. But I've got a real image. Hold on.
Wait a minute. Is that a picture or is that like a kindergartner trying to make fun of you guys?
Well, as I just said, it's a diagram showing a future eclipse.
I thought you guys were talking about the picture.
I know. I feel like you're not listening then because I just told you.
Sorry, I was waiting on the picture.
I know. I'm saying that this is a diagram. I have a picture I'm about to show you, but this is also a diagram showing you how it gradiates away from where it's the darkest. But I'm about to post a picture. Hold on. That's a picture.
That's a picture.
It is a picture. That's from the Epic Discover, and this was an eclipse that
you can't even see the path of totality. It's so small.
Well, yeah, you can see how it's it's lighter. The shadow is lighter than the center part, but it's obviously darker than everything outside of it.
Don't worry, bro. Just keep toting the line.
I mean, do you understand? From seeing it from Earth is one thing. Seeing it like this is how it actually seems that more intuitive. That when you have an object and you're making a shadow, it's going to appear as a shadow on the thing that approximates the size of that object.
Yeah, but you can't even see the path of totality, right? This is where the sun is like partially eclipsed.
You're not expected to. That's something you see from the ground.
You wouldn't expect an object to cast a shadow the size of the object.
Oh my God! No, the path of totality is a phenomena from something you see on the surface looking at it. but it's not how you would intuitively think of how shadows are, how you experience shadows. You would experience shadows by looking at the object and the shadow formed on it, right? And that's when you would expect it to be around the same size. But the path of totality and that kind of thing, using that to approximate its size is not. It's not just a. It's a misinformed way to do it.
So saith the king, right?
No, it's apparently the truth.
It's a baseless assertion. Can you provide
I'm
any
showing you
evidence that
these two
measuring
images.
the path?
That's not the truth.
So can you provide me like hardcore evidence that measuring the path of totality, where the object is completely blocked out the light, that's not a good way to measure the size of an object? And it's better to actually measure the whole area around that where it's partially blocked out, because the size of an object is what? Where it's totally blocked out or where it's partially blocked out? Think about it.
Hank, what I told you was that using either of those methods would be, I don't know, the wrong way to do it. I wouldn't use using the path on the ground of where the shadows are to determine the size of an object, because this is the wrong intuition for what the shadow should be doing. When you actually view the object and you view the shadow on it, this is a more correct intuition, but it's not going to give you accurate numbers either, because of the fact that the angles aren't perfectly linear.
So saith the king. But I'm going to say that I don't think you should try to measure the shape of the earth by measuring shadows coming from a sun that's not giving light that's coming straight at you, but it's actually converging and to itself. That's not going to be a very good way to measure a shadow. And to assume that this shadow is somehow linked directly to the shape of the earth because we know it's spherical, I don't think that's a very good thing to do.
Well, you can think whatever you want, but you're false on this one, because the sun's basically coming lights are basically coming parallel.
Except for during an eclipse day, right?
No, they still come in parallel. It's just that the moon is.
Then why is the sunlight wrapping around the moon?
It doesn't wrap around the moon. These are straight lines. Once again, look on the
Then
diagram.
why is there umbra and penumbra?
It's correct.
If the sunlight, go back to the video that I posted and tell me the sunlight is not going around the moon.
Listen to me one last time. It does not go around the moon. These are straight lines and this is where the half a degree comes in. It is not perfectly parallel because the shadow from the moon has a ways to go before it hits the earth. Now, your shadow from the stick has a much, how many muches do you want? 3, is that the correct rumpus amount? Shorter path before it hits the ground. It doesn't have time to diverge.
Well, either light travels straight or it don't. And
see, that's the problem. You have like a good science denier. Everything has to be perfect all the fucking time, and it's not science. It's not perfect. I'm sorry, but it's close enough.
Well, if it's not perfect, then how are you going to make a perfect, accurate measurement of the Earth?
Based
on assumptions. Oh, it's negligible, right?
Close enough.
Negligible.
Close enough.
Yeah, it's negligible. Yeah.
Close enough. Within a margin of error. Everything always has a margin of error.
It's within a margin of error, and it's negligible enough to where you
everything always has a margin of error. See, that's the other thing that you missed out when you fell asleep in high school science class, obviously.
So, does light travel in straight lines, or is there refraction?
Yep, all the time.
Oh, so there's no refraction. So that means
light travels
that
in straight lines.
The horizon's 10 times farther than it's supposed to be.
Oh, please
right?
stop the horizon stuff. We're not talking about horizons. I'm tired of talking.
Oh, we're not talking about light. Sorry, we're talking about light.
We're not talking about horizons. Nope, not talking about horizons. We're not talking
does light have anything to do with the horizon?
We're not talking about horizons.
Does it refract?
Well,
you can't have your cake and eat it too. I'm sorry, bro.
We're not
you should get
talking
2
about
pieces
horizons.
of cake next time, bro.
You should learn. You should actually learn some stuff. You should stop flip flopping and talking about one phenomena, then flip over to another phenomena because you think that you have me on it, and you don't.
We're talking about light, right? We're talking about the physics of light. So, does it travel in a straight line during an eclipse?
Yes.
Does it travel in a straight line when you're observing the horizon? Does it travel in a straight line when you're measuring a shadow?
Yes. The Eratosthenes experiment. That's why you do it at solar noon.
Okay, well, that means that the horizon's 10 times further than it should be. Thanks for playing.
We're not talking horizons. We're talking about the light coming straight down.
Right, we're talking about light, the physics of light.
You guys always want to talk about the horizon.
Try not to get on another topic. We're talking about the physics of light.
No, we're talking about
Does light travel in a straight line? Come on.
We're talking about the Eratosthenes experiment and the fact that the light at solar noon has minimal to no refraction. because it's coming straight down at you.
Try to keep up. Does light travel in a straight line?
Try to keep up. We're not talking about horizons right now. You don't understand
We're
horizons
talking
either.
about light. We're talking about the physics of light.
We're not talking
What
about
is light
horizons.
doing? Is light traveling in a straight line? Come on, bro. Play the game. Is light traveling in a straight line?
I'm not going to play your game. I'm not playing your game. That's the problem. You see how
you don't want to play?
You're going to go to horizons, and you confuse yourself on horizons, and this is a totally different phenomenon.
I'm not confused. It's a game. Everything I said is logically consistent.
No, it's not. It totally isn't.
So, does light travel in a straight line? It's a simple question.
What's the evidence for the flat Earth?
Does light travel in a straight line?
What's the evidence for the flat Earth? That's a very simple question.
It is a game.
You're focusing on that one word because you guys are desperate. You guys do that a lot too.
What's the evidence?
Next,
for the
you guys
flat
are going to say, "That's not what I'm saying. That's not what I'm saying."
We're far from desperate. But
Go ahead and say it, guys. That's not what I'm saying. That's what you guys are going to say next, right?
I observe it as this way. If we're desperate, there'd be thousands of us in here. Instead, there's 2 or 3.
You guys did rally together when I put you guys on stun.
2 or 3, 4 people, maybe. How many?
Yeah,
Hey, Larry.
One guy came in here. Hold on. One guy came in here and said, "Hey, wait, what's going on? Who said what now?" Like he was trying to catch up, like somebody invited him.
Yeah, 2, 3 or 3 of us. That's not desperation. We're just here to chat, man.
So does light travel in a straight line?
Larry, can you hear me?
Yes, sir.
Oh, okay. You know how light travels?
Well, I don't know if light travels or it's at a rate of induction. Why don't you tell me?
Light travels in whatever way you need it to travel in order to prove the globe.
So what's the evidence for the flat Earth?
Yeah, that's kind of their position usually.
Hold on, real fast. I got the evidence for the. Yeah, I got the evidence.
And bendy.
Sorry, bro. I know it's your room. I'm almost done. I'm gonna go on mute. I apologize. I know it's your room, and I sincerely apologize. But I just wanted to say, yeah, my point was that light travels straight unless we're looking at the horizon. Then it does whatever it needs to. Thanks. I'm done.
Oh, we know
We
about
call him Scary Larry. Here's all the gloopers.
Geo, how are you doing?
So does anybody have any evidence for the flat Earth?
No, I was just kind of saying the same thing Napalm was saying. It seems like in general, the guys who assert a globe Earth they'll use straight light when it needs to be straight, and then they'll use bendy light when it needs to be bending in order to account for the fact that there's no curvature and that the model doesn't work on a spherical system.
The model works very well, and we know about
No
refraction.
doubt about it.
Yeah,
You just got to change bendy lines, horizontals, and light and water. Got to change things as you need it.
Everything on Earth is based on the globe model.
So, is there any evidence for the flat Earth, or should I just go today?
Yeah, the horizon's 10 times too far because light doesn't bend, like you said.
That's not evidence for the flat Earth, but okay.
That's perfect evidence for the globe. Your geometric horizon disappeared like fucking Santa Claus. Probably never existed.
Do you have a place without an atmosphere that we can go observe the geometric horizon?
Yeah, that's what happens when Eratosthenes was born. When there was no refraction and light was traveling at 0 degrees parallel.
We see when light is coming straight down at you, it doesn't refract. Do you understand that, or do we need to go over Snell's law?
What about the second position where his buddy measured? Was he at the zenith position as well, 500 miles away, or was there refraction involved? 500 miles is close. It's negligible, right? Yeah, it's negligible. Moving on.
Yeah, itty tiny bit. How much refraction would you expect from 500 miles with the angle of? How much would you expect?
Well, I would expect it to be negligible, like that number with 120 zeros behind it.
Yeah, something like that. Something like that. Yeah, so you can calculate if you want, but you just can hand wave it or say no, because I can't calculate it or something.
See, I used to envy you guys toting the line. I used to think that it must be so easy toting the line that's crafted for you guys. All you guys got to do is pick it up and figure it out. When Flat Earthers 7 years ago, we didn't have a line. We were trying to figure shit out, right? And now I'm starting to hold on. Let me finish. I'm starting to realize that I don't envy you guys anymore. It must fucking suck to be on your side.
No,
because
actually,
you got to make shit up as you go. Add theories.
It's the other way around.
Dark matter
It's
and
totally
dark
the other way
energy
around
to make our model work. We're going to invent 95% of the universe to make our model. Do flat earthers make up 95% of bullshit? So
No, 100%.
Oh,
definitely, yeah.
100%. They make up 100.
times too far.
They make up 100% of the bullshit.
No, we ain't got to make up shit. We can see 10 times too
make up
far. Sorry, guys.
100%.
Where's that
A
geometric
personal
horizon?
dome,
Where's that
lemon
geometric
vision,
horizon?
or perspective.
Where's that
We can
geometric
do this
horizon?
without all the
guys?
rhetoric.
Do you have a place without atmosphere? We can go look at the geometric horizon.
Yeah, the day Aristophanes measured his stuff, it was without atmosphere.
That was coming straight down again. See, you're conflating two different things.
Not from 500 miles away. That's
How
not
much
the same
refraction?
position.
500 miles. You know, we can calculate.
It's negligible. It's
correct.
negligible.
Very good.
Like the number with 120 zeros back.
Something like
It's
that.
negligible.
Probably not that small, but enough that you can ignore it.
Deja vu.
Deja.
Oh, taboo
Deja
conspiracy.
vu.
How long is this thing?
Deja vu all over again.
Oh man, I gotta watch a taboo conspiracy video.
Well, I mean, Paid, I posted it because you probably ask for evidence for a quote unquote flat earth. You probably ask for it when you're in the VC between 20 to 30 times a day.
No, less than that actually.
So I posted a video for you of 37.
Thank you. I'll look for it. I wonder how long I have to listen to taboo conspiracy though. That's going to be painful.
Okay, I guess you can have complaints about the producer, but
No, I mean, I'll go. I'm going to watch it, but can I watch on two speed? Maybe that'll be better.
Well, I think what would be good is if you watched the entire thing and gave us a full review on it before asking for more evidence. Why don't we start there?
All right.
Why don't you go through all 37 of those? Give us a review. We'll give you a whole hour. We can do a special show where you give us a review of every single 37 of them.
No, I don't need to do that.
And until you do that, I think asking for evidence endlessly is just a fruitless effort.
Well, it is a fruitless effort because until this video, all I got was water and it looks flat. I've been doing that.
Well, you mustn't be listening very much.
Yeah.
You seem to be only focused on your obfuscation tactics.
Water.
Try to listen next time.
Hold on, I gotta watch
It looks flat because it's flat, right?
It looks flat because it's really big and you're really small.
Oh, it's really big.
It is. Yeah, it's really big.
It's pathetic, bro. So saith the king who has no clothes.
You're really big and
who's desperate?
Theirs is really big and you're really, really small.
Yeah, tell me which one of his arguments did I misrepresent? NASA Page Show.
All of them.
Which? All of them.
All of
He
them.
hadn't even mentioned it yet. You're so delusional, bro.
All of them. You basically have not said a correct thing most of the day.
So your mom's not a whore. Ooh, dang. If only I could get it right next time.
My mom's not a whore. That's correct. So you get one thing.
All right, there's probably some fruitful discussion we could have. I mean, Paid, if you're against.
I'm going to listen to Taboo Conspiracy for a while. I'll just listen.
Right, yeah. Well, I mean, it's like you're showing up to the party and just like I've said this before. It's like if we're like hanging out in a park and we're listening to music and we're drinking beers and we're hanging out and having a good time, and somebody walks in and like, hey, what the fuck's wrong with you guys? This music sucks. Your food sucks. You're ugly. Your clothes suck. You're just going, you're ugly, just walking through. It's like, dude, you're just bunking the party. Like there's a lot there's a lot of interesting things we could talk about on multiple levels. If you love a globe and you hate a flat earth, fine, keep it to yourself. Do whatever you want, but we're trying to enjoy interesting conversations. So if you want to just come in here and shit on everybody, basically leave because we're going to have a good time and talk about interesting things. And if you just want to loop in circles about how you hate a flat earth and you think a globe is whatever you think it is, fine, go to another server, go somewhere else where you can do that.
Gio, do you really hate me?
I don't have any hate for you at all. I don't have any hate. I'm critiquing the thing that there's a lot of interesting conversations we can have, and like we're in a like I said, we're in a park having a party, and you're just coming in and just shitting on everybody. It's just
you sent me a 2-hour Taboo Conspiracy video. That's like
because you asked for evidence for a planar stationary Earth on a daily basis. So I gave you a video that has 37 succinct sources of evidence. If that's what you were requesting.
2 hours of Taboo Conspiracy. You really hate me.
Oh, that's only the start, dude. I could give you hundreds of hours. That's only 37 of literally tens of thousands. So we could continue.
No science.
That's just step one.
Oh,
I know. I honestly, like I said, I get deceived by the Globers a lot, very often because I think that they have learned the argument of flat Earth and they just haven't. Like they haven't paid attention to any of the proofs or anything. It's like Crazy.
Proves. Hold
They
on.
still
man.
think that you should be able to see Mount Everest from across the entire Earth if it was flat.
For real. They say
They
that.
still
Yeah,
say
it
that,
is
bro.
true that you should. And there's places you should be able to see it silhouetted from like 3,000 miles away. That's absolute fact.
You should.
That's
be able
that's
to
an
feel,
absolute fact.
You should.
If you can see the sun on the horizon, and Mount Everest is 3,000 miles away, and it's a flat plane, and the sun's on the horizon, and Mount Everest from that distance is above your angular resolution, that means that it's going to create some sort of silhouette in front of the sun. There's nothing that can prevent that.
Big would that silhouette be? How big would that thing be?
Yeah, how big is that?
Size of Mount Everest.
Well,
Yeah,
how
how
big
big
is that
is
with
this?
angular size?
Mm-hmm.
Yeah, the angular resolution of your eye is about 0.02 degrees.
So if you pull up a weather app on your phone, it usually gives the visibility, sometimes 5 miles, sometimes 1 mile. So you're telling me that there's at some days your weather app is going to say visibility 3,000 miles?
No, that's what I'm saying. I didn't say you can see this from that far.
Never.
I'm saying the silhouette. If you can see the light from the sun, then you can see the things that are blocking the light from the sun if they're big enough to be resolved by your eye.
Like
this is 100%. It's 100%. I mean, there's no way for that light from the sun to be reaching your eye if there's something in between it that is blocking that light.
I discern from the other shadows everywhere else, cause from people walking, street lamps, birds flying.
Yeah, those aren't big enough to be resolved from that distance.
In the horizon.
Mount Everest.
The horizon merges.
I mean, there's no way to get around that. That's not like if it's big enough to be resolved.
What would be the angular size exactly?
The angular size, you'd have to find what the distance would be before it decreased to 0.02. And
you
as I
said
remember,
thousands and thousands of miles.
Yeah, it's thousands of miles, but I used just 3,000 miles as because that's someplace you can actually be and see that. But I think it doesn't increase to 0.02 degrees to about 15,000 miles.
And you really truly don't see why some people are just gonna leave your side and come over here. You don't see why.
I wouldn't be bothered if they did, but I don't see why that. I don't understand what you mean.
Okay.
Well,
that was the point.
From my math that I'm getting right now, if I'm correct, I'm getting about like 1/5 of the size of like the moon or the sun or whatever. So like 0.1 degrees of angular size.
0.02 is But what were you saying about that size? What's the point of that size?
Oh no, just saying that would be roughly, yeah, like it would be visible. You'd be able to see that, yeah.
Oh right, yeah, from that distance, sure. But even if the visibility didn't allow you to, that's a fine argument. But if you can see from the horizon the light from the sun, that means that the sun is on the horizon, and if there's something big enough that is also, in between you and the sun, which in that case it would be Mount Everest would be in between you and the sun, and it's big enough to be resolved. That means it would be blocking the light that's coming from the sun, which you're seeing.
Really? Wow.
Okay,
so
so
the
let's
sun,
say
the
you're-
sun is.
Can I get in real quick? Just if you're on a flat plane and there's a human being 1 mile in front of you, and then Everest is 3,000 miles away, you think the human's going to be blocking out Everest?
Yeah. If the
so why would you see Everest?
Greater than Mount Everest from that distance?
So why would you see Everest? Why would you ever see Everest?
Because I described to you, I didn't describe to you the person's in front of a crowd. I said the person can view the sun on the horizon. He's
so you don't
over,
understand
he's looking at it over the ocean or something like that. There's
Yeah,
not.
but
It's
then-
on the horizon.
But then we step into a difficulty because we then need to talk about what the horizon is, right?
Well, before that, what about all the topography between you and Mount Everest and the angular size change and things further away?
That's exactly the point. So all those things, their angular size is going to be either too small to be resolved, or you're going to be if for whatever reason you can't see them. That's what I'm saying. You're viewing the sun on the horizon, so you would not do this someplace where you can see buildings, for instance, on your horizon. You'd see nothing on your horizon, like just the ocean, and then you could see the sun setting on the horizon. If you're in a position to where the sun is setting and Mount Everest would be intersecting your position and where the sun's setting, and you're viewing it over the ocean, like for instance in Japan or something like that, you should be seeing this obstruction because it's large enough from there to be blocking that light from the sun, and the sun's on the horizon.
Wow, yeah. So just so you know, my man, The sun's an apparent location. The horizon is an apparent location where the sky appears to meet the ground. Things change with angular size, and there's something called light attenuation. Light doesn't go on forever. We would in no way see Mount Everest from across the entire world. If it was flat, that is very, 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 very dumb.
Well, the points that you made, I don't want to say dumb, but you criticize that. I mean, they didn't address anything because, as I told you, the angular size was already addressed in what I said. We made sure that the angular size of Mount Everest was still in the angular resolution of the eye. So that checks out. Light may not attenuate forever, but we do know the light from the sun is coming from the sun to our eyes. And so as long as the sun is somewhere beyond where Mount Everest is, which at that given point you can find out that it actually is, and because it'll be shining in that place, and you can see the light from the sun, that means that it doesn't matter how far light can reach, it's reaching from where it is to you. And if it's
Maybe
reaching
I'll
from where it
repeat
is
it
to
'cause you
you
don't
and it's on the horizon,
Yeah, you don't
that means
seem to
that
be able to
anything else
understand.
that's on the horizon that's big enough to be seen should be obstructing some light.
Yeah, you said that it didn't address it, but you just kept skating past it. The sun's an apparent location. Try and focus.
What does that have to do with anything?
It's
What
not
does
an
what does the
actual
fact that the sun's
position.
an apparent location have to do with
It's not
anything?
an actual physical position where you see the sun. It's not like this actual object being precluded by a physical object, and you would not be able to see it from that far away simply because topography between you and the object itself. You're saying that the sun would be physically obstructed. The sun's an apparent location. The horizon's an apparent location. The angular size of Mount Everest would be, clearly not visible at thousands of miles.
At that point of the day, when you're in Japan, you're seeing the sunset, and the sun is probably somewhere, let's say over the western part of Africa, for instance. Let's just assume that's where it is. And Mount Everest is intersecting where the sun's path would be from where it is to you. It doesn't matter if the sun's an apparent location for whatever reason. The sunlight is coming from over there. I mean, that's just where the sunlight is coming from, because that's where the people over there are seeing it from. That's where you're seeing it come from. And in between you and there is Mount Everest.
Yeah, but here's the deal. So when you have like layered density, like density layers, and you're going through thousands of miles, you eventually can't see any further, Kosho.
Yeah, but if you can see the sun, then that's not a problem in those layers. If you can see,
Well,
light
it is
from the sun,
okay.
then you
Listen
can see things
carefully,
that far.
Kosho. The sun is much higher in the air than Mount Everest is, isn't it, Kosho?
Yeah, but not at that moment. It's on the surface. You can see it across the surface.
On the surface.
There are
The
things
sun's
along
on the
the
surface.
Visually wit. All right.
Oh, visually doesn't change anything.
Yeah,
does
it's not actually on the surface. I'm saying from where you're standing, it seems low enough to where anything on the surface would be in between you and the sun. And
But it's not.
mostly everything else is not going to be visible because it's too small to be seen. But Mount Everest is
It's like the reason that it's on the surface is the reason you don't see Everest, but you don't understand it.
No. The reason it appears to be on the surface by what you guys are saying is because it's so far away. It's so far away that it appears to be have lowered in the sky, and that's fine
Yeah.
if that's what you think. But that just means that if there's anything between you and the sun, they should be in front of the sun from where that is. And for most things, it's not a problem because they're too small. But for Mount Everest, it's not too small. It's actually fairly large, and
So the sun gets lower, but the mountain gets higher. Like, what do you?
No,
think?
the mountain would get lower too because of the angular size would be changing by what you guys are saying. The angular size of the Mount Everest gets smaller and smaller and smaller, and so it's going to appear to be lower and lower and lower. However, I'm describing a distance where the size is not too low to be resolved.
Okay, so how far exactly away?
Well, like I said, it's a while since I did this with Japan, but I think it's about 3,000 miles from Japan, 3,500 miles, something like that. And the angular size.
So when you guys say across the whole Earth, you actually mean less than 3,000 miles specifically?
No, wait, I'm sorry. Ask that again.
Wow. So the point I made was a lot of Globers still say that if the Earth was flat, you'd be able to see Mount Everest across the entire Earth. So what you're saying is you should be able to see it up to 3,000 miles away?
No, I use that example because I had to use a place where you would be looking over the ocean so that you could see the sun setting. So there's a reason I used a specific place in Japan when I did this before. But from what I remember, the angular size doesn't decrease to 0.02 to about 15,000 miles. But I might.
Okay, so just clarify. You think we should be able to see Mount Everest from 15,000 miles away if the Earth was flat?
Again, I didn't say that. I just told you why I use Japan, which is the reason why I'm there's a reason.
Sounds like you're saying we should see anything that's 15,000
I'm
miles.
So I'm not saying you should see it from 15,000 miles away. I'm saying that the angular size doesn't decrease to to be unresolvable until that distance.
Well,
But
see, it's a combination.
there may be other reasons why you can't see from that distance, like other obstructions or the atmosphere, for instance.
Okay, yeah. It's a combo of the Atmos and angular size, and so it's just perspective and Atmos. But what you seem to not understand was the question was, why do globe earthers, like anti-flat earthers, still say stuff like, if the Earth was flat, then why can't I see Mount Everest across the entire Earth? You guys literally say that, and then you jumped in and defended it. So I guess now what you're saying is you don't defend someone saying that, right?
No, what I'm telling to you is exactly what I said to you. I said from the position that I'm talking about from Japan, I said about 3,500 miles. Okay, I'm not describing any other location because it takes more. There's more things to think about. Like I said, if you're not looking over the coast, then there's a very possible you can't see it because there might be things obstructing it.
I see if you can pay attention to what I'm saying. So if you look through the densest layer of the Atmos and you look through 3,500 miles of it towards Mount Everest, and Mount Everest is changing in angular size with that increase, that bottom portion of the ground, the visible ground in Mount Everest, is going to be precluded by the most dense part of the Atmos and shrinking in angular size. The sun looks as if it's optically decreasing just because it's going away further and further and further. And then it merges into this merged area called the horizon, which is, in this scenario, where we're going to have all the compression of Mount Everest and all the most dense layers of the Atmos. So we have like this area that's just basically not visible. We're just blocked of visibility. And then the sun being higher than that, we see the optical declination because it's decreasing in like optically as it goes away. But it's not in the most dense part of the Atmos. It's just going to keep going. Then it optically looks like it's going down towards the ground, and it's going to go down towards this area called the horizon, which is where there's optical compression and a vanishing point. So you would not expect to in any way see Mount Everest from that far away. Do you understand
the
why?
light?
So wait,
And the light is limited. That is
right.
as well.
So everything that you just said, right? It's not real. So when you say that, things like the light, for some reasons, they get smaller and smaller, and they all merge together. Even though that's not how they merge together. They merge together at the by the angular size. If the angular size, if it's big enough to be resolved, the angular size is where you, from your position where you see it. If it's great enough to be resolved, you can resolve it. It doesn't matter. And I mean, as you change your angle, as you change your angle in reference to it, and things like that, that's going to change the angular size. But as long as you can determine the angular size and you know the angular resolution of whatever you're using, like your eyes, this is going to determine when it becomes merged with other things.
All right. Now, let's see if you can pay attention.
The way it works. And the other thing is, if light can reach you from the sun, then light can reach you from anywhere. So if sunlight is like sunlight is not a special light. Any kind of light, whether it's being reflected off something, whether it's being emitted from something, if it can reach you from across that amount of atmosphere, any object light, if there's enough of it, can do the same thing.
I like that you said it's not different than any other light, though. I can agree with you on that a little bit.
Yeah, but he just doesn't understand still. So, I mean, am I not being clear? Okay, so then you rebutted my point by only talking about angular size, and then strawman me to say that light has some type of angular size. That is what my explanation was. But no, I said that the most dense part of the Atmos, right, creates a convergence point, a vanishing point where it's like fuzzy and blurry. I actually make observations, Kusha. Maybe you should try it. There's an entire area in the sky that becomes blurry, right? It's not just where the horizon is. It's above the horizon and below the horizon. It gets blurry and starts to merge together, kind of fuzzy, right? And we have an optical vanishing point. There isn't some wall that pops up there. And that area changes every single day. You can see further or closer depending on the Atmos conditions. That area precludes your visibility of anything like Mount Everest from that far away. You just combine that factor with angular size. But Globers have to separate them and strawman them and then not acknowledge the actual point, or they don't understand what I'm saying. Do you understand what I'm saying? Is that what it is?
So if you're viewing the sun on the horizon, this observation, and you're viewing the sun, and it doesn't look like you fucking need to wear glasses because it looks like it's extremely blurry and you can't tell where the outline of the sun is, then I think you can conclude that it's not doing some weird thing where you just can't resolve, crisp images or things like this anymore. You can resolve something that's big enough to be resolved. It may do this to smaller things, but if you can see the sun and you can see that it's not a blurred out, there's not a blurred light in the distance, it's actual crisp image, then this is not going to be an issue for something that's large enough, like I said, to be blocking light from the sun.
Okay, so you still don't get it. So in your paradigm, the sun goes down behind a curved obstruction. But on the flat Earth, it just looks like it's going down in the sky because it's moving away from you. We have an area of atmos that's very dense on the surface, and we have topography on the surface. So sometimes we can't see things that are much bigger further away. Even though they're much higher up, we can't see them because the things that are smaller are much closer. So they block them. Okay. But in addition to that, we have an entire area in the distance far before 3,500 miles where things are no longer resolvable on the ground. Right? Is this correct?
I don't know how that's relevant in this when we're talking about something that is something that should be resolvable from that distance. And so that's one. And two, the light from the sun is coming to you crisp enough for it to not seem blurred. So it shouldn't create a problem with something blocking it either. So I don't understand how you're using that as an argument.
Are you keeping the Coach? Are you saying the Earth is flat, but everything else, the sun and everything else, works out how you determine it works?
No, I'm using the Earth as being flat, a flat plane. The sun is overhead and it's far away enough to be low enough on the horizon to where it appears to be, like I said, on the horizon, and it's still above where it actually is above at that same time. So somewhere in Africa or something. So these things are true, but the Earth is a flat plane. And Mount Everest is the same size it is, this kind of thing. And everything works.
You can't see Mount Everest, though, because of the layers of the most dense layer of the atmos.
Okay, what's it? Your light from the sun. The sun's where it is. The sun's coming from where it is to where your eye is. Mount Everest is in the way. Okay, all this stuff is the truth. So how is what you're saying going to solve that problem? If Mount
All right, listen carefully. Maybe you can listen carefully.
From.
All right, yeah, maybe you can listen carefully. So the sun is higher up, right, than Mount Everest. Now, where Mount Everest is, it's on the ground. Now, if we look out over a vast distance of a plane on the ground, eventually we can't see stuff on the ground anymore. It's not just because of angular size. That's just one of the factors. There's tons of very dense gas in between us and there. And eventually what happens to the stuff in the distance is it becomes unresolvable, not because of angular size, but because of the atmos. And there becomes an area of convergence where it all blurs together. And we call this central line the horizon. The sun's further up above than that. It starts going down towards this blurry area in the sky. And eventually it starts to disappear in that blurry area of the sky, which, mind you, constantly changes. Now, within the blurry area, it comes down to the top of the blurry area and starts to disappear. But the blurry area is covering all the stuff on the ground. So the sun starts to disappear because it's reaching that vanishing point, the top part of the blurry area, where the Mount Everest is within the blurry area from the top line that the sun's disappearing around. Below that, did that make sense? I don't know how else to say it to you, Coach.
Yeah, but what you're saying does not make sense. If the reason why you guys claim that the sun is disappearing is because it's close and local and going far away enough to appear to be lowering. So if this is happening, that means that the angle of the light coming from the sun is becoming shallow enough from its position to you to make it appear as if it's on the horizon. So this is something that makes sense. But if you're using a different paradigm now, then the sun becoming lower doesn't make sense all of a sudden. So unless the angle is becoming shallower, the sun becoming lower doesn't make sense. And if the angle is becoming shallower, that means that the path that the light is taking from where it is to where you are is intersected by some object, a very large object, which is about a tenth of a degree in angular size. And even if you can't resolve it, it's still blocking a portion of light from that sun.
But the sun
a large portion of it.
disappears before it gets to that, Kosho. The sun disappears when it reaches the vanishing point, which is an area that constantly fluctuates based on Atmos. It disappears before it would ever get blocked by Mount Everest.
No, it doesn't. You can actually you can see what time the sun sets in Japan, and you can see where the sun subsolar point is at that moment and what's directly beneath it, and you can determine the path that it would have to take in order to reach Japan at that time. So it's much further than Mount Everest at that point. Like I said, it's like the west coast of Africa.
Well, you're not even, the sun is going to start to disappear in the sky above Mount Everest.
But it doesn't.
Oh, it doesn't. So can you give me some visual evidence or something of this?
Yes, you can see where the sun is when it sets in Japan, as I said, where it is. If it's past Mount Everest, if it's already gone where Mount Everest is and beyond it, and it still hasn't set yet, then you're good to go.
Okay, so you're still not understanding it. So I'm going to say it one more time. So if it goes past Mount Everest, and Mount Everest is between us and the sun, but eventually we get so far away from Mount Everest that we can no longer make it out because of the Atmos and combined with its angular size. So the angular size is just a variable that makes it more and more and more difficult to see as it continuously decreases. And we have the Atmos increasing more and more and more as the angular size continuously decreases. We have a blurry area where we can no longer make things out because the Atmos is blocking it. It's called light attenuation. The sun itself is much higher than that. It optically declines. The optical declination eventually reaches a vanishing point. That vanishing point is not the same every single day, all day. It is not. I make observations all the time. It's objective. It's not the same. It changes. The sun then begins to disappear relative to where it is that day. That place that it begins to disappear is not going to be the same place that Mount Everest is at. It doesn't actually physically go down beneath Mount Everest. It's just optical. And actually, in addition, honestly, you think the Earth, I know they love to just strawman flat Earth. Wait. With the little physical,
I never said it happens every day.
Sun, the little physical sun over top of the Earth, and some flat earthers say that. That's not what it is. The sun is an apparent location, and it looks like it's magnetic holography, and the actual data shows that it's basically a toroidal movement over top of the Earth, and it's relative to the observer on the ground. But so, I know you don't want to talk about that because you didn't trigger you. But
you strawman my whole thing because I specifically said on there's a specific place on specific days where this would happen. I didn't say every day.
But I described that it doesn't happen. It's random based on Atmos conditions. It isn't a mathematical formula you can come up with and it's identical every single time. You want to pretend it is.
I didn't say that either, dude.
So then how do you know what day it is?
Dude, I didn't say that. That's what I'm saying. Like, you guys are not listening. What I'm saying to you is there would be a specific day. So if people who observe the sunset every day would eventually see this happen, is what I'm saying to you. Not saying that you can. Oh yeah. I'm going to mathematically tell you which day it's going to be. I'm just telling you that the sun setting from Japan. Well, there's going to be a day during the year where that sun setting is going to intersect with where Mount Everest could be seen from that position.
Why do you say that? Why do you say that? Because I just described that
it travels like that. That's how the sun. That's how the sun is going to move. You can look at what do you call it?
So we do know exactly where the sun physically is.
Similar to the Mount Canigou.
Yes, exactly. That's exactly. I was about to say that as an example. It's exactly what I'm talking about. Mount Canigou.
We know what you're talking about. We know what you're talking about, but all I had to do was talk you through it, and you've just now. I
said that at the beginning. I said that's the first thing I said.
Okay, Kosho, so you have no foundation for your claim at all. You're just saying, eventually, one day, someone will be able to see it because eventually the sun would be visible. So here's my question. This will expose the whole thing. This will expose the whole thing, Kosho. Just answer my question,
before you have to strawman me.
Kosho, I'm not trying to strawman you. That's why I'm asking you a question. I'm trying to ask you.
You literally just said what you think my argument is, and then you kind of counter.
Calm down, man. Calm down. So you said that I didn't say it would happen all the time. It would just be one particular day. And I said, dude, it changes day to day. There's no way to predict it. It's based on Atmos. It's not like some formula that you can predict. You said I didn't say it is. So okay. So here's my question. You're saying you wouldn't be able to see it every day. My question is, why can't we see it? If the Earth was flat, why couldn't we see it on the days that we cannot see it?
Okay. So regardless of what you're asking. I'm going to make clear what I'm saying. So the other guy who was actually listening, I think it was Trunks or whoever. I think he's or Tanks. He said Mount Canigou is a perfect example where it's not something that would happen every day, but from that position of observation, there was a specific day where Mount Canigou can be silhouetted, it can be silhouetted by the sun because the path of the sun is going to be directly behind it on that specific day. And this happens because Mount Countigue is large enough in angular size that it's going to be blocking a portion of the light from the sun. It's perfectly reasonable to understand. And this is my only point. The reason you can't see it on any other day is because the light is not going to, the path of the sun is not going to be intersected by the mountain on that day. But there is a specific day where it would be, at least once a year. So,
right. What's the specific day for Japan?
Like I told you, I'm not trying to sit here and calculate what day it is. If I could if it was any way necessary, but it's not. The point is just to understand that from that position, as the sun moves across the sunset moves across the earth, as you can see in timedate.com, there would be a day where it intersects Mount Everest.
So you remember when I told you that it's not like a mathematical formula that you can just predict at what like declination in the sky that the sun's going to disappear because it changes day to day based on Atmos. And you said, I'm not saying it is. And now you looped full around to, yeah, we know exactly when it is. It's very specific. No, my point to you is in reality, the declination of the sun, like the disappearance, the declination of the sun where it disappears changes all the time. It isn't a predictable thing.
What you keep claiming I'm saying. I'm not saying
that. Okay, someone else talk to him. I can't do it anymore.
Well, stop strawmanning me, dude. Like if you think I'm saying something and I'm saying that's not.
It's all recorded. It's all recorded.
No, it's not all what I said. I didn't say you can perfectly predict it. I'm saying there would always be a place. So Japan is a very long country, and it doesn't matter if the time that sunset's supposed to be changes or varies by a couple minutes or whatever. There's going to be a place in Japan where from there at some certain time during the year they can see the sun setting where it would be intersected by Mount Everest. There would at least be one place where that happens.
What I try to tell you is that on clearer days, the sun declines further in the sky than on less clear days. Like the sun appears to disappear at different places in the sky based on the Atmos conditions. I have tons of documentation of this. This is what happens in reality. The sun does not disappear at the same place in the sky every day. I'm talking about the same declination. The same declination. It doesn't do that.
I'm saying either of those things. I'm not saying that.
Okay, well, do you understand the implications of it? Do you understand the implications that the sun can disappear higher up in the sky just based on Atmos?
Yeah,
and
that's fine.
It's going to disappear above this layer of Atmos that would be precluding Mount Everest.
Okay, well then that would be not one of the days that you would see this. I'm saying there would at least be some days in some places in Japan where this should be visible. On the days where it's obvious the atmosphere is not allowing for it, or where they're not in the position for this to happen, obviously that's not the day.
So you don't know the day.
I don't know why you're using days where it wouldn't happen.
So you don't actually know a day. You're just saying you think it should happen.
No, I'm saying it should definitely happen. It's
when
the size of Mount Everest in reference to Japan, from that distance or from the distance of Japan, it's 1/5 the size the sun should appear to be. So if it's in the way of the sun, it should be taking up 1/5 of the light. Whether or not you can see the outline of Mount Everest or not, it should decrease the magnitude of the sun by at least a portion of it by a great deal because it's.
Have you ever seen one
size?
You ever seen one cloud block out the sun? Just one cloud.
Yeah.
How many clouds do you think are within 3,000 miles?
Well, I don't know why you're bringing up clouds. Obviously, you wouldn't do it on a day where there's clouds.
Just a thought experiment. See, it's not on a day that it's this, a day that's this, but it has to be a certain time of the year. But I don't know when it is. That's the summary.
Okay, the point is, it's not going to be on a day when it's snowing and you can't see anything. The point is that it should. This observation is an observation that should have already. People should claim that this happens. This is a thing that it's not going to happen every day from every place, but this should be possible from Japan on some day.
Sounds like a clear day, right? With less refraction.
Well, it's going to be. Obviously, it's going to want to be on a clear day. I don't know why you're suggesting like these weird outliers where you shouldn't be seeing. Of course, on those days it should not be seen.
If the light's refracting, it might just be like refracting so bad you couldn't see it. So you wouldn't want to do it on a snowy day or a refractive day. You'd want to do it on a clear day so you can see further, right?
It would want to be a very clear day, a crisp day, a day where the sun sets and it seems perfectly crisp. You're like, oh wow, what a beautiful sunset from Japan. The sun seems crisp. There's no clouds in the sky. Whatever other weird phenomena is happening. And also on this specific day, the sun is setting from a direction exactly where Mount Everest is from my position. Like this is not this is something that should have occurred at some point. Like I said, at least once a year from some places in Japan. So it's not far fetched to say that. And if it's a fifth the size of the sun, regardless if you can see a perfect outline of it, it should take up it should take away from the the magnitude of the light from the sun.
Well,
And
so how come? What if we have a day where the sun has less magnitude and you just don't ever actually attribute it to some type of topographical obstruction?
When does it
So
happen?
you're just making stuff up. When does it happen? So
What
you're saying the sun that has the same magnitude every day?
Okay, what are you describing? You're saying the sun's magnitude changes through day by day?
No, you just said that the magnitude would change. I'm asking you, does the magnitude not ever change? Or are you saying
A
the magnitude?
portion of the sun would be visibly darker, and I'm
Okay.
not by a fifth of the magnitude of the sun, or
With
the region
no
of the sun
atmos
should be
obstruction of the
shadowed.
yeah,
And
with no
this
atmos
doesn't
obstruction
happen
of the.
naturally in any other
But
case.
what about the atmos obstruction of the shadow itself?
If you can see the sun from that same portion of the sky, like the horizon, then that part of the atmos is not going to somehow allow that light from the sun to go around the mountain and you see it. It's going to still be
Right.
blocking the light from the sun.
Yeah. So again, the lower area just has like a convergence point, especially over those distances. So you just have like this fuzzy area where the sun eventually like disappears into, right? And so that's just all there is to it. And even if there was some type of obstruction or outline, which is retarded to even say that, there's no guarantee that through 3,500 miles of atmos you'd be able to make out any single bit of it. And for you to basically say that there should be a slight decrease in magnitude, but we're not going to account for the preclusion of the actual atmos in between us and there, and the fact that our Mount Everest is on the ground itself, where it's all dense. Should just all be the same. The sun and the Mount Everest depictions should be the same, have the same type of effective obstruction, and we should be able to see it sometime at some point, even though I don't know exactly when. Somebody would have seen it by now because I did my mathematical straw man of a physical object over a flat surface. And that is objectively not a straw man. That is everything that you've said.
Right. So in this image here, here's the sun, right? And I think you can imagine what 1/5 of the size of that would be, right? So in this image here, if Mount Everest were intersecting from this position, this is from Japan. If you're viewing the sun and something a fifth the size of it was blocking the light from it, even if there was atmosphere for some reason is making you not be able to see the object, it's not going to allow the light to somehow magically go around the object and not change the magnitude of the sun from that portion of it. That portion of it
this is what you don't.
Significantly darker, if not you can see the outline itself.
This is what you don't get. I'm glad you posted a picture, right? So you see that horizon? That horizon's actually not physical, right? It's just an apparent location. And if I take this same observation of this sunset like 2 weeks in a row, like how low in the sky the sun is before it starts disappearing will change every day. Because that horizon that's just apparent will go up and down, up and down, up and down every day. It's not the same place every day. Okay, so if there's 3,500 miles between us and the sun, we're going to have a horizon somewhere, right? Far before 3,500 miles. And that horizon is going to go up and down. You're not going to see stuff way behind it. Do you understand that? The sun's going to disappear before you see any type of obstruction because it's all going to be disappeared by the horizon, which is what I keep telling you with the vanishing point over and over. There's no way you didn't understand at that time.
Yeah, give me 1 second, and I'm going to post something. Give me 1 second.
Okay.
Hey, while you're taking a break, I wanted to ask you to look at what I posted at 20 minutes after the hour. It's 8:20. It's now 9 p.m. where I am. So I posted one of the paths of totality, but it's a diagram from 2021 to 2040 of all the paths of totality. And what I'm showing here is the path of totality for like the next 20 years, 19 years. And I'm looking at it, and it doesn't look like how a shadow would work consistently on a globe. For example, at what point is Antarctica like being covered up by the moon in their model? And when you look at like ones that go over like the the equator, and then they go much higher right towards the pole. Like, should the shape of the moon on a spherical surface shouldn't it like what deranged and oblong and oval shaped? But we see that for the most part it's pretty consistent. Isn't that a pretty good proof that it's not a sphere? Because if you take a golf ball and you put a shadow on the globe at different angles, the closer it is to the equator, it's going to be like a perfect sphere. But the further it gets like towards the polar region, even if it's on a tilt, it's still going to be like oval shaped, right?
Yeah, maybe slightly. I would have to see the numbers though, because I already know they're just going to say that it's probably a small amount that's negligible. They have like a huge window to play with, dude. It's unfalsifiable. It's all unfalsifiable. Coach, are you going to respond to what I said, or are you just going to talk past it?
This picture I just posted with the sun in it and the black object at the bottom of it represents the angular size of of Mount Everest from that distance, and how it would appear to be if the sun were on the other side of it. And regardless of if you think that the atmosphere would be so thick that it's you wouldn't be able to see the outline of Mount Everest normally, if light is coming from the sun and on its way to you, Mount Everest is in the way, then it's going to be blocking some of that light. And it's going to, if you can't see a crisp outline of Mount Everest, which you probably would, you would at least see the light to be extremely or much dimmer at that portion of it, because it's not able to reach you. So I don't understand why. I don't understand how there's some mechanism that's allowing the light to travel to you from where the sun is, but it not be obstructed by this object.
Right. So when I asked you if you were going to talk past my point, I guess that was a yes, right? So if you look at the little picture you just made with the pyramid there, my point is that with 3,500 miles there, you see that line, that's the horizon. That's not a real place, and it isn't always there. It goes up and it goes down. Okay. So with 3,500 miles between you and Mount Everest, you're going to see a horizon far long before you get to Mount Everest that will stop you from seeing any further, because it is a vanishing point, and that will go up and down in the sky. And if it goes up in the sky, no matter how high up in the sky it goes, that's where you'll stop seeing the sun. That's where you can't see the sun anymore. So if that vanishing point is higher than your little Mount Everest from 3,500 miles away, you would not ever see Mount Everest. You're going to see the sun going down to the horizon, which is an apparent vanishing point of convergence. That would be before you see Mount Everest.
So if you were to think
right, like it's past the point of extinction. There's optical extinction. There's a limit to how far you can see on the ground and in the sky, which is essentially what makes sunsets and so on. But yeah, like the way you just described it is exactly correct. Mount Everest would be, it's way too far. I mean, that long distance can go at 275 miles. And so now you're just expecting that same thing would happen at 3,500 miles?
No. Yeah. So, okay. So I just want people who can think, just listen. If the sun is further than that distance and the light from the sun can go from where it is to where you are, that means that light can go from where that distance is to where you are. It doesn't matter. It doesn't matter if you can see things or whatever. If what Witsit said is correct, that there's some distance where you just can't see anything because there's a vanishing point or a vanishing line, and they're merging. Well, what put here is a crisp line. If you take the size of that triangle, which is representative of the size of Mount Everest, it doesn't look like there's that size of a blur from above and below that horizon line. As a matter of fact, nothing below that horizon line doesn't look like it's water, and nothing above that horizon line doesn't look like it's sky. It looks like there's a crisp line there, not a blur.
Yeah, but that crisp line moves up and down every single day, and in fact throughout the day, because I make observations all the time. That's just what it does. So this, where you take this apparent location, you pretend it's like some solid, definitive place that the horizon's always at, and then you put a triangle on top of it. That's not reality, right? Because the horizon is going to optically rise and block your view at a vanishing point far before Mount Everest. So higher up in your sky, perceivably, than Mount Everest would be. Mount Everest would be down below it. And not because the Earth's a ball, but because of optics, because you have a vanishing point of the sky and the ground. That's going to happen long before 3,500 miles. The sun cannot be seen beyond that vanishing point. The sun will not be seen. When you say it's this far away and the light can be seen from this far away, you're skating past the actual argument, which is why Globers are still Globers to this day, because they don't understand. You wouldn't see the sun anymore, Kosho. You wouldn't see the sun anymore. Listen carefully. You wouldn't see the sun anymore once it gets to the vanishing point.
Right, but that's perfectly fine. That makes sense to you as you say it for some reason, but you're not thinking about what you're saying. Because if there's a vanishing line, and at some point in the distance, some point where things above
Kosho, you said there. You just said if a vanishing line.
Hold on, dude.
There is a vanishing line.
Hold on, dude.
There is an optical compression.
Just hold on.
Yeah, don't just interrupt him. Just let him finish.
If there's a place where this happens at that point in the distance, then things in the water and things above the water, these things would appear to be blurred together in the image, meaning that the bottom of that line would not look like it's purely water, and above that line wouldn't look like it's purely sky. It would look like it could blur something the size of that mountain, for instance. There'd be a region of that image where it's blurry enough to be bigger than that size, and there's nowhere in this image where there's an obscure enough region to hide something that big.
Yeah, Kosho, in reality, if you zoom in, you will see tons and tons of area that is blurry around this line, which is why I think it's sad that Globers will come on here and debate it so long they just won't go make their own observations. But if you take this picture where it's pretty zoomed out, you get a nice clear shot, decent resolution from zoomed out. If you start to zoom in, you're going to get really, really blurry areas all around that line. And that line changes. It goes up and it goes down. Okay. The sun can't be seen past that line. Wherever it is for that day, you can't see anything past it because that's the vanishing point. And that vanishing point changes based on the atmospheric conditions. You can't see something beyond it. The sun will start to disappear at that point. That point happens far before 3,500 miles.
Okay, so in your mind, the mountain in this image would not be in front of the sun. It would be somewhere below that line because it would be too far away to be seen. And that line represents where everything below it that it's obstructing is being obscured by this region.
More important.
That's right.
If it's not below that line, then it would be obscured in front of the sun.
That's right. It would be below that line because that line would rise up optically in your view long before 3,500 miles. And then the sun would look like it's disappearing once it gets to that vanishing point relative to your position. That's correct.
Right. And so what you're saying then is if you take that mountain and you bring it down lower than that line, then there's a region that thick that is not water like it looks like, but actually just really, really blurred out, all the rest of the earth, like, different, the cities, part of China, everything else that you can't see because it's too small is all blurred within a region at least the size of that mountain, because that mountain is also one of those objects.
It's so blurred you can't see it, buddy, right? Because there's a visual acuity. There's an angular limitation to that information of blur. That's why you have calculations for it to represent the effect. But if you're trying to say that you can see the effect when it's actually past the unresolvability, then you don't understand the whole principle of the angular resolution limit.
Yeah, that's what I'm claiming. I'm using the angular resolution limit.
Oh, again, infinity is a point. Infinity is a point that exists.
I'm trying to talk over you. Okay.
Well, you shouldn't, because at the end of the day, you're being disingenuous because the infinity point, the point of, let's say, any perspective point where you can actually draw it out and represent a vanishing point. There's an artist representation of where they draw that line. Let's say the first, second, third perspective point. The point is you can draw objects behind that point and objects in that foreground to that point, right? But the point is that information is still there, but it's past our visual acuity, and we have a calculation that represents this. And ironically, I can search through all of optical information, and I'm looking for a refraction calculation, right? And the only refraction calculation that I can find is located in the sextant manuals, and it's not based on the shape of the Earth. based on refraction of optics and your height above the surface of the Earth. And the reason why I know it is a hijacking of that particular effect is because you can change optics and therefore you change the effect or the calculation. And that can be demonstrated. For instance, the square root of the observer's height multiplied by 0.96 is a common sextant refraction calculation. Well, ironically, that's very close to your globe model of 1.22, right? Well, we can debunk the 1.22 times the square root of the observer's height by changing optics, showing you that it's a refraction effect, and we're quantifying that angular limitation due to the refraction of light and the effects of diffraction and refraction combining into that one simple calculation. Now you can break it down even further, but at the end of the day, there's a calculation to represent that very convergence, whether it's a perspective point, the Rayleigh criterion, the Aries-Disk calculation, whatever it is, you can't deny that it exists. So that horizon line that we see is a byproduct of that visual acuity that I'm talking about, combined with refraction and the diffraction of light.
Yeah, it's crazy because my whole point was just like it's really crazy that people that have been in this conversation for so long still say some of the like mainstream 10 ways we know the Earth's not flat argument, and they're just very easily disproven. And I'm just trying to understand the phenomena. I guess I just find it.
They don't understand. They don't understand that the teachers are teaching. Okay, so here's something that you should try when your next activism. Inquire how far the average person thinks how far the horizon is, and then tell them what teachers tell them. Because the teachers say around 16,000 feet, you should be able to notice any boat passing that point, dipping down, and so for the mast of the boat starts to disappear, right? This happens to be around that 3-4 mile mark. But in reality, when you ask people how far away the horizon is, they think it's 30-40 miles. The average person. This world that has been created with the flat Earth, think about it. There's no purpose for the flat Earth calculator. There's no purpose for it, period. So it was solely designed for this debate.
Yeah.
Mick West had a bare bones calculator. 3 years later, he had all of these angular and refraction informations added to it. It's literally the curvature calculator has no practicality in reality, zero. There's no use for it in any application that I could find. Because it doesn't represent physical reality, it represents optics. But that's why they're using that model, is they have to keep that model go. They have to keep that model going to prove that it isn't optics. It's all to do with the terra forma. But in reality, the terra forma is a plane, and therefore you can bend the plane light, if you will. You have to have something straight before you can bend it.
Yeah, something else. So another one they say, it's really funny. Like Xanax says, this is the number one proof that the Earth's a ball. If you ask him what his number one proof is, horizon drop with altitude proves the Earth's a globe. Only a sphere could do that. Horizon drop with altitude. Do any of the Globers in here that have been doing this for years agree with that still? Yeah.
Do you see where it could be hijacked, though, that claim? Because that claim could be valid if you were flying a plane over land that was sloping towards the ocean. Because if you look at any topography data, any bodies of water, the land is always sloping at a rate, at a certain degree rate. No, Joe, check it out. So it could be a hijacking of the rise over run, which gives you that slope degree. But all bodies of land are all sloping down towards the bodies of water. So if you're having an observation long telephoto zoom lens and that land is sloping downward, it will appear lower than your telephoto zoom lens due to the nature of your high elevation above it. Not because the ground is curving, but because it's sloping towards the water. And funny enough, there's this interesting thing how our creator even makes land sloping at a certain rate to makes it safe for us. Like it's crazy, dude. Like how we can farm with it, the rate of river flow, the way it all floats down, even I don't know if there's a correlation to the 8 inches, this overall slope, but I'm sure there's a grade you could average out, but it must be very similar because we all live by those areas what do you call them? It's like where you can see the massive flood of water came from the top of the mountains and came in and pushed the whole flat basin land. It's just before the mountains, you know what I mean? Like if you're coming into the prairies and you're going into the mountains, there's all this beautiful flat land where all the water pushed against and flattened it out. And you can see how it ran down from the mountaintops and did it. You know what I mean? Anyway.
Yeah, well, just like on a flat surface, like the horizon would you're going up above the ground, so it's below you. It rises towards eye level, but it doesn't rise to eye level. It just rises towards eye level, so it would be slightly below eye level as you increase altitude on a flat surface. And so, I mean, flat earthers have kind of been saying that wrong a bit.
That's only if the land is doing that. If you have clear day, and you're over a land that isn't, let's say, sloping, like it's a pretty good flat basin area, which there are areas that are like that. You'll get that. You won't get that significant drop as if doing the same observation over land that's sloping away from you. Because when you're zooming in, you're at peak elevation. It will appear like the land is dipping down below you, right? But that's because land fucking slopes toward the water. So any observation that you're making towards a body of water will appear as if it's, if you are obviously, like Bev did a perfect example of how the effect could be, right? If you film towards a beach and you're, let's say the slope is not drastic, you're not, 30 feet, 40 feet from the beach and it's 20 feet elevation, right? Like, let's say it's a good gradual slope. It's a cool effect anyway to see. And it could be an easy way to, hey, look, the earth is curving, right? Look, the land is sloping underneath the telephoto zoom lens,
Yeah, I mean, slope can have a factor, but also how far you can see is going to change where that horizon is going to be constellated. So, I mean, if you're in an airplane and you can see really, really far because it's really dry, the horizon may appear to be lower than it would be if there's like a lot of clouds and you can't see as far.
I've never noticed that, man. At 2,500 feet, dude, the horizon meets my eye level, dude. So I don't notice any of these effects you're talking about. When I'm
it's
flying,
below horizontal. It's always below horizontal.
Well, because we know we're above surface of the earth, but refraction effects due to the angular optics of our eye, we're going to have this apparent junction no matter what, right? And it's an effect due to angle of light to the eye. And obviously the surface that's reflecting or just giving us the light, right? Because we're not directly looking at any source, we're just receiving what's bouncing off the surface of the earth, if you will, or objects on earth.
It definitely appears like generally at eye level, like I know what you mean, but I'm saying if you measure it, it is a bit lower. Like if you measure it.
And like I'm just saying, and when Globers say that that's impossible on a flat earth, they're just objectively wrong, obviously.
Well, the thing is their observation already is flawed because you're at a higher altitude, so you can't negate the feet and inches value lower to the ground, and this is why I push them to conform to a certain dimension, because they claim that they need optics, that the height to determine their dimensions, right, and their calculations. And that's the thing, is why they're determining their height. Because if they use their just calculation, mathematical calculation, then obviously the observation would be incorrect, right? Because what their model is constrained to is a rate of drop at a certain inches per value, and we know that that's not true. So they have to add in the observer's height to hijack that information as well, right? And that's demonstrated by scaling down and asking them to do a model and conforming to a size.
I'm just thinking of like the really easily debunked talking points of how the Earth's a globe, but how like the OG veteran anti-flat earthers still say them.
Here's the thing I got to ask you, because the Book of Job, and I wanted to ask this for a bit towards you. The Book of Job, right? Job is being asked, were you there when I laid the foundations? Were you there at the gates of the deep, right? So basically, Job's like, no, I wasn't there. I know nothing of this earth. And then he gives it a description. Because it's a clay pressed seal. That's his description of it. Do you think that do you think God wants us to argue over the shape of the earth? Like, do you think it's like,
no.
How do I verse this? Sort of a couple questions rolled into one, as I usually do that. But this whole model of the Earth was created by Christians, by the clergymen inspiring Christian scientists. That some of these scientists, by the way, they left their faith, and then closer to their death, they came back to it. Don't ask me the names right now because I don't have them handy, but there's quite a few of them. There's, if out of the world we live in, 3 or 4 did it, then it's kind of coincidental, I suppose. But what are the odds that they're brought in by the clergy, educated by the clergy, and they're creating models that are not scripturally based, right?
Mm-hmm.
Anyway,
Yeah, like,
they create this.
I don't think we're supposed to debate. I don't think he'd want us arguing about it as much as like, okay, if everyone accepted that the Earth was a stationary plane with a firmament, it's just amazing and big. We never know how big it is. He wouldn't want people arguing about what they think it is in entirety. But I do think in this context, of course, yeah, I've actually prayed about it. Like, yeah, he really doesn't like the lie that's been cast on everybody about this because it's like a direct attack on their soul, effectively. So,
well, I came across the scripture. Yeah. He kind of frowns on debate. Right, there's a scripture in there. He frowns on debate, and I just came across this recently, right? Because I was like, well, I was new to the debate world and new to the conspiracy world all in one, right? I just thought it would be one hell of a ride to start, I guess, go diving in, if you will. Anyway, going back to the question, the clergyman and the model. Do you think that it's going to be going to a political stage by 2025? Because I believe that if there is a group of people that do believe that institutions are lying, what's scary about it is that form of Marxism that's on the left right now, they're doing that to institutions, and there's a correlation to what Flat Earth does and to what the Marxists are doing right now, right? Meaning is resetting or changing things. So there's a form of Marxism involved, which is actually kind of interesting, because how is Marxism tied to Flat Earth, right? Because Marxism doesn't believe in God, essentially. The left are not really into God per se, right? The leftism, if you will. So it's a really interesting thing that's happening. But by 2025, are you looking forward to the politicalness of it, like the expansion of it? Like, what are you hoping happens?
No, like Flat Earth. I don't really know, man. Like, I unfortunately think the most probable thing is that we're being set up in a way where like they're guiding the awakening, and a lot of like the leftists that took all their jabs and all that, like, I don't know, that they're kind of frustrated with how hard it is to wake them up, but they're also not really a factor. So I think that we are kind of being propagandized and conditioned to accept whatever new system they bring in. And Flat Earth will kind of get wound up in that because it'll be like, well, look at all the lies the old system gave us. We got to do away with it. It's not salvageable. So in that sense, I do think we're being set up in a way. And I don't think that we should just abolish all systems we have because we're not really in a situation to do that. Is my overarching. What do I think about 2025? I really don't know. I think that they will eventually absorb that they lied about the Earth, but they may not actually absorb that it's flat. They may just say that it's stationary and electric and that the universe is not what we thought it was. Or they may absorb the flat part. I don't know, but yeah, I think they're going to absorb a truth bomb about the Earth within the next decade.
Wouldn't that ruin metaverse? Because metaverse is all about the sphere, Earth, and planets, right? And that the elite and the left really have, especially technical side of it, the technology side of it, they're really heavily into neoliberalism, leftism kind of thing, right? So they're all for the metaverse and planets and all that stuff, right?
Well, I think they'll keep the planets, right? That's why I think they'll do something in the middle where it's like they absorb, like somewhere in the middle where they absorb like geocentrism and the electric universe, but they still keep on to the idea of like planets and just basically they say everything out in the universe was kind of an optical illusion and was tricking us, and it was a little closer than we thought, and we didn't fully understand the background medium that was up there, but it's just all electric and there still are other planets, I would think, because I agree that in the sense of like the imaginative idea of going out into space is way too useful to in the trash, I would think, but I don't really know. I mean, if we're talking about exception this big, I mean, the metaverse is adaptable, right? Like, if you can bring in a whole new system, I don't know. Like, I don't really put anything past a paradigm like that. I think you could effectively reset everything with enough perks.
Well, here's the new system, because I've been researching crypto, right, for the last year. And I've here I don't know if you've done much of it. So the idea is to have because there's streaming movies, streaming music. They want the banks doing the same thing, right? They want to have this streamline going because the idea is that each tiny little transaction will be documented for tax purposes. So it's just another way to tax, right? This new system that's coming. But I didn't know this, right? So I was looking at all these currencies, and last year I came across this XRP. Well, just last week I bought a little bit of it, right? And I had no idea. I was like, okay, XRP, banking coin, not thinking anything of it. So I did a little bit more research, and I find out that if you type in, this is just the mystic side. I went to use the gematria calculator. I type in XRP. It says Antichrist and God is a human. I was like, okay, didn't know that. And then I keep digging further, and I find out that it's one of the main chosen coins of the World Economic Forum, XRP. I was like, okay, I didn't know that. The idea is this particular currency is going to be the underpinning of all the banks. So it's going to basically be this interoperable system that allows all the banks around the world to connect instantaneously. So Japan's heavily using it right now. I believe Russia's about to do their own CBDC using XRP as the blockchain protocol. So it's all coming towards this new system that we talk about, which is just basically 24-hour surveillance, right? So did you bother to go into this realm of cryptocurrency or whatever for the new financial system? Because the idea is, and this is right out of Powell's mouth, Federal Reserve, it says the new system is going to leave a lot of people behind because they won't know how to operate the technology. And then they're going to introduce automation by 2027, where they're going to replace lawyers. They're going to replace accountants. They're going to replace any of these clerical jobs because they have AI can speak now. They have all the data from obviously all the insurance, all the years that we've done stuff. They have all the data now, all the formulas to break it all down. But that's what's coming. And basically this cash flow system will help all the AI run the financial system. So you'll have cabs operating and using Bitcoin on their own, paying for their own parts, having their own shipment, and then some human comes in, part-time worker, installs it into the robot. Like it's crazy what they have planned, right? How are you going to walk away from all of that?
Yeah, I don't know. Yeah, I don't think people are fully soaked in. That's why I mean, I always say flat Earth's not going to save you, but neither is like religion. Like, but I will say like I think a personal relationship with the Creator, like that lacks like being super content, meaning just like humility in the sense that you're always like, show me what I need to do. I'm sorry I did this. I can tell I need to work on this. I'm sorry I lost my cool here today. Like, help give me humility, blah, blah, blah. Like, give me control and wisdom and discernment and patience and long suffering and these type of things, like a humble relationship. I think that then you'll be fine. Like, he's not going to leave you hanging because you haven't left him hanging. But I think if people take the flat earth and they kind of like, they go full out where they don't acknowledge something's much bigger than them, then I think they'll be in the same boat as everyone else. And I think the only way you can pull that off is an entirely new system that throws out majority of the old lies and acknowledges that we were misled about the earth. I think to replace the financial system, you got to show the problems with the current financial system. To replace the current federal government, you got to show the problems with it. To replace the right and left, you got to show the problems with it. To replace the monetary system, you got to show the problems with it. Which I think I just said that, but at the prison system, you got to show the difference. The technological system, you got to show the problems, and they're going to show the flaws in all of it with one fatal swoop of an update. And I think it'll just look really good on the surface, and people fall for it, flat earther or not. And that's kind of what I think. I think those that have kind of already mentally and spiritually prepared for this will probably just be chilling with chickens and have a garden and hopefully have made some babies, and they'll kind of tough it out. And that's what I foresee happening. I hope that doesn't happen super fast, but that's how I look at the whole thing. I just know that we're supposed to speak the truth. And as to the we're not supposed to debate thing, I think we're not supposed to debate with fools specifically. And that's why I've been convicted about like rooms like this quite a bit. honestly, because then my ego gets involved, and then I start like lowering my vibration. I start getting like worked up and like saying names or whatever, and I just know I'm not supposed to be doing that. But we are supposed to debate in the sense that iron sharpens iron. We're supposed to always pursue the truth, and we're supposed to have like wise exchange where we differ in ideas. And it says a wise man will learn to speak articulately in a convincing way, so to bring people to the truth. And so there is like a middle ground here. I think the debate's not bad. I think that futile pursuits of debating with dishonest, foolish people is discouraged. And I would say that part of it is something I need to work on. But overall, I don't have too much of like a black pill look at it all. I think that the creator loves everyone here. He has a ton of mercy for the people that have been deceived, and the vast majority of us was deceived for a long time. And so I think he's honestly just trying to wake people up and spark a passion within them that they'll kind of go try to wake other people up. And I think that we need to be humble enough to just kind of do that and let the chips fall where they may. Like, we definitely don't understand the full scope. We can see where they're headed, I think, but there's no way that we really know. And yeah, that's kind of my long tick.
There's no coincidence the United Nations has a what you would consider an Gleason's map as their flag, right? Like, looking back, you would be looking at United Nations before you knew what they were part of, right? Planning anyway. They would represent that flag, and then of course there's no Antarctica, all right? And then the treaty and all this stuff's supposed to expire at a certain year. I think 2030 something. Here's something. What about 2030? That's interesting. 2031, they're going to apparently retire the ISS. January 30th, 31. ISS is retired, and sorry, I'm just getting a text here.
Crashed into the ocean, and supposedly China might replace it.
Well, I just think that for me, for the financial system, I have no land. Right? So what they're saying is that XRP could be the next Ethereum, right? So I'm hoping before the full setup, because the integration of the system, it comes down to when this lawsuit settles, right? And I'm hoping that I might be able to have enough to buy a piece of land. That's the whole point of this, because how else am I going to get my little chickens, my little eggs to be part of the breakaway, right? You're not going to have.
I told everyone that XRP. I agree with you in that sense. Like, XRP is clearly being like controlled. The price is being controlled and held down, and it's like hands down the most like valuable in sense of utilization, and it's clearly like the currency. It's like the world currency. But yeah, the question is, are you able to cash in on the profits prior to some type of trap or whatever? But I think you probably will have some time. But yeah, I don't know. If I suggested at 16 cents a few years ago that everyone pop in there, then I told everyone at 160 to take out, which I just got lucky with that because it crashed at 178. But anyway, long story short, yeah, I do think that XRP is kind of good. I don't think it's bad to. I've also prayed about that, like crypto investment. I don't actually like crypto because I do know it's going to be used to basically usher in the downfall of the world. But I don't think it's necessarily morally bad to take advantage of it and use wisdom and get out in front of it. And it's kind of like the people that were talking about the internet. Like, the internet will never be a thing. Oh, you're going to send mail through the air? Like, you're so stupid. You can't send mail through the air. And then now everyone alive has an email. And so it's very similar to that. It's very abundantly clear that this is not going anywhere, and we will transition to digital currency. And yeah, like, it's probably wise to take advantage of it if you can, and then just immediately turn it into sustainable assets.
Well, that's what my goals. But Japan is paying their clients interest on holding XRP. So if you hold XRP, they pay interest on it in Japan. This just happened last week. Yeah, so it's unrolling. It's unfolding anyway. But did you hear what the United Nations just announced 2-3 days ago? And I haven't fact checked this. I got this from doing the research videos and coming across guys that were talking about the new environmental laws reducing fertilization. They claim that once it's implemented, the reduction of 30% of fertilization, they said there'll be 100 million deaths, apparently. Now, I haven't fact checked that 100%. I just wanted to see if you heard anything like that. But they're actually talking about it at Davos and the summits, these summits they go to. right?
Wow. No,
So
I
they're
haven't heard
talking.
that.
Yeah, famines like apparently, obviously, the poorer countries, because the idea is that you will reduce already people who are already in poverty even more so if you reduce. You know what I mean? Because it's just that two-class system, really.
Yeah, but is there any reason to trust what the United Nations is saying?
Well, that's the thing, is that they've said so much disinformation. I'm just shocked that it's in the open as much as it is. I'd like to go back and find that video that I saw again. It had the World Economic Forum and all that stuff on there, because they're talking about a little bit of pain first, right? This is the transition into the new financial system. There's going to be a lot of pain. This is what they kept delicately put, right? There's going to be a lot of suffering, if you will, because there's a transition into the digital economy. They want to get rid of, like, for instance, I don't know if you guys noticed, all the Walmarts here where I'm living, they have less workers and more automated machines. And a lot of these guys, or if you watch these interviews, like if you watch the audience presentations, whatever they have, they'll show you they want to get rid of lawyers, they want to get rid of accountants, and it's just going to be all digital, all animated, streaming instantly. So this annual idea of doing your taxes is non-existent. As soon as you pay something, you pay tax on it, you're done. You're not going to have to. They want their money up front. They don't want to have to wait anymore, right? So, and they're telling us.
Yeah, crazy. I'm actually gonna go chill with the wifey, but it's been nice talking to you guys. I'll catch up with you on a flip. Peace out.
Later, dude. It's interesting times anyway, but I'm going to take a risk and pop in a few $100 on XRP, because if it does Ethereum, that might be a little piece of land for me.
I was trying to find something on the fertilizer debts, but I couldn't find anything. Sorry.
What do you think, Jamsey?
No, he mentioned XRP and that kind of stuff. And did you say you're gonna buy XRP? Well, are you in Canada? In data mentioned XRP. It was him, right?
Yeah, I think he left the VC though.
Yeah. I just heard like the last beats of what he was talking about the taxes and stuff, and there's something there, but who knows? They're definitely trying to kind of facilitate the financial system to make it easier for the administrators to do all the accounting easier for them, and kind of cut a lot of the handwork for sure. So a lot of the systems are gonna be kind of automatic, like he was saying, in the money side.
Yeah, I mean, I don't necessarily see all that as a bad thing, though.
Yeah.
Right. Yeah. Unless you're a tax accountant like me, right?
Okay, I'm not laughing at you. Sorry, I'm just.
No, it's okay. Trust me, you're laughing with me, bro, because I've seen the writing on the wall within my industry as far as automation is concerned. We went from hiring like gangbusters when I first started to, I'd say, I don't even know if we've hired anybody in the last 2 years. And our transition has started to where the bulk of the people I work with are shifting over towards creating digital automations to do the jobs that we're doing.
Yeah. Yeah, like in the past, you will have to do kind of like an appointment with the guy at what was it? You know that those offices to do the taxes for you, and you go sit down and whatever. Now you go on your phone and you do it there. The tax stuff.
Yeah, so just to let you know, I'm on kind of the compliance aspect of tax, meaning it's lot of work paper preparation, form prep, filing, a lot of that type of work. And we have literally been working as hard as possible to automate anything within tax compliance that requires a human being to do something. Like the more we can whittle away the human interaction in tax compliance, the better for the company. And it's literally become, not only is it like a not hiring situation, it's almost an encouragement to leave situation for the human being still doing the things, in hopes that the automations will catch up to really replacing everybody within tax compliance that is actually performing accounting functions, to where the only people working within tax compliance are ensuring that automations are completing the tax work. And that's within the already complex system. So if they make a shakeup within that to make the laws within taxation a lot more streamlined, then yeah, it would take a snap of the fingers for I would say 99% of people who are actually accountants doing actual accounting work vanish.
It looks like they're setting up this system to kind of like the government is gonna have this phase that they're so inefficient and this kind of job of administrating, and now these big enterprises are gonna come with a bunch of solution in the monetary side of things. So it's gonna be like, okay, we're gonna facilitate the job of the government. You're still gonna pay your taxes somehow, but it's gonna be included into the whole transaction somehow. You won't be able to just not engage in commerce without kind of like doing the government getting their percentage of it.
Yep, it's going to be so streamlined and so digital that it's going to be something you don't even notice, right? A fraction of a percent of every single transaction that you do is just going to be shaved off as everything becomes digital. Simple, very easy,
convenient. That's why it's going to be adopted by most everybody, because it's going to be more convenient.
Mm-hmm. Everybody's going to look at it as an overall net gain for them. But
and the savings of fees, and like in the fees, transactions, bank to bank, and financial institutions, they're gonna see a savings on whatever fees for the user and that kind of stuff. So yeah, it's gonna look good. Yeah.
And it's going to be sold to the people in a way that's probably it's going to come from an angle where it's going to allude to the fact that large corporations are no longer going to be able to dodge taxes, and rich people are no longer going to be able to dodge taxes, right? Because it's going to be this streamlined, integrated system. And to an extent, that's going to be somewhat true, right? But what that does is the amount of loopholes that are available to everybody that qualifies for them, should you understand how to operate within tax law, those are all going to go away as well.
Wow, yeah.
And then every single thing that you do is digitally tracked, right? So it's not like you're going to be able to avoid any form of taxation that they deem is necessary. So once the system is all started up, could certainly be sold with, hey, it's just going to be a fraction of a percent of every transaction is just going to be skimmed off. That's going to be what we consider taxation. Everybody's going to jump on board. And then all they have to do is slowly increase that amount. And then what can you do? What can you do to avoid it at that point when everything's completely shifted over? What if they come out the next day and say, actually 50% of every transaction that you do is now going to be taxation? Now that everything's set up on digital, everybody's hooked up to digital, everything is set up to only interact digitally. How can you say no to that? And how can you avoid it?
Yeah, I mean, I kind of think that everything's going to be going digital no matter what. So to me, it's kind of a question of, I mean, just to put it kind of bluntly and a little bit in a way that's a little bit kind of generalized and all of that, but just the way I was going to say it, which is that if you have sort of this like NWO agenda, you know, this sort of evil, dark thing that they want, you know, that like the worst 1984 outcome, you know, just total control over your bank account, over, you know, social credit score, the whole 9 yards, you know, required jabs or else you can't get access to your money and all this stuff. Like if they're going to roll it out to that level, like that level of control and whatever their dark sadistic, you know, drive that I think they already, you know, they're already expressing, and it already has been expressed in all kinds of ways, like especially in wars and stuff. But if that's taken to the level to where they really corral humanity into that, then in a way they will have succeeded at that sort of NWO agenda. And then, yeah, at that point, we're pretty much just completely enslaved by them. And, you know, that's rough in a lot of ways. However, that's like the negative outcome. But there's another outcome that people don't necessarily allow that to happen. Like sort of we, the people, either give enough resistance, or you can even go on the extreme side that there's like a massive level of awakening that people go through to the point to where, you know, many, many truths are revealed on multiple levels. And basically their NWO agenda, like a house of cards, gets, you know, the bottom card gets pulled out, meaning that we, the people, kind of don't allow them, because like they need to get through certain checkpoints. Like they need to get us to there, and then they need to make sure everyone's on board, and then they need to get us to there. So it's like getting into a, you know, trying to rob a bank with all the, you know, laser, you tripping the lasers and all that, you know. So it's sort of like they need to get us through all that. And if they do, then yeah, it could be a pretty dark outcome, like with the digital, the way they could use the digital stuff and the control mechanisms and the police and the military and all that to really control us in a way that could be a pretty negative outcome. But on the other side, if enough people push back and if there's enough like awareness of these criminals and what they're doing, then we can move into a more digital era that actually could be more of like a renaissance, or like a in a positive way, where there could actually be like, we could have more freedom, more money for less time working, you know, more ability to explore creativity and, you know, farming natural foods and all kinds of things like that. So it's sort of, to me, it's like it's going digital no matter what. It's just sort of a matter of like who gets the control, basically. Like, do we, the people, get more of like our sovereignty and freedom and able to use the technology like in a decentralized way that's actually, you know, more fair and has transparency and honesty? Or do the kind of NWO guys kind of get their, you know, what they want? So it's like,
I agree. No, I agree with you. There's that is a big piece of the kind of like a wing of the system that is going to be flying with the whole monster. You know, one of the wings of the monster, like the actual user, like the people that, you know, you said the banking, having the bank accounts and stuff, but in the ledgers and the blockchains, the user himself can actually hold the keys of the assets and kind of set up bridges to utilize the assets in the economics, right? So it's about how those bridges are going to be connected through, because, you know, to your whatever monetary transaction or commercial transaction. So there's going to be, in the economics, there's going to be an environment where the user and the communities are going to have a lot of kind of voting power, for say, in how the money is managed, instead of having a centralized institution making decisions. It's going to be the way I see the ledgers and the blockchains design, it's gonna, in a way, yeah, it's transparent and public, and you can see a lot of the transactions. And there also that way of managing it where the users kind of hold the power instead of one powerful institution. It could be definitely utilized like that. That's the way I see it should be. The company Ripple, because Data mentioned XRP, and the Ripple company uses the XRP ledger, which is a public good, right, to provide services to the banks, right? So now Ripple is being described by the central banks and I think the IMF. Ripple is being described as a bank providing services. So when they use the XRP ledger, Ripple doesn't own the XRP ledger, but they there's a bunch of nodes, and they have some of the nodes. But the company Ripple can, even though they are looked as a bank and they provide banking services for banks and financial institutions, the company Ripple can go out of business and close down, and the XRP ledger is still going to be there, being operated by the users that are utilizing the ledger. Do you know what I'm saying? So the money, the assets are still going to be there. It's not going to be one guy like Ripple controlling the whole XRP ledger. It's going to be the whole community, and the way they utilize the services they provide, and the way they move the money. You know, when you hold the keys to your assets, to let's say the XRP or your wallets, you're holding the assets in the ledger. The bank is not holding the assets. The bank can say, hey, we're gonna set up this app where you're gonna move your assets here. We're gonna provide services. We're gonna charge you a fee if you let us hold the keys and hold your assets. That's gonna be part of the economics. If you want to have a bank that does that for you, you're gonna pay them to provide that service. But if you wanna function as your own manager of your assets, you can also hold your own keys and manage your own assets. You don't need the bank to do that for you, because the ecosystems, the environment is gonna be there for you to do it yourself, instead of paying someone else and allowing them to control your assets. And that's what I see is one of the biggest points of the why a lot of small businesses, individuals, and even scaling it up to enterprises and institutions are gonna utilize these ledgers and blockchains to move money, information, data, and content around in this digital version of the economic system, which is gonna integrate the user and the finances. So, and that right now, the government of Colombia, they made they made a registry of all of the land in Colombia. I read it in Spanish, so it's a little different. So the land registry of Colombia now is being made on the ledger, on the XRP ledger. So everything like the certificates of ownership and everything that has to do with the lot of the land is gonna be on the ledger now. So from now on, when the transaction is gonna be, there's gonna be a bill of sale of the lot of land is gonna go through the ledger. So it's very interesting that they integrate, the governments are integrating this, and it's like everything is converging into this. When we talk about the economics and the finances, everything is kind of converging into many of these technologies that it's not going to be one, it's going to be a bunch of them working together, interoperating to flow not just money, but information, data, coupons, documents, a bunch of different things. I think it's an interesting time that we're moving forward, but I think it looks like this economic system that we are standing on the moment, they're gonna kind of break it in a way to give us the new one. Because right now we have this debt and this all of this debt and all of these problems in the world with economics that's gonna just break somehow, and then out of that burning, the Phoenix will come out and they're gonna say, "Hey, we have a better version of the economics. There you go, embrace it," and people are gonna take. We're gonna take it.
Yeah, it's a good point. Everything is going to be shifting over to digital, and I liked how Gio had kind of a macro overview as well. And Jimsy, that was a good point on kind of the financial side and how that integrates a lot of the economics. And that idea, Jimsy, is just one small portion or one key of the overall metaverse that they're going to be installing, right? And the virtual reality aspect of it, that's going to be a much later addition to the metaverse, right? First everything kind of gets shifted over to digital. We're still kind of living in the same physical reality as the shift takes place. And as we know, right, companies like Amazon that have been built up since the advent of the internet, right? When we first got the internet, there we couldn't even fathom back in the early 90s that I could have used my computer to have somebody deliver food to my house, right? Like, we could fathom it, but certainly felt like it was really far off in the distance. Now that's not necessarily just a reality, it's a norm to people, right? So people of an older generation kind of understand it, utilize it a little bit. The generation before them completely never even got on board with it, right? So now we have generations of young kids right now that spend a vast majority of their life involved in something related to a screen, typically video games and things like that, right? So they're already conditioned to experience much of their life in this digital form already. You already have some sort of commerce being involved. I don't have children, but it's my understanding that in video games you can purchase things, and many of these purchases are digital things like guns or clothing or any of that stuff, right? Not necessarily a real asset, but once the whole metaverse comes on board, you have NFTs that allow for you to create these digital things and then be able to generate some revenue off people purchasing these items from you. It's like a digital trademark, right? So all of this is all coming into play to the point where a certain generation may not know much of the actual physical nature around us, because at that point they will be integrated for the most part, living most of their life through a virtual reality type device. That's a little further off, but the whole economics of it is coming. It's all being structured. Just to let you know, within even my world of accounting, the biggest things that we are trying to do, try to figure out, and try to help our clients navigate in the future is the metaverse. There's nothing else that is a focus at this point in time. It's literally a focus on how are we going to help our clients navigate the metaverse. And I'm not just saying that because it's what I think is going to happen. I know for 100% fact that that is the focus of many major corporations at this time. So it's not just some sort of idea or concept or conspiracy theory that everything will be shifting towards that. I guess the big question is, what is the eventual outcome going to be? How long is that going to take? And what are the steps that are going to get us there? I think it's going to be a slow transition, slowly conditioning the people. And when I say slowly, it's going to ramp up in speed, and you will have some tipping points, some major tipping points for some major sectors that might be noticeable. But a lot of it going to be a slow integration in a way that we've slowly been integrated into purchasing the not only purchasing but asking for all of the technology of control under the guise of it helping us already, right? So we're already establishing. You would be hard pressed to walk into any home right now that doesn't have some sort of microphone or camera and or both that are attached directly to the internet. Do you think you'd be able to enter a home right now of anybody that doesn't have some sort of device that has a camera or a microphone on it that is attached to the internet? I mean, that's
Bro,
already there.
I heard someone the other night talking that they went to a bowling place to play bowling, and they were complaining how it was the balls and the pins, there was no screens, and they were complaining that there was no screens, no digital accounts of the scoring. They had to do it themselves, and they were complaining about all of that. That's kind of funny. The customer that went to play bowling, so they're complaining that they prefer to be in a place where they have the TV keeping the score instead of having the actual analog version of it. They don't like the analog version. They want the digital version of it. They don't like the regular bowling, which is you grabbing the ball and just accounting how many points you got or whatever. The one,
Just wait, Jonesy. I'm pretty sure we're at the point where people are going to go to a bowling alley and be disappointed that it's not like a Nintendo Switch or a Wii, that they have to actually physically touch the ball and roll it down the lane.
It was kind of funny. I heard them. I wasn't thinking about any like metaverse or whatever, but it was kind of funny that they were kind of complaining about that. They mentioned that there was no scoring TV or anything. Yeah, I found that kind of funny. Yeah, they were having a good talk, but I just overheard them talking about that. So it kind of relates a little bit to what you're saying. But the metaverse on the gaming industry, because the gaming industry is huge, right? They make a lot of money, and people find entertainment. I do some gaming sometimes as well, and the purchasing thing about products in the metaverse, like whatever skins or whatever characters, that is a huge. That has a huge profit margin. So I've heard some gaming companies saying that instead of buying a skin on a game and locking that skin in that game, you're gonna be able to have some type of digital wallet where you're gonna be able to move whatever you buy in the metaverse, move it around different games, which is a lot of people like that concept. So it has utility in the game gaming. So the NFTs sense of that does have a lot of use. But the NFTs is way more than that. You could have legal documents, land certificates, vehicle certificates, bills of pay. A lot of different documents are gonna be moving through the NFT sense of that market. But yeah, the gaming industry is huge, and they're definitely adopting a lot of this technology.
Yeah, and they've already kind of got some people really excited about digital art and NFTs with this promise of making money, right? There's people starting to create the digital art that were never really, let's be honest. Growing up back in my day, there was let's just say there was really no such thing as digital art, right? We had to do physical art, painting, drawing, stuff like that, right? And to be honest, there's a fairly small percent of people that can do that stuff well, right? Now you've got a vast majority of people that are convinced that oh, well, I'm just going to be a digital artist. I'm going to create these NFTs. People are going to buy these things that I want because maybe, you know, this image that I've created, they really enjoy it, and they might want to hang it on their wall in their metaverse apartment, right? These are kind of the ideas that are taking place, and it's just going to shift across all aspects of digital life. Think of kind of like Ready Player One, right? And you've got your avatar. Well, if your avatar wants to go get some new avatar clothes, he's going to go to an avatar shop, and all the clothing within the avatar shop that you can look through has all been created by various different people, or you have people who decide to work for a digital clothing company that help a digital clothing company design all of these pieces of digital clothing for your avatar, right? So then you're going in to purchase these things. So
well,
you can
if you
see
buy it to that store and buy a hat, you can get a digital version of the hat when you buy the hat and go to the metaverse and have that hat in the metaverse. And the only way you can have that hat is if you go to the store and buy the physical one or something like that.
No,
you guys are missing the whole point of it. The whole point of it is once you're decked out with this stuff, it gives you perks in real life. So what they're doing right now is, for instance, if you buy a digital hat, it'll give you perks at their store and physical location, right? So it's pretty crazy, man, what they're doing with this walking scheme they had. Like, people were making $200 a day US, sometimes up to more than that, because they would actually just put the phone on these devices, or like they hacked the program by making the phone move, because it's counted by steps, right? But yeah, they're moving towards this system, dude. It's crazy, man. You're gonna have to get a digital pass to do something in real life.
Yeah, well, a lot of what you now consider real life is eventually going to fade into the digital, kind of a Ready Player One type scenario, right? There
so a
is
dystopian world, a world
Yep.
that's absolutely miserable. The people are like trapped in hell.
Yeah, but
Do you think
think of
do you
it.
think it's gonna be
Think of how
miserable
many.
because the doors of your house are not gonna be closed? I don't think you're not gonna be able to go out there and do things. So I think
No,
it's gonna be like an expansion of the metaverse. But if you decide to sit down on your computer all day, you can do that. But it's not gonna be like the computer has changed and you won't be able to stand up and walk off it.
Exactly, but what's going to happen is that you're going to have to attain this stuff in the digital world to go to places in the real world. That's what's going to happen.
That's a big part of it. Yeah, real quick, bro. That's definitely gonna be a big part of it. But you're not gonna buy, let's say, a Bugatti for $5 million and just having that's a possibility. You can buy a Bugatti digitally, right, for that amount, for $1 million or whatever, right? But if you buy a Bugatti and then get a digital version, and the only way in this metaverse to have a Bugatti is getting whatever, right? Like
you'll get
the
it
real version of
tokenized.
it.
You'll get
You
it
get it
tokenized.
yeah.
So what happens is you'll actually buy it in the digital world, and it will be tokenized, and you present it as a contract for the real life thing. That's what it's all about.
Yeah.
And then you'll have it tokenized, and it's yours, and that's your whatever it is. Or maybe you rent it. You have a token to rent it for a while, and there's your car. You pay the token price for the year, and it's yours.
Exactly. Yeah. I mean, and like I was saying earlier, the banks they're gonna still offering services, right? But the banks, what we know as the banks, right, the one that we can walk in these days, they might close a lot of their branches because they're gonna offer online services. They're gonna be connected to the ledgers, because when you look at the company Ripple, and right now the big institutions are looking at Ripple as a bank, right? And Ripple utilizes the XRP ledger to provide services, financial services, right? But Ripple doesn't own the XRP ledger, like I was saying earlier. Ripple can go bankrupt and be closed down, which I think is not going to happen in the near future. But they could be closed down.
Ripple just opened up
But
an
what
office in
I'm saying
Toronto,
is
right?
that Ripple can be closed down, and the XRP ledger is still going to be there, being utilized by institutions. You know what I'm saying? So the banks are going to participate in the new financial system, But you yourself, like Flutter data, right? You can either decide to give your keys and your access to a banking institution that is gonna, in a way, facilitate the transaction and offer perks for you for utilizing their services, or you yourself can have your own keys and have your own access to the ledger that is not controlled by the banks themselves. There's gonna be people that when you look at the ledger, you can have your own keys, right, and have the assets there. But like I'm saying, there's also gonna be people that don't know how to use that, and they're gonna allow the institutions to provide the services to do it for them. But yeah, I'm just saying that I think the market, the access to money is gonna be in a way expand. It's being expanded for people to access it and kind of have a certain control away from the financial institutions that they are still gonna participate and gonna offer a lot of services and gonna have a huge customer base, but there's a bigger environment for people actually having small businesses, content creators, kind of having a better environment for themselves to create content, services, and products, and putting them in the market and making a profit without that middleman taking a big chunk out of their product or their service or their content.
Well, it gets rid of copyright issues, right? Because this is the whole thing when they keep going and everything's on the blockchain. And if you sell 10 items, it will be 10 items. Google is already looking at implementing a program due to this, which is related to the crypto sale of the tokenization of art. That it can't be, if you make a, like, how they copy, what's it called, when they knock off, it's a knockoff, right? You can't have any art knocked off because it's connected to the blockchain. So it gets rid of that, right? Artists having their products ripped off or copywritten, or even brands for that matter.
Yeah.
Or knocked. Well, I think I think Klaus Schwab did say this. That of all the negativity, this is what Klaus Schwab did say. He says they have to make crypto work. In other words, what he was saying, he said that they have to make people wealthy. They have to show that it works. If they don't, people won't gravitate to it. That's what came out of his own mouth.
I agree. Yeah.
What I think too, it's also important. Like I don't know how true this is, but I think a lot of the developing cryptos and stuff that we're seeing are specifically for developing nations, third nations and stuff. This is sort of my theory, right? Like
it's exactly what it's for.
Yeah.
You're absolutely right. They need taxation models, and they also need people to have liquidity, and they can make everybody their own bank. That's what Cardano was supposed to do with Africa, right? Cardano was supposed to be the currency for Africa, but for some reason, they're incentivizing it there. They're advertising it. They're giving it away, just like the China's doing with their yuan digital currency. They're giving it away. So it's yeah. Go ahead, man.
Yeah, well, it's not like that. Crypto is obviously not a part of the West over here. It's just going to be implemented in the form of CBDCs, right? Like the bank isn't going anywhere, right? Like the bank is just looking to capitalize on this, of course, and but as a whole, I think a lot of the cryptocurrencies that we're seeing, we're seeing like adoption from countries like El Salvador. There's other like Brazil now, as I think, or so I saw some other country, Colombia or something, it's like ready to adopt another cryptocurrency stuff, and like these are all like poor nations, right? And it's like it makes sense, right? Because they want to what they want to do is
Japan just took on China, or sorry, Japan just took on XRP, and they're paying their customers interest if they hold XRP. So Japan just passed that. Japan is using XRP, I think by the end of November or something like that. So
Japan is gonna allow the settlement of debts, and credit cards, and even buying property with digital assets, including XRP. And also, like I mentioned earlier, that the government of Colombia, they were gonna create a land registry in the Ethereum network, but they decided not to do it there. They're gonna do it on the XRP ledger, and they already have a functional land registry of all of the property in Colombia that is gonna be in the ledger, in the XRP ledger. So that's interesting as well. land being in the ledger. I mean, that's
It's all going to be tokenized, right? Your car insurance, your property, your guitars, everything you're going to own is going to be tokenized if you want it, and then that's your asset value for your credit.
Yeah.
So essentially, the more assets you have tokenized, the better your credit score is. Or apparently, anyway, I don't know how that's going to work, but sorry, you have more leaning. You have more stuff to lean.
So, what's the name of that institution? Right now, I can't remember. I have to look it up. I think it's the B. It was the Fed before the Fed. It was this institution.
IMF?
No, it's not the IMF. It's bigger. It's an institution that is bigger than the IMF. I gotta look it up. It was the
Trilateral?
people.
Trilateral?
No. A lot of people haven't heard this term, but let me look it up. It's the BC something. It's the ones that actually created the Federal Reserve, and the ones that they're actually talking about this stuff. The ledgers and the XRP ledger and that stuff. And these are really big institutions that didn't. This institution I didn't even know it existed, but it was the Federal Reserve before the Federal Reserve. So I gotta look it up again. It's a specific term. I'm just doing something else that I cannot touch my phone at the moment. Yeah. Let me check real quick. I have a break. I'm gonna give you the term in a minute. I've just gotta find it. So I think the environment is being set up in a way that a lot of the participants in the public, right? Like, public companies, banks, and the users, the workers, and this huge side of the wing of the economics, which is the one that the middle class, even the rich people, right? This environment is being set up to have a more fluid interaction in the economics and the movement of money and access, making it like globalized, so easier
They
for
want to streamline money. Yeah.
streamline money. Yeah, it's gonna be like it's making it more convenient, making it easier and more accessible. And obviously, when the internet was the financial system that we have, there was no internet as we know it today when those systems were set up. And now we still use the old economic system, and now they're kind of upgrading the whole system with the internet and all of this digital version of the universe that we do in our day-to-days. And the globe is included in that, right? You see people buying like property in planets and that kind of stuff.
Yeah, so you're gonna have to earn your trip to Mars through the metaverse.
Yeah. Yeah.
What a mess.
But that's one section of it, right? Because the actual service providers, like the people that are gonna, I don't know, like open a company to provide services for your home, like, I don't know, fixing your roof, or I don't know, cleaning your backyard. I think people providing services are gonna have the opportunity to be rewarded kind of in a better sense for their efforts and their service provided. And the content creators and all that stuff, I guess in the economic sense of things, it's gonna be better than what we have at the moment, because we use the economic system at the moment, which is kind of messy and inefficient, and we still utilize it, right? But this upgraded version apparently is gonna be better for everyone. That's the claim, right? It's gonna be easier to manage your money and have access to it and control it. So hopefully for the best. Who knows? Maybe we'll be worse, but I don't know. I'm still optimistic. I don't want to see the worst version of everything. The worst version of everything. I think there's a good chance that we could be better off if people have more control over their finances. Hopefully that's a thing.
I agree with you, bro. So, like, Gems, do you have any cryptos that you think are, like, not connected with the NWO agenda? Like ones that you think are legit or independent of that, or ones that you think are actually on the positive side?
Well, when we're talking about the finances of the world, I think there's gonna be like it's gonna interoperate between many technologies, right? So it's not gonna be one thing that is gonna be controlled by let's say, I don't know, Satan or whatever. If you're asking me about the projects that I think are gonna be integrated into the financial system, I won't be able to tell you if they're being controlled by the WO or whatever like that. But I will say the XRP ledger is one of my favorite ones, even though that has big connections to the banking institutions. But it's still a public good, so it's like it's not owned by the banks. It's not owned by Ripple. It's a ledger that is a public good. So I guess there's a possibility that it can be used for whatever it's gonna be used, right? Good or bad. Then there is the XLM Stellar Lumens. I guess that's a decent one as well. XTC, which is a hybrid ledger blockchain that is gonna be on the finances, the stocks, and right now I'm doing something else. But the XDC XFIN is a good one. Another one, HBAR. I mean, but this is the thing. The question that you asked me is kind of like a tricky question, because the Hedera hash graph, which has to do with data, information, coupons, even NFTs and all that stuff. Hedera hash graph, HBAR. It's the governing council of that one includes MIT, Google, Deutsche Telecommunications. We own Steam Mobile, IBM. So it's another one that I think is has a lot of utility on the upcoming utility market, because right now we are under the speculation market. But the utility tokens, I think those are the ones that if you're gonna do an investment long term, that they're gonna have some value in the finances. XRP, XDC, XLM, HBAR, and another one that is under the radar of many people is the Casper network. CSPR Casper is a decent one. There's IOTA, IOTA that has to do with machine communications, communications between machinery. Is a very interesting technology. IOTA. You know, you have your fridge that in the future is gonna use Amazon to you can just click a screen on your screen to order a product that is already low in your refrigerator or whatever, your cabinet. A lot of people like that kind of concept. So the machine communication between the phone and the the utilities in your kitchen and your house, the machinery is gonna communicate. So there's blockchains for that. IOTA is one of the more interesting ones that has a lot of connections. And another one, give me 1 second. That because between all of these technologies and blockchains, ledgers, they do their functions, but they have to interoperate and function together. So one of that layer of interoperability, I think one of the biggest one is gonna be Quant, which is QNT. The function of that one is connecting all
It
of the
uses
networks
XRP.
together. What was that?
Quant uses XRP.
Yeah. But Quant is gonna kind of connect XRP ledger because XRP is the token, right? The bridge asset between the all of the other assets in the ledger. That's what XRP is gonna do, bridge the assets. But that's the XRP ledger is the technology, and then companies are gonna use the XRP ledger to do that. But then to connect the XRP ledger to Casper, Data Hashgraph, Stellar Lumens, even Bitcoin, Ethereum, to connect them, you're gonna have an overledger, and that overledger, from what I've seen, Quant is solving that problem, the interoperability of all of the ledgers and blockchains together, which is a big thing, having them working together efficiently, seamless, basically. So look into that as well, because the blockchains don't just interoperate just like that by magic. They need the factor that can make them work together, right? You know that, right? It's not gonna be one blockchain that is gonna run everything, or one ledger that is gonna run everything. It's gonna be many of them, and they need interoperability, and there's going to be an overledger. And when you look at Quant, that definitely is going to use the XRP ledger. Quant is going to connect them. That's from my research, that's what I see. Quant is going to be a huge one as well. Yeah, that's in reference to what Geo asked me. But for them to be disconnected from that what you said, the WHO and the IMF, I don't know if you're gonna have kind of like a very successful system that is gonna be disconnected from the whole system, because this is a whole role, connecting the whole system. So yeah, how you gonna be I don't know, going to Target or Walmart and making these payments utilizing a system that is not connected to the system? It's gonna be hard to do that. Does that answer your question, Gio?
Yeah, I was enjoying listening. Yep. I mean, I was just sort of wondering, which ones like.
Do I always sound doom and gloom there, Gio?
Like which ones you're rooting for, and or which ones you think are, like I was saying, kind of on the positive versus on the dark side in that sense, to kind of do that, polarity.
ISO 222. That's the best coins you can find. It's not about a feeling. It's just about being an early investor in the ISO 222 coins or currency software or whatever.
Yeah, the thing about the ISO 20022 is that that's a language that you need them to speak to be able to participate in the central banking messaging system. So you could have a blockchain that is very good, but if it doesn't speak the language, the ISO 20022, it won't be able to send messages through that system, and that's a huge pool of money, right? The central banks of the world. So yeah, you kind of want this utility token asset that can speak the language that is needed to participate in the world economics. If they don't speak the language, they're gonna be left behind, because imagine going to get a job and you don't speak the language, you're gonna lag, you're gonna stay behind. You can't speak if you can't communicate with the your coworkers or your employers or customers. You gotta speak the language. And yeah, ISO 20022 is that messaging system. Do you think that's right, Data? You gotta speak the language, and many of these tokens that speak the language, I think they're gonna be okay in that sense of things.
The key word is interoperability, right? Apparently, that's the universal language. So,
QNT, yeah.
Yeah, the only concerning thing I think here is the forking. What's happening with Ethereum and Bitcoin? I think there's two serious technical issues with Bitcoin and Ethereum. Well, there's more with Ethereum, but generally, I can't remember the code with Bitcoin. But apparently, if there's something that is if it fails in sequence or whatever, Bitcoin collapse. But apparently, it's been working flawlessly up to this point, right? And then with Ethereum, you obviously have the scalability issues and obviously the 2.0, but they're claiming that the IT department of Ethereum, if you will, are going to fork Ethereum. So you know how you have the classic Ethereum, now you have this Ethereum. They're going to fork it again, so you're going to have the old Ethereum and then now the new Ethereum, which is it's just crazy that you have to keep having these subsets of blockchains in sequence to each other. So you have like dual blockchains now. So every time they're doing that, they have to create this double set of blockchains, which you don't have to do with that with the XRP ledger. Doesn't make any sense. XRP ledger is cheaper, more efficient, faster. I get when I transfer XRP, and if I've sent it to friends or whatever, it's instantaneous. If I do Ethereum, it's at least 10 minutes to half an hour.
Yeah, how you doing, guys? Is Gio in the house? Gio, are you there?
Yeah, I'm here. What's up, Jim? Yeah, we were just talking about
nice one, man.
cryptocurrency
Thanks
stuff.
for the discussion the other day, yesterday, or a few hours back. Brilliant. I've got two requests. One, Riggs is wondering, can you unban him, Riggs? Remember? Is it possible? Bring him back into the fold. Any chance?
Yeah, I saw that he had sent me a DM. I haven't. I'm kind of backed up on DMs right now, so yeah, I was planning to respond to him. So yeah, I got it.
Any chance of having him? Because he's asking me to say like, ask Gio if he can unban me. So I'm asking.
Yeah, I'll respond to him in the DMs.
All right, brilliant. Yeah, because he's waiting. You know what I mean? Yeah. And what about Pete O'Shea? Now he hasn't asked me anything. I'm just fishing. I mean, what about Pete O'Shea? You know, and the Dodo. Do you want him back in or not?
Is that George?
Yeah. You know the guy I'm talking about, Pete. You know the Irishman, Gio.
Yeah, I know Pete Shea, yeah.
Yeah. Do you want him back in or not? You know, he's a likable character. He can be a bit wild, but you know, he's pretty good.
Yeah, figure that out. Gio and Data. You know that there was some interview recently with some of the creators of the Ethereum, system, right? The Ethereum blockchain. And these guys were speaking a language that they are kind of, I don't know, kind of confused about what's going to happen. But they were asking, they made these comments about the Ethereum, in the Ethereum one, you know, the one that is at the moment, and they describe it as a prototype. Like they saying it's not scalable, so they have to change it to be more scalable. So they say it was designed as a prototype. So people are holding what a $2,000 prototype that is not, it's not like um, how do you say, scalable compared to other blockchains and ledgers. And there is have you heard something that people call Ethereum Gate? You know, like the Pizza Gate, but they call it Ethereum Gate. There is something big about how Ethereum has very deep connections in a certain group of corrupt individuals in the governments at the moment, like the SEC, and they were allowed to be able to have like a free pass to be able for people to be able to use it, while XRP Ripple was sued to not be able to participate in the free market.
That's because JP Morgan's behind Ethereum, and that's why apparently there'll be a nice big push here after the Ethereum 2.0 release, the forking. But then there'll be a big dump, and apparently Valak sold most of his Ethereum shares recently too. So
yeah, I think there's something very fishy about the Ethereum stuff, and you were saying something about Ethereum. I don't hold any Ethereum, and I think there's a lot of corruption involved with the people that operate that blockchain.
well, Ethereum, my experience with Ethereum was a nightmare. It was unpleasant. I had to do these because so you have these gas fees, right? So if you don't actually put in a right fee and it's a lower fee, it will be truncated. You have to go back, pay a proper gas fee for it to have your fee go through. So you could do all these transactions and not be aware of that one transaction, and all these transactions will be held until you clear that one transaction. And it's all because you just went a little lower for gas fees. So it actually ends up costing you more money to compensate, because it costs you double, triple the amount of fees. And then if you did invest anything like into anything that would pay you perks or interest or whatever, you'd go to withdraw it, and it would, let's say you had $150 on something. It would cost you $1,000. Eventually, at the peak of gas fees, it would cost you $1,000 to withdraw $150. What a scam. You know what I'm saying?
Yeah.
So what I'm experimenting with now is Sologenics. If you've tried Sologenics, it's way easier. You can load up NFTs for next to nothing, and you're using XRP, and then you can. Apparently, there's this token. It's called the third generation blockchain, which is apparently better than XRP, but it's called Corium. And you have Solo tokens and Corium tokens, and apparently Solo is only 400 million, and Corium's only like 500 billion or 500 million or something like that. So these tokens, if they actually get used, the value, by the way, Solo went up to $7. It's sitting at, I think, 29 cents right now, something stupid. But I've been fooling around with that platform. It's way easier than OpenSea. It's way easier than Coinbase. Everything I've done on the Sologenics platform, the DEX platform, has been mind-blowingly easy.
Wasn't there like a recent hack in the Sologenic? And
I've never
also,
heard anything. And Sologenics is backed by XRP, right? So XRP is actually sponsored, like Ripple, the company, pardon me, not XRP, but Ripple paid, gave money to Sologenics to open a decentralized platform. And I mean, I don't trade on the platform. I just put like, you know, peanuts on it just to experience it, to see what it's all about, so I can write about it. And I'm telling you, Sologenics, it's fast, it's easy to do NFTs. I mean, I didn't sold anything, mind you, but
Actually, yeah, Sologenic is in the XRP ledger.
Yeah, it's all XRP
Yeah, I
related.
thought you were talking about Solana. You
No,
were talking about
Sologenics. I don't like Solana at all, but Solana is going to come out with a phone. Come out with a phone here. It's the next. Basically, they're changing phones, right? Like, obviously, the phones have to change. Can't operate the same phones anymore, can we? So Solana is going to come out with their own phone, and it's going to be a crypto phone. I can't get up top.
Solana has been down like over, I don't know, many
Oh, it's been
times.
hacked left, right, and center. Yeah. Oh, here's an elevator. I got it. I got it.
And their big companies bailed them out with $100 million, something like that. Like,
fuck, dude. Sorry, dude.
So no, but Sologenic, yeah, that one is legit in the XRP ledger. Yeah, that one, I've heard some good things about it.
It's really easy to use. It's cheap to load NFTs. It's plug and play, man. You download the app, enter your thing, record your seed phrase, open up your camera, scan the QR code to your Google site after you after you want to connect the wallet, and then you can upload a whole bunch of NFTs, songs, whatever you want. I mean, the music, you can see that it's the beginning stages, right? So you can see that because you can't upload full songs, you can't upload full videos, right? So it's just the beginning stages. But another platform I've been fucking around with is the Internet Identity Protocol platform, ICP. Have you heard of that? The Web 3.0.
Yeah, I've heard of it.
Yeah, fucking around with that. That's interesting. It requires a little bit of programmer knowledge because it asks you to program canisters. So the idea, I think, I mean, obviously, if you're going to go to the next level, this particular platform allows you to write your own smart contracts. So people are trying to write clever contracts, a part of the financial system, so they get residual income. I haven't figured it out because I haven't really spent much time on it. But that's one thing you can learn is how to write smart contracts. And Cardano, same thing, smart contract based. But ICP allows you to write it to upload your own. The Sologenics doesn't allow that or whatever. So there's these different platforms that allow you different things attached to the financial system. So ICP is about your neurons, because they have these neurons part of their blockchain, and you can spawn your own. You can either take the maturity interest, which is the profit off the money that you've left behind, or you can grow your own coins, kind of thing. They call them neurons or whatever. So it's just all this crazy new platform, Web 3.0, internet identity, and they're trying to make an economy out of it. Because if they truly want to preserve the environment and have less waste and less energy and all that stuff, then they have to have a way people can generate income. And so whether that's training people to write their own smart contracts, so they make percentage off of every deal, you know what I mean? That happens on the internet. Because that's the idea, right? Your own bank, your own.
Bro, and now that I remember, that's interesting. You're gonna continue that after. I was gonna say the DTCC, the Depository Trust and Clearing Corporation. They settle most security transactions in the U.S., right? So this is the Federal Reserve before the Federal Reserve. And they've been talking of they have mentioned the XRP
I'm sorry,
ledger.
say the name again. Say the name again. Oh, they've been working on this for 20 years, dude. This isn't new. This is all a stage show. They've been working on the CBDCs for 20 years. Like this.
Yeah, but
Powell already said it in an interview, man. We've been doing this for decades and decades. They've been planning to roll this out for a while. So, and where was XRP created? California, dude.
Yeah. Because we in the, let's say, the conspiracy circles, people talk about the Federal Reserve and that kind of stuff, but recently, with looking into this stuff, then I saw this other body, like the DTCC, which is like even bigger than the Federal Reserve, which is very interesting. You know, sometimes we stay talking about certain groups, but there's actually the layer goes deeper or higher.
Most of the time, when we're focused on what we're focused on, it's a misdirection. That's what I've concluded is that 90% of the stuff that we're ever polarized towards is just a misdirection. And of course, that's a learning curve if you're ever subjected to, like if you come from a world where you're not internet savvy, and then you go into this world, and then you get you get the dark web, if you will, right? The things that come along with the seedy nature of the internet. And then when you get into that, you understand there's a lot of lost souls, right? And so it's kind of like that reality is not really present if you're not really exposed to a lot if you're not exposed to the digital world. So what I decided to do is expose myself to the digital world, and it changes your mind, right?
Yeah, I've put some energy into it, and I think I guess, we do put a lot of time and energy into making money, whatever. So informing yourself about how
Don't you feel good though
economic,
when you've done? Don't you feel good when
yeah,
you've actually done a good deal and done a good contract or something and done a good day's wage? You come home and you have a good meal and you get paid for that hard work. It's a very satisfying feeling. And if people, I think sometimes people take for granted that that experience, and then they become sort of whiners. Really, like I mean, I can't believe. I don't know. Did it happen because of the tolerant Christian? I often wondered that. Because imagine if you had every group that you had that non-tolerant Christian in your group. He didn't want to hear you bedwet. He didn't want to hear you whine. He didn't want to hear you play victim. He wanted you to believe in God and get up every day and pull up your bootstraps and be good, be kind, don't lie, don't cheat, don't steal. You know what I mean? Treat your neighbor as you want to be treated. Get up and work your ass off 6 days a week. Rest on the seventh day. Right? But what I think we're just full of tolerant Christians now.
I think you can actually do a lot of that and also be, in a way, successful in the economic sense. You could do a lot of good deeds and still, I don't need any. I don't need
You're
to.
talking about works. I'm just talking about a lifestyle, not works. I mean,
lifestyle.
a lot of people have shitty lifestyles, do a lot of good works.
Yeah. You can combine and refine both of those, right? Works and a lifestyle.
Well, it depends because initially, for instance, I've seen it happen. People who become more successful, they end up feeling slightly guilty, right? So what they do is they compensate for that guilt. So it's a weird dynamic. I've seen a buddy of mine who, well, obviously becomes a little isolated because he's stated that he's like, well, none of my friends can do anything I want to do, right? When I want to do it. I was like, well, I understand that. He's like, no, you don't, because his whole life he's lived that way, where none of his friends can do what he can do, and he can do whatever he wants. Can you do whatever you want? Can you go into? I can't go into a plane right now, book a flight to Paris, and then book a flight to Argentina, then book a flight to Rio de Janeiro, and then not skip a beat.
Take
You know what I mean?
take a year off and explore the world.
But I can't do that. So imagine being at that level of thinking where it doesn't even affect you. You can just do it. People are not on that. Most people are not on that frequency. We're on like trying to pay rent, budget. Okay, am I going to buy the good quality
Survival
craft dinner or the cheap quality craft dinner? You know what I mean?
Yeah, many people like in survival mode. Like if I don't make ends meet, I'm gonna get kicked out or something. I gotta make money to buy food, put gas in the car. It's kind of like survival almost.
I don't think there's a greater time to be alive because either the Bible is a lie or the Bible's true. And if the Bible's true, we're in for a one heck of a roller coaster ride.
Definitely feels like a roller coaster.
Yeah, but a roller coaster ride you want to get off because you're going to throw up.
You
Yeah?
can't get
But
off it.
eventually,
Man.
you get
You
off
can't
this
get
one
off it.
eventually.
If you think they're gonna let you live in a rural town, you think they're gonna let you live in a rural town? You really think that the breakaway society is gonna exist? It's not gonna happen. If there's no
No,
gonna
it'll
be,
happen.
you have to get rid of the two. This is all about getting rid of the two-party system, brother.
Yeah,
There's
it's
no
easy.
flat Earth. There's no globe. You understand? That's a two-party system. Red and white. It's red and blue. You're a
It's
flat earther.
easy.
You're a
Just
glober.
don't
It's a
vote them.
two-party system, bro.
Yeah, it's a one-party system, really, and they're just fucking you up. That's what it is.
There is a no party system. There's only one unity, and that's God's religion, which is not man's religion. It's the natural way that we're supposed to live. Don't lie, don't cheat, don't steal. Love God with all
That's
your heart.
right.
Treat people how you want to be treated. That's the universal law, man.
Yeah, and that's easy to do. That's easy to achieve. Just step away from the
That's
stupid
not
system.
easy to
Stop
achieve.
lining up.
If you start cutting into somebody's
Yeah.
money, somebody's food, that goes out the fucking window.
You step away from the stupid system and start putting value in yourselves.
You can't.
Working
You
for
can't.
yourselves.
They own all the land now. I can't even buy a piece of land for
No, they
$5,000
don't. Look. Let me tell
to
you
go
something.
raise
Let me tell
chicks
you
and
something.
cow, dude.
Hang on.
I can work for a
Hang on.
fucking year and save $5,000, and I still can't buy a
Okay.
piece of land. Come on,
Okay.
dude.
Watch it
Nobody
now,
gets out of
though.
here
Watch
alive.
it now. You take the military. You use them because we pay for them, so they're on our side. You remove the cancerous, stupid leaders. You've got the land back. Simple as that.
That's only after the two-party system dies, bro.
Yeah,
It
but
ain't
that's
gonna be
right. You
about
use the
flat Earth
military
or a
to remove.
globe.
That's what I'm talking
Once
about.
the argument,
Removing the two-party system.
once the argument flat Earth and globe is dead, then you have your reset.
That's
You
not going to be
understand?
dead.
We're just at
That'll
the
never be
beginning.
dead.
We're just at the beginning. We're just early to the party, brother.
Well, actually, yeah, the heliocentric model will be dead, and people will be living good because they'll realize that there is no
No, there
globe.
won't
Those
be
are
any
lies.
model. It won't be about flat Earth. It won't be about the globe, bro.
No,
The
it will
flat Earth
be.
is just
It
the
will
flat
be.
Earth is a
It will
misnomer,
be.
misdirection.
It
A
will
lot
be.
of
It's not
people,
a
aren't
misdirection
learning
because we can go and find out
about the
now.
things they need to learn
We
about.
could go to Antarctica and find out. No, that is a quest that has to be quenched like a thirst. So that's definitely going to be done. Don't you worry. You can be sitting there twiddling your thumbs. We'll be off on an adventure. The adventure begins. Talking about you ain't even living. You're worried about the Bible. I want to see more
Not
of
worried
this
about no
land.
Bible, bro. I'm wondering if the Bible's true or not. Because if the Bible's true or not, then what's coming our way is one hell of a ride, man.
Well, if the Bible's true, then
They're already
everything's
on the ride,
provable.
man.
So
They're on this ride
far,
already.
the Bible's pretty damn correct, right? I mean,
Is
it's
that
been living up to its name.
Is that enough
I'm
of
not
a
going to say
generalized
that.
statement, though? Is that like a generalized statement that has enough weight to it? Meaning that what I mean by that is that to me it seems like the Bible is a collection of so many different like parables and different things to where there certainly is truth in it in some of those parables, but the idea that like the entire Bible just being true or not true, like is that something that is just black and white like that? Do you think?
Yeah.
Well, I don't really know the purpose of having revelations come true to fruition and then an institution claiming to be one world government, and the correlation between the written and the action. I guess it's just coincidental. I don't.
Yeah, I mean, I think in like in poetry and in word, there can be truths that can be combined, and certain like moral,
There's direct
high
implications
vibrational
by scripture,
concepts.
Geo. You're missing the fact there's actual written scripture, word for word, talking about things that will unfold, and it's happening.
Hell yeah, the Euphrates River's drying up. That's a sign.
Well, the push for one world government, one world currency, although the American dollar was the attempt at the paper form of it, we're proceeding towards where we're getting into the ideology of gender confusion and no religion, right? Because they will eventually consider Jesus Christ to be blasphemy. So this is what Jesus warned, the Bible said. So whether they're manifesting what's written in this text, I can't say. I'm just saying that it's unfolding the way that it's supposed to, apparently. Who would have thunk? And you know what, you know what? Here's the thing. You talk about positivity in crypto. There's nothing positive about crypto. The only thing that's positive is gold. That's it. If we're not dealing gold, nothing is positive. Everything is just a byproduct of man's religion, which is technology. Gio, I said to you, go into Gematria calculator and type in XRP. It literally says Antichrist and human is a god. Digital is the interpretation of analog. There's nothing wrong with the analog. Everything wrong with the digital. Hey, Gio, did you see that they're going to bring back analog computers now instead of digital computers? They believe that now analog computers can help quantum computing. Did you know that? Apparently, I'm quoting Potassium. I'm paraphrasing Potassium.
Gotcha, man. Yeah, I've been listening, but wasn't really able to respond. Ruhif. Yo, Ruhif, you here?
Did you type in XRP into the Gematria calculator? Did you see that it says Antichrist? Did you see that it said God is human?
What's up, Ruhif? Dude, I just want to tell you in a very funny, joking way, Janus is actually pronounced Janus.
Janus.
You remember
Janus
when
is
Gregory was calling him Hugh Janus?
Yeah, it's Janus.
No, you want it to be Janus for the obvious reasons, but the word is Janus. Like, do you know Janus, the double-faced god?
No.
Polarity, Jan. Yeah, it's a. What pronunciation were you thinking of it as?
Janus, obviously.
It was just funny because you came in the chat and you didn't really say anything other than that. You just kept correcting Gregory that you wanted him to use the troll name instead of the pronunciation of Janus. I just thought that was funny. Yeah. And it was funny that he was saying Janus. Like, that was just his default. It was just funny.
How you doing, Ruhef? Staying sane, are ya?
I am, but I'm on mute. So I'm in a cafe.
Well, you deal with a lot of flat earthers all day long. It must drive you fucking insane.
No, you do.
Do you know of, just before we move on real quick, do you know the Roman god Janus? I just posted it. It's just,
Oh, I just Googled it,
yeah. It's basically like a dual-faced, it's like a god connected to polarity.
Oh, Two-Face.
Yeah.
Oh, good.
So what's new, Ruth?
Not much, just picking up my daughter. My boy started a new school, so hopefully that goes all right.
Hey, Ruef, I got a question for you. Do you know where in practical reality that people use the Earth curvature calculator? Do you know where it's used in academia or any practical application?
Yeah, the radar tower positioning. Yeah.
Do you know of any institution, just off the top of your head, that uses that Earth curvature calculator for any science?
Institutions generally don't, position towers. I know companies that did. When I was trading Korea, a couple of companies built a massive microwave tower relay between Seoul and Busan, and that would have needed a curvature calculator.
Well, why would you need an Earth curvature calculator if it was based on the transmission power?
Because you have to reach the next tower to relay it.
Yeah, but why would you be
millions.
concerned about that? Because every wavelength the light has in its distance, its reach, if you will, has a certain amplitude to it. And if you increase the amplitude, you can increase its reach for the most part, unless the item doesn't have or it diffracts, right? So even though you have an amplitude or a power or wattage or whatever you want to describe it as, you have a distance to that power, you still have diffraction happens. So let me ask you a question. When you're looking at your Earth curvature model, did you calculate how the light of the instrument, the transmitter, would actually bounce off the surface of the Earth and then diffract up?
No, this was not bouncing off anything. This is direct microwave. And they had to.
So what's the beam? If it's direct microwave? If it's direct microwave, it's a pencil beam, right? So it's a straight line of light, correct?
Yeah, it's still refracts though.
Awesome. So it's a straight line of light, right? Or does it
still
curve?
Yeah,
I'm sorry, no.
right.
Microwave technology can go up to 147 miles, no problem. It's micro beam technology, 5 millimeter wavelength, 60 hertz. So what are you talking about?
It still curves.
No. There's no curvature to it. The whole point is it needs to go. No, because it's used in 5G technology, and the whole point is each transponder between point to point, and you can do this Euclidean. It's straight lines and angles. This has to be done for smart cities. So where does these lines bend? Can you show me in the in the demonstrations these microwave beams bend?
Microwave curves to the end. It refracts.
Okay, so you're claiming refraction, so that's over a distance. So that's not because of Earth curve, it's because it's hitting something in the medium.
It still curves and allows you to see further than otherwise would.
Yeah, so it's refraction. It's not due to the physical nature of Earth. It's the idea of the signal passing through the medium, which will experience refraction. You're correct, but has nothing to do with the shape of the Earth.
Yes, because you have to see the next tower. And that may or may not be obstructed by the.
They have nothing to do with the shape of the Earth. What you have the signal diffracting, depending on the way that the beam is produced. You still have a diffraction to that beam over a distance. I mean, in other words, that the beam will separate, divide. The beam will separate and divide over a certain distance. This is just a natural function of the wavelength of light that's shot into the instrument. They all have it. The divergence of the beam will diffract. Yes.
That's not diffraction. Diffraction is going past an edge or through a hole or something.
No,
like
diverging, and then bouncing off the surface and rebounding back off the surface will diffract the light. You talk about an edge, right? You talk about a horizon. That is caused by the diffraction of the beam diverging and then bouncing off itself. That's what it's caused by. That is an effect that is, you can't deny that effect. That is calculated for, and that is measurable. So why are you not acknowledging that?
This particular project was point-to-point microwave towers, and I think there were about a dozen or something, and they would have had to take into account curvature and reflections.
They don't, though. Unless you can show me where they do, I'd like to see that. They don't.
Oh,
that's a lie. I can show you a test done with a 147-mile microwave beam, 5mm, at a 15-foot tower. Or sorry, no, that's not true. That's not 15. I think it's less than 15 feet. I have to go back and read the paper. 147 miles, very close to the surface of the Earth.
Ruhif, is there any part of you that would actually be relieved if you came to the conclusion that the Earth actually wasn't a globe? Do you think there's any part that would like take a breath of
relief
and actually be relieved? Yeah.
I've answered this before. I would literally consider myself insane.
Really?
Is it because of the opposite
Seriously,
rotations? Is it because of the opposite rotations of the celestial bodies? Is that why? What's insane? What's insane about believing that the opposite rotations are perspective effect?
What?
No, dude, I don't know where you came up with that. No, what he's talking about, he's saying that if he realized the Earth wasn't a globe, like for sure, definitively, or he saw whatever it may be, proof that it really is not a globe, that he then says that he would think of himself as insane. Is that what you're saying, Ruhu?
Yeah, I would say that I'm insane first before that would be true. No, I'm not trying to insult anyone, but that's just what I think.
Is it possible that it's because you're insane right now? You're right. You are insane right now, and that's maybe why you think it's a globe.
No, that's what I mean. If I somehow came to the opposite conclusion, I would have to be insane.
Yeah, but that's the feeling that you go through when you realize it's flat. There's like the 3 stages: grief, anger, and sanity, and then you come to the realization that you were wrong the whole time.
When all the evidence points one way and none the other way, yeah, I don't know how else to explain that but insanity.
Well, wouldn't it just be that you were misled by false information rather than being insane? Although part of sanity does involve knowing what's reality and what's fiction. That's like schizophrenia, like the inability to know the difference. But I mean, would you really have to label yourself that way, or do you think? Because I think you would be shedding something and rising to more sanity. Like, there's no way that coming to the truth will cause someone to go insane. That's basically what I'm saying. It doesn't work that way.
If I have my own information and it leads solidly to a result, it would have to be my information that was wrong. So, my own data and information, not anything that I've been given, but stuff that I've measured. That would all have to be wrong. My reasoning would have to be wrong.
Yeah,
And
your explanation
for
for what you observe. Yeah, your explanation for what you observe would be wrong, but the Earth would still just be what it is.
Yeah.
Here's the thing. What do you think of this logic? What do you think of this logic, Ruhif? When I told Penis or Paige Schill that I flew my aircraft at 2,500 feet and I flew 500 miles from point to point, I never had to think of a ball. I don't have to correct for curvature. I don't have to correct for spin. None of it. And then I would explain the 60-to-1 rule. Do you know what the 60-to-1 rule is when you fly an aircraft a certain distance?
It sounds like a glide ratio, but it sounds too big for glide ratio.
It's exactly what it is. It's wind drift, essentially, nothing to do with rotation. The idea is every 60 nautical miles, you drift 1 degree off your path. You always have to make a course correction, 1 degree to be parallel, and another degree, whatever you're off, to correct towards the destination you're headed. The idea is that this happens to do with wind drift, right? So when I fly my aircraft, and this is only a small student plane, now you have to keep in mind that my teacher thinks the Earth's a ball. I didn't say anything to him. But first day of class, he said it was flat, and with the implications were is that his students, the implications of that, what I thought were different, but he clarified. He said his students think that it's spinning and it's a ball. It's not. It's a plane. So when I'm up there, I fly, and I don't account for anything. This is what Penis says to me, Paige Shell. He goes, well, you don't have to worry about it. It's such a little plane, and it's such a little distance that you don't have to account for any of that. So essentially, he's admitting that I'm flying over a horizontal surface that's stationary, because that's what is empirically true. Now, what's insane about that exactly, Ruhif?
Negligible. Didn't say it was
okay.
flat.
So do you think that it's more insane to look at your reality and not account for it, and then say that it's negligible that I'm accounting for it, but I'm observing empirical reality? What's more insane? To think that the Earth's a ball, but observe it not as a ball, but observe it empirical and tell yourself that it's negligible because you're not seeing a ball. Like, what kind of insanity is that? Can't it be just for what it is, which is a plane that isn't the plane that isn't moving, and that it's horizontal just as it is? Can't it just be that?
Hang on, 1 sec. Hang on. The car's about to take over. There we go. All right. What corrections do you think you should make in that plane?
Okay, so you might have missed the point. So when I asked Paige Schill, when I fly my aircraft, X amount of height, whatever, he goes, well, you don't have to account for it. It's just too small of a plane and too small of a distance. But yet he's admitting that it appears stationary and that it's horizontal everywhere I go, because that's what I see at 2,500 feet.
I don't think you should.
So what is insane about looking at your empirical reality, looking at instruments on the aircraft and operating it as the function as this? You're flying it off the air. It doesn't give a shit about the shape of the Earth. But when you're flying over this Earth, it is a plane that is stationary. That is what's empirically observed. So what is insane about that?
Adjustments. Yeah, because in that sort of plane.
So the adjustments that I make, I told you, is this 60-to-1 rule, which is about wind drift. He asked me.
Well, but you gotta let him respond, man, because I feel like you interrupted him within seconds of him responding.
Yeah.
You laid out something really good. Like, if you just ended right there, it would have been perfect, and then let him go for 30 seconds, and then you can respond, because you did the thing where you just interrupt him right the minute he starts talking.
Thank you. Yes. In a general aviation aircraft, there would be no difference between flying on a globe and a flat Earth. It's only when you do long distance and you've got to make a great circle route that's big enough to show the difference that it matters. The end.
I'm glad that you stated that. So here's the conundrum. Again, this is the insanity that you claim that you want to avoid. And I'm confused because it sounds pretty insane when it's explained. And the explanation you gave me is that I'm in a small aircraft and it's negligible, so forth. But, Ruhif, most of your arguments are done at the surface of the Earth, claiming that you can measure dip, drop, and curvature. Do you not think there's a little bit of a problem there, Ruhif?
Most of the flight path arguments are long distance. You're talking about like seeing curvature now, right?
No. Listen. I'm at 2,500 feet. Right. There is no negligible curvature. There's nothing I affix for when it comes to rotation. And the only law that I apply is the 60-to-1 rule, which is every 60 nautical miles, I adjust it 1 degree to remain parallel to my position, or adjust for the correction to arrive at my target, whatever the distance is, 120 miles, 120. So the point is, that's all I function for is wind. That's it. Over the distance that I'm going. Now, Paige Shell says, well, you don't have to worry about a ball Earth. Now you're admitting the same thing. It only comes into play when my plane is bigger and I go a farther distance. Fair enough. Yeah. But the problem is when you make that statement, Ruhif, 99% of your observations are taken over a couple of 100 miles. And you're claiming that an observer on the ground, you're claiming that an observer on the ground will notice this curvature. But yet you don't notice it at 2,500 feet. You don't notice it when you're flying 500 miles. You don't adjust for any of it. So explain your logic if that's not insane to you, because that is insane, just so you know, that you claim to measure curvature on the ground, but you don't have it up in the sky. That's an insane statement. I hope you realize that. Now clarify the position, please.
Oh, hurry up, Data. Fuck.
All right. Are you making observations that you can then analyze from your plane?
So what I notice is when I fly over the surface of the Earth, I fly off of the wind. I
Okay.
don't care about the shape of the Earth. I fly off of wind. When I do so, my job is to fly as parallel as to that wind as possible, as level as possible, regardless of the shape of the Earth. That's why I can fly up mountains, down in valleys. That's why I have total control of my aircraft and why I can actually fly the physical topography of the Earth. But the
But are
main
you
principle
making
of that
observations
topography
up
that
there
I
that you
fly
then analyze?
is horizontal. That's the main topography that I fly. Why? Because that's your object. You don't want to increase in elevation. You don't want to decrease in elevation. You want to maintain a horizontal position, right? So you can maintain a consistent altitude. This has nothing to do with the shape of the Earth. Again, your logic states in your mind, and keep in mind, you think you're sane when you say that as a tiny little observer on the ground, 6 feet, you can quantify with optics physical Earth curve, but yet they're not noticeable at the scale that you say so on the surface as it up in the sky. What would be your
Well,
logical reason for that?
in their
Are
model,
you
the
making
curvature is in
observations?
the sky. Hold on, Ruhiv, let me jump in. The curvature is in the sky in their model as well. But I
It would
actually don't.
increase in exponential, though. The higher
I
you
don't
go, it
think
would be
that.
more noticeable. If it's noticeable on the ground, it would only logically concluded that the higher you go, the more of that curvature would be noticeable. Because
Okay, now you're not. I'm gonna have to mute you so someone can respond because you'll just keep going. Okay, so what I was trying to say is that the curvature will exist in the sky. I agree with what you're saying with that. However, when we're dealing with airplanes, I think that it would not be any different on a globe because essentially they have gravity, which is their idea of that, everything clinging to the center, and then there is the wind, there is the lift that the airplane needs to require. But the amount of curvature that would be on the Earth would be minimal to the point to where you would just be adjusting for the wind. And then if their theory of gravity, which obviously I think is totally pseudo physics, however, if it existed in a kind of computer model or something, then there wouldn't be an appreciable difference that a pilot would be able to physically measure, and gravity would kind of pull it as it went around, right, Ruhiv?
I was going to ask Nato, has he made observations from this plane that we can analyze together? Or is he just like looking out going, oh, it looks
when
like
I fly at 2,500 feet, okay, and I have a bird's eye view, I can see at a certain square mile of surface. That certain square mile of surface, I can take a photograph. Now, if I go up to, let's say, 5,000 feet, it's even better. But if I have a bird's eye view and I use my camera and I have I have a flat 2D image of that surface of Earth. From that 2D surface of Earth, I can look at from left frame to right frame and have a distance of over 20,000 feet between the 2 points of the left frame. And notice there is no way that an observer left of frame, being the bird's eye view looking at this image, if you will notice curvature dip or drop between the right frame. Why is that? It's because when you look at these bird's eye view pictures and you're looking down at Earth directly, they're using straight lines and angles. That's why it's all square images, right? You don't have any curvature. So you can take that image. What you can do with that is you can actually turn it into a map. Ironically, guess what happens? It looks just as we see it, bird's eye view, as we do in a map. But more importantly, Ruhiv, if I fly that map, I fly it as I took in a photograph of it. In other words, there's only distance and elevation information. In other words, I only have to fly in the air at a horizontal position to gather that information, meaning that from position point A to point B, I don't have to navigate over a curved surface. The problem is if I make that statement, you want to then include that if I go higher up in the air, that it would be the same as a ball, like Geo stated, while ignoring the fact that you're on the ground, claiming you can measure curvature, would only mean scientifically and factually that if you increased in elevation, there would be more noticeable curvature. There'd be more noticeable dip drop. There would be more noticeable y-axis and x-axis and y-axis curvature. Wouldn't
it be less?
That would be more. No, it would be more because you're noticing it on the surface.
Because in the center,
so if you're noticing it on the surface,
no.
Think about it. If you see a hill, if you see a hill in front of you and it has curve, and you drop in height, you're only going to see more of how that curve of that hill drops down. That's it. You're not going to see less of it. You see more of it. So if there's an x-axis curve or a y-axis curve local to the surface of the Earth, it would only indicate the higher you go, you see more. And the ironic part is you don't at all. What you see is the outward of the extension of the land. That's what you see.
Have you finished?
Well, explain to me the non-insanity with claiming you can measure curvature of the surface of the Earth, but there's no curvature at 2,500 feet. No noticeable curvature.
Okay, you've asked your question. For the third time, have you taken observations from your plane that we can analyze?
So the observations I'd be taking would be no different than taking on the ground. They would be optical, they would have an
yes or no?
optical convergence
That's a
point.
no?
Yes, I have video footage of it, but you're not going to
Okay,
get
have you
angle
analyzed
measurements
it?
per se. Yes, there's still an optical
Okay.
convergence, which is optical, which is there's no real convergence. It's due to angular limitation. That is the effect of optics. Cameras should teach you enough that what we're seeing is an optical illusion and apply it to your own fucking eye. If you haven't done that, then I can't help you. But there's a vanishing point. There's an optical illusion there. That's not a real angle. Refraction, apparently, refraction of light exponentially increases as it closes together or moves away from the observer. The intensity over the distance squared is no different than the 0.666 squared mile square 0.666 feet per mile squared. You can quantify it as such, but the problem is that if you change the optics, that formula fails. That's how we know it's an optical formula and not a physical geometrical formula. It's because you can falsify it.
Do you have one of these observations that we can analyze? Are you claiming that we see too far in one?
Okay. So again, I just told you. Now, if for some reason you want to glance over that statement that Penis made, Paid Shell. There is no adjustment for curvature at high elevation. You agreed. It's negligible, is what you said, which means I don't account for it. Then you say, well, what are you expecting to account for it? And I just told you, the only thing we count for it is the 60-to-1 rule, unless we have direct wind directions that are, pretty intense. Then we can account for our heading direction change if we do some calculations based on the direction of the wind. We can do that stuff, but that's mostly the function that we do at 2,500 feet, 2,500 feet, 5,000 feet, which is peanuts. But you're telling me the only thing for me to notice the Earth curve is I got to get into a bigger plane and travel a farther distance. But yet you're telling me that a 6-foot person can measure curvature on the ground. It's absolutely insane. You have to realize that's an insane statement.
When you travel a long distance, you will need to take a route that is not on a flat map, right? You'll need to take a great circle
They're
route.
all flat maps, Ruhif. They're all flat
They're
maps.
not.
They have no diverging verticals. It's all distance and horizontal distance and vertical information. That's it. It's exactly what we observe. So while the globe could be 2D surface, could be flat, as you suggest, there's no dip or drop or curvature, Ruhif. There's nothing.
If I gave you a start point and an end point, could you map a flight route on a flat map?
So what I know about wind, is that it can change your speed, therefore change what you think the distance is over time. Right? You can do all these calculations and all of these variables. Fine. You claim that you think that these maps of our world are correct. I will say they're not, Ruhif, and I'll say that you've never hopped behind a commercial flight and you've never entered coordinates and actually as a pilot studied those K coordinates to figure out what the original coordinates are. You've never done that. Nobody has, because there's over 1 million calculations they use to devise these route plans based on weather patterns. So it's not based on the shape of the Earth, Ruhif, it's based on weather patterns.
So a flight from Sydney to Johannesburg, does that go over India? Show me a map.
You can have any flight you want. I don't know what the map of the world is, Ruhif, and I can tell you that you can manipulate up to 3 to 1,000 miles, which is pretty significant if you want to travel distances. So there's not actual truthful known distances I can verify right now with you. All we have is a bullshit story, buddy. And I have to believe authority because you tell me.
You don't have a map. Okay.
Listen, I have a local map that I can use that backs up my statement that empirically over 500 miles, there's no dip, no drop, no curvature. The map shows it. I can empirically see it. And I have all the information. I have all the information to substantiate empiricism, which is distance and elevation information.
What did you say, Ruhif?
I'm saying he's a very difficult person to have a back and forth conversation with.
I know he's in that category with like Zanuck and some of the sometimes Brian Leaku, or it's almost like you have like a mod has to just literally mute him every time because they'll just overtalk and it's
and just talk too long.
He does overtalk a little bit. He likes to pile on points, if you will. And you're trying to respond to point 1 while he piles on point 2 and point 3. And then he feels like he's interrupted, so he feels like he has to pile on 2 more points, and it can just be interminable.
It would just be nice to concentrate on one point and then, hopefully settle it. Not that that's going to happen, but,
So the one point is, Roof, if you agree that when I'm up at 2,500 feet flying 500 miles, that I do not have to negotiate a spinning ball Earth. It's negligible. You agree with that, correct?
Yeah, that was the original kind of point you had brought up. And then your evidence for it was your own optical experience, right?
It wouldn't be just optical. It would be instrumental. It would be map formation. It would be gyroscope information. It would be empirical observed reality. It would be repeatable. It would be demonstratable. And you can actually probably do a few tests to prove it, which means you could fly over this location back and forth, left, right, and center with a whole bunch of planes and never adjust for Earth rotation. Never adjust
my
for
daughter's up
curvature.
early, so I have to go. Hey, chicken.
Day today.
Excellent. All right. Thank you. See you soon.
All right, later, Roof.
And just for the record, I'm not saying that proves the Earth's flat. I'm just saying that that's what empiricist reality is, and that's what we navigate in.
Right, but I mean, you think that in an airplane, there's a way to tell the difference between whether you'd be dropping 8 inches per
It
mile
works
squared
off of air.
once
It
you
works
have,
off of air. The plane works off of air, Geo. It doesn't give a fuck the shape of the Earth. The gyro is meant to help us be rigid in 3D space so that we can fly straight past, so we can fly curves past, so we can fly up valleys, fly down valleys, fly over mountains. It's allowed us independent control, and it does not care the shape of the Earth.
Well, more what I'm asking is not really what your opinion of it is. Like, okay, what test could you devise that would denote in an airplane,
not my
any way to
opinion.
test it in an airplane that would allow you to differentiate between an 8 inches per mile differentiation of the ground?
I have a
versus
map.
Other factors.
I have a map. Here's my proof empirically. It's just demonstratable, repeatable, and you can do it yourself. Take a map, have a known distance between those two locations, fly your course, correct for every 60 nautical miles for that 1 degree, which is like Euclidean. The map that you're going to be drawing on only has distance and elevation information. The operation of that aircraft is horizontal. Ideally, you want to fly the plane at 2,500 feet, and that's only possible if you keep it horizontal, because without that, you can deviate. So this is why the gravity has no effect on curvature or bending, because you can elevate, you can raise in height and lower in height, which means you have total control over the plane because it flies in the air. It has nothing to do with physical shape, gravity, curving, bending, nothing. It's a little point in 3D space that has its own orientation. And by the way, without that natural stated function, you wouldn't be able to fly over anything. You'd be crashing into the ground or flying up too high.
Well, when you have to keep lift up against wind in an airplane, that's enough of a task in and of itself. So yeah, I think it'd be pretty tricky to find a way to measure the difference between all of that and an 8 inches per mile squared movement, especially if like the way they claim the gravity is all clinging it to the middle. It'd be interesting to see a test that would be able to delineate that, but I think it'd be very hard to do. Even if you had like infinite funds and resources, I still think it'd be pretty hard to actually.
So wait a sec, Geo, there's maps, right? There's maps,
That's right.
500-mile maps, easy.
Yeah.
You're telling me this map I have to prove curvature when the map itself tells me how to navigate it, which is horizontal.
Well, that's
if
something
if I
different.
didn't,
If you're talking about horizontal travel over a planar surface and distances, that's different. I was talking about the actual airplane itself and the drop that the airplane would have to make.
they're meant to work off of
Distances is-
The
air.
instruments are there, though.
They
Gio,
they
the
have to be
instruments are there.
independent of any gravity, any surface, anything contoured. They have to be independent, or else it wouldn't work. How do you trace?
Yeah.
How do you have a baseline or measure anything if it doesn't have its own point? What are you going to measure it against? How do you know to fly over a valley or up and down a hill? You have to have a base point.
Exactly.
That's not created. That's
The
not created by the
instruments.
shape of the Earth. That's created by the individual device.
Yeah, the instruments. Look, everything that this man is telling you about flight and the instruments is bang on the money. The experts are telling you the same thing, that in the flat and the curve, that, you know, if you subjected the instruments to a curvature Earth, they wouldn't work. The plane's attitude would have to
That's
change.
not
and everything
necessarily
else.
that's not necessarily true. It just depends on how the surface is. The idea is, if you were to have such a curving Earth immediately like that, then it should be noticeable. You should be able to.
Yeah.
If you're telling me 16 feet, people can measure a different drop in curvature, which is 3 miles away, then these instruments should show it, but they don't.
Yes.
So we know the difference between the optical vision and the physical reality, and the physics doesn't match the.
Exactly. The instruments would tell you. The plane's attitude would change because you're in a 3D world, you're flying now. And like you said, with no instruments, you don't know if you're horizontal, flying up, going down, you don't know. You're lost. You're blind.
Oh, God.
That's why the instruments are there.
All right,
Guide
Dave,
you.
this is going to be the best conversation you've ever had with Jin and Data. Are you ready? You guys
Yeah,
you're all going to be
fasten your
civil.
seatbelts.
You're all going to be civil. You're not going to interrupt each other. You're going to blow our minds with your knowledge. It's going to go
Are
perfectly.
they talking about airplanes again?
Blow
we
our
need
minds with
your
our
expertise.
knowledge.
Hold on. Yeah, we need your
I don't have
expertise.
knowledge. I'm just regurgitating what I learned.
12:30
Tell me
at
how.
night.
Tell me how I can use a gyroscope to prove Earth curvature when in class they tell me that I can recalibrate it, but that's due to just velocity changes of the airplane. And then I apply the 60-to-1 rule, which is wind drift. So tell me in class, please, where do I navigate for a spinning ball Earth?
Well, the Discord user who has chosen the name Paid NASA Shill claims to have his certification and is a pilot. So maybe he could enlighten us as to how the curvature is taken into account. Oh no, you're Sky Push now, dude. Sky Push is a cool name. I saw that earlier. That's actually awesome,
Sky
dude.
Push.
You're no longer. Yeah, you should no longer be Paid NASA Shield.
You're thanking me for that, right? I break your balls so bad the other day you had to change your name, huh?
No. What happened here is that gravity is no longer a thing. Pull down isn't a thing from now on, according to people in the server. There is no such thing as down pull. There's only push from the sky. That's Sky
Hell
Push.
yeah, I love it, dude. That's awesome. That's definitely what's going on. It's both, really. But
So
yeah.
what don't we understand about? Are we doing the typical flat earther dip the nose?
Hey, Chill, didn't you tell me the other day that when I fly at 2,500 feet, 500 miles, that I don't have to account for curvature? It's negligible. Do you remember saying that?
Yeah, I remember, because you're flying at 2,500 feet at 70 miles an hour. Barely overcoming pigeons, but
Can't I go 80 miles an hour? What if I go 80 really fast? Pop the engine full core.
80 miles an hour. I don't know if you can handle that. That's a lot of speed. See, what happens
Come
is
on,
then you have
come on! I got up to 150.
How about
I got up to 150.
how about you land at a real airport and walk over to the side where the big boys are and get on the airplane and go somewhere far away.
Do I actually get to look at the actual data? Like, do I actually look at the coordinates when I enter in? Do I or do I just operate over a plane surface that doesn't rotate, just like when I asked the pilots?
Okay, what did you ask the pilot?
So one pilot I have on video, I went up to him and I said, "Hey, look, I just wanted to do an observation here with a protractor." And what I decided to do is, when you announced that you were landing, I decided to calibrate my protractor to the airplane in 3D space, hoping that when you land, I could prove that the plane was at a set degree. And I said to him, "You landed, you came to a halt at the airport. Guess what the protractor said that you were at cruising altitude, what the angle of the plane was?" And he said 3 to 4 degrees. And I said, "Yeah, basically." That's what the protractor said. And I said the reason for the observation is because over 700 miles, or even an hour before descent, there'd be some way to detect curvature. There must be some way. And he goes, you're right. There should be some way, but there's nothing. That's what he said. And then he said that, and then later on, when I pushed a little harder, he said, well, I needed a special gyro. And then we ended the conversation after that.
Well, you don't have to push the nose of the airplane over. That is a great flat Earth misconception.
So just so you know, the observation, Penis, was to highlight this, that I could calibrate the device of the aircraft in 3D space, which would match the gyro, because the plane would be tilted 3 to 4 degrees up, just like the protractor calibrated. It was about 45 minutes before descent, right? So when he announces that we're about landing, which we're at cruising altitude, I calibrated the plane because I wasn't going to record the protractor for 3 hours. Although I did have it up for a period of time, it just all it showed was pitch of the aircraft. That's all it showed, right? Which you would expect, as suggested, as it flies over a plane, how you would operate a plane, which would indicate elevation and elevation changes in the pitch of the nose, which is, that's what you learn.
Yeah, how about that?
So the airplane flies at 3 or 4 degrees nose up. Okay, gotcha.
Before you came in, dude, we were actually talking about, like this whole thing. So I was saying more actually the globe side, that I don't really think you'd be able to. I mean, if the globe were a globe and the gravity and the whole thing and the way that, the kind of what I would call pseudophysics, but let's just apply it to a model and say that it's real. And then you've got air and air currents and lift and everything going on in the environment, the weather, all of that. The 8 inches per mile squared would be so minimal with the gravity kind of pulling you around, as it were, that not only do I think a pilot would not be able to decipher.
You have to first prove the gravity and prove the 8 inches, Gio, before you beg the question.
I think that it would be. He was just rudely interrupting. I was trying to finish what I was saying. And actually, what the reason I think it'd be even difficult to know, because I was saying to Data, he never really gave an answer. And actually, I want to ask you, Skypush, as well. So, what test could you devise? Let's say the resources, the money would be, infinitely available, so as much as you would need. How could you actually test and decipher whether the airplane itself is curving in its flight or whether it's horizontal?
You want to detect that in flight.
Because that's what this argument's based on. The planar flat earthers are going to say, no, you would have to adjust for it, and we don't. Therefore, that the globe earthers often say, no, we wouldn't have to because of maybe some of the reasons I mentioned. You may have other reasons.
When you're level at cruising altitude, you stay at 30. I don't know, whatever you stay at that level, and you don't have to push the nose over. It just stays at that level as you go.
Because you're flying off the ear. You've created the right amount of thrust and pitch, so to keep cruising altitude, right?
Right, cruising altitude.
And so when you're doing that, there should be a way that the surface of the Earth, if it is dropping at a rate, because the plane, you have to beg the question that the plane flies straight. Now we know, in reality, we create these gyros so we can distinguish between, or we can tell the orientation and pathways. For example, I've already presented this to you. I've already presented this to you before, Penis. Is that if you take a drone, I can fly a circular path with it, and I can fly a straight path. Now, I'm going to ask you, can we distinguish between a curved path in an aircraft and a straight path in an aircraft? Yes or no?
Yes. Well, straight path meaning straight over the surface. Yes.
So listen, like I said, like with a drone, it works off the same principles as an aircraft. It works off of propulsion of the air, thrust, and all that stuff, drag, all that stuff. Works the same principle. Well, I mean, laminar flow is different than the drone. But anyway, the point is that it works off of the air, right? They work the same way. The gyro works the same way by giving its orientation in 3D space. So you can actually program its routes. So if I take a drone and I want to program a crazy route with it, like curves and all kinds of crazy patterns, I can do that. And then on top of that, I can take 3 drones and make them a perfect triangle and move in perfectly straight lines. And then I can show you the actual digital path that's recorded in 3D space. In other words, I can clearly, with the gyro, distinguish between curved pathways and straight pathways. Just to clarify,
curved pathway, curved over the ground.
So, okay, just if you will, there is lots of drone footages online, drone fireworks, if you will. That's probably the loose terminology for it. You can go look at all these drones fly all these crazy hyperbolic pathways. Then you can look at them fly completely straight pathways. The point is that they're measurable, noticeable, recordable, demonstratable, repeatable. My question to you is, when you look at the path that is straight and you look at the path that is curved, in your model, you can't have straight pathways because you live on a geodesic model, which means all straight lines are curving. You must have that. That's bending a space-time. Are you telling me that the curved paths are double curved in that concept? How are curved paths treated in space-time? If already straight paths are bending, well, your model has bending in space-time. Your geodesic model doesn't have
space-time. There's not a space-time meter up in the cockpit.
But I'm just saying that you in your model can't have straight lines because of bending space-time, right?
You have geodesics.
Yes, so you can have straight lines, but here's the thing:
the geodesic is the equivalent of a straight line in spherical geometry.
Okay, great. I'm glad that you said that. So in your model, you have what you claim to be straight lines. So my question to you is, if we're on your geodesic, if you're on your model, how do you quantify curved paths? Because I can demonstrate curved paths and straight paths. How can I get
change headings?
Yeah, but I can show you the difference between the two. In other words, I can control my reality regardless of your model. Your model is begging the question that you have to have geodesics. The WGS84 says there's no straight lines, that you have to have that based on the mathematics, right? That's what your model states.
The geodesic is the equivalent.
That's what your WGS84 is, a geodesic model, no straight lines. Okay, the point is that I can show you the difference.
The equivalent of a straight line.
Your model, geodesic, has no straight lines, right? It cannot have straight lines.
You just understand. You understand me that the equivalent of a straight line in spherical geometry is called a geodesic.
Yeah, but it's not actually straight lines, right?
Sure. What do you mean it's not straight? It is straight.
Well, no, because there's a distinguishing difference between a curved path and a straight path. Your model has to have curved paths for it to work. Now, my question to you is, in your model, if it already has curved paths,
it's a straight line. It's a geodesic.
Right, but it's a curve, right? Your straight lines are curved.
No, on the surface, it's equivalent to a straight line in spherical geometry.
If that is true, what I have not seen a calculation for curved paths in the geodesic. Where you're telling me that it's curved, but it's straight.
It's on Haversine.
Haversine's Euclidean, right? You're taking
Haversine
a circle.
Is spherical. It's not Euclidean.
No, you use a circle and a right angle triangle. Do you not with the Haversine? I have to go back and take a look. Okay, so if you're going to use the Haversine's not based on the shape of the Earth. It's based on the moon. That's what the Haversine was designed for. It's designed for the moon. So the Haversine. No, it was meant for the moon path, right? It was meant for the chronometer, and it was meant for they were using spherical trigonometry for the moon, and it wasn't working for them.
So hold on a second. Are you denying that if I'm flying from Los Angeles to
It's not about denying.
London.
Again, you have no validity. You have no way to verify your argument. You're just telling me a story over a path. No, you don't. I'll tell you why.
Here we go.
There's a million calculations for flight paths, and you guess what they determine? They don't determine the flight path based on the shape of the Earth. Guess what they determine the flight paths for?
No,
based on. Well, do you not know? You know aviation.
Oh, please tell me.
The fundamental one of the main calculations out of a million they apparently use, this is coming from the aviation site that I looked all this information up, it's weather patterns. They don't do it on the shape of the Earth. They do it based on weather patterns. Now,
weather patterns are important. Yes,
that's not a response. That's not a response. That's not bullshit. That's not a response.
Stop.
They don't do it on whether the Earth is curved.
Yes,
you understand?
They do.
No, they don't. They also have an initial. No, they don't. They also have.
Yes, they fucking do.
I do not. I'm telling you, they don't.
Do. Look, okay.
Hold on. Stop. The only transposition of the model is equations.
You're in the weeds right now, and you got to let me fucking talk.
Hold on, real quick. Paid. I mean, Sky Push. I have to step away for a minute. So, dude, I'm gonna give you a temporary voice mod role.
Give me.
Yep. Because I think if you guys are gonna keep talking, he's more likely to be dominating and not letting you speak. So mute him if you need to.
How do I do that? I've never been a
Well,
mod.
give it to me and I'll mute both of them, Gio.
I've given it to Sky Push. I'll give it to you too, Terry.
I've never been a mod.
It basically
Okay.
lets you,
Gio, I gotta test this. I'm sorry. I gotta test
it
this.
lets you server mute people.
Oh wow.
Yeah, I know how it works.
Sorry.
My
Oh,
Discord.
you did it! You muted me.
Yeah, I muted you just for a second, just to
Nice
see if it
one.
worked.
Just
Sorry.
give it a test.
I just had to
Test it
do
out.
that. I had to do that. I'm sorry. I only did for a second.
I want to meet Bandy one day for the fun of it.
Don't burn the house down.
I
either.
won't. I promise.
Yeah,
Okay.
we won't
Now,
light any fires.
I'll be listening on and off here, but yeah, I gotta do some stuff.
this
so.
is the issue. When you fly a long flight over the Earth, you will fly a great circle route. If you pick two of your favorite places, New York and London. You're not flying. If you look on a Mercator projection and draw that straight line on the Mercator, you're not going to fly that path. You're going to fly a path that curves north of that significantly, up over Churchill, up over Greenland, and down south into England.
Okay, so if you really want to try this game, okay, so let's do this. Let's pick a flight distance, right? And I'm going to take a right angle. I'm going to take a right angle triangle. I'm going to take a right angle triangle. I'm going to take a position. Let's say I'm in the United States, okay, deep south United States, and I'm going to measure my angle to Polaris. I'm going to get my latitude, whatever, right? I'm going to subtract it from a 90 degree. Let me finish. Here's what I'm going to show you, okay, that you can do in practicality for you. Now, I'm going to be honest here. There's a little discrepancy in the math, but it's off by 50 miles tops, right? Very peanuts in distance, but it's nonetheless off. Take any position anywhere in Canada or United States, get a distance to Polaris. Use Stellarium, okay? Get that angle measurement, minus it from 90 minus that angle measurement, multiply it by 60, and you will get the distance to it. Or better yet, multiply it by 111.31, and you'll get the kilometers to it. This is using a right angle triangle, a 90-degree right angle triangle, and I'm getting the distance between 2 points on a map. Okay? So please spare me.
You know that Stellarium is based on the globe, right?
Again, take a right angle triangle, pick any location anywhere in the United States, get an angle to Polaris, get an angle to Polaris, go to Stellarium, get that angle. No, it's not a flat Earth, first of all, moron. The Earth is not flat. You keep saying it because you hold on to it like it's a fucking cookie. Let go of the cookie, dude.
What do you want to call it then?
The Earth's not either you have to admit that people are living upside down for your model to work, okay? Because that's how you're going to get opposing.
People are
well, they're not. They're not. But for you, they have to for opposing rotations and opposite moon patterns, right? So if you don't think they're living upside down,
they're not living upside down.
Well, they're antipodal, right? They're antipodal, right?
Yeah.
Okay, and so this is your disingenuous nature. So antipodal is different than upside down. Antipodal is different from upside down.
If you've ever been to Australia,
antipodal is different from upside down, is it?
If you've ever been to Australia,
what is Australia considered? The upside down? Isn't Australia considered the upside down?
If you ever go to Australia,
isn't Australia considered? Don't they put men standing upside down in Australia? Do you ever see that do that to the kids? Their penis? Are you being this intellectually dishonest?
Okay.
No, we do that. We do that to you, don't we?
I was just say, do you feel upside down?
No.
Yeah. So there we go. They don't feel upside down in Australia. Let's see if I can unmute him now. I had to try to do that. I'm sorry. It was just a test.
So you just went off the senses, right? Yeah. Okay. So again, I'm going off of empirical reality. The reality is there's no upside down. There's no antipodal. You need antipodal for opposing rotations. That's what you need, correct?
Well,
that's the only way that you can explain it in your globe models to have people upside down to me.
How do you explain opposite rotations on the flat Earth?
Okay, so the one way you can look at it is if you and me are on the opposite sides of a highway and a car is going one direction, it'll appear to go in another direction to you, but it's actually going in one direction. It'll also appear to go another direction to me, but it's actually only going in one direction. Right? Do you understand? So perspective is an effect here. Now, I'm not saying that's the sole cause for the rotation. To be honest with you, I think Earth's flat space up there, and we have a lot of angular effects due to optics, and we have a lot of geometry we still have a lot to learn about. So I can't model the opposing rotations on a plane Earth. It doesn't work. But if I think, what I'm trying to model is reverse and engineer the globe. That's what I'm trying to do, which is take two opposing rotations and lay it over a plane Earth. That is the red herring. That is the that is the misdirection they want to go in. The reality is it could be flat space with two opposing rings, and the way optics work and with refraction, you can have the same surface. Now, can I model it 100%? Not exactly, because I'm not that skilled in precise. But what I've noticed is that you can use right angle triangles to find locations on Earth easily by taking the angle, subtracting it from a 90 degree, and multiplying it by 111.31, which is the conversion of kilometers, and you're about 50 kilometers off. So there's a slight.
Thank you. Welcome to the globe. That is a globe calculation.
Yeah, it's a right angle triangle that I use, and
It's a
while the
globe
distance it's a right angle that I use. It's using a hypotenuse and a right angle triangle. The hypotenuse is a straight line.
Using the 60 nautical miles per.
I use 111.31 kilometers.
Okay,
No,
fine.
it doesn't matter. It's just a unit. It doesn't mean the shape of the Earth, buddy. Good luck to you.
Actually, it does, because
It
there's
doesn't.
no way.
What it means.
Hey,
what it
did you see what
means.
Terry posted at 58 past the hour?
Yeah, so here's what you got to
That's
do.
what it
Take
would
your
look like on
car.
flat Earth.
Take your car. Use a right angle triangle. Okay. When you
This
find
is a
that you
globe
move, when you
calculation.
find that you've moved 70 miles from one
Welcome to the
location to
globe.
another, you're using a right angle triangle. Do you understand that, right?
This is a globe calculation.
Okay, so again, it's not, and you just invert the triangle because it's either the position of the heavenly bodies.
How and why does the change 60 degrees?
You can invert it. Listen, you're
look at-
being
did you-
disingenuous.
did you
You
see
can
what
invert
Terry-
it, yes or no? Can you
No, you
invert it,
can't.
yes or no? Can you have the
can't
top
invert
of it go?
It won't work on here. Do you see the
It
thing Terry
totally
posted?
works fine.
Did you see the thing?
You're being disingenuous. If you flew a flat
That's not
circle,
being disingenuous.
Did you see what Terry posted at 50 past the hour? That is what would happen on the flat Earth. It will not be the 60 nautical miles, 111 kilometers per degree on the flat Earth. That is a globe calculation.
Okay, so there's many ways to devise this circumference that we're dealing with. It is a flat circle that is in the math. The flat circle has a circumference size that can be broken down into radians and degrees. It doesn't matter. The point is, it is a circle and a right-angled triangle. So whether you apply the right-angled triangle to the heavenly bodies or invert it to the center of the Earth,
no, this is
it's not. No, it's not a response. Let me finish, please. You can invert the information and you can have a flat circle equal the same degrees. Now, whether that applies linearly to the surface of the Earth or angularly to the surface of the Earth, that's going to be debated. It's also debated in your own model. In other words, they claim that stop saying no, that's not a response. They're claiming that
wrong.
It's not an argument, dude. 1 arc minute is 1 nautical mile.
This
but
is
let me
a
finish.
globe
But
calculation.
it's not. It's using a
It
circle
is.
and a right angle triangle.
No, it doesn't
It
work.
is not.
You
can draw a circle. Listen, you guys are disingenuous.
It does not work on the flat Earth. Do you see what Terry posted at 50 past the hour?
Yeah, let's talk about that one.
That is what would happen on a flat Earth. You would not get what you say you'd get, because not only that, but then you'd have to have you'd have to start invoking what are they called? Individuals, the visual domes.
Personal dome.
Yeah,
Personal domes.
That's it.
Here we go. Coming there.
Yeah, it's simple.
So again, you're correct, and I can use a right angle triangle. There is a website you can use. You can have 2 known distances between them. You can make your star measurement to Polaris. You can take that angle measurement, Polaris, whatever latitude you're on. You can minus the 90 minus that measurement, and you get the distance to it. Plus, less or minus 50 miles, which you can add in some refraction if you want. 2.5 degrees of refraction over a distance of
2.5 degrees of refraction.
That's
it's
a
just
shitload.
peanuts. But that, yeah, it is a shitload actually over a few thousand miles. But the point is that's what's required roughly to get maybe compensate for that extra 50 miles, right? Let's say, or no, it's not that. I had to go back and look at that. The point is that you can use a right angle triangle to deduce these 2 points, and you can do it plain as day on a Mercator map, no problem. Even though it's a projection of the globe, it's still using a right angle triangle between 2 points. That's the whole point of it. So if you want to say that it's a globe projection and I can use a right angle triangle, well, it's just proving that it's the surface quantified flat, right? Distance and elevation. That's what's observable. That's what's practical. That's what's used. That's pragmatic in applications of.
It's not what you use. Fuck me.
Listen, when I use a conical map, I'm worried about right angle triangles and circles. That's it. Circle, circle, circles, right angle triangles. That's it. I want to make a triangle actually, and I want to make circles. That's all I want to do. And why that's important is because it's a simplification of navigation. If it was any more complex, you wouldn't be able to crunch the numbers over curvature of a ball. It doesn't make sense. Again, I'm talking about operation of a single pilot, 152, 25 to 5,000 feet. You don't account for this ball, so you have to understand my position. I don't account for it, so you have to understand my confusion. And then when I hear the argument, that guys on the ground can measure it and ignore optics, interesting. And then on top of it, guys, just to finally before I'm done, every single sextant manual gives you a refraction calculation, not an Earth curvature calculator. It's just square root multiplied by the square root of the observer's height multiplied by 0.96. Now I'm going to ask you one question before I'm done. What is the 0.96? Because it has everything to do with an angular measurement. But I want you to tell me why they used it for refraction, the 0.96.
Yeah, I've derived it.
So we've got to answer questions, but we're not.
They derived it by optics, Ruhif, not by the shape of the Earth, buddy.
Yeah, because you're looking up in the sky.
Right, if I may,
it's because the ground appears to rise up to the neutral point. Appears to, right? So they have to. Yes, don't stop with the no. The apparent convergence of the sky and ground. Later. Yeah, again, you have no argument. Right. The apparent junction of the sky and ground. The convergence of the sky and ground is optical. You do see the apparent junction of the sky and ground called the horizon. It is not a physical location. That's why it can change based on weather and optics. You must come to this conclusion at some point, and that if we traverse over this land of 16,000, 20,000 feet, there is no dip or drop. You are quantifying optical illusions. You must realize.
Right, if I may interject, everyone's talking. Can I now get in onto this conversation for about 30 seconds?
Before you do, Jin, I'm just going to say this to Ruhif. Ruhif, over 10 miles, I can estimate 5 minutes of arc refraction, and then over 100 miles, let me finish. Over the surface of the Earth, if over 10 miles, I can estimate 5 minutes of refraction. Why? That's what's in the papers. Over 60 miles to 100 miles, I'm looking at 60 arc minutes of refraction. Okay? This is what is in the papers for refraction. So if you want to apply that Euclidean,
stop using so many words. Get your fucking point out and then stop.
Don't tell him how to speak. Excuse me. Now it's my turn. Shut up.
Jen, this is a common thing. I've always wanted to mute you. I muted you just because.
Sorry, are you a mod?
I am a mod.
This is a mod area.
I am a mod for it, and I have always wanted to mute Jen. And I just muted you, Jen, just basically because I could. Okay, I'm sorry.
Sky Push Hard here was shocked when he was asked to be a mod.
I'm going to make a disclaimer now.
How did you get mods?
I'm going to make a disclaimer now. Hang on, it's my turn, please. My turn.
Keep that up, Ruhif, and I'll
the man that was speaking. The man that was speaking earlier. Hang on, ladies and gentlemen, if you're paying attention, those of you in the live chat, the man that was speaking by the name of Arbiter. He's a man of impeccable integrity. He's explaining to you exactly how aircrafts fly in a 3D environment. He's absolutely correct. Ruhair, on the other hand, hang on a second, I haven't finished. Ruhair, on the other hand, is worth less than the toilet paper in your toilet. Don't even worry about that guy.
He's not that bad. But you know what? He's been called out for some integrity things. Ruhif, you both, Penis and Ruhif, agree that up at 2,500 feet, flying my plane 500 miles from point to point, it's negligible that the Earth has curvature and rotation. You both agree on that.
That's correct.
So guess what? Welcome to what you would consider a flat Earth. Okay.
Now again, like I said, get your little airplane, go fly to a real airport, go over to where the big boys are. Get in an airplane
Yeah,
and
no
fly
problem. Yeah,
from-
I'll still just enter coordinates. I won't have anything to do with the operation of the calculations
Actually,
because
they
I would
will.
I would fly
No
based on
problem.
weather, not on the shape of the Earth, but
No, you
based on
fly in
weather.
the shape of the Earth.
Ruhif, I got a question for you. You like modeling, right? I got an observation for you. So
I'm trying to
in
get out
your
a question to you from a couple of minutes ago.
well, you like modeling,
That
right?
don't mean any shit.
Yeah, but
So
as soon as you ask me a
have
question, I'm going to get my question out from a couple of minutes ago. So
sure.
Yeah,
ask your
don't
question.
worry.
So you like modeling the ball Earth. I want you to model the ball Earth and then put a gnomon at Perth. And then I want you to show me how you can get 120-degree sunrise on your ball Earth.
Thank you.
Okay? That's
Easily.
all I want you to do.
There you go.
So put a
Easily.
gnomon. Okay, I want to see it. I want to show me it and make sure that when you because I tried getting Jem to do this and he pulled a fast one. He wouldn't set it up the way that I demonstrated. So just correct me. I'm just going to tell you how I set it up and tell me if I'm wrong. Okay. I'm looking at my observation.
What degree?
Right?
Though? What degree?
Okay, so basically you're going to look at January 21st in Australia.
Yeah. What degree?
Okay. Well, here's the thing: your model won't match sundial or suncalc.org. Okay, so suncalc.org will say the sunrise will rise in Perth at 118 degrees. Okay,
Yeah,
this is
okay.
January 21st. I want you to put a protractor on your ball toy, line it up 90 degrees to the pole, put a gnomon, a little stick in the ground, just like you would in real life, right? We're just putting a stick. We're not angling to Polaris here. We're not trying to make it parallel to Polaris. We're just putting a stick in the ground, and we're going to get a shadow angle. And I want you to show me how you can get with the 23.4 degree tilt. I want you to show me how you can get that 120 degree shadow angle without tilting your Earth more than 23.4 degrees.
Yeah, I'll check that. It sounds about the limit though. 118 sounds pretty high. But you understand that I can get like it will rise south of
you'll
east,
never.
right?
In reality, is different than the toy model. Is the point? What
No,
I'm
but
going to tell
in a
you.
globe model,
What I'm going to
you
tell you
understand
is
I
your
can
globe
get
model.
greater than 90
globe
degrees
model,
south of east.
Your globe model does not match shadow angles on a plane Earth. They would be off, correct? All I'm saying is if you can take a toy model or your 3D program, put a gnomon right on Perth, put the sun right on that equatorial plane, have that Earth tilted at 23.4 degrees, you will not get 120 degree shadow. You won't get it.
Do you agree that I can easily get a sunrise south of east on a globe?
I'm not worried about south of east sunrise. I'm
Okay.
worried about the degree. On your ball model, it ends up to be like 140, 150 degrees plus. If it's January 21st, you're not anywhere close to 120 degrees, buddy. So, and that's 120 degrees. It's way more.
Huh,
your shadow angle is way more than 120 degrees. If you live on a globe model,
did you count for magnetic variation?
This is just sun and shadows, buddy. This has nothing to do with a compass.
Magnetic variation.
This has nothing to do with a compass. It's a stick in the ground watching a sun shadow, bud.
I think.
Keep in mind, sun shadow has nothing to do with North Pole or my compass. I'm not using a compass. I'm using a stick in the ground and the sun. And what I'm doing is.
I do think that do
your geographic north. No, do your geographic. You do a geographic north. Just your toy model is a geographic north. It's not a fucking magnetic north. So use a geographic.
20 degrees off.
It's more than 20
use
degrees
less
off.
words, Data. Less words. Right?
Can you be smarter and realize that you're insane for thinking that you can measure curvature on the ground and a plane doesn't see any?
Anyway, I want to ask you the question. What was the formula for refraction to the celestial object? Because you said 0.96 something.
No, this is just in the sextant. This is to get your horizon, right? The apparent distance to the horizon is a refraction effect. All the formulas are saying they're refraction. Yeah,
horizon
due to refraction. That's what the calculation's for. That's why it has an exponential in it, because it's not based on curve of surface of the Earth, bud. It's based on optics. That's refraction.
We're talking the formula to get the dip correction, 0.97 times the square root of
so
1
here,
feet, right?
if you don't want to use the exponential parabola function, which is square root of anything,
so many words
you can do this one. Just over 10 miles, add in 5 minutes of arc refraction, vary, and over 110 miles, add in 60 arc refraction. This is what the papers say. So why don't you go look at what the papers say for arc refraction and then apply the square root calculation, see if there's a correlation. Interesting.
Right. Do you realize that I've derived that
here's
formula?
the thing. They're all rooted in refraction.
use
Do you
a few
realize that
words
I've
when you
derived
speak,
that formula?
Ruhev. Don't use too many words.
You
Ruhev.
did not come up with it. You didn't derive anything. You did
No,
not make it. You did
not
not
me
invent it.
personally. I have
Of course you didn't.
replicated
It's
the
all in the
derivation.
It's all in the sextant, dude. All you have to do is look at the sextants. Go look at a whole bunch of sextants information. It's
Yeah,
all there.
I have,
You did not
right?
create anything. You did not derivate anything. The
But,
hijacking of
Jesus,
it, though, Ruhev.
data.
The
Stop
hijacking of it.
using so many words.
The hijacking of it, Ruhif, is the square root of the observer's height multiplied by 1.22 is an optical refraction effect calculation. It isn't based on physical geometry. Do you know how we know that, Ruhif? I can break that calculate. Okay, so if I look at the size of the Earth, 7,918 miles, or if I better yet, if I take time, 60 by 60 by 24, I can quantify a circumference.
Jesus.
Now, do I know the
come out?
Well, it's all from time. You want me to break it down? It comes from 60 by 60 by 24. We live in a 60. Fuck, what do you want me to tell you? We live in a 60 by 360 system. We didn't invent the fucking numbers, dude. I can show you that all these sacred numbers, geometry numbers, are telling us the distance to the stars. It's not based in science. You're telling me sacred geometry is based in fucking science? Give me the fucking break already, buddy. Just for the record, I don't care if the Earth's flat or a ball. I'm just about the truth and truth seeking, and finding intellectual honesty and people who are in that order.
Thank you, the arbiter. That's the arbiter speaking. Brilliant. Everything he said you can take to the bank. A man of impeccable integrity. He's even telling you he's not arguing the flat earth, he's arguing the situation. And when you look at it, it leans to the flat earth at the end of the day. These guys,
well, Jin, the flat earth, listen, it's about a two-party system. Jin, it's about a two-party system. We don't live in a two-party system world. We don't live in a two-party system, dude. It's either good or evil. Good or evil, that's it.
Let me just finish what I'm saying. Now you have the man called Ruheth. He's worth less than the toilet roll in your paper, okay? So you can just flush him down the loo. And as for Push Sky, who is actually NASA shield, if a man has to change his name to survive, what good is he to you? Okay? There you go, ladies and gentlemen. Welcome to the Flat Earth Truth.
Well, Jin, in fairness, I'm Flat Earth Data. I'm Flat Earth Data, but I changed my name to Arbitar, so you can't come after Paige Schill for changing his name. I changed my name because mine's the worker. Yeah, I did change my name.
You need to just have some standards. Have some standards, yeah? Because if you was in my server, if you changed your name, you'd be kicked out immediately. Because I don't want my listeners having to work out who's speaking once they've acquired a name for a particular voice. So if you're going to start changing your fucking names, you're gone. Have some standards.
Well, you
yeah?
know, if you want to do that, there are settings to do there are settings to do in the server that you can prevent people from doing that.
At the end of the day,
look, he's mod for 10 minutes. He knows all about it already.
Coming in with your new names, you got your standards.
Because there are
got no coherence. You're lost.
There are some servers
can't even
that
have a
will let
name,
you change
ladies
your
and
name.
gentlemen. Can't even have a name. Having to change their name every second, ladies and gentlemen.
Yeah, well, it's a permission on the server. It's a setting. You can allow certain roles to either change their names themselves, like change their nicknames. And then you can also give mod permissions that mods can change people's names for them and like override their own name change,
24/7 does that.
Yeah, but have some standards for yourself. Have some respect. Have some standards. And keep your name. What's going on here?
I'm not allowed to be in 24/7. They booted me because I break their balls too much.
Well, don't break their laws then, unless their laws are silly. I mean, I'm a member. I've been banned 3 times.
I don't break laws, man. Breaking laws is a waste of time.
Well, I don't know if you want your freedom.
I break at least 3 laws a day. I drive my van with sandals on. Apparently, that's a criminal offense here in Canada. You can't drive your car with sandals on.
Yeah,
so
then you constantly break the speed. Yeah, and you
no, I don't really do that. I don't break the speed because I'm I don't have a sports car, man. I have no. What do you want me to see? What do you want me to rev up my 4-cylinder engine and drive like super fast, like it's cool or something? I don't know. I'm not a Honda guy.
When I say constantly break the speed, if it's at 30, you might be doing a 40. That's what I mean. I don't mean going berserk, but you break.
Oh, I'm crazy like that. If it's a 30, don't piss me off. I'm going 39, man.
Well, there you go. So you're breaking
In
the speed limit.
California, it seems like in California, about 15 miles, at least 15 to 20 miles faster than the speed limit is pretty much the standard everywhere.
Yeah, if you go to
There
speed
you
limit in
go.
California, you get hit from behind.
Pretty
Have
much.
you ever seen? Have you ever seen the series Kenny vs. Spenny? It's a comedy series about two guys who challenge each other through duels and, like, for instance, one guy had to wear an octopus on his head for a week straight. Right? There was a contest to
Ew.
wear an octopus. Yeah, but you know what he did? One of his like the contest was between two roommates, and what he did is he slipped the other guy some acid. So they had to, it was pretty funny. So, and they make these bets, right? So if you win or lose the bet, you have to do something absurd, like lick weird poop off a window or something. But Kenny vs. Spenny, it's worth well, I don't know about now. Maybe when I was a kid I watched it, but funny shit, man. Can be funny. Can be pretty. Two Canadian roommates that would like torture each other basically for a contest winner.
I learned something this week. I didn't know that Canadian pizza was invented in Canada. Hawaiian pizza, excuse me. Hawaiian pizza was invented in Canada.
And
Really?
pineapple.
Yeah. Some guy in Ontario put ham and canned pineapple on a pizza. I saw it on a list of Canadian foods, and I'm going like,
Yeah,
what?
was it ham or spam? Because
No,
that's
it's
the thing.
ham.
SPAM, spam, wasn't
Yeah.
it?
Yeah, it's not, it was
Yeah,
definitely
well,
Speaking of food, did you see what they did for now? They're taking insects and they're grinding it up in water and reducing it to fat, and they're putting in baking goods, and they're going around doing taste tests. Apparently, there's a perfect ratio of bug lard that you can add to the baking goods that actually taste like the real thing. But if you go slightly more, you can actually taste this weird buggy pasty flavor. Quite interesting, eh? They just did a survey. Like I watched them go out and handle all this food and do a taste test on it. Yeah, but apparently the right amount of
yeah,
bug
quite
lard, you
interesting.
can't tell the difference.
Chin lives in Japan. They'll eat anything.
Yeah, but the point is, ladies and gentlemen, you don't need to have lard in your diet. Okay, that's the thing. Avoid lard like the plague.
Well,
If
this
you want to
is
be
bug
healthy.
lard.
Well,
And
not
have some longevity.
there's a lot of different viewpoints on that, Jen. Like what you talk about saturated animal fats in general, or
Way better for you than bug
I'm talking
saturated
about
fats.
saturated fats, animal fats, yeah, because they do clog up your system. If it's clogging up in room temperature, you don't want it. That's the thing. But if it's liquid in room temperature, then that's fine. That's generally
yeah.
policy.
I would say it depends on what species. I mean, if you're talking about like a domesticated pig, yeah, that's a pretty toxic fat. But if you're talking like wild moose fat or elk fat or something like that, that's a whole different thing. That's the real.
Yeah, I would agree with you there because the nutrients from out in the bush there, yeah, absolutely different.
And the actual these animals,
apparently our brains need it.
The animals have been genetically modified so that the fats are actually damaging to the human body. Like the actual fat is modified through the modification of the animal.
Yeah.
So yeah, so like
Thank you.
pig fat is like a GMO fat essentially, versus like in my
That's
viewpoint,
right.
versus like let's say a wild animal or something that was.
No, I would agree with you there. I'm with you on that one, definitely. Wild boar, beautiful.
Yeah, like wild deer.
Wild deer, again, beautiful. Yeah, no qualms there at all.
It's kind of addictive though. It's almost like a damaged fat. It's like addictive. That's why people love bacon and all that so much. And it is kind of like weird, and it is kind of good in a weird way. So.
Do you know what's weird about it though?
Not natural.
I don't know if it's weird for you guys, but when you kill something, you like for me, when I've killed something and ate it, I don't feel I feel kind of weird a little bit. But here's the thing: when you're really hungry and you kill something, you don't give a fuck. Now explain that.
Well, yeah, because you're, of course, you're hungry. You got to eat.
No, I'm telling you, even if I'm hungry, like I've killed things before, right? In a long time, been a decade at least now, hunting and things like that. But when you do it, you first week is kind of hard, right? Because you do it, you're like, okay, and then the feeling was like, okay, you get it, you're killing things, right? And you're gonna eat them, take their fur, whatever.
Yeah.
But then here's the thing: if there's a switch, because when you come from city life into it, there's a little bit of a uneasiness to eating it. But ironically, you can
Yeah.
have somebody else do it for you, prepare it, and eat the same thing and totally feel completely different about it. So that psychological effect of killing something and eating it, for me, it required an adjustment to enjoyment. And the significant fact was when I was really hungry from pedaling through the bush and then coming across and like getting the jerky, better yet, just shooting some grouse, cleaning it there, stepping on the wings, pulling the legs out, popping it, washing some water, mustard on a bun right there in 15 minutes. You have no qualms about doing that. It's like almost secondary, the motion, the action, the process, and the enjoyment. And the enjoyment with it is like, wow, this is sustenance, this is life, and the fact that it has, fed off of the earth. There's nothing pollutant to it. It's just
Exactly, satisfaction. You've done it naturally.
more natural, one more natural
done it.
process to do it. But there is a little bit of of that shift going into the urban world. I didn't notice it so much when I was younger because we were hunting all the time when you're younger. But when you get into the urban world and then go back into it, it's almost jarring. It's almost like you either society has brainwashed you into thinking that it's morally wrong, but then instinct eventually takes over and you feel that it's naturally right. So that's a really bizarre headspace to be in, or not headspace to be in, but a headspace to notice, like the psychology of the two.
Well, when I became a fitness instructor, we had to learn about anatomy and physiology. And when we were looking at it, it was the same as the chicken I was eating. I stopped eating meat for a while because I felt that I was committing a crime. The muscles, the gristle, and the knuckles, and the cartilages, that's what I was looking for, the cartilages covering the bone and the joints and that. I thought, wow, I'm eating a human being like. That there is the same as in my leg.
But why would you even be, the thing is who and what would have that thought? Well, who would be a person who would want to identify maybe emotionally to things more than another person, but more importantly, is their motive to identifying something as a sentient being and therefore it shouldn't be eaten. But if you do that, you realize that many, many people are actually going to starve if they do not eat it. In other words, the moral.
Not necessarily, you see.
Well, listen, yeah, because 99% of the world eats meat, right? There's only like 2% of the world are vegetarian. It's ridiculous.
No, but Japanese eat 10 times more. Hang on, the Japanese eat 10 times more fish than meat. So you've got to be more accurate there, please.
Well, it doesn't matter. They eat animals. Is the point, right? It's just animal eating. It's not. There's no. Most of the world eats meat is primarily the reason here. Like 90% of the world eats.
Okay,
well,
fish and meat combined, 99%.
So the thing is who would create this ideology, right? Because it is an ideology, giving a food source a sentient personality or a sentient presence. And what could be done is taking something good and turning bad and then morally justifying it by showing how bad that process is. And I think that is done by corporatism. In other words, you take this entity, which they are feeding a village, a town, providing work, etc., livelihood, etc., an economy, etc., which is good all around for everybody in the town. But then they mass produce it at a point where they abuse the product or abuse the process of the product to create more wealth for the corporation.
Yeah.
In other words, they inject the fish with formaldehyde or they give it hormones or whatever these bad things are to increase weight. So they have the same amount of chickens. All they did is make them fatter, so they make more weight off of that, right? So we understand that, but that's driven by greed, not by moral people. See, the idea is that, like, for instance, in Costa Rica, there's a chicken farm there. It provides half the town with jobs. And guess what? They're all chickens that are fed in the fields. And everybody gets these chickens once a week, and it feeds the town. This is brilliant. This is a great process. This is good, and this is natural. So who is the individual that who wants to interfere with that? It has to be the moral corporatist. But the cognitive dissonance with the moral corporatist is the corporatist hates the corporation, but yet is unified through some moral virtue. It's the most bizarrest thing I've ever watched happen, and the language that's used to make it happen, it's like the syntax and the lexicon, it's like they want to get rid of it all. It's mind-blowingly fascinating.
Yeah, I can see that. In my life nowadays, I consume more fish than meat, and I don't eat that much fish at the moment. I'm consuming more vegetables. I'm happy. I'm fine. My children, on the other hand, they love their meat, so they're eating a lot of meat. at the moment?
I think once you've kind of overcome the conundrum of the moral virtueness of like giving, it's like a form of Buddhism or a form of monkism. It's literally they want people to be self-sacrificing for a world that has amounts of abundance of good if corporatism wasn't involved. But more than anything, do you know what I think what the byproduct of society is? The tolerant Christian. I think it's the tolerant Christian's fault why the society is the way it is.
I think it's the tolerant humanity, not just Christians, because the same can be said for all the other religions as well.
If that was true, Islam would be attacked right now. Jewish
well, I mean,
Buddhists
there's a
would
lot
be
of people
attacked right
gravitating to
now.
Islam. I mean,
Everybody hates.
Islam is
Yeah,
the
exactly.
fastest growing religion
Everybody
today.
hates Christ. Everybody hates Christ right now, dude. Everybody
Yeah,
hates Christ.
Islam
In
is
fact,
the fastest growing religion, has been for the last 15 years.
I shouldn't say everybody hates Christ. That's not fair.
Yeah,
I'm saying is
that's
that
right.
I'm saying that the disdain and contempt is growing for Christ. It's evident.
Okay,
It is true.
look at 9/11, right? Look at 9/11. After 9/11, the amount of people that moved to Islam just spiked after 9/11.
Well, you
know that?
obviously have a growing leftism push, not liberalism, but an extreme left, Marxist, neo-fascist, I don't know, neocon Nazi, I don't know what you want to call it, but it's these strategies that come from previous rulers, right? And writers, and the strategies are, you have to. This is what's happening to China. Apparently, China's taken down all their Buddhist statues and all their ancient structures.
Yeah, I don't know why they would
Right?
do that. That's strange. Yeah.
Well, that's what I heard. I can't verify that. That's what I heard going
Yeah.
through information. And the thing is they want a new system, right? They want a new financial system. They keep telling us about this great reset, right? They keep saying what they want: a digital, accessible world where there's less, the AI.
Well, they have what's
things.
that monitoring system that they've got at the moment, where you got to have you're in a red, green, or whatever. What's that called again? Social something system.
Social credit.
Social credit. Yeah, they got a social credit system.
It's been around anyway. We're in one now, but it's not public. It's not public ledger. So the different, well, it is public ledger. That's not true as well. It's just on steroids. How about that? The next
it's
financial
very
system
established in China anyway. Very established in China.
Essentially, if you have your IP address, you have your own node anyway, and then you have comments associated to emails, and obviously they can, put all it together. But the point is that you have your own box where nothing ever leaves that box. Not that it's not the same now, but it's just more compartmentalized to your life. So everything is imagine like Facebook. Facebook is your node of the world, and that's basically what blockchain is. It's going to be the node of your world. Your Facebook is that node. Whatever you do on Facebook is your node. Can't escape it. Can't get out of it. And that's how that node is going to be accessible by other nodes for credit check, for whatever, rent, bills, taxes. You're going to constantly get noded.
Yeah.
It's because it's a streaming system, right? It's all about streaming. If you go buy a gallon of milk on your crypto and you pay tax, they instantly got the tax. There's no once a year filing your taxes or your tax returns. I mean, I'm not. This is like way in the future, man. Like 2027, so not too far off.
They're the ones that do.
What's that? See, the thing is
talking about as soon as you pay the taxes, extracted. Go on.
That's all I did. Well, this is the whole point: is that the financial system that they're building is essentially that everybody has access to financial systems instantaneously. So you don't have brick and mortar stores to go to. And how they're going to apparently do it, as Ada is an example, is they're literally handing it out for free in Africa, right? Getting everybody used to the system, building it up, getting people to buy and sell on it, whatever it is, grow the system. That's the idea. And if it is true, and the positivity of the World Economic Forum is true, then they will equalize Africa and raise the poverty out of that. Since China is heavily invested in Africa, in fact, I think Africa's kind of in a little bit of a pickle right now because China has built all the roads, all their airports, all their building, their construction, and people have prospered from there, prospered from the development of China's investment, which is great, right? The African people have
but
raised up in status.
there's been a problem with the Chinese though in Africa, and they're being deported in their hundreds because of their behaviour. They've been taking advantage of the Africans and the legal loopholes they're in, that they're being deported as we speak.
Yeah,
So
I have
the
to look in
Africans
that.
are waking up to the Chinese becoming a little bit of a problem now. Now they're being more cautious. You'll find now.
Well, I know that their banks are pushing. Well, not banks, but some banks are pushing and refusing the central bank digital currency stuff. Right?
That's right. That's right.
Japan, I think, refused it, but they're using XRP, and they're paying their customers interest if they hold XRP. I don't know. I hope people that are impoverished or that have been in poverty and that are impoverished, that they can actually help them out. It's a good thing, right? It's a good thing to bring these people up. The negative, possible. I think the negative with it is that because there is a breed of people, if you will, that do not agree with a lot of the authoritarian rule, and it's maybe 30% of the world, right? 70% maybe more complicit, 80% more complicit, but that 20-30%, they're the kind of who I believe who navigate the choices of the 70, kind of direct the reality of the 70%. So what I think break it down. Just as there's good hackers, there must be bad hackers. Just as there's bad, there must be good hackers, so forth, right? So it has to be equal balance. It can't be all about a group of hackers that are all for corporatism. It can't be all for that. Can it be all for that? Is that what it surmise itself to as an entity? Is that it's just all these hardworking people, but that just are on the bad side? I can't believe that. There has to be a good side to balance it out, right? Because I think the entity that controls the left and right wing would be terrified that if either one actually got a full hold of everything.
Yeah.
Right? So it has to be this this amazing little fucking story and broadcast. We're in for some good times. Apparently, the September 26th is the Shemitah. Shemitah ends, which is the Jubilee. So we get a resetting of the financial system. And then November, they vote on the cryptocurrency. And then December, it's called C-Day. I don't know what that really is. As far as they state it as where they implement the new system, is where they flip the switch.
That's when you're going to see if you go under or not.
Well, that's what they say, and then the funny thing is when you watch all this stuff and you read this stuff, and it is entertaining, right?
Yeah,
and it's like a car accident. Well, you can't look away because you're like, really, this is what's happening. Because you can listen to them talk about the financial system, like Powell and the Fed and all that stuff, and they can talk about how they're going to implement this new technology. People are going to lose jobs, and you see a little bit of it. Just take that day one that you've noticed it and compress it into 10 years, and then tell me that what the next day is going to look like. Drone delivery, the Elon Musk self-driving delivery trucks.
Yeah, I've visualized that already. You're right.
Right?
Yeah. Mayhem, as far as I'm concerned. You're
Well,
walking down the road and a drone drops
I'll
on your
be
head.
old. I'll be old, and the government will probably pay me off with social credit, or what do you call it? Social assistance or whatever when you're old.
Yeah.
Live off of soup. You know what I mean?
Unemployment.
That's what probably
benefit,
happen to me if I get. That's what'll probably happen to me if I get old enough. Is that I'll have to go beg to the government, like, I'm an old man now. Take care of me. I have my chair and my whatever, right?
Well, if you paid your taxes, you're entitled. Remember that.
Well, exactly. And then you see the kids grow up and they got coding jobs. They're not hooked on the fast food, and if they are, it maybe has a different I don't know. Are they?
Well,
Is it? Have they?
They might be getting fined. They might be getting fined because that's all going to be clocked in and monitored. So if you know you shouldn't be in a hamburger because you have some kind of medical condition, but you actually got
I don't
that,
know. I don't know if they'll
you
get
get a
away with
ticket.
that. I don't think they'll get away with that. If they want happy customers and they want to earn tax money, they're not going to fuck with people's food that much. I don't think. I mean,
Well,
let's
it
say
depends because if it means
hold on.
if you're eating
Here's a
stuff, yeah,
scenario.
go on.
Well,
Yeah,
here's
go
a
on.
scenario. So if let's say you are obese or don't take very good health of yourself, and
There
you go
you
to your
go.
doctor,
There you
and
go.
your doctor says, "Listen, we don't mind you're obese. We don't mind the fact you like food, but let's help you improve in your diet." And you agreed to it because you're getting money, digital UBI, and then oh shit.
Yeah, you'd be
Then
digitally locked out of hamburgers.
the person has the way of taking pills and whatever to recognize they're taking the thing or whatever. Right? They have the technology to, whatever it's the little scan on your arm that goes into your skin or the pill that you
That's
take
right.
that
That's
is
right.
notified
That's
your medicine, right? Oh, it's registered. She's taking. Okay, so they make an arrangement that you get this lifestyle and do it. I've tried to apply the logic and like the actual energy and effort into that example for an experiment for myself. In other words, I'm going to take an app, put it on my phone. It's going to tell me what to eat, how to exercise, remind everything for 2 weeks. Right? Now you have two options. And I did this myself to experiment. Right? I do all kinds of shit. Now, to be fair, if I had actual like clinical, I cheated. I wasn't, but I did really like you do. You change your pattern if you do. You change your behavior if you do. Right? You just do. If you listen to it. But the thing is nature kicks in, nature takes over, but life takes over. So the app interferes with life. In other words, you're doing something for work or helping somebody else, and the app says you have to do this. Well, you can't do that. And then if you can't do that, you have to say, why can't you do it? And then you get like deduction of points. So it doesn't apply to actual reality, it interferes with reality. Although the system is designed for you, it doesn't take in that human factor.
There you go.
You get disciplined unnecessarily.
You see, you're going to be if you're on an app thing, if you're on a surveillance thing in the modern world, like like China's social credit system and everything else, it would mean that if your doctor said to you that you can't have this, and this in your diet because it's hampering your health, we want to improve you, then you'd be locked out of that. So if you go into a place and you try to order that and it's got that, you won't be able to get it. That kind of thing. I think that's definitely
that would only be if you consented to it. In other words, if you were obese and unhealthy and you were taxation on the health system, they would say, hey, listen, we want to help you out. We have this program, and you agreed to it, then that would be the case. But you would have to have consent for it.
I think in the way it's going, you won't have a choice.
No.
Like China, you wouldn't
listen,
have a choice.
Because I don't think they'll be successful in it, dude. Because you're going to create misery is one thing, but if you create murderers, that's one way to do it, or a suicide, or what do you call them? People
The
who
reason I say it be mandatory. The reason I say it mandatory because they don't want to have anyone, relying on the medical system because of their own inability to control their eating habits. So that's what I'm saying. They would control all that. You wouldn't be able to get on the national system.
What they want is a box at your house. You do blood tests. You put your finger in it. You have a computer, just like rated 1984, dude. When you go to see a doctor, it's a virtual. It's not. It can probably be a virtual doctor eventually, but as of now, you're going to put your finger into They already have it, dude. You put your finger into the box, it reads your blood, they tell you whatever, you get the doctor. So again, because of technology, you don't have to go to the doctor's office. And that is kind of cool. So essentially, if you had medical conditions, you'd have a home aid at home, which would be a robot to pop out the pills for you. And then you'd have that blood tester at home and then a screen. So technology is great that way.
Well,
but there's not a lot of, there's not, well, it is for sure, because if you're sick and have a blood disease, and it's hard for you to travel, or let's say you're immune compromised, it's great, right? It's great for you.
I suppose it would be great when you're looking at.
Well, think about it. If you're quadriplegic, you've been quadriplegic for 50 years of your life, and somebody introduces you to this 3D world, like the metaverse, and you can walk. It's going to blow your fucking mind. Well, I'm not saying you are, but I'm trying to optimize and maybe look at it as a positive for people of why the things are there for entertainment purposes. But there's
Yeah,
also
I can appreciate it.
there's also that fear side to it because it's digital tyranny and because of the way that
Exactly.
the way that we're designed, and
Exactly.
we have videos that are giving us 20, 10, 30-second clips, shorten our
Yeah.
attention span.
Yeah. I will never be in that world. You will find me in the forest, in the bush, listening to the sound of the river, the birds, real life. That's
Yeah,
where
but
you're
you're
going
on
to
here.
find me.
You're on here quite a bit. That means you have a cell phone. You're
Oh,
connected
yeah.
to the
Yeah, I've
internet,
got that stuff. Yeah.
and
My
you're
cell
well
phone is from,
versed.
yeah, my
You're,
cell phone is from 2006. And the iPad that I'm talking to you on right now is from 2012. So it's not nothing up to date by the standards that are out there at the moment.
oh, you
Yeah.
still got access to your porn, right? You still got
Well, I don't
access.
even
You're a
look at that
dude.
stuff, really. My
Wow.
porn is my wife. My porn is
Well, I'm
what
just
I'm married.
saying. Well, I'm happy to hear that. I'm just saying that's they literally were when I saw the iPads come out, I literally called them jerk pads. It's the first thing that came to mind.
Yeah.
You know
No,
why?
I'm not. I'm
It's
not
because
really. I'm not
I
really into
already
that
know
world.
what people would do. I shouldn't say I already know. That's just stupid. What I mean is
Exactly.
natural behavior, the world we live in, what they represent on TV, what we see in our music, what we see in our movies. It's really easy sometimes to see where they need to go. Not only for the fact that they show you to some degree,
Yeah.
but it's pretty easy to destroy something by showing that you cannot create it, but you can invert it or pervert it.
That's what they do. But like I said, I'm not really into that world. You know, I mean, myself. Like I said, I'm using the system as I choose to use it. It's working well. The only reason why it won't work is if they stop supporting it, they switch off and say you've got to update and things like that, and that app doesn't work anymore. Fine, and you find some other methods. But there you go.
I don't think I hardly think when it comes push to shove that most people on this server would actually have the balls to do the breakaway. Because why? Why do I say that?
No.
It's because monetarily nobody would have land to go to, or I mean asset wise they would have no land to go to, and if they did, it wouldn't be their land anyway. It would be compute
Well, no,
feudalism.
I mean, I'm that man. You're talking to that man now because I have broken away. I've never voted in my life. I never will.
No, but you're talking
My taxes.
You're talking about flat Earth
I
though,
never
which
will.
is a psyop, dude. You're talking about
No,
flat
I'm
Earth.
talking
which is a
about
psyop.
me. I'm talking about me here. Me living free on the land. You know, you're not listening now. So I do break the laws, and I break them because I think they're restricted of my freedom. So I will break them. Doesn't matter where I am on this earth. I am taking my freedom. That's what I'm telling you. I am the original free man on the land. So do I pay my taxes
if
all
you
the time?
have,
No, I do not. Do I,
if you
except for the
have,
taxes that I have to pay when I buy a product that's been extracted. You know, you've got to work
yeah,
through the
nobody
system.
escapes it. It's sort of ridiculous. I mean, I've looked at it at the options
I
as
will
well.
escape it. I'm going to escape it. I'm escaping it as I speak.
Nobody.
I haven't got a bank account. I don't even have a bank account. Haven't had a
No
bank account
way.
in 23 years. There you go. 23 years now. No bank account. How it's got to be. You've got to take back your freedom. Otherwise, you're in the system all the time.
Well, unfortunately, the day that you can do that is probably pretty freeing if you are not looking to attain travel and locations that require.
I can travel. I can travel now, and that's not going to stop me from traveling. I've traveled everywhere so far. I've had the only reason I haven't traveled in the last 2 years because of stupidity rules that they brought in with the mask and everything, all that shit. But no, that doesn't stop me. Don't be silly now. Come on.
Well, it'd be kind of hard not to, it's kind of hard to raise kids and have a family if
I've
you.
got 4 boys. I've got 4 boys right now in Japan. One is at technical college. They know the earth is flat. They know that America is just a fucking quicksand. It's not the apple pie, the best land in the world. They know it's not the best country. They know that Britain's part of the elite that are controlling the world. They know all this shit. They know what's going on because I've told them. They know. My children, anyway. The youngest one is still.
Well, we're pretty free here in America.
In your prison.
We're very free on the land.
In the tyranny with the bombs going up and the anthrax and the GMO and the fluoride and the radiation.
Yeah, half of the country is GMO corn, but we're free as can be over here.
Yeah, under tyranny. Whilst you're busy voting for your enslavement in taxation and imprisonment.
No, I mean, actually, the United States, it's actually pretty good. It's pretty stable. You can kind of make your own way. Like, you won't be impacted too much. You can.
I don't know.
Pretty free.
Yeah, but that means you're living out of the system. You can't be living in the system and say it's pretty good. That would be shit. You're making your own way because you're out of it. That's what would be that would be the only way. Anyone saying that they're voting, then no, you're not living good. Sorry. Can't be. If you're a voter, you voted for your demise.
I think I voted one time in my life. When I was like 18, you know?
Yeah.
And whatever the voting age, yeah. And I basically voted like that first year. I forget if I did it that first year or the year after or whatever, but I just voted for who my dad voted for at the time.
Yeah, I understand.
And then that was because I was like a teenager, and that was the only vote I've ever since then. I've never even voted again. It's just I've just known that it's not even a legit system. The whole thing is so rigged. It's just literally a waste of time to even put any energy into it.
Exactly. Don't even. Exactly. You're devaluing yourself to do so.
Exactly.
How do you get land or anything? Like, how do you get your independence without first using the system to get that freedom?
Right, you need the money. Yeah, the money is needed.
Well, yeah, but you can work for your money by working not in the system, but you're providing services, and you keep your money, and you do what you want to do with your money. You don't hand it back.
Well, you can be a peddler, right? Like, one of the oldest trades in the world is peddling, and that means you just find a wholesaler, buy the product off of him, and then resell it either retail or wholesale again. You just be the middleman.
Exactly. You can do all that.
That's fine.
doable. Yeah.
But if you're living in a place that has inflation and you have that job, it means you can get lots of cash together.
Correct.
The land is not for sale. There's nowhere you can buy land except for really where it's undevelopable.
Yeah.
And it's still overpriced.
Where are you talking
about?
about?
What it is.
In the U.S.?
Anywhere in the world.
No, in the U.S., land is cheap.
There's tons of land all over. Yeah.
In Canada, I can't find a cheap piece of land that's actually like, let's say 20 acres. Like, in the States, I can buy $5,000, 20 acres of land, no problem.
Depending on where, yeah, it's hugely dependent on where. Like not in California, but maybe
with a river on it. Bro.
Tennessee
or with a stream. $5,000, 20 acres.
Yeah, there's certain parts like the Midwest, like you can get some amazing properties for.
Yeah,
but they're it just depends on your location, really.
Let me say 10 grand. 5 grand's a little too cheap. Like, let's say 10 grand. Anyway, they've probably gone up since then. But the point is that it's dirt cheap compared to here in Canada. There's nothing for sale. I can buy a square lot land that's the size of like maybe a quarter acre for $7,000. And that's
it seems like Canada is like half terraformed by the government because it's closer to the North Pole.
Right.
No, dude, there's
not as much like shit for sale because it's all just like sort of weird, like blocked off areas.
No, dude, it's beautiful, it's massive, and it's endless. There's tons of land.
That's very true. That is absolutely true. But like Gio said, though, they're controlling.
No, it's massive amounts of land. If you were to really look at aerial photographs of the size of the cities here, and then the land next to it, even though Edmonton is apparently the third largest city in the world when it comes to square miles, the way that the whole outer regions are measured.
Yeah.
There's still so much land in between everything. It's massive.
Not to mention those fragmented islands as well, just above Hudson Bay. And I mean, Canada's beautiful, no doubt about it.
I love it up there. It is incredible.
Yeah,
pretty chilly in the winter, but summers.
You know what the problem is, though? The problem is the weather sucks balls.
Get out of there in the winter. That's all. That's
Well, I like the winter. I like the summer, the spring, the autumn. So I don't mind. I've got all the equipment to survive. You give me a chance to live in Canada, I'd have a ski-doo. Rather than a motorbike, I'd have the ski-doo.
Are you a wintry person, Jin? I mean, I've lived a lot of my life in winter because I grew up in Michigan. So
Right. Well, I grew up in England, so we have some cold winters there. I like snowboarding, and I also like mountaineering, and mountain bike trekking and things like that. So, if I had a chance to live in Canada or in the like Devon Island and that, you see, I could run an off-road bike, the XR600, and do my business and have no problems. No, I don't let the weather or the terrain slow me down.
Jin, we'll have to make another meme for you. You know the one that Bandsaw posts of the motorcycle with all the machine guns? We need to have one where it's a snowmobile with all the machine guns, and it's a Jin CBR1.
That's right.
And then you put your little quote right there. I don't let the weather get me down.
That's right. I don't let the weather
slow me down. That's what you said. You don't let the weather slow you down.
No, I don't blame nature for anything. I've embraced her, love it. I have to take what she dishes out. So if you have the equipment, you will survive. That's how I've always been. Yeah.
Have you ever been snowed in with 3, 4, 5 feet of snow and you can't even drive out? Have you ever been snowed in?
No, I haven't had that. I've been to areas where people have been snowed in to enjoy their snowboarding and that. Yeah. But where I live, no, we didn't get snowed in at all. But I've been to those areas where you've got to have studless tires or you're not getting anywhere. Love it, man. Just love it. And I drive like a rally car driver. So I will overtake you. If you're going on like a snail and now I'm off. Next lane. Spitting out sand, snow as I'm going past it. See you later. Down the road. Just love it. Yeah. It's fun.
Yeah, I mean, I can appreciate winters in a certain way. There is something cool about that, like biting cold and just the energy of like the environment when it's cold like that.
Yeah.
There is something cool about it, but I feel like I've fully exhausted any interest I have in it for the most part. I don't really even want to live in it anymore because I kind of have already done a lot of years.
Yeah, you've lived it for many, many years.
Yeah, and I've been
saturated.
Yeah.
Yeah, I can understand that, you see. But we don't get enough of that. So, but I do appreciate, like the children appreciate the food more because their body core temperature drops now after 2-3 hours snowboarding. Okay, let's go and get lunch, for example. So then they put their snowboard up in the rack, go in there, have that ramen soup, and you can see the way they're devouring that ramen soup. It's like they haven't eaten in days. You know what I mean? And it was only 3 hours of being out in the cold. But they appreciate it more.
Yeah, warm food is definitely amazing. Like if you're like skiing or doing anything out in the cold like that. Because I used to do skiing, and a really hot meal definitely. It's like there's something about the internal heat of food, which seems to create some kind of harmony between the outer cold.
Right. I was instrumental in helping a ski resort break their protocol. Okay, because for example, we like what's called as miso ramen soup, which is miso. It's fermented soya beans soup. Okay, and they always put pork in there. I don't eat pork. I don't give pork to the children. So I said, look, no pork. Can we have double egg instead of the pork? You keep the pork. You give me double egg. So they said no at first. So we didn't have the egg. So we just had to have it as is. But I was always complaining. In the end, after a few years of going to the ski resort, they changed the policy and they said, yeah. No, because they could see we were still coming. And they probably felt guilty that they were taking away the meat, but not giving us something in replacement. They decided to give us the egg then. You see what I mean? Right? That was one success. Then one day, a few years later, they were going to change the logo and stop the egg. And I said, excuse me, how can you do that? I spoke to the manager because I want to speak to the manager because there was no eggs. I said, I want to speak to the manager of this place. I said, look, we've been coming to you for umpteen years. If you're going to change anything about this place, you need to consult your customers because it's us that come here that you make your revenue. And Hunter Mountain is the egg. The egg is the logo. How can you change that and then not supply eggs? What's going on? Eggs are finished? No eggs in Japan? They didn't change it. They just kept it going. still there today. Yeah, man. I kicked up a stink and instrumental in that because, like I said, how many foreigners do you get coming here in this region? How many? Not many. And how many black? None. Only me and my family. And we've been coming for years. Look at the photograph, show them the mobile phone. Okay? So for you to change the logo, it's like sacrilege. You can't do that. Not here. And the guy kind of like, the manager obviously spoke to their bosses and that, and they didn't change it. It's got a waste of money, man. What are they doing? And yeah, so today when we go, no problem, man. They know me and my children because of that. Yeah. So sometimes you've got to, endure. State the truth. State your facts. And sometimes they listen. And I've had that result twice in Hunter Mountain. A place called Hunter Mountain Ski Resort. Love it. Yeah. So all I'm trying to say is that sometimes, it works when you push back rather than just take it without saying anything. And the Japanese tend to think that, customers are always number one, you see. That's always been their policy. And I'm speaking on behalf of the customers because most Japanese people don't. It was the same when I went to Guam Island. Okay, Guam Island, we're in the ski resort. Now, I've noticed that there's a lack of maintenance. A little lick of paint here, some oil lubrication here, things. They're not doing that because tourism's down and that, okay. But, you still can afford a little bit of paint and that, make it look good. Anyway, the water pump had stopped on one particular water slide thing, but this pump was supplying other water slides as well. And they were going to shut the whole thing down. And they were telling the Japanese, that we're going to shut it down. And I got there. Maybe I've been there like 30 minutes because it just arrived. And I said, well, excuse me, hang on. Are you telling me you're going to shut this one down and this one down? And I've just paid $200? $200? I don't think you're going to do that. I want my money back then. And then they said, okay. We'll shut this down. We'll keep these two open. So I explained to the Japanese customers, I said, they're going to keep these two open. They're going to shut this down. We can still have some fun. Yeah, what the fuck they think they're doing? That's me, man. Take no shit, I'll tell you. Otherwise, get $200. The thing is, if you go the next day, you get a 50% discount. So you've got to go back the next day or the day after. And then with your tickets, you get a 50% discount. But you've laid out $200 initially for a family of 6, that was. But the youngest one couldn't really do anything because he was too young. He'd be just be in the paddling pool. But the rest of us, yeah, we will really gain our money's worth. But that's me, I don't care where I am. I won't be ripped off. You give me back my money and we're getting out of here. Thanks. I'll have a refund. Thanks. Fuck this shit. Yeah, you lose dollars. Don't fuck with me. You've got to stand up wherever you can for your rights, for the right thing. As long as you can do that, you'll enjoy your life a bit more. That's what I've learned over the years. And I come from Britain, where I was born, and strike was always on. There was always a strike of some kind going on. So I come from that culture, if you will. Yeah. But I do love the seasons. I love nature. I don't blame nature for anything. I'm at her mercy. That's how that is.
Yeah.
Yeah, man. I'm a kind man. I mean, I'm here at the English school. Children are sick and they can't make it because they've got a cold and their parents ring up. They get a 100% refund. I make no money. That's how it is. Fair is fair. That's how it is.
I'd charge them 200% because they got sick. Give them incentive not to be sick.
Yeah, I might try that. Yeah. Look after your health better.
Exactly.
And Gio was just talking about that motorcycle that you put in the server. You know, I was looking at it yesterday.
Oh, the bazooka one.
Yeah, I was going to post it to wind you up. I was going to post it, but I thought, nah, I won't do that. Next time I will, but it's right there. I haven't deleted it. I've still got it.
Oh god, gee, when I first saw that, bang! Like it was like two peas in a pod. You on that motorcycle was just yeah, perfect.
Yeah, that's what I've been doing that in Gem Pandas. These last 8 months, we've had success. We've thrown down the gauntlet. The steel gauntlet. We've slapped them up and dominated. Me, Merle, Lemon, and a few others. Some of them come from this server. We've controlled it good and proper. I was kicked out of Gem Panda server 4 times, and the last time I had to the only way I could get back was if I apologized, but there's no way Jim's apologizing unless I did something wrong, worthy of an apology, and I'm still back in there.
There you go.
I'm still back in there, yeah. Because there's some of Gem Panda's own people know that I was being treated unfairly. So the Queen of the Trolls and Captain Bullshit, they got my back. They said, don't worry, Jim, we'll get it sorted. Don't worry. I'm not going to be apologizing and none of that shit. And I'm back there again. But we've been successful in delivering the truth to the listeners. Because, you know, they're not going to pay attention, that Gem Panda and their gang. But they've got a live stream and they've got their listeners coming in. And that's who I talk to. That's why I always say, ladies and gentlemen, pay attention now. Listen to the voices. You know who you're listening to. In CBO1, you got Merle, and then you got the rabble, for example. Right. Listen to the emergency in our voices and the discern. Right. And then we're giving you, I know you can't see our screen here, but we're giving you the information. Get your pen and paper ready. Yeah, man. We've been successful. I'm telling you. They're actually saying, ladies and gentlemen, now.
There you go. Well, interesting tactic, I must say. Interesting.
Yeah. You've been there as well, Bansal. I've seen you come in. You know, I've been there listening. I've been on mute because they had to mute me, of course. But yeah, you've been in there a few times. I've seen you come in, and they treat you like shit. Yeah.
Well, I wander over occasionally, Gem, for 5 seconds, and
yes,
it probably reminds me why I only wander over for 5 seconds. To be quite honest.
Yeah, because you're polite, silky smooth, total relaxed, calculated, precise, and methodical in the direction you want to go. But they just shit all over you and that, you know. But it just rolls off like a water of a duck's back, mind you, and you carry on. Then they just boom, they've muted you.
Wow.
You know.
Look, it is what it is at the end of the day.
Yeah.
I don't lose a millisecond sleep over it, to be honest with you.
That's right. Whereas for me now, you know, it might take me sometimes 3 days to conclude that message through all the stoppages and pushing back and trying to stop the truth. But I get it out in the end. And then you know, a couple of days may go back and I'll revisit that. So now, Jem, are you going to concede that Hawaii isn't the 50th state of America because of the dethroning of the Queen by gunpoint? You know what I mean? Yeah.
I can see why you have such a disciplined exercise regime, Jin, because you need your stamina. You need your stamina to keep on doing what you're doing.
Yeah, that's right. So everyone has their niche, you know. Yeah, Gem Panda. That's where I'm really excelling and making inroads to the listeners. I'm the neutralizer, like you have the equalizer. I'm the neutralizer. I neutralize their lies. Yeah. Got to balance those scales. Keep those scales balanced at least.
Yeah.
Yeah. And I always address the listeners, ladies and gentlemen, but you have to confess to yourself, you've never measured the curvature. You've never actually detected the spin. And you know you cannot have any kind of pressure without some kind of containment. So our air that we have, that we breathe, that is precious, has to be contained. Otherwise, we'd be dead, ladies and gentlemen. If you're not aware of that, look at the video called Flat Earth. What's it called? Flatten the Curve, for example, or Level, or The Biggest Lie Ever Told. You know, I'm giving them videos to check.
Yeah.
Whilst we're speaking, yeah.
So I've got a question for you, Jin, because it seems to have been. I haven't been around for the last 4 or 5 days, but it seems to be a bit of a hot topic these last few days. So I'm hearing the discussion about ether. Okay, and so what's your thoughts on, say, the theory of ether? And look, to me, whether it's ether or, say, dark matter, it's probably in the same bucket. It's a placeholder for something that we kind of don't know, really.
That's right.
So whether or not we call it ether or dark matter, to me, it's really 1/2 and 3/4 of the other. But are you an ether
proponent?
Yeah. Like, are you open to ether / dark matter, or is it something you kind of put to one side because you just don't have any kind of like tangible substance to it?
Okay, I'll give you my initial reaction. Okay, so when I became a flat earther, that's when I actually heard of the ether thing. Actually, I heard about it before becoming a flat earther, and I thought it was a load of shit, right?
Yeah.
Become a flat earther, I still thought it was a load of shit. Dark matter, blow that into the dustbin. That's definitely not a proponent. But I seem to have come round to the ether because of the Michelson-Morley experiments, Sagnac and Aries Paley, you see, because they said that they used the ether to detect that the Earth wasn't moving. And I thought, well, okay, if that's the case, what is ether? Is it smoke? What is this thing? Is it a membrane in space? So I'm still out on what it actually is, this thing. Yeah, that is my honest position.
Do you want to know what it is? Yeah, I'll tell you what it is. It's the quantification of the tiniest particle that does not reflect light. That's all it comes down to. That's it.
Yeah, but can I see this thing? That's the thing. Can I actually see it?
So
it doesn't reflect light. You can't.
That's right.
I guess that one's in the category, Jin, kind of like you were saying, you can't see your brain. I think that's going to be in the same category.
Yeah. But I know it's there.
Lord, there you go.
And the Earth is our God, the brain of God.
Yeah, there you go. Because they're saying that the ether was the one how they detected that the Earth wasn't moving. So there you go. So I'm with Lemon. When Lemon describes it, he does give a good description. He's a very good proponent when he starts talking about ether. Poetry in motion. So I'm more for ether than I am for dark matter.
Yeah, I kind of put them both in the same bucket. They've just got two different names, to be quite honest with you. I think they're exactly the same thing.
I would
I have a question for you. Why does there have to be? Okay, so the idea is that the absence of air and the transmission of radio waves through the absence of air is concluding that there has to be something greater than air to transmit the radiation. Like, what is the problem with that?
Well, for me, Dana, there needs to be a conduit for something to travel along.
Why does there have to be one? Right? Just out of curiosity, because they're trying to remove air, and then they say that they can, because they're claiming they use a vacuum. That means they remove everything. First of all, which is a false premise to begin with. Secondly, they're saying if we do this, how does all this other stuff work when we do this one thing? The ego in it is, why would the fact that I do something to something that it wouldn't transmit or propagate anything to begin with? Why do I have that assumption because I removed something it would otherwise work?
Okay, I'll tell you. For me to move anything from point A to point B, I need a conduit of whatever that conduit is. Right, it needs a track to follow. Now, if you have a
But hold on, let me interject. You again are doing it again. You're saying that you have to have a. You're saying that you have to have a cause for something to have an effect, right? That's what you're saying.
I am giving you my logical reasoning why I think there has to be something, right? Now, it doesn't mean there has to be, but this is my reasoning, right? So for me to move something from point A to point B, there has to be a conduit of some sort, right? A container, a track, whatever the case may be. Now, if I have a track between me and the table, for argument's sake, like a railway track, okay? And I put my little rail card on it, and I push it along that track. I can get it from myself to the table, okay? Then now, if I put a brake in that track, that little cart is then going to, because there's nothing to hold it up, nothing to get it from point A to point B, is then going to fall onto the ground because there's nothing to continue that path. Now, I could continue that path if I was to say put like a little ramp in there, and if I had enough speed, it could then jump that gap. But then it has to jump that gap between point A and point B. So to me, the light, if the light is traveling through the gas or through the water vapor or whatever, that little gap between those, it is constantly jumping from point A to point B, which would be a disruptive path and would affect its speed, its path, direction, all these sorts of things. So I think, just trying to think about it logically, I think there is probably something in between everything.
Yeah, but see, here's the thing with dark matter and ether that doesn't describe what's going on. And I wrote a definition for this for the because what it is if space-time, ether, dark matter, they're all one of the same structures as far as quantifying the propagation of electromagnetic energy, matter, whatever magnetism you want to talk about, whatever the 5 elements there are, or 6, whatever it is.
Yeah.
The definition would be properly described as a field array, because within a field array or a scalar field, you have what's described, and I wrote it down here. Let me just read what I write. A field is marked by the presence of particular. A field is marked by the presence of particular features, such as objects that contain light, sound, pressure, magnetism, and non-manifested energy. So let me read that again. A field is marked by the presence of particular features that are objects, light, sound, pressure, magnetism, and then non-manifested energy. It's called a field array because within that array, the array is the collection of magnetism. If you want to look at modern science, it would be the gravitational formulations, right? That would be the idea of the arrangements. You'd have the magnetism calculation, gravitational calculation. You would have all those other, I can't name, I forget the names right now, but you understand what I'm saying? So a field array would properly describe it, because it would be, like I said, it would be a collection or an arrangement of sound, light, magnetism, that full spectrum, right? That would be the field that would contain it, and the arrangement would be such. And if you look, all of the structures themselves literally have places within the field.
Yeah.
Right? So when we talk about the ether and we talk about space-time, it's not delivering the actual, because anything we can, like I was looking at an experiment today, actually. It's not an experiment, but an observation, which if you take a guitar string and you pluck it, but then you have a rolling wheel with straight lines across it. So in other words, you have, I can't remember the actual effect. I should have written this down. But you spin this wheel that's got horizontal lines on it. You're staring at this wheel spinning, and it's got these horizontal lines. And then you have guitar lines, or guitar draped down in front of this rotating wheel. And what happens is you see the sine wave of the guitar string. You can see this if you film it with a GoPro or camera and so forth. But the point is that you see this guitar string as a representation of anything oscillating, vibration, and sequence, right? And this is how we've quantified all of the wave theory, all of the energy theories we see. We see the is it the macro, and we quantify it to the micro. But we find that the micro doesn't operate like the macro, unified, right? That's the issue, because we have what's called the action at a distance, which doesn't necessarily develop pressure, or as a consequence of pressure, magnetism, but it is a consequence of light, which essentially is electromagnetism. So it's a conundrum, right? I don't know. That's what I'm trying to figure out too, right? Is wrapping my brain around it all. But I think it's a field array rather than ether and rather than space time.
Okay, well, I'll put it another way and just quickly just shout out to Nate. But if I was the creator, to me, you know, whether or not it's, or I said ether or dark matter, but you know, I'm happy just for ether. You need a building block to build upon. So to me, the ether would have been the very first initial building block that he put in place for everything to be built upon that and within that. Because to place something in absolutely nothing, like I said, you know, it comes down to, and I'm just a mere mortal, just mere logic, to build something within nothing, to me seems absolutely impossible. You need an initial building block, an initial foundation to build upon, to place all your bricks and mortar on top of everything. So to me, it's the foundation of everything to be built upon. You know, whether that energy, you know, that light, that magnetism, everything is built upon that. So yeah, that's just why I think it. You know, it is what it is. There, the very initial building block data.
I don't think we'll ever be able to unify it because our calculations change, and if we have all of these compartmentalized equations, how do we expect to unify them if they change and they conflict each other, especially if you keep repeating the data? So I think if you keep repeating the data and the data conflicts with each other, where do you go from there? Which, in other words, if your theories are incorrect and you keep adding to the theories, when are you going to admit that you're just chasing your own tail at some point, right?
Well, me myself, I'm not chasing, you know, the ether myself, but you know, there are many more smarter people trying to chase, whether it's ether or dark matter or all these things, and you know, perhaps
the ether's chasing us.
Yeah, and perhaps things just aren't meant to be discovered or quantified either.
Can I tell you where probably it's ingrained ourselves socially, and tell me where, if you guys agree. Besides this corner of the web, let's just talk a little bit of truth. So I come across this book. It's quite an interesting book. It's very old. It's called The Great Psych, and in it talks about the transfer of ether. And in a sense here, tell me if this is true, if you think this is true, because I think this is kind of true and may lend to the idea in the expression of how we are trying to see our brain that we cannot see, so to speak. We know our brains exist because we can't see it, right? So that was your guys' claim, right? You made that statement. So this is kind of leaning towards the idea that you have these, looking at the basic, here we go, thought transference is what the subject is about, and they claim the thought transference is due to the ether. And for instance, they give an example here. So sound, the sense of sound, that is an action by which the brain hears familiar voices or note of a song or melody or other activities, including physical actions, as if knocking,
Wrapping, steps, rustling rustling of clothings, moans, swinging of a tree branches. So basically, it's indicating that if you hear a type of sound, it may bring back all of these thoughts. Right? Let me continue on here. These are received by the latter organ, which is your ears, although they originate in an entirely different manner. That such sounds and noises, so I'm reading in the dark here, so such noises and sounds have transmitted but what's called telepathy. And if you research the word telepathy, it's receiving messages without normal senses. And so sounds, words can have all these triggers. Do you follow what I'm saying, guys? I'm sorry, I can't hear you.
Yeah, kind of. Yeah, continue.
Well, I'm not writing this. This is in the book called The Great Psychic, and they're talking about thought
Yeah. I'm following you so far. So carry on.
Anyway, they talk about sound, they talk about touch, they talk about our basic senses. But each of these developing senses that we have trigger these transferences of thoughts, which they claim rely on the ether, which is that ethereal space in between reality and dreams and thoughts and presence and not being present. Like it's that thought transference. There you go. The telepathy. Receiving, doing something, being a part of something without actual physical, like being part of it physically, but it's there. Let me read what they actually say. Hold on. I didn't equate it to best. Hold on.
So,
there's one little statement that nails it.
Yep.
Oh man, I can't find it. I'm in the dark here, man. I'm trying to find this in low light here.
So, like a telepathy being transferred through the ether.
Yeah. I'm in the dark as well, mate. We're in the dark here as well.
No, I'm just having a hard time reading quickly when it's on low light. That's all.
No, yeah, I appreciate that. Totally understand that. No worries there, man.
I could move my location. I just haven't.
Yeah.
It's kind of funny.
Yeah, I've got a few things to add to that afterwards, anyways. But carry on.
While you're finding it, I've as far as that that thought transfer through the ether. I have well, not personally myself, direct experience, but I have two lots of twins that experience that exact thing. They quite often will be getting in contact with one another because one has done something, one has thought something, and the other one has got in contact with them. It's just like, thank God you called me, or whatever. I was thinking exactly the same thing, or they needed help with something or whatever, and the other one's calling them straight away. Like there seems just they had that connection through, some might say,
Empathy through thought.
Yeah, exactly. And is that traveling through the ether? The conduit of the ether. It's a very
my brother, who is 6 years my junior, his birthday is November 22nd, which is when Kennedy was assassinated, by the way, and mine is November 18th. Okay, now we have this through our lives, we've had this thing where we thought of the same thing at the same time when we're having a conversation or whatever. People have said it as well. One time he went to the shop, to buy a pair of shoes, a shoe shop, and this woman who was serving him said, after she never met him before in her life, never met my brother in her life, and my brother was his friend, so he was buying a pair of shoes, and he's like, can you show me this size, that size? Let's have a look. And then this woman who's serving him said, you're not Jin's brother, are you, by any chance? And my brother just looked up and said, what? You know my brother? are you Jin's brother? She said, yeah. She goes, you act just like him. You know, amazing. It's just, I was just blown away. You know, she never met my brother in her life. She knows me because I shop there. Okay, and he goes in, and she picks him out as my brother. What are the odds?
There you go, Jin. God.
Yeah. And my brother comes back and tells me what happened, and a number of years later. Amazing.
It's hard enough having one Jin in the world, let alone two. What the hell?
Hey, question for you, Bandsaw. When you're there,
isn't that amazing? Isn't that
Bandsaw,
amazing?
when you look south, right, where you're at, is the sun ever at your back?
When I look south,
yeah,
is the sun ever
at your back?
Well, when I look only
in the middle of the day, yeah.
Yeah,
not
in the morning.
Okay.
Not in the morning. In the summertime, it'll be like to the south of the east-west line.
Yeah, I'm pretty south though. Oh, directly at my back.
Well, roughly. It doesn't have to be directly. Probably off.
No, it should be in front of you though. In our summer, which is your winter, it should be in front of you, surely.
Yeah, well, it'd be.
No.
What do you mean no, Rui?
You got two Australians fighting over it. This is interesting.
Yeah, that's
What do you
right.
mean, Rui?
One's being disingenuous, and I know who that is.
Yeah, Rui.
This is a good debate. Two Aussies disregarding the sunsets is the same thing. Wow, what's going on here?
If you're facing south, Andy, at midday, the sun will be behind you.
Yeah, at my back.
Right. So we agree.
Yeah, so from the morning to midday, it's going to be at my back.
No, in the summertime, in the morning, it will be in front of you, to your left or to your right, or to your right at that sunset.
The sun ain't bloody well in front of me in the morning.
Yeah, to your left it will be. If you're facing south, it'll be to your left in front of you, not behind you.
It won't. It shouldn't be in front of him. No, it'll be slightly just above him, slightly behind him. No.
It's not in front of me. It's behind me.
It's not behind you. It's sunrise. It's not.
You need to reorientate yourself.
Yeah, there you go.
The sun rises south of east in the
sun
summertime.
rises from behind me, from behind the mountain, behind me.
Yeah, east. Can't be south.
In the summertime, the sun will rise from south of east, which is in front of you.
Ruhif will soon find out if he goes to model his ball earth correctly that the sunset cannot come in 120 degrees on your 24th or 23.4 degree tilt. You'll have to have less of a tilt or
no tilt.
Okay, you're having a hard time listening. If your model that you have, your ball model that I can buy from Walmart, is a correct model, then it should produce correct shadow angles, but it doesn't. I have many examples for you to try out, just so you know. This is just one of them. So
that's your challenge.
Just go give it a try, bud. I have given you another model challenge. I've given you other ones with actual math dimensions and all kinds. I'm just waiting on one of you to do one of them. I've given you at least 3.
SunCalc says 118, right? Do you disagree that that's what reality says?
I'm saying that the SunCalc says 118 degrees, but your model won't represent that.
Yes, it will. Are you saying something different?
Ruhif, if that is true, please go take a Walmart globe model, line it up geographical north, put a gnomon at Perth, and show me this angle that you talk about, please.
Right.
Exactly,
and if I come up with 118, what happens then?
Then you prove me wrong. Then I have to go look at how I modeled it, and I may have modeled it wrong.
So you show.
So I have Ruhif, you don't understand. I've done this. I've asked many people, not just you. Nobody wants to do it.
One guy claims to do it. One guy has claimed to do it. It's really easy. All you have to do is line up a protractor geographical north, put a gnomon on Perth, put the sun at 90 degrees, which is at the equator, to parallel to your model it that way. It's really easy. All you have to do is make your sun and press 90, and it will go to the equatorial plane. Tilt your ball Earth, put a gnomon there, and show me this. Show me how it matches sun calc.
Okay. All right. So if I get 118, right, same as SunCal, then you admit
Then
you fucked up.
I have to look at how I took the toy model off of the shelf, how I lined up a protractor to the geographical north, how I put a gnomon there, and then I have to position the sun. Because I can make it work. I have to just change the position of the sun. I can make it work, Ruhif. I can take the model, and the point is that if I do be honest and I have it at 90 degree to the equatorial plane, I won't get that on your model. Now, I don't get the model example of real life, right? So you can make it. You can fudge it. You can fudge it. So again, no. Again, here's what I'm going to challenge you. Now I know how Blender works, right? When you have a sun, you can have it at the zenith position of your model, or press 90 and make it 90. Just make it 90. Throw a map on your ball Earth. Put a little gnomon on there. Tilt it at 23.5 degrees. Have it sun, and then show me what shadow you cast. That's what I asked Jem to do, and it was a struggle just to get him to. Okay, that's it. Yeah. And it was a struggle just to get him to slow down and show me the information.
Later, right? We're having a back and forth. Right? Now, I will do it mathematically.
Sure, you can. Numbers are arbitrary in a model setting. You can have it 1 instance size. It doesn't matter. They're arbitrary numbers. So you're not going to do anything mathematical, buddy. 0.
That's how I will do it. I will do it.
Yeah, but you won't do any. You won't do anything mathematically. What you'll do is you'll create a sphere model, arbitrary in size, because when these models are numbers, the numbers are arbitrary. Then you're just going to put a gnomon there. What you can, that's not arbitrary, is tilt. After you throw a map on it, you can actually tilt the ball, so you can see evidence of that, right? The tilt, and you can actually clarify that it's at 23.4. You can actually see the gnomon right on Perth, at least where it apparently is, and then you can show me how you put the sun at 90 degrees. You can blast the sun rays up as hot as you want. And then throw a protractor, geographical one if you can, line it up to your ball and show me.
Are we doing it mathematically with that?
Make it as easy as possible for me, because remember, I'm the crazy one, right, Ruhif?
Yeah, correct.
So feel sorry for me and just be real slow and kind and show me, because at the end of the day, I've asked many people to do it. You're the model guy. It's really cut and dry. It's a real simple observation. And then when you're done that, I've got one other trick up my sleeve once you're done modeling, and that it will destroy the whole thing that you presented to me.
So basically, Rui, you can do it mathematically, all right, and then come summer, right, I can go outside, right, and I can put a stick in the ground, and your mathematics will line up to my stick in the ground.
Yes.
Absolutely.
There you go, Data. How's that sound?
Oh my goodness.
How's that sound?
Sounds fantastic. Do it up, buddy. Let's see the math.
Well, I can do the practical part of it. Rui can do the mathematical part of it.
Yeah, sounds good.
Okay.
Probably not tonight, but I'll get it in the next few days. Yeah.
Well, we've got to put in.
There's no rush, Ruhif, but I appreciate you guys playing. This is, you know what the funny thing is realizing that society is stupid and there's got to some type of way to educate people, or at least gauge it. What would you do, Ruhif, without this job, man?
Math. Learn some math would be good.
Math is good. Math is good. I like math a lot. I'm not afraid of math at all. I brought a lot of math to Flat Earth, actually.
I'll just go outside and have a look. I don't need the math. I'll just look at it.
Yeah, but you got to do declination and shit if you're going to do a compass reading, right?
Hey, Ruhif, if you do me a favor, if you want to do me a favor, if you can, go to Nathan Oakley's show next time and ask 10th Man how to calculate his declination angle without an equatorial plane.
I tried to engage 10th Man about 6 months ago, and he doesn't want to talk to me, so, you know.
Yeah, but if you actually talk to him about the sextant and ask him, how do you navigate in, let's say, I don't know, July or August in the ocean, how do you find your latitude during the day? And watch him lose a fucking wheel.
What do you think he'll say?
I've already called him out on it, dude.
He wasn't honest at all. He was dishonest. Look, there's flat Earth liars too, buddy, or fucking trolls or shills or whatever you want to call it. But he was full of shit. You need to have a size in the almanac. You need a size. You need an equatorial size to get ratios. So you need an apparent angular relationship to the overall circumference. That's how you get a declination from the 0 point, which is the equatorial plane. I haven't mathematically broke it down because I'm not mathematically at that level and spent much time doing it. But you need a circumference, which you don't need a sphere. You just need a circumference, right?
You don't need circumference to get latitude. You need to know the
No, but
declination.
Okay, so listen. Here's the problem. Maybe you need to understand the scenario. I'm at sea, and I have no almanac. How do I find my latitude using the sun? Well, you can't. You can only find your latitude in the Polaris. Stop. Hold on. You need an almanac to get you a declination angle from the equatorial plane to know where the sun is during its season. Hold me finish. You make 3 noon measurements within a duration of 4 minutes, let's say. You make the 3 observations. You're going to get a calculation. You're going to take that angle and you're going to add it to the declination angle from the almanac, which is the GP position of the sun based on the season. With that angle, you can figure out what latitude you're on. That's only possible with an almanac. The only time you can do it without an almanac is during the equinox. Let me finish. Okay, you can mathematically equate 6 months. Okay, you're at the equator. The month is you can mathematically break it down to where approximately you are mathematically based on time. And of course, you know when the equinoxes are. Towards the solstices, you can break it down mathematically loosely. Yes, you can. But doing it, I haven't done so. Logically, I understand how it's done, how it could be done through time and knowing the dates of the equinoxes to the solstice and then breaking it down per month, right? And figuring out that way what month I'm in July, doing some mathematics, quick duration, you know what I mean? Finding that. Yeah, but it's a lot of calculations. And when you're at sea, you're not doing that. You're using an almanac. But more importantly, you have to have an equatorial plane. That's the point. You have to have a 0 base, which is the circumference size that we deduce all of our degrees from.
You don't need the circumference to work out your latitude.
You do, or else we wouldn't have 24 by 24 by 60. We wouldn't. Listen, the pendulum swings at 1 second, right? The pace of a man over 1,000 paces is 5.28 feet. The ratio of the average ratio of a human thumb can be 20 to 1 or 30 to 1, depending on the size of the human being. We have these constant ratios that are irrelevant to where we live, right? But we use these ratios to navigate and to provide us information of our surroundings. Anyway, I'm off on a tangent here. I lost where I'm going with it, but
yes. Anyway,
Rue hair, worth less than the toilet roll in your toilet. Get your shit together.
You know what? He's imagine fighting this hard, right? You got to realize he's fighting this hard because he has a dog in the fight. He must have a dog in the fight, which means he's either getting paid to do it,
yes, exactly,
or do something with it, right?
Exactly.
So you got to feel sorry for the guy because what it means is the
tell.
society's pretty stupid. It's pretty dumb because to pay people to fight against something, one of 2 things. Well, if it was a serious thing, you wouldn't pay people to fight against it. Number 2. So it's weird that people are paid to fight against something that shouldn't be a threat or shouldn't be a concern. It just doesn't make sense, right? So if you do that,
sitting in a hair salon. My daughter's getting her hair done.
Sure, awesome, man, it's great. You love it. It's fantastic. You can be as likable and as personable as possible.
I'm
it's all
happy
good.
for you that you got some element of real life going.
There's no crime against that. The point is that there's no reason to have a dog in the fight. Now, I was new to the whole psyops and to the whole internet shit. I just had a little bit of time off, and then I got introduced to a couple of ideas that took me on a rabbit hole, if you will. But Ruhif, I spent time in this rabbit hole with a purpose because once I realized I was being lied to and tricked about everything to a certain degree. Not everything is a lie, by the way. But a lot of the things that are propagandized on television, media, and stuff it's plain as day once you are educated to it. That only happens when if you're lucky to recognize that only happens when you're willing to turn it into something. So I said, I'm going to turn it into something. If I'm going to go down the rabbit hole, I'm going to turn it into something, which is a great, crazy story, dude. You're involved. Nathan Oakley's involved. Q's involved. Like, it's a crazy story. In 20 years' time, There's paid people to fight against flat Earth, and then there's the United Nations flag, no Antarctic on it, the Antarctic Treaty. This is like one fucking movie that is unbelievable. It would pack the movie theaters, right? What actually is unfolding? It's mind blowing, dude.
Man, tell him again, man. Tell him again. Beautiful.
I've tuned out. Massively tuned
Yeah,
out.
it's all.
Zoned out.
Yeah, of course. You look, it's all good,
Yeah,
dude.
you're
You
gonna
can tune
tune
out all
out.
you want.
Of course you are.
But what if your daughter came home and she said, "Dad, the Earth's flat"? What would you do?
Dishonor. Dishonor.
No,
Constantly.
Yeah, man.
you know what? You know the thing is, Ruhif, it's not actually about being flat. Hey, this is what I've realized through it all.
It's a
Not
flat
actually
Earth, Daddy. Daddy, it's a
It's
flat
not
Earth.
that. It's not that. It's whether or not you're willing to accept what you've been told, what life is, and what it is. Period. That's it. That's what it's all about. It's just whether or not you're willing to accept what you've been told.
So,
That's just different. You're telling on yourself, Data.
all it
My-
takes is the shape of the Earth discussion, and all.
Who's that going?
There's a good echo going there, bud.
Not me.
No, there was an echo earlier. It was coming from Geo's.
No, it was through Jin's, I think, but it was maybe through mine, through Geo's, or I mean, through mine, Jin's. No, I was saying, Ruhif, that when it comes to the shape of the Earth, for you, unconditional love just goes out the window. Apparently.
Oh, okay. What was I going to say? Yeah, you were telling on yourself, Data.
I mean, I hope
Like
you were,
what we've
I
been
hope you were
told.
joking, saying that you would disown your daughter if she realized the Earth wasn't a globe. I mean, that's twisted. I mean,
Yeah.
even if you
I'll
don't
be disappointed.
you don't know for sure. I mean, you're kind of, you just like believe your thing because you think a bunch of arrows are pointing at it versus what actually is proven to be the case.
See this? From an objective point of, from a subjective point of view, right? Both of us would be, absolutely certain to whatever level of certainty you have that the Earth is a particular shape, right? From both sides. Do you agree that it's like, do you have a level of certainty around the shape of the Earth?
Well, I think let's just say yes for everyone so you can make your point.
Okay. Yeah, I have that same certainty. And I also know that you are wrong. And would you say the same about us?
Well, me personally, I don't have any reason to tell you you're wrong. I'll tell you what I think the Earth is and what I think it's not, but I'm not here to like judge or label you in that sense. However, technically, if we're going to look at it as what the Earth is, and if it's not a globe, then yes, I guess in terms of that. But I'm just saying I wouldn't like come at you with like you're wrong, like that, in that kind of way.
But it's an interesting situation where we both have, the typical flat earther, we both have certainty of our positions, and we both have certainty that the other guy's wrong.
Yeah, on the kind of like full size of the spectrum, yeah, on like the extent of, because people, there's obviously a range of probably various different viewpoints on a lot of things, but when it comes to the shape of the Earth, the actual shape, yeah. So you were saying before that you feel like you would be insane if it wasn't a globe, but instead of being insane, wouldn't you just want to go back and see where you went wrong, and then just kind of get it back on track and just go from there? I mean, you wouldn't have to be insane. I mean, if you believed all the globe stuff, I mean, it is there's a lot of government and money backing it. So I mean, I guess it is like fairly like convincing in that way. I guess like if you kind of see that level of sort of authority as some kind of standard of something.
Right. But it would be equivalent to, you heard the conspiracy of like they plant the dinosaur skeletons as proof of evolution, right? But it's all planted by Satan to look like evolution happened. You've heard that, right?
Yeah, the Bone Wars.
Yeah, that's what it would be. It would be we are intentionally planting all the evidence that makes it look like a globe, even evidence that you collect yourself. And my reasoning would have to be wrong. My logic would have to be wrong. My measurements would have to be wrong. Everything would have to be wrong.
Absolutely correct, Ruhir. Absolutely correct. You've said this 1,000 times, and I've always been there to just remind you, yes, 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 Ruhir. And like I said, I would wrap you in a toilet paper and flush you down the loo because you're a piece of poo. Okay?
Right. So if all my
Oh, come
reasoning
on, dude.
and
That
all
was
my
good
logic,
until the last part there. Oh, come on. Although that was a bit like
if
comical.
all my reasoning and all my logic and all my measurements and everything is wrong, then I'm insane.
Why are
I
you
can't come
insane
to
instead
any-
of why are you insane instead of just being wrong on that particular thing?
Because then I can't reach a conclusion about anything.
Well,
Well,
but I mean, you're just
wait a sec. But here's the thing: isn't it okay that things are beyond your senses? Like, isn't it okay that you can not know things beyond your senses? Like, you'd laugh at ghosts, right? You don't think ghosts are real. You think that's kind of silly, right?
Right.
It doesn't bother you that ghosts aren't real, but yet you want to be able to know where you're living on. Like, I don't understand that logic, right? Like,
Well,
how do you
I
compartmentalize
know
it like
where
that?
I'm living. I know where I'm living. I love the argument.
You can coordinate where you're living for sure, but you don't really know. I mean, you're just a tiny little guy. I mean, do a scale comparison. Even at your own modeling, you're 7 million times smaller than the Earth. Your own modeling, your own numbers.
We are just little ants on the earth on computers.
Well, you're just little.
I can still work it out.
You can
Regardless
work
of
out
that
a model. You can work out a model, yeah, for sure. You
Yeah.
can take
And that
apparent
model
motions.
matches reality.
You can take apparent motions and induct, some kind of prediction, right? Once you develop a constant, which you've done so, but it wasn't, something that we invented. It just came from the Egyptians, the 60 by 60 by 24. The system has been, what, 3,000 years old? 4,000 years old? I mean, by
don't know where you're
historical records, anyway. The point is that it's all devised by one base system of time and an apparent motion and size. Now, the issue is like the exercise that I gave you with the model is to show you that your model won't represent reality.
Yes,
Just like how when you go to do the model, you'll notice that the sun will change apparent size, particularly in January 21st, the day that I gave you. If you go look in Stellarium, you'll see the apparent diameter as it moves along its pathway slow down, stop changing size, slightly increase in size, and then reverse on back down to reducing in size as it moves away from you for the summertime, right? So January, it's going to move. It's now for 21st. Now it's going to be heading towards its cycle away from you towards winter, right? So as you see that, the sun should actually start to reduce in arc minutes when you watch Stellarium. The point is, you have these. You have these. Let me finish. You have these changing.
Why does it move away from you winter? Why does it move away from us to winter?
So in the summertime, in January 21st, apparently the sun is arc minute of 22.5 arc minute. As it moves away from you, it's going to reduce in 22.5 arc minute to 30 arc minute. And when it does this,
why does it move away from us? Hold on. Why does it move away from you in January?
So according to your model, it's tilting away from the sun, causing the apparent diameter, the change of the sun, right?
No,
and
that's
flat Earth,
not
flat Earth.
Fuck me.
Okay, so the apparent diameter changing of the sun changes based on what motion of the Earth? No motion of the Earth?
Mostly the orbit. Mostly the orbit. Like the orbit changes.
So the orbit. The orbit is changing. So through the day, as the sun is tilting or away from the sun, you're telling me that it's the orbit that's doing it, but it's not the tilting of the sun that's doing it.
The sun doesn't change from day to day, over the course of a day. The angular
Ruhef,
size,
it does change angular size throughout the. It changes angular size throughout the day. You were wrong.
No, it
doesn't. Changes very.
No, it doesn't.
Okay, so listen, boys. Listen, boys. Listen, boys. If in 6 months it changes from 32.5 arc minutes to 30 arc minutes, changing 2.5 arc minutes, it needs to do that daily to complete that cycle.
No, it doesn't.
Fuck's sake, Data.
So both of you guys, would you like me in the chat to post you a video backing up what I'm saying in Stellarium?
Yes, which
in
is
Solarium. You reckon it's going to
Yeah.
change by
You guys listen. I hope
why
you
are
guys
so
do buy. I
confused?
hope you guys support me and you buy the book. You'll be quite pleasantly
What do you
surprised.
mean, book? You're
There's
you don't understand
sections.
basic
There's
logic.
there's section in there of your storytelling, Zanuck. There's
Yeah, I don't
sections
have
in there.
storytelling.
I don't know if I actually have a really good story about you,
Basic
Ruhib.
math,
I've
basic
asked you
physics.
questions
The stuff
before.
I talk
You've
to you
answered them
about
honestly,
is
which I
8th grade.
appreciate. But I have a story of Zanuck, and it's this little pendulum story. He likes the pendulum argument. It's in fact a great story that one of his friends came and aided him in, and it's one of the really shining moments of Zanuck. So 10 years from now, Zanuck, when you buy my book and you read it, it's right there. That whole experience that I had with you is right there. It's
Let's
very
talk about it.
comical. It's
Why
very
is it comical?
comical. No, it's very comical and funny.
Why is
And
it
I hope
funny?
really I get
Because
a way to
people
get it.
have worked
I
on
hope
certain
I hope I
devices
do get it
that
out
are
there because
correlated.
everybody who
Why
took
do you
their
got? What, you
time and
cannot stop
effort.
talking, can you? You can't stop. You just can't.
Everybody who's taken their time
You
and
just, all I
effort
hear
to
is your
come to
voice.
this
You never stop.
to
You never
this
break.
dark web.
Yeah, that's definitely into the beyond monologue category. Go ahead, Zanuck.
Show us this evidence of the sun changing size throughout the day in Stellarium.
I thought, Zanuck, did you want to?
Oh, if I was commenting about the Foucault pendulum and any kind of pendulum experience I had in college or at it's comical that he thinks that these experiences are so funny. That's funny. Why is that funny to you? That we can actually have a Foucault pendulum?
Listen, it blew my fucking mind. I didn't care if the Earth was flat or a globe. I chose flat Earth data because I didn't believe any of it. Right? So listen. When I actually found out there are men, I played a character too, buddy. I'll just let you know when I first started. So at the end of the day, when
Zanuck, you might as well just interview him. It sounds like he wants to be interviewed.
I don't want to be interviewed. I'm just telling you. I couldn't believe it. Grown men were fighting against flat Earth.
I'll interview you.
Grown men were fighting against flat Earth. I was blown away by that, Zanuck. Why would grown adults fight against flat Earth? Why would they care so much? And you know what's funny? I played.
It's interesting. You make good arguments, and it's good.
Too funny.
Well, really,
it's enjoyable to engage in these intellectual conversations about physics and math. That's enjoyable for a lot of people. It's no different than playing chess. It's no different than playing sport, tennis, and basketball. It's the same thing.
You're fighting against flat Earth, dude.
We're not fighting against flat Earth.
You're not fighting against physics. You're not fighting against.
No, we're fighting against physics.
Against flat Earth.
In fact, last night.
No.
You're
talking about models. You're talking about models, and one of them.
Please allow me to speak.
Guys, calm down. Come on. Yeah, Zanuck.
Last night, Gio and I talked about something completely.
Discussions.
Gio. Last night, Gio and I spoke about an hour about something completely non-flat Earth related, but it was related to physics and math. And we went on and on and on, back and forth. It didn't matter that flat Earth or round Earth. It was only about physics and what is correct. Right, Gio?
I believe so. Yeah, we did talk about things.
What was the thing we were talking about that had nothing to do with flat Earth? That was physics related.
Oh, all kinds of things.
So I'm not generalizing your life here, Zanuck, by no means, but I am fascinated. You're correct. It is entertaining, but I'm fascinated by people who think things are crazy. And I bought into it for the entertainment factor, for some of the level of it too, until you become a little bit more wise up to debating and the skill sets that are involved, because it's almost like when you do this, Zanuck, you realize the Earth is not flat like a pancake, right? But you still hold on to the banner as if it's like your badge and why you're here, and it's just really bizarre. That's all.
It's not bizarre. There's just so much evidence.
You're here for flat Earth, dude. You're literally a flat earther. You are here.
Physics.
You're literally flat Earth wouldn't exist if you didn't show up, buddy.
The Earth is not flat.
Do you understand? Flat Earthers need you. You're a flat earther.
I'm not a flat earther, and neither are you. You're just an argumentative pain in the ass most of the time. But you're funny.
I'm a truth seeker.
You're entertaining.
I'm a truth seeker, dude.
You're like a clown.
I'm a truth seeker. I'm a Columbo style. I'm a Columbo style truth seeker, buddy. In other words, Columbo acted like a clown, right?
Can you stop talking?
He clowned around, right?
You can't stop.
Come on. So Zanuck, if you're here for say the physics and the science, part of it, right? Isn't there other forums that are specifically just about those things that you could be a part of?
No, because there's no debate. There's no debate about the basics, which are things that I'm very versed in, and that are the fundamental foundations of bigger picture physics. So when you go to a physics forum, you start debating like, what's the cause of gravity? Is it cause of force? Is it a force? Those debates, then they squash them. They throw them out. What are you, an idiot? What's wrong with you? And you can't even have a discussion because it doesn't matter to them. It's just semantics.
Okay,
So you hear what I'm saying? You hear what I'm saying? What did I say?
Yeah, no,
so why am I not there? Why am I not there? I don't think you're listening. Why am I not there?
Well, if you let me get a word in,
He's a
right,
flat
well,
earther, Bandsaw. He's a flat earther. That's why he's here.
Starting to know my answer. No. You started talking before I was done, Bandsaw. So you must know the answer. So what is it?
Well, okay. Now,
If you were listening, what was I?
I would have thought, like in physics and science forums, there would be lots of debate about lots of different theories, because there's lots of different theories on many different things where people do disagree vehemently on different theories. So to say that everyone kind of agrees on physics and theories, I think is probably myself a little bit incorrect. Now I don't know the ins and outs of it, but you know, talking to some very switched on people that are in the fields, there seems to be like there's a vigorous
So
debate.
you didn't hear anything I said. So I was just a waste of breath on my side.
In the fields.
I told you I didn't want to go there for a specific reason. You can't tell me what I told you because you weren't listening. So there is no debate about, for example, what Coriolis is, or why a balloon hovering above the Earth doesn't have the Earth rotate underneath it due to Coriolis. If you understand Coriolis, it's very apparent and obvious why that can't even be a discussion in those forums. Because you have to have motion in a rotating reference frame for there to be Coriolis. But that just keeps on getting hand waved away and ignored.
Xanax,
so that's
can I ask you a question about
time and time again to talk about what Coriolis is, so we can at least get the fundamental foundations of these concepts understood, so we can have discussions about other things that are more important, like the shape of the Earth. Or
Xanax been out there flat smack in the city.
All right, so you're here to be my teacher, to teach me the fundamentals of Coriolis, because I have it wrong. And when I have the fundamentals of Coriolis right, then we can talk about the shape of the Earth. And then you can then teach me then that my notions of the shape of the Earth are wrong, because now I have an understanding of your correct notion of the fundamentals that are correct, because you have now taught me, right? Put me in my place, taught me, got me on the straight and narrow, right? So now we can have a discussion about the shape of the Earth and then get that right, right? So basically all you're here to do is just to teach me and to continually argue with me, because I'm so dogmatically wrong, and you just get maybe kicks out of you thinking that you're right and I'm wrong, and vice versa.
Well, that's what the dogma is. And yes, if we have a fundamental understanding, the foundation for the physics, it's much easier to talk about the questions, which are, what is the shape of the Earth? So yes, that becomes more interesting at that point. Now, it's a matter of me teaching. Yeah, I enjoy teaching. I've always been a good teacher, and I've enjoyed teaching kids about physics and mechanics and mechanical engineering, et cetera, even at the professional level. And I enjoy that. It's fun to be able to transfer knowledge and shortcuts, and maybe shortcuts in understanding certain complex concepts and understanding them in simpler terms, so they could become useful and more of a foundation for what those people are doing, whether it be a student or a professional engineer in our modern world. So yeah, I enjoy that. I don't know why. It's just kind of fun helping people out. I don't know. Maybe that's just human instinct.
Are you what do you think about the difference between just forcing your teachings on someone and assuming that they're your student, rather than actually getting, an actual agreement from them to actually be in a receiving mode for whatever you're teaching?
Well, I think there's a blurred line between me thinking or treating someone as a subject or a student and me treating the topic or the discussion or the argument that if I can educate or enlighten, it becomes the same thing. So I am teaching. If I can do that, I'm teaching, but I'm not. Obviously, the person does not want to be a student. They want to argue. Their point, they think they're right. I think I'm right. We have the interaction. So even though the end game is the same, the method to get there might be a little different. And so I'm not teaching at that point, although it
So you have a goal that you want to kind of fight with people and then force your teachings on them.
No, I want to expose them.
You do kind of bring that whole vibe. Like a couple of you guys will bring that. Like not all, but some will.
A lot of them do. I actually kind of like it. Like when Emerald talks and a few other really smart young guys that are in the field now of engineering.
Why do I bring that vibe, Gio?
Kind of enjoy the fact that these kids are really bright and they have some specialized knowledge in certain areas. Actually, quite broad knowledge in a lot of areas, but in some areas very specialized. And that knowledge is impressive to me. And I learn because they know more than I do about certain things.
All right. So your teaching capability then,
Knowledge, by the way.
Right. Sorry?
I covet knowledge. I'm envious of knowledge.
Yeah. And that's a very admirable.
And I actually look at flat earthers. And I look at flat earthers.
You come to a fringe subject for the information, though. It's bizarre.
No, it's not.
You don't have to do this. Yeah, dude. Before I got into this stuff, I watched science channels, all the physics stuff. Before I didn't have any to go to flat Earth to do this. When I learned my cameras and my optics stuff, I had no idea anything to do with the flat Earth conversation. The only thing that brought me into the conversation, the only thing that I did, dude, I did this professionally in fucking film, dude. Get the fuck out of here. I knew. Anyway, it doesn't matter. I don't have to give you my fucking expertise in that.
Yeah,
shit.
you do. What you say out of your breath?
I don't have to. I don't have to.
Did you get formal education in this? You don't.
Doesn't matter. I have a professional education, dude.
Being rude.
I have a professional career in optics, buddy. It doesn't matter what the fuck I do. I used optics for a living, lighting, all that shit. So it doesn't matter what I have to profess to you. The point is that
you don't have to do that. No, he just has to stop attacking you.
I've learned all of that stuff independent of the shape of the Earth. The only thing that got me into the subject of the shape of the Earth was the refraction and diffraction of light in general. The man's quantification of the duality of particle and wave. That's what got me into flat Earth. It was all based on optics. And then, of course, you look at optics next is geometry. And it was just a succession of those educational things. So without the introduction of flat Earth and the idea of having the disposition and the idea that you were equal to somebody like Eratosthenes was prevailed endlessly from the globe side. In other words, anybody could be Eratosthenes, right? So if you could be Eratosthenes, then what the fuck this guy do? He took geometry and apparently measured the whole size of the Earth. Okay, let me look into that. Bullshit. Let me look into that a little further. Oh, I can take the Rayleigh criterion, which is an angular relationship due to diffraction, multiply it by the distance of the horizon, get the circumference of the whole of Earth. Interesting.
That's awesome. That's awesome, man. That's awesome. That's beautiful that you just shared.
Do you want to write it down? Do you want to write it down? I'll give you the formula right now, and you can fact check me.
The 1.22 unique 9 are not the same number.
Hold on, Xanax.
Stop.
They're just coincidentally close. They're very close. They're not the same.
It doesn't matter whether it's close or not.
Do you know the difference between diffraction and refraction? Without looking it up, what's the difference between diffraction and refraction?
Spare me your shit, please.
No, please. I'm curious. If you think you know this, I want to prove to myself that you do.
In the case of circular apertures, you have what's called the first minimal light, which is a point where the banding is created for the first beam of light to enter around a circular object or an object in general, any boundaries. You have a first minimum. In this case, it's 1.22 for all limited diffraction systems, which are associated with camera optics. Stop, Xanax, please. I'm just telling you.
You don't even need that.
I'm not going to wait. I'm not.
You can get rid of it altogether.
The Rayleigh criterion. The Rayleigh
criterion. No, that 1.22 and the 1.219. They're not related. Just coincidentally, they are close in value.
Shut up, please.
No, you should.
They are all related to
Guys, you've got to calm down. You're making it audio chaos. Absolute audio chaos.
Yeah, if anyone else wants to pick up any conversation, otherwise I'll unmute these guys one at a time. But you guys gotta like get into some conversation because at that point you're just screaming at each other and insulting each other.
I just wanted to know,
Talking
Gio,
at the
like,
same
do I come off like Xanac or?
Right now, no.
Okay.
Worse.
What about most days?
As I
You're
try
at
to
least-
explain,
you're at least 10 times more jacked up than Xanac right now.
as I try to explain this
10 to the
diffraction limit,
negative 17 more jacked.
The diffraction limit isn't the Rayleigh criterion, although those are related.
oh my
That
goodness,
value,
Danik, you just made
so
yourself
the
sound
Rayleigh
like a fool.
criterion,
Please
yes,
stop.
good. The Rayleigh
Please stop.
criterion, as I told you many times, is something
dude,
that tells you whether you can
what
discern
is-
between two objects
Sure.
being one or two. That's all that is.
So
That's
I
the
have
Rayleigh
a
criterion.
calculation. I have a
At
calculation.
what
to
point does one? I'm still talking, Bansal. You got to let me.
Guys, yeah, it's been taken. Guys, you two have to take care of this yourself. Otherwise, we'll just unmute you one at a time for X period of time and then remute you and then do it that way. We can do it the
Yeah.
easy way or the hard way. Come on, guys.
Well, ideally, we don't really want to have the server set up that mods have to sit there with their finger on the trigger all the time, muting and unmuting people one at a time. I mean, if it's like a debate or like a structured thing, yeah, that makes sense. And if a mod wants to do that, they can. But you have to literally sit there and like mute them and unmute them one at a time. So, yeah, I mean, I don't want to just like leave you guys muted, but you got to somehow like flow with a conversation. But I wanted to say, what's up, Nate? I want to give a shout out to Nate.
Yeah, I think we should be able to mute ourselves and take turns. But when he starts, you try to reassess and reaffirm. Hold on, reaffirm his position.
Danik,
he will
nobody
talk
cares.
over and not give any space. I
Just
will.
do it.
Nobody
Just do
cares,
it.
man.
Right? Just do it. Mod yourselves and just do
I
it.
will.
right?
I will. I will.
Thank you, Nick, and thank you, Data. Go.
So here's my evidence of the 1.22. It's written in camera optics for limited diffraction system. What the correlation of the 1.22 is that if you take the apparent diameter of the Earth, you break it all down, it means that at 1 foot high, there is a horizon line due to physical Earth curve 1.22 miles away. Now, what does that mean? Well, it depends on what you think the horizon is. Now, in camera optics, it means it's the first minimum angle of light that has the limited resolvability, and it's caused by diffraction. In other words, this first angle of light that's subtended from the object through the aperture, as it passes through, it diffracts. In other words, the information is lost, it's unresolvable. But not only that, we also have a focal point which converges this light into an angular acuity. That is theoretically broken down with a mathematical equation called the Rayleigh criterion. That criterion can be used to treat wavelength of light as actual physical objects.
No, that's not how it works.
Let me finish. Let's stop interrupting. So you have a nanometer, which is measured in meters, which is 0.0000122, which is the 1.22. When you break it down from nanometer into the radians, or the value that you need to divide it by, because you're converting it to meters, right? So 1.22 nanometers is 0.000122 meters, because what they do is they quantify wavelengths of light and they give it actual physical properties, because there's a physical property response as light passes around objects or boundaries, which is called diffraction. Not passing through a medium, but passing through boundaries of objects.
All right, so if you're going to do a really long stretch like that, you also would then have to be
Passing
fair.
around and on.
I mean, if you'd have to now give Zanuck the mic so he can actually respond.
Yeah.
To that.
Well, do you
Passing
see how
around
there's a
and
lot
on.
of information? Did you see
No,
how
but
there's a
no,
lot
you
of
just-
information?
I
You
know,
don't
but
allow
you have to
interaction
not,
along the way.
You just had a good stretch. Now you have to mute your
can-
mic and let him respond.
Yeah, you're conflating
Really pretty
the
simple.
1.22 times the observer's height value with the diffractive limit. Those are two values that are not related. The numbers coincidentally are close, but they are not related in any way, shape, or form. You have the wavelength of light, you have the 1.22, and you have the optical size. That is an equation for the diffractive and for the Rayleigh criterion. Both those are related for sure. And the Rayleigh criterion, all that does is tell you when and when you can't see the difference between two objects of a similar size. They become one. They blur it into one. And the diffractive limit is when you can determine whether there's one or two objects. That is the Rayleigh criterion. It is based on and has a fundamental foundation being the diffractive limit. Fraction is the bending of light, and we have the refraction, which is different than diffraction. But you're
Okay, Zanuck, are you repeating what I'm saying? I'll just do a little more concisely for you, okay? Since you attempted to do it. The whole point of the calculation is to determine resolvability. That's it.
No, that's the diffractive limit. Not
let me finish. Let me finish.
That's a foul.
I get a strike.
All of optics uses the Rayleigh criterion for angular resolution. In other words, how you discern, let's say, the shape of a letter E at a certain distance. It doesn't necessarily mean the resolvability between two objects. That's why you can use what's called the Aries disk calculation. It's the same fucking thing, which uses the Rayleigh criterion, and it's a simple calculation to determine at a distance what the size of the Airy disk would be. In other words, could you see something resolvable at 2 feet away, or 2 feet in size? How far away would it take to be a 2 foot blur? In other words, you couldn't tell the information. So these calculations are usable. I took that same calculation. I used the theoretical 500 nanometers and the theoretical 0.05
No, that's
centimeters.
not theoretical. That's the green. That's the green wavelength. Don't say theoretical. That's a
in optics, let me explain. You interrupted again. In optics, you have a theoretical calculation. In other words, the human eyeball isn't exactly all of these calculations, whether it's 0.05 centimeters or whether it's 500. You have to have a base. In other words, just like a 0 point. Oh my God! Shut up already!
No,
Shut up!
We're talking here, two guys.
Shut up!
The lens diameter and the
I'm not
wavelength of
asking
light.
for your verification. I'm not asking for your validation. Okay.
Quickly finish up, Data. Come on.
Yeah.
Anyway,
I mean, how long do you think
I tried it.
that he could even even have a response? Like all he's going to do is just try to lecture you. Because
I'm not lecturing. I'm giving you factual information. I'm giving you factual information.
Just get on an actual point with him.
Yeah, he's not going to do that.
So I'm trying to say that the calculation used is derived from all of these factors: Aries disk, Rayleigh criterion, and the fact that cameras have limited diffractions of 1.22. There's a correlation between optics of the human eye and the limited diffraction systems in cameras. There's just a correlation there, I guess, right? It doesn't mean that it really means anything, does it, Zanuck? But besides that, if we're going to look, hold on, besides that, if we're going to look at the surface,
it depends on the lens diameter.
No, I didn't.
The lens diameter, the wavelength of light, and the one.
Sure, you got different diffraction limits. All of light has a refraction limit and a diffraction limit. Yes. The point is,
what's a refraction limit? What's a refraction limit?
So you know that there is limit.
Do you know the difference between diffraction and refraction?
Oh my God! Please, yeah. Vanek, you're just a waste of time. And if that's the way you are, dishonesty is it's a waste of my time to be with a dishonest person.
I don't think anybody thinks I'm a waste of time.
I took this. Yeah, absolutely, you are. I took the Rayleigh criterion calculation, and by chance, when I used the 500 nanometers and the regular standard size of the human eye, I end up with a 0.0069 maximum theoretical angle. Why I say that is because the human eye has to be perfect shape, perfect everything to have this perfect angle. If I took that angle divided by the tangent of 3 miles, I end up with 24,911 miles. Interesting how the whole reason.
Oh, never mind.
The interesting thing with that calculation, Zanuck, is it's based on optics. And now what's really awesome about that calculation and what confirms that the square root, the observer's height multiplied by 0.96 is that exact interpretation. It's because one is based on refraction and one is based on the idea of the theoretical angular limit of the eye.
It's not based on refraction.
Listen, Zanuck, if you didn't know it.
That was really good. All right, you just laid that out. That was potent, dude. You just laid out some good stuff. Now, Zanuck, do you have an actual response? Not an ad hom, not just some BS. An actual response to what he just said right there. That was succinct. I followed every word of it. I assume you did too.
Well, he forgot that.
What's your response?
1.22 times the square root of the observer's height.
That's your response to everything he said?
Well, that's one. I should be making a list. Everything he said, I have a problem with.
Well, I think
we all know that it's
yes.
1.22 times the square root of the observer's height.
Of course, dude. He knows that.
And the lens size is they take it's not a standard, it's an average, and they use that value of the diameter of the lens of your eye, the eye opening. And then they use the 550 nanometer, not 500 nanometer, because it's roughly green. It's the middle of the visible spectrum. So that's an average also. And in most calculations, you don't even need to use 1.22. For accuracy, you can make it a little more accurate. But the Rayleigh criterion uses a couple other factors, and that is also that you mentioned the Airy circle. That will determine whether those Airy circles will intersect and whether you can see and discern between two objects as being two, or are they just one oval and you can't see a seam between them. That is called the Rayleigh criterion. The diffractive limit is whether you can see them or not. He roughly went through a calculation in a long, roundabout way to determine that it would be close to 0.02 degrees. That's the size, that's the angular size of an object that you would not be able to resolve through a lens of a given height, generally a human eye, the wavelength of light being green, and the 1.22 constant. So you're making everything much more complex. It's very easy.
Again, Danik, you're saying that I'm conflating the 1.22. Stay on topic, okay?
Yes.
How am I conflating the 1.22? Here's my argument before you answer. The 1.22 is not conflated. It's a representation of an angular limit. Henceforth, the 1.22 in limited diffraction systems, like I said, which is solely based on the angular limitation, and the 1.22 that's in the Rayleigh criterion. Whether you call it diffraction, whether you call it...
It's not 1.22, though.
Let me finish. Okay, stop, Zanuck. The Rayleigh criterion uses 1.22. If you'd like me to refer you to an educational video where I learned the optics equation, I can do that for you. Better yet, I'll just tell you, go to Encyclopedia Britannica and type in Physics 101 Optics. There's a lesson for you there. If you disagree with my statement and my information mathematically, then you disagree with Britannica, okay? Because it's not my information. I didn't invent
I'm not
it.
saying that number is wrong.
So,
I'm
let me
saying using
finish.
it for
Let me finish. Let me finish.
1.22 times, hold on, the square root of the observer's height times 1.22. It's not 1.22 for that particular equation.
Okay.
That is
Here's
does
how
not
it
define.
correlates.
Hold on, that does not define a sphere. It's 1.219. It's 1.219. It's a
I don't even
different
think
number.
you understand the content. I don't
They're
even think you
close.
understand.
They're not the.
I don't even think you understand the contention of the argument. What is the horizon in the flat Earth model versus the globe model, Zanuck?
Where is the horizon? Well, the horizon in any model, any flat Earth model, will have to rise to eye level.
Okay, I'm gonna try it again for you. What is the difference between a flat Earth horizon and a globe horizon? What is the difference?
Flat Earth horizon will rise to eye level. The round Earth horizon will always dip below.
Okay,
Based
so
on roughly, this is not an accurate. It's not. Hold on, let me finish. I'm not even finished with the fucking word in your. The roughly,
because you don't even know the definition of horizon.
God, here we go again. You can't help yourself, can you? You're such a rude bastard. So that's
you're going full.
Okay, there you go again. I can't even speak.
All right, dude.
Forget
you guys
it.
are doing pretty darn well there. I got to give you at least like a 7 out of 10 for effort. but where are we at in this? Because that was good there for a moment, and then it.
Come on, you guys really thought Zanuck had any response to my statement?
That's kind of what it came to, Zanuck. Yeah, you couldn't really keep with the. I mean, to be fair, you couldn't really keep with the intellectual. I'm not saying you're not. You weren't keeping with the actual intellectual argument, is what I'm saying. Like you weren't actually rebutting that, and then it. Yeah, so
I was. Gio, he was talking about the 1.2.
You weren't, dude. You actually ran away like a little bunny, and you got.
I haven't run away anywhere. I can't even talk. You won't let me speak.
There's a question on the table, so you want to answer that question, Zanuck?
Yes, the 1.22 is not 1.22 for the square root of the observer's height times 1.22. That 1.2 is 1.219. It's close, it's not the same. They're not related in any way, shape, or form.
What's not related in any way, shape,
the
or form?
The 1.219, the 1.219 versus the 1.22 of the Rayleigh criterion. They are not related.
So what is the 1 point?
Can I finish? So you're not letting me finish. You see what's happening, guys? I'm trying to explain it, and he won't let me finish.
No, what's the 1.219? And what's the 1.22?
What is the two difference? I will tell you if you let me finish the statement. The 1.219 is an average of where the horizon will be below level for a given distance based on the
Right.
observer's height.
Can you show me how you've gotten that formula? Because I can show you where I get the 1.22 for your model. Can you show me where you get the 1.219 for yours?
Yes.
Okay, write it in the chat real
Basically,
quick.
it's a sphere. You take a sphere, and it's
What
25,000
size?
miles in circumference, and that,
Oh, so it's
that value will
25,000,
pop up.
not 24,
And on
not
short
24,901.
On short, oh my fucking god, really?
Not 24,901.
Just
Yes.
just let him
24,901, something close to
Okay, so
25,000.
but you said 25,000, right?
Yes, because I'm at
so Zanuck, what diameter is the Earth?
Sub-percent. What?
What's the diameter of your Earth if you have a 1.219?
The diameter or the radius?
Yep. Diameter, please.
It's roughly 4,000 miles. Or 8,000 miles, sorry.
Your diameter?
Yes.
Your diameter.
Diameter.
It's only 4,000 miles?
Zanuck, honey, I shrunk the Earth? What happened?
No, I said very clearly the radius was 3,900 and the
I
diameter
asked you
is
the
double
diameter,
that.
bud.
And I said
4,000.
double that. I said double that.
You said 4,000.
Immediately.
You said 4,000.
I said double that, 8,000.
Can I?
Okay, so it's not 8,000.
May I interrupt
either.
the kindergartners just
It's
for a second?
close to 8,000.
Please, Chronic. Please.
All right.
There you go.
Okay.
Do it up.
Take a breath, you first and second grader. I'll let you guys guess who's the first and who's the second grader. I had a quick question that my brain is now melted from listening to them too. It is yeah, it was for data. It was for data. Well, actually, first of all, I've never heard an optics expert call it limit of diffraction. The term that's usually used is diffraction limited, but that's neither here nor there. But for an optics expert, I don't know. Maybe you learned it the other.
So
the
does
words
it mean
the
the
other
same
way
thing? Does it
around.
mean the same thing? Or
Yeah,
is it
probably.
totally...
I've never heard an
diffraction
expert say it
limit
that way.
or the limit of diffraction.
But anyways, that's neither here nor there.
Sure. Yeah. You pick up on something that doesn't mean anything.
So, data. Is there any?
No, it doesn't mean a limit of diffraction. It's not. That's not what it means.
It doesn't matter if I misspoke. The translation is there's a diffraction limit.
Said it
diffraction
eight times in this conversation.
Diffraction limited cameras.
It doesn't matter.
I've said,
it doesn't matter.
So how many times did I say diffraction limited cameras?
Just now is the
how many
first
times
and second.
I think you gotta go back.
Anyway.
They're diffraction limited systems. I said it many times.
Question. It's a moot question. It doesn't matter. It doesn't matter.
He's got no argument.
Now I have
he better smoke a joint.
I have a more serious question about the resolution limit. So you're discussing resolved objects. Are there any? Do you have to consider anything different? Take any different considerations when you're in the regime of point sources? Different point sources resolving different point sources, or extended sources. What's the difference between the two?
So all scenarios are done. All scenarios are done with straight lines and angles. What do you want to add to this scenario? The first premise, the first order of measurements is straight lines and angles, with a known distance or a known height or a known angle. So what's the premise?
Huh? Like I asked a direct question.
All first order measurements are straight lines and angles. That's the first thing. In other words, what we're going to use is linear.
Was I muted when I asked my question, or
no? But maybe you should ask it again. Because
okay, I'll ask it again. Sure thing.
The question that you want to.
Yeah. As direct as I possibly can, directly into Data's ear.
Right.
You're asking me if there's anything else, any other variables. That's what you're asking me. I got that.
No,
you were
not at all.
starting to go into like a
I was asking. I was throwing him back at him.
To ask a particular thing.
I asked.
Yeah, I was throwing back at him.
Question.
Is there anything in the medium between the 2 points that will affect the observation? Right. Essentially, correct.
No. Maybe you didn't. No. Of course not. Nothing about the medium. Absolutely nothing about the medium. Okay. In the context of this whole conversation you've been having with Zanuck, my simple question is: it sounded like you were describing and you were talking about an extended object at some distance, a resolved object. So you can resolve things on the surface of this object. Is there any different considerations you have to make in the regime of the diffraction limit, the angular resolution? Are there any different things you have to take into account if you're dealing with just point sources? Not a resolved source. I'm not here to teach you, but as an optics expert, you should know the difference between those two, correct?
So if you're using refraction effects, in other words, telephoto effects,
absolutely
you're going to have
nothing with refraction.
Well, that's how you get your telephotos.
This is
lens,
as
right?
simple as an optics question gets, man. As an expert,
It really is, Data. Come on.
That was still kind of a winding way of
it's ambiguous. It's ambiguous because he's asking.
Don't come to don't white knight for Data.
No, it's I don't understand the question. It sounds ambiguous to me because
an optics
it's
expert doesn't understand the difference between point sources or resolved sources.
Oh, is that the end of the question?
Yeah.
Oh,
it's an extremely it's a 101 level.
It's a clear question.
Okay, then my bad. Actually, that is a clear question. I thought you were just cutting off there, and then there was more to it. So okay.
No, my answer is there are considerations you have to make, but I'm curious what the optics expert.
Well, I don't understand a scenario that I've actually had to worry about a point source unless I was lighting something. And if I was lighting something, I would have to have a point source to get a good reading for lighting purposes. So there are effects with point sources that I can gauge for cinematography purposes.
Okay. Okay, that's enough. I'm understanding more and more as you speak more, so that's fine. We don't have to
understanding more and more. So do you understand that there is a convergence? Doesn't matter what you're looking at. Doesn't matter which direction you look at. That object doesn't change shape or whatever.
You can say however many more words, but I asked you a week 1 introductory level question that you kind of flailed around on like a fish a little bit.
There's what importance is there to a point source when it comes to
learned
angular
in like
resolution?
week number 1, day number 2 of like optics. But
sure, give me an example. Just refresh my memory. Give me an example.
The easiest example ever in the world that anyone can imagine is let's just say a bright flashlight that someone's holding at some distance from you.
Sure, you get an ISO reading. Sure, you get your lighting source. You get your ISO. You get your the frame rate if you want.
Just trying to say a lot of words to sound
okay.
smart.
Again, so if you're shooting at 800 ASO, if you're shooting at 800 ASA or ISO, that will give you
very
more.
Very photoreceptive.
Let me finish. You can shoot at lower light. You can go up to 1600. You can go up to 2400. You can throw it's not words, no reason, you motherfuckers. It's just bullshit lies. Optics. I know a lot about optics, dude, and point source light and how to light a scene. Absolutely. But you're asking a question. You're asking a question.
Unrelated.
If I have a point source light in a scene that's really bright,
you know what a point source means? I don't think you know what a point source of light means.
He's demonstrating he doesn't, but.
Well,
he is an optics expert after all.
Just to be fair on the timing, since Data, you did go for quite a long stretch there. Let's pass it back to Chronic.
Chronic did call me a second grader. I don't resent that.
Could you tell us?
You were the first grader, Zanuck.
What? That's not nice.
Chronic, could you now tell us your answer to the question?
I don't. I'm happy to, but are we acknowledging the teaching that is going to be needed to happen, or do we not appreciate teaching?
Acknowledge the teaching that's going to be happen, dude. You give a scenario of point source lighting. What am I saying wrong about optics? You're challenging my optics level of knowledge, but you're not pointing out what I'm saying wrong. Use an arbitrary, because I rephrased the word when it's limited diffraction systems. You said I first time said it. I said limited diffraction systems many times. You're coming out with no argument, period, and no rebuttal.
No,
you're saying we're going to learn.
It's called a diffraction limit. Those words have to be in that order.
Limited diffraction system is an actual word. Limited diffraction system is an actual word when it comes to optic cameras. Did you guys know that?
I've just never heard an optics expert.
Type it
That's
in.
fine.
Type it in. Then type it in. No, it's not fine.
Like I said, it's neither here nor there.
Type it in. Limited diffraction systems.
Sure.
You have a problem between camera resolution or optic resolution and sensor resolution. Ends up causing diffraction. Listen, buddy, your point source argument, trying to fucking what argument do you have? What am I teaching that is wrong? What am I saying that's incorrect?
I was not.
Limited diffraction system is a real thing. You can Google right now.
I was simply asking if in a different regime, in a point source regime, instead of a resolved object regime, if you need to take different, additional considerations or not. That's not an argument. That's a question that you still haven't answered yet. You started spitting off a lot of different words.
In camera optics, we've tried to find the sharpest. We try to find the sharpest focus point when we shoot against the grid. Do you mean like what do you mean? Like I don't understand the practice of it. So when we go to test out lenses, we shoot them against the screen for sharpness and distortions, and we use a
point source to focus in on, right? When we do that, we can tell the grade of the lens and we send it off to the studio. So tell me, at what point would I use your example as an exercise or something?
I am
you're telling me that I'd learned in the first week. What is it? What would I learn in the first week? You just said that. So what is it? Please educate.
Your descriptions that you gave when you were in first grade arguing with Zenek was a resolved different features of some object. You might have even said like a 2-foot radius object or something at some
So the
distance,
Aries
right?
disk calculation derived from the Rayleigh criterion, you can use to determine the Aries disk blur. That's what I said, word for word.
Sure.
And I think the terminology, just a second, guys.
Okay.
So we're diffractive limited resolution with cameras, and I just put it in the chat of them talking about this limited, where 2 Airy patterns are no longer distinguishable from each other. The diffraction limited resolution. You didn't say diffraction limited resolution. You said the diffraction limit.
Limited diffraction system is a description used in optics. You can type it in.
So
you can go look at it.
Limited resolution. Yes.
You have a diffraction limit calculation, which is the Rayleigh criterion.
Exactly.
And I can derive out of the Rayleigh criterion the diffraction calculation. I can use that Rayleigh criterion angle once I've done it to determine the Aries disk blur. They work together in conjunction with each other.
I regret the semantics.
The diffraction limit is where the 2 Airy
That's what I mean, dude. You came across as a jerk. You came across as a jerk.
The diffraction limit resolution
dude.
often
You came
referred
across
to
as a jerk, just like Zanuck does. You came breaking my balls. I'm a truth seeker, dude. If I am wrong, tell me I'm fucking wrong, but don't be a fucking douche about it.
I asked a simple question, still hasn't been answered.
Well, Chronic. Okay,
show me what I could use it for. You told me that you would learn it in the first week, so please educate us.
Yeah, Chronic, it's kind of a bad look. You're asking this question with this.
It can't be. How many people are in here right
mind
now?
Already. You're waiting.
You
for
learn
him
it
to
in the
say
first
something in your
week,
mind
you
already,
said.
but
So
you're
come
asking,
on,
like,
educate us, buddy.
Hold up.
Please.
Did you not hear me talking, man? Like, you guys can
I did hear
interrupt
you
each
talking,
other
man.
if that's like the standard that you guys want to go for, but I won't accept it. So I was
the
saying,
guy comes out telling me limited diffraction systems. I never heard an optics say that.
I'm almost done.
Well, I
So
mean,
Chronic,
I'm a truth
basically
speaker.
fishing for an answer that you had in your mind already, and then you're saying I'm just asking a question as if you're being, as if you don't know. So if you're looking for him to say a specific thing, and he's asking you for more clarification, then just say it so you can move the conversation forward.
I was giving him more clarification.
You're doing it as an exercise to try to maybe expose him or something like that, but it's not really working. I think you're exposing yourself more.
As I was listening to the elementary school argument going on, a few things just popped up here and there that Data was saying that were kind of contradictory to his claim of being an optics expert. That's all in my head as I was listening.
What is it? You haven't said it yet.
There were a few pieces of terminology that you used that kind of piqued my. I was like, huh. Limited diffraction system. That's never heard an optics expert refer to it that way. But anyway, that, like I said, I regret that's a semantics. That
was a stupid one. Let's move forward.
Yeah, I know that. I admitted that was a stupid. Yes.
Well, there are two different things. A diffraction limited system is different than a diffraction limit. Those are two different things.
No, they're definitely certainly related. Yeah.
They are related 100%. Okay. It's the first subtended angle of light, the first minimum. It has a ratio of 1.22 derived from the Bezel equation. I don't know how to fucking do the Bezel equation. I tried to learn it. I don't have any application in reality to learn it. So I just use the constant, which it changes from 1.22 to 2.56, 3.52, and so forth, depending on the fucking aperture size. The point is, I don't say shit unless I'm trying to. Anyway, I'm not trying to be incorrect, even though I can sound like an asshole and rant and be pedantic. I try to be accurate as possible, and I can guarantee you Google limited diffraction systems, you'll get all the education you want on it, buddy. Now, being I said that, please, what do I learn in the first week of optics, since you consider me a faulty camera optics professional or whatever you want to fucking think I am?
Yes. Yeah, so when discussing these concepts and when discussing diffraction limits in the Rayleigh criterion, it seems a little weird. Maybe that's just because of the specific profession I'm in, but if you're discussing it in the context of resolved objects, images that you're taking of something that is resolved, meaning it's anything that is not a point source. Okay, I know that's a weird explanation. Anything where you can resolve, let's just say for the simplicity of the explanation, features on the surface of this object, be it a Rubik's cube or whatever.
Okay,
like you can
so
resolve
you didn't
the
hear
different
me.
little
Okay,
blocks.
I understand what you're saying. You didn't hear me. Okay, it doesn't matter where you place your eye. All objects will converge into a point. This is called a perspective point. Okay, I can give you an equation for it if you want to help you understand convergence.
I understand perspective.
Okay,
But
do you understand
again,
convergence? Would you like a simple calculation for it?
I do understand.
Take any diameter. Take
But
any
again,
diameter.
You're taking a left turn a little bit. Remember,
No,
we're
buddy.
sticking on Rayleigh criterion, airy risks.
You're talking about a point source of information. In other words, you're trying to.
No,
what are you
I said
trying to imply that?
source. I said resolved source.
Okay, if you're talking about a one direction point source, or is this anywhere the eye can land point source?
What do you mean a one direction?
Here, Chronic.
Okay, so
I gave you a simple example of it.
Let me just ask what I would like to hear. Maybe
you didn't.
Sure, go ahead.
Hold on, because okay, my question would be this: could you, Chronic, could you just repeat your question to Data, and then you give the answer of what you think it is?
Okay.
I'm just gonna mute him. Sorry, Data. I'm just gonna mute you for like a minute. So okay, neither Zanuck or Data will interrupt you. You totally have the mic. Yeah, go ahead.
My original question was in regards to discussions about the Rayleigh criterion and airy rings and airy disks and all of these things, right? The constant, the 1.22 times lambda over d, all that. When discussing this, there's kind of a subtlety that's important in my opinion. It's pretty important, and so I'm not okay. The original question was: is there any consideration that you have to? Are there different considerations you have to make when you're discussing this angular resolution Rayleigh criterion in the context of an object that is resolved in your images, like you're taking pictures of something that is resolved, meaning you can see features on the surface, you can discern different things on this one larger object, versus if you're taking images of an object that it is a point source of light, for example. And so the example I gave was like a really bright flashlight in a dark, field or something, at whatever distance, and you're taking images of it. I would consider that approximately a point source of light in your images. You're not in your images, technically depending on the size of your camera, your aperture, whatever, the diameter of it. But in this more simple conversation, it's a point source of light. So you can't, for example, you're not going to see like the handle of you're not going to see, the different parts of the lens of the bright flashlight. Your imaging is only going to resolve a source of light that is a point. And if you're imaging it at the diffraction limit, then that point will have airy rings that are emanating at different distances from the central point, from the centroid of the point spread function. But it's getting too much in the weeds. But anyways, so that was the question. The explanation is, in my opinion, this doesn't hold for resolved objects. You can't show me a resolved object that has airy rings. So it's kind of fallacious to have a conversation in the context of resolved objects. I understand the resolution limit still applies in a way to, for example, resolving like letters on the side of a ship from really far away. It does, but it might be my own professional bias that deals only with point sources of light, aka stars. But that I feel like Data now because I've been rambling for 5 minutes. But anyway, that's my rant on point
and
source
I won't take
versus,
more than a minute. And I won't take more than a minute, by the way. I promise I won't take more than 30 seconds. So Data, the value for the distance of the horizon is based on this assumed distance of 3963. I said 4,000. You're wrong. You're trying to catch me on 30 something miles, 37 miles of difference. Yeah, okay, 4,000. Double it. The diameter is 8,000. Big deal. The geometric horizon would be 3.57 kilometers times the square root of the height of the eye of the in meters, or about 1.23 miles. So the 1.23 is not 1.22, and they're not related in any way, shape, or form. Even though the numbers look close, and they are very close together value-wise, if you're looking at miles, if you're looking at kilometers, it's double. So 3.57 is not even near 1.22. And by the way, the 1.22 in that Rayleigh criterion is based on other things being rated in what? Meters. So why would you say there's a correlation between these two values that are in the different units of measure? Completely different.
I obviously agree with Zanuck, by the way. I didn't see it
so
yet, they're completely unrelated, but go ahead.
Yeah, I'll educate you why they're related and how that works, okay?
Okay, before you go,
it's just a unit. Now you have to do a pick your own adventure. You have to choose to respond to Chronic or to Zanuck.
I'm going to respond to both of them
and you wrap them into both at the same time. You're like a ninja with
both equations are based on an apparent position called the horizon, correct? Yes, we know that is. That's
what
it's
in both
used
positions.
for.
What do you mean?
So if I was to take the square root of the observer's height
already with your first sentence.
Exactly. I do not agree with.
Are you telling me the conversion units of 1.22 miles and 3.57 kilometers isn't the same? Just units are just transposed.
Yes, that's why I asked the question. Yes, those are the same value.
Yeah. So again, if the idea here, and this is what you have to really
but the
listen
1.22
to carefully.
is based on.
Are you going to let me finish? You keep interrupting me.
I'm sorry. Go ahead.
The premise of both calculations, whether you use kilometers or miles, is to determine the distance to the horizon. Well, this is the conundrum for you fuckers, because that square root calculation is used in the sextant for a refraction calculation to determine the distance above the ground to the horizon, which is an optical location. That's why the calculation is refraction. So if we look at your globe model, you have a parent location with a physical distance based on feet and inches value, not refraction. Because the calculation, the square root you're according to you that you just presented, is not based on refraction. It's based on physical dimensions of the feet and physical dimensions of the Earth. That's what you just presented to me.
Yes.
But here's the thing. Here's the thing, Zanuck, that you can falsify that square root of the observer's height multiplied by 1.22 if you claim that calculation is representation of a physical location. You can debunk that calculation with other optics. Here's where the 1.22. Let me finish, please. Let me finish. Here's where the correlation with the 1.22 is.
It's 1.23. We already decided that, right? You agree.
Again, here's the correlation between the 1.22 with the horizon.
It's not 1.22. It's 1.23.
Here's the correlation with the 1.22 and the horizon calculated with the diameter. What are you afraid of there, princess? You keep interrupting me.
Because it's not the same number. And it's
what are you afraid of, princess?
English.
So here, I'll give you the math. I'll give you the math for the diameter of the Earth right now. 7,918 miles times 5,280 equals 41,807,040. I square root that. I divide that by 5,280. I get the you're gonna end up with 6,000 something. Divide that by 5,280. You end up with 1. You end up with 1.22459. That's based on the diameter of the Earth being 7,918 miles or 3,959 miles radius. That is how you derive the 1.22. Again, the argument is it's 1.22459.
Yeah, it's because that's the radius.
And the Rayleigh criterion is really 1.219.
Hold on, guys. That's because it's the radius of your field of view.
It doesn't matter. The point is the contention is the point of position. The point is the contention is the point at which you claim the position of the horizon and what causes it.
I got brushed right out.
In your calculation, Zanuck, that you just presented me with the 3.56 kilometer version is based on physical feet and inches values, where it's not.
No, it's
refraction calculation. It's not.
Yeah. No, it's based on 678 kilometers, which means 3.75, 3.57.
The smile on your cheeks, but the smile that you guys get from me showing up, it's good. You know, it's all just a shit show at the end of the day, buddy. I hope you get paid good. You do the investment. Look, you're smiling even more, dude. It's all good. I came here to write a story anyway, dude. So I get to sharpen my skills. I get to sharpen my skills.
Chronic's having fun.
I get to stand against bullies and liars, right?
All right.
Okay, Data. Can you address the thing Chronic said? He was very long-winded.
He said that he agreed.
Hold up.
He said that he agreed. Okay, the point source thing. Yes.
Let
yeah,
me
I'll respond.
Finish, man.
Stop interrupting, man. But yeah, he's basically saying that Ares disk isn't really observable outside of point sources. Like you wouldn't use it.
Yeah, so if you use back in the day before optics and camera lenses became better, like again, it has to do with sensor and camera lens quality as part of the diffraction too, they would end up shooting stars at a distance and experiencing this Ares disk thing, right? Came from shooting stars. So I don't know what this guy is talking about. You can go look at how they had a problem shooting stars, and that was one of the issues they had to resolve was this Ares disk shit. So they improved their camera optics and they got rid of it. Now the point source light thing that you're talking about, yeah, it's hard to resolve light, especially if you're trying to find the source. And the only way to find the source is to obviously put filtration into it to get low enough to make sure that the intensity is like even when you put an ND filter, let's say 1000 ND for the sun. I mean, that's, we're going to put a light source on that to see something in space. Now it's going to be hard to do, right? You have to have a low pass filter to begin with. So you need as much light as possible. So how do you throw filtration over these light sources? You can't. So you can't really resolve them.
They can do with the sun all the time.
Yeah, but you're saying that
the sun you can, yeah.
See it with resolved objects.
And closer stars and stuff.
Percentage is picking up more of what I'm saying than you are, Data. And
you're talking about resolving light sources, right?
When you're saying
you're trying to resolve light sources, right?
A resolved source.
I heard
of light, yeah. So check this out. Here, tell me this.
I'm not done, man. I heard the criticism was that you were using Ares disk with resolved objects. And to me, that doesn't make sense. To me, Ares disk only makes sense with using point sources or like.
Okay, so it's called Ares disk blur. Okay, and there's a calculation that you can use from Encyclopedia Britannica. It comes from a ancient guy who did an observation 34 kilometers away at a certain height in a mountain. He apparently
not a resolved object, right?
Let me tell you the story what Britannica teaches you and how to do the calculation where the story comes from. So basically, it's to calculate a 9-foot man. And whether or not how far away you have to be to see a 9-foot man. Well, apparently, this king emperor did a quick calculation. He determined that the size of the blur of this particular object in the distance. Now, I can't verify the story, but they give you a calculation. They say this is how you calculate the blur. In other words, anything smaller than 9 feet would be unresolvable at this distance. And what happened is he saw this blurry figure that apparently was about 9 feet according to the optical calculation that this king had. This is their story. This is how they teach you, and they give you the equation how to break it down. Which, do you want the equation? Do you want me to tell you what it is?
No. I don't think that. No, I'm not saying you can't use the calculation.
So it's an Ares disk blur calculation. It's not mine. Whether you have a problem with it or not, I don't give a fuck. It's not mine.
Bro, I think you're getting it twisted. I completely agree that you could use this calculation to figure out, the diffraction limit or what have you of a resolved object. But they got this calculation or this equation or what have you by observing Ares disk in point sources, because resolved objects don't have Ares disks. That's as far as I know. Now, if you're going to correct me and say that resolved objects
we're doing the Ares. Yes, I understand. You're talking about the rings of Ares disk. I'm talking about the Ares disk blur. So I guess there's two interpretations of it, right? There's one where objects blur in a circular manner, and then there's the rings that blur.
Yeah, so you're saying it a little wrong, but I mean, sure. Now that I have the stage, I'll go ahead and correct it.
I'm saying it a little wrong.
Yeah. So the
I mean, not fully wrong, just a little wrong.
Yeah, percentage to add on like one additional statement. What you said was great, by the way. But if you think of a resolved object, so an object that you're imaging that has some spatial area on your image, within that. So imagine within that resolved object that you're imaging, there might be features that are on that resolved object. So a really quick example is like a boat, a ship or something that has letters, that like the name of the ship. And as it gets in further distances, the resolution limit, the, angular resolution of those letters, let's say, on that resolved object gets harder and harder to discern at, let's say as it gets farther away. But the ship itself is still a resolved object. So yeah,
that would be considered Aries disk blur. You could use the calculation to figure out how far away that boat has to be before that letter disappears.
I would disagree with you, Chronic. I wouldn't consider it resolved object anymore.
But no, we can talk about resolved objects too. So when
It's like a mountain. It's like a mountain. It's like a mountain with trees. As you move away from the mountain, the trees blur into one green mess. You can't see the detail of the trees, but you can still see the mountain.
That could be based on the radar criterion. So this is the
that's based on the Aries disk blur. The radar criterion is all about the diffraction of light. Yep. Resolvability of the light.
Just bite it for a second.
Go ahead,
bite
John.
it. Yeah, thank you. Wow. So when an eagle looks at, and this is a great common example, looks at two mice that are close together, the Rayleigh criterion is determined whether they see two mice or one mouse, and the Aries discs on those are two resolved objects. There's two Aries discs that are created not from a point source but from a resolved image. Would that also make sense, Chronic?
I actually was
from a resolved image. No,
sorry, I dropped out while you said that last few sentences. Sorry about that. Something about an eagle looking at two mice or something.
Yes, and then because they're close together, when they reach the Rayleigh criterion where you cannot distinguish between those two objects, the Aries disk is certainly a part of that calculation and a result of the calculation. And that's not a point source of light.
Sure.
See, you're just transplanting this calculation that you got from observing point sources of light, and you're applying it to a resolved object. There's no problem in that. But the fact is, there's no Airy disk if it's a resolved object.
Exactly.
Well, that's what I'm saying. Isn't there? I mean, I'm asking the question because I know in most descriptions
in practice, I've never myself seen Airy disks using a diffraction.
Here's an example. I just gave you an example.
Okay,
as you look at, I gave you an example.
Yeah. So Chronic. So I'm listening to Chronic. I think you're saying Chronic is you've only seen it with point source of light. I get it, Chronic.
Let him finish what he's saying, and you got it next. Go ahead.
The only in practice, my own experience using diffraction limited optical systems, telescopes, cameras, whatever, have only ever imaged the Airy disks of point sources, never resolved objects. In my own experience.
Go ahead, Dad.
Data can say his 9-foot man on a mountain.
So you're a guy in optics, but never you mocked me from limited diffraction systems.
I never said I was at all.
Yeah, you mocked me, claiming I'm a professional, and I'm not because I said limited diffraction systems, right?
Don't worry,
professionally
he ran
trained
it back,
in optics, dude.
He ran it back. He said it was stupid.
So I have a professional career using optics, buddy. It was what I relied on for income.
That's fine.
Yep,
That's
absolutely.
Fine. Okay.
So at the end of the day, I grasp it very well. I think, I think I'm better than most at how it works, right? So again, at the end of the day, I can present an argument with this, which is if you're looking at a mountain, you want to see a disc, a form of the Aries disk blur, take two large trees and move away from them. They're going to blur, and you can still see them. You can see the shape of them, but you won't see the branches. Eventually, they'll all meld into one.
With anything you're
so
saying.
that's a fucking listen. That is an Aries disk blur. It's calculated. You can calculate
you're not
it.
Imaging in the first Airy ring.
Again, it's a blur of information. That's all you need to know. Whether it's a ring of information, it doesn't matter.
The words you're using are demonstrating your lack of
technically it would be an
optics
Airy disk blur
expertise.
if it's
that's what it's described as. Whether you want to look at the image in your mind of shooting a laser through a hole and seeing the ring, or you want to look at a shitty old telescope information, we're not talking about that. We're talking about a disc that's blurred. Not discs.
No, it's
but
not
one
a disc.
disc.
If it's a resolved object, there's no disc.
The only why it's
not
considered a
resolved.
disc is because the only way it's considered a disc is quantified through a circular aperture through our eye. That's what it's quantified as.
You can image an Airy ring on different shaped apertures. It doesn't need to be circular.
You can use
this is imaged all the this is easily
if you want.
This is easily imaged in any diffraction limited system, optical system. This is seen. I mean, your atmospheric conditions and weather could be bad and stuff like that, but this is easily seen all the time. And your example of the two trees, whatever terminology, English words you want to use, blurring, whatever. What percentage
they're
is saying
not my
still
words.
holds though? No, but what
they're not my
percentage
words.
is saying, and what I'm backing percentage up, that he's saying is that in your example, you are still not imaging any Airy ring however you want to call it, the airy blurring
No,
of
it's
the
just
whatever.
it's a
So,
description of
Chronic,
diffraction.
thank you for
is
the
all it is.
explanation, and I
So
don't
when
know
you
enough
use
about
a,
it.
when you use
I
a
think what you're
formula,
saying
the
is that
formula
we've
is
only
representing.
seen these rings
Let him respond.
through a point source of light.
Zach.
Hold
I
on.
think that makes
So
sense.
you're trying to hold on to one example of it.
Thanks.
but
I
you're
just had to
not.
get
You're
that in
not.
there. I don't know how I got it, but thank you.
You got it, Zanuck. I got you.
Data, you
You're
have the
holding
right
on-
principle. No question. And this is a very, very minor thing. Basically, airy disk, like resolved airy disk, applies to point sources. Resolved images applies to objects. It's as simple as that. Airy disk blur applies to point
That's
sources.
what the calculation
and
is
then,
directly for. Straight lines
blur
of
of resolution or what have you, or just not being resolved applies to the object. It's basically the same thing what you're saying. Your terminology I felt was just a little bit off because you're using airy disk for resolved objects.
That's not
and that
my
just didn't make sense.
terminology. It's literally called an Aries disk calculation, and what's the calculating
Absolutely,
for?
because the calculation is derived from observing a point source. No one's disagreeing
The
with that.
observations derived from the Rayleigh criterion based on a wavelength of light in the aperture of eye. It's not based on a point source. The information.
Where does the wavelength of light come from, man?
Okay, so again, it's based on the wavelength of light in the aperture of your eye. The distance away has a relationship absolutely to the eye, the object.
Of course.
That's what the
Same with the
that's what the
resolution.
that's what the calculation is designed for, is to tell you how far away, based on the wavelength of light and the size of aperture, how far that object will be resolvable.
Yeah, if you
That's
keep the resolving
essentially-
power the same.
And that's called the Aries disk blur calculation. That's what they call it.
Absolutely.
Why do you want to
because
get
they've
it? Why do you want to
derived
get
it
into
from-
this? They derived it from the Rayleigh criterion, dude. That's it. They derived it from the Rayleigh criterion.
No,
the calculation
they've
comes from
derived
the
it from
wavelength of
observing
light.
these wavelengths from a point source of light.
It's fine.
Well, you have
Not
to
from
you have to have
resolved-
you have to have
anyways,
yes, you have to
take
have
it or
a
leave
point
it.
source of you have to have a point source of light to pass it through an aperture, correct? But when we're observing an object, it's not necessarily we're observing an actual physical light point, a point source of light. It doesn't have the same calculation as it would as an object, right?
So we've slowly got you agreeing with us.
I've already known that it's you
Sure.
cannot calculate linear size of light using optics, dude.
Huh? Okay.
What?
It's-
Well, how did you get from where we were to
don't
that?
even address it. Don't even address it, Zanuck.
Oh my God.
Because you can't determine anything about the distance of a star, its true size. its true
Sure.
anything.
Imagine
okay.
imagine you have a marble, all right, and you zoom into it, and there's a specular like highlight from light. Just light is reflecting off it, and you zoom into that light, and you zoom into such an amount or the resolving power you have, or whatever, where you have an airy disk on that light that's reflecting from the marble. From that, it's basically a point source within that object.
Sure.
Now, initially, it was a resolved object because you could see the entirety of the marble and it was resolved. But as you move in to the point source, the marble itself is no longer resolved because you're zooming in. Your resolving power is being focused on this light that's reflecting off of it. And sure, you might see an airy disk. That's because it's no longer a resolved object. You're just resolving that point source. You can't have both. That's my point.
Look at percentage, man. He's kind of.
You can't compare terrestrial objects to celestial objects the same way.
Okay, as a fun transition, I know a really cool at home, basically free experiment. All you need is aluminum foil. I don't know if any of you have seen it, but you can actually you can see the airy rings and basically the point source, the point spread function. I'm sure nobody knows what that is except maybe Data, the optics expert. But you can see the airy rings of your own eyeball, and all you need. I'm turning into like a teacher right now. This is kind of cringe, but all you need is one sheet of aluminum foil, and you poke a extremely tiny pinhole, like with just the tip of anything, a very, very, very tiny little pin prick hole in the aluminum foil, and you set up. So the last object that you'll need is like your smartphone, just a cell phone with a flashlight for the camera, that you take a picture on, and in just one room, a living room or something, you set up your smartphone with the flashlight turned on, and that is going to represent a point source of light. You can set that at one end of the room, and at the very other end of the room, you walk with your aluminum foil, and you stand at the other side of your whatever living room or bedroom or something, and you put the sheet of aluminum foil up to one of your eyeballs. You can just use whatever of whichever eye you want, and you look through that tiny little pinhole at the light from the camera. And you will literally see, assuming that you made the pinhole small enough, it depends on the size of that hole, the pinhole you make in the aluminum foil. But you will literally see with your own eyes, you will see airy rings around that point source of light from the cell phone. And that you're basically imaging you're seeing the point spread function of your eyeball. It's actually an incredibly fun little free at-home experiment.
I got a question for you if you're into this observation stuff and think quantifying it.
Sure.
Tell me what happens this. Okay, so let's say I'm looking at 10 words, and I'm about 3 feet from those 10 words, and they're about maybe a centimeter in size, maybe even less, maybe like a millimeter in size. You could barely make it out, right? The wording. If I take my finger, and if I just look above the surface of my finger where there's that little haze, you see where you go to focus in on your fingers, that little haze over there.
Pinhole diffraction. There you go.
If I put my finger close to that wording and I just look.
I mean, you lost me at haze, but continue.
Okay.
Just for the sake of it.
Okay, so
a pinhole diffraction camera.
Here, look past your finger and tell me if you see a haze over it.
I mean, do the conditions in the room matter?
Let me finish.
I'm in a dark room. Okay.
Well, you need light, but look past. Like, have your finger maybe like 6 inches from your face, and look past it. You'll see like a blur over top of your fingernail. If you look past your finger, 6 inches from your face, maybe a little farther, maybe 10 inches from your face.
Sure.
Have you ever had a pinhole diffraction?
There's a little blur. You see that blur there, right? You see the blur when you look past your finger. You see a blur.
Sure. Yeah. Go ahead.
What do you mean by
Okay.
blur?
Awesome. Now go.
Just go with the percentage. Just say
look
yes.
Past your. Look past your finger, 10 inches from your face. You'll see that there's a little, there's a halo over it or something, like a little. I don't know. What do you want to call it, man?
I'm saying blurry. Yes. I'm saying yes. Go ahead.
Okay, so now take that blur section just above your fingernail. Take any text, really small fucking text that you can't see normally.
Pinhole diffraction. Third grade science.
Hold your finger up to it.
I might have heard.
Now, why can I see if I'm looking at letters and they're blurry? But I take my finger and I just put it 10 inches.
Pinhole diffraction.
Let me finish, buddy. And I look just
You've
above
already
my
finished.
fingernail.
Why are you spoiling it, Zanuck? Let him finish.
All of those lettering all of a sudden become in focus. So why can I focus? I've been trying to figure this out. How am I controlling?
Let me answer, Zanuck. Let me answer, Zanuck. Let me answer.
Yeah, go ahead.
It sounds like pinhole diffraction to me, but if Zanuck wants to elaborate.
So there's no pinhole I'm looking through, so it's not pinhole diffraction.
The same effect.
Third grade
experiment. It's the same effect.
Okay.
Dude, my experiment's 10,000 times more fun to do. Get that piece of aluminum foil, man. It's amazingly fun. You get to image your own.
Pretty cool.
You get to image your own eyeball airy rings. That's.
Yo, you lost me at Halo. Like I'm.
Yeah, Data's talking about.
Look past your finger. Look past your finger.
Data's talking about a blurry finger. All you need is one sheet of aluminum foil with my experiment. Do my experiment. It's way fun.
See, he gives you the airy disc. You're not giving him an airy disc. Data. The pinhole diffractor.
The wavelength of light as it goes over my
pinhole
finger.
Diffractor does.
Just do
this
it.
This is something you think probably 5th grade. They go over this.
I've never done the
pinhole. It's actually
pinhole
really cool.
Yes.
You can actually look through. If you make a fist, and look through the tiniest hole that allows light to go through the fist, you can do the same thing you're talking about, Data. You can look at things that you cannot see with the naked eye, but suddenly they were in focus through the pinhole diffractor.
I find that absolutely fascinating.
It is fascinating, but
I never did it. Listen, I only came interested in science literally 6 years ago when I came across diffractional light. I was a rock and roller, musician, actor, hung out with famous people, did a whole bunch of shit, and then I got into this fucking thing.
Yeah.
No, that's how I got my job. Is I actually had to learn about cameras and shit.
Gotcha,
so, a camera expert, I would say that I'm more so than some. And then, in fact, you know what's going to blow your mind is the interviews I've done with optometrists, and I've only done a couple, 3 as of date. No, but better yet, when I here's the thought experiment. Here's the thought experiment that I've done with them. 2 of them out of the 3 anyway. Is I get them to imagine a hallway, or if we're down one, talk about it. But in this case, we weren't down a hallway. But asking about refraction and this convergent point. Both of them, when I asked them to apply the same effect to the horizon or the sunset, they both literally were almost like both of them basically said they never thought of it that way, which was mind blowing to me. Yeah, it was great. I wish I just could have had their faces on camera though. Again, it's navigated as such, but whether or not you want to deny your senses, I guess it's up to you, right?
Your senses aren't they're not sensitive enough. Your senses
I have another.
Right on, buddy. Right on.
I have one more interesting question, Data, that's slightly sophisticated. So I don't actually expect an answer from you, but there's 2 main.
Ease up on these like.
There's 2 main
comments, man.
Oh, so do I preface it with I expect an answer, or do I not? You called me out earlier for not for going the other way percentage. Which way do I do?
Oh, just the way you say it, it's sophisticated,
okay.
so you might.
So
not,
your
like,
P brain is not going to understand it. Yeah. Okay.
Don't be so goddamn
I should have
sensitive. Come on, we all hate each other.
It's just literally voices on the internet. It's just words on the internet. Okay. There's 2 main characteristics. There's 2 main characteristics. There's probably a few more, but the 2 primary characteristics for actually resolving 2 point sources of light that are extreme, that might be blending or read at the resolution limit or things like that. Can anyone guess either of the 2 before I just give the answer?
Distance and resolving power.
The distance is definitely one. Distance is definitely one.
A guy went to court and he won a court case using the Rayleigh criterion and a radar gun to show that the wavelength of light could not discern.
So you're not answering the question.
Well,
the radar gun had a certain length to the diffraction limit of this gun, couldn't tell apart the 2 vehicles that were coming towards the radar gun. In other words, the guy showed, using the radar criterion and the specifications of the radar gun, showing that it was past the diffraction limit. In other words, he could
How
not,
do you show that in
officer, because he used the specs of the gun.
Took the diameter of that lens,
the distance of wave,
the frequency of the radar, and he got the distance, and that was perfect. That's a great case. I love it. That's awesome.
Yeah, you can go fact check this. It's there. They show you how he did it, but it goes to
I just
show
told you how you did it.
I didn't do it. The guy did it.
Send me the link.
Told you how you did
learn
it.
on this. Learn about.
I found it years ago, dude. I just didn't.
No, it's not that complicated. You already know what it is. I mean, I'm not data. You have the diameter of that radar gun's lens. You have the frequency of the radar given, the laser radar, and then you got the distance of the objects. If they're a certain distance away, you couldn't tell. The radar couldn't tell which one he was looking at. That would be very, very close, by the way.
That's the whole case.
Yeah,
the radar
but
case.
That's
pretty
just
good
math.
to use.
That might not sway a judge.
Yeah, it does.
Is it just math? It's not just math, because there's actually limitations to these tools, bud.
Yeah, and if you can prove them,
wouldn't it have that in the operations manual or anything or whatever to say?
Yeah, it's in the operations manual.
At this distance, anyways.
That's like the main thing they think about. How do you know? Pointing at it, so they have to actually know the distance. And the trick in that case is going to be, how do you prove that that's where he pinged you for the distance? It must have been like coming around a curve or something, or something that actually marked the distance, because otherwise it's just his word.
He just said it was too far. He just said it was too far away to be tagged, and he proved it. But how do you prove that? How do you prove it? What point source did he tag him? Right.
Well, maybe he came around a turn and then stopped, so you knew he didn't go any further than that. You got the distance around the curve. He didn't see after the curve because you stop, and he still had a value for you before you stop.
Yeah, it works
something
like
like
speed traps too, where you know exactly what the cop was.
Yeah,
measure it. Anyways,
sorry, percentage. You got half the answer actually, 50%. That's pretty good. I'll give that like a C.
Yeah, the other one I said was resolving power, like the angular resolution of the lens.
That's important, but it's not the 2 primary ones that I kind of had in my head. But what the one is definitely distance, obviously. So the separation of the 2 point sources. But interestingly,
okay, then distance between the 2 objects.
Well, no, that's that's 1/2. That's 1 out of 2. The distance between the 2 point sources of light. But also the it turns out the ratio of the intensity of light is actually really important. So I would use the term flux ratio. So if the 2 point sources of light are equal brightness, then that's one thing. But if one of the point sources of light is 100 times brighter than the second point source of light that's right next to it, then that actually contributes to the
luminosity. Another big word we're going to have to deal with.
You're talking about the reflection rate can change based on the electromagnetic
luminosity.
coming off.
Luminosity, intensity of. I call it. The term I use is flux ratio. So it's the ratio of the brightness between the 2 point sources. So if one is extremely bright and one is very, very faint, then there's a function you can think that the resolving the 2 point sources of light is much, much harder the closer they are together. If their flux ratio is really huge. But if the ratio of their brightnesses or their flux ratio is near 1 or equals 1, which means they're exactly the same brightness, then
that would only be true. That would only be true if you didn't know the distance apart from them. Because if you didn't know the distance apart, you wouldn't know their size. So you need to know at least a variable of distance. But if you knew the distance,
point sources. What do you mean distance? What distance are you referring to?
So distance apart from two. So if you have a distance to the 2 sources, but they are a certain,
the distance is how far the sources are from each other on your image. That's the distance.
Yeah, that's what I'm saying. Away from you, they have a distance apart, right? If you know that distance, you don't have to worry about this flux of light that you talk about, right?
No,
you don't have to worry about it.
Flux unit per area.
You definitely still do.
On that surface.
Not
if you have known values of the distance apart from each other and they're moving towards you. No, you don't.
No. What if the flux ratio is 0.000 with 10 zeros and a 1? That doesn't.
Well,
then
if you know the width,
if you
know a width of an object, you can calculate the distance of the perspective point or the convergence.
Point sources.
Exactly. It doesn't matter if you have 2 point sources. And you know the distance between those 2 objects moving towards you. All you have to do is do a quick calculation to know at what distance they will converge. You don't need to know anything about the light or the velocity or the speed and the intensity.
One dim headlight, and they're on the same vehicle.
Well, you would have to calculate a distance greater than 2-3 feet.
How do you know how
4
big
feet
the
or
car
whatever
is?
the
How do you know
distance?
if it's not a Lamborghini or a freaking Volkswagen?
Dude, at the end of the day, what do you got? A 5-foot separation between the two, 4-foot separation? There is going to be an average.
But if one light is dimmer than the other, how does that work?
You have a distance between the two. You have a known value. It doesn't care the intensity, brightness of the light anymore.
All I was referring to is analyzing on the image plane, on the image, not so that it doesn't take.
So you're talking about a 2D sensor, 2D flat image. You're measuring on. Okay.
Yeah. The distance between the 2 point sources. Yeah.
You can measure intensity if you have filtration, but you still don't. You still have to have known variables like size and distance anyway. Like, how do you get accurate information without that detail?
I would argue filtration doesn't matter when you're considering point sources. These are point sources. No amount of filtering, whatever, in the ideal scenario that these are.
Well, if you're already a point source, you're reliant on no light except for the point source light entirely anyway.
No, but it comes through your optical system, as you explained, as the optics expert earlier.
Yeah, I know, but so have you done this? Have you zoomed in
all the time?
Okay, so you've taken, let's say this, an observation 2 miles away, there's a lamppost you can zoom in on. You zoom in on it, you fuck with the settings. Can you get an Ari's disk blur?
That lamppost, I would not consider that lamppost a point source of light.
Why? It's in the nighttime and it's the only source of light that's there.
Is your optical system diffraction limited?
Of course it is. They're designed that way, either sensor or lens wise.
Okay, and what happens when you zoom in on the lamp though? Then what happens to your diffraction limited system?
I can open it up and I can resolve
something
the detail.
happens though. Something happens there. Remember, something is happening when you're doing that zooming, right? Yes,
well,
we
it's
both
opening
agree.
up
We don't
the
disagree.
limit. It's opening up the limit of resolution. Yeah.
And guess what else happens?
And it's narrowing the angle.
You can start resolving features on that lamppost.
Yeah, but here's what I'm trying to say to you.
Not a point source.
Yeah, exactly, because it's at a distance where you can resolve it. So you don't know what the point source is. The reason why I gave that example is because you can show the Ari's disk blur by long lens zoom by out of focus with any light, any point source light. You can show this effect by throwing the camera at a focus light at long lens. If that lamppost was farther, like 5, 6, 7 miles, it doesn't matter how long that telephoto zoom lens, or it does matter now how long that telephoto zoom lens is, because at reach a point, no matter how far I zoom in, it will end up as a blur.
No, what you
right?
need are 2 lampposts.
It doesn't matter. There will always be a limitation to the camera's resolvability at point source. The only reason why you know it's not you consider it a point source is because you resolved it in and saw that it was a lamppost.
No, but
still
if you
at
have
point,
2 lampposts and you result like
you can know the distance
an
between the
angular
parts.
resolution that's good enough. You'll see that there in fact 2 resolved lampposts as opposed to just 1. And that's how you'll know that you've reached the Rayleigh criterion.
You'll only know that by knowing the distance apart or the distance to them. I mean,
we don't
how far away you'd have to go to reach that limit, or how far they would have to move away from you to
Or
reach
how
that
much you'd have to change the resolving power of the lens you're using.
Yeah, actually, I never thought of that. Yeah. Well, this is why I go back to the 1.22 and how it correlates and how it's proven to be an optical calculation and not a geometric one.
So
through the use of optics.
So when you zoom, are you adjusting the diameter of the aperture?
Well, usually when you zoom in, you need more light, right?
So is that a yes or a no?
Well, I'm not personally doing it. The camera would do it automatic unless I'm manually adjusting it. But you need more light the farther you zoom in, so it would open up. Yep.
So I just have one more last
Giving
question
you more depth
before
of
I get
field,
out of
right?
here. One more question. So
No, we're
I would
not
actually
doing the aluminum foil experiment.
No. This one's gonna be a more contentious one.
Making that with tin aluminum foil. I thought that's what you were gonna do.
Well, after you use the
Think
tin
it's
foil,
yeah.
after you see the airy rings with your own eyes, then you morph it into a hat and wear it. This one's
Too
gonna be
late,
pretty.
already
This
used it
one's
on
gonna
my
be
Faraday
contentious.
cage.
I'm happy. I'm gonna get out of here on this one because
maybe it's an ether collector.
it's gonna be a great one that's gonna cause some arguing. Which
Is it
great.
directed towards me?
Hey guys,
Sure,
don't interrupt.
sure.
Let's let him hype it up for another 2
Yeah.
minutes.
Okay, so the
Wait, let me get my popcorn. Hold on.
It's the mic drop before the mic drop.
yeah, so I would argue, and many people in here would disagree, but
And don't be drinking milk out of a straw. You're gonna spit up, and it's gonna be like a mess.
I would say that for years and years and years and a very long time now, people using telescopes to measure, and observe, stars and galaxies and what else, stuff in the sky, the moon, whatever. For a long time, there's been quite a simple correction that is done to correct for what's called differential atmospheric refraction. I won't interrogate data on this. I'll just get straight to the point. Or DAR, for example. But so you actually to correct for this, you actually only need 3 very simple things. Arguably very simple. You guys might get peaked on one of the 3 things, but anyways, you need. So in order to correct for this differential atmospheric refraction, all you need to know is the elevation of whatever you're observing, the elevation angle. That's 1. Number 2 is
in the curve.
Yep. No, you're not presupposing. No presupposing any curve, radius, nothing. You just need the elevation angle of the object that you're observing. Number 1. Number 2, you need the parallactic angle, which is just simply the direction of the zenith from your observation. Pretty easy to get. Again, you don't presuppose anything. And the third and final thing you need is some model for the atmosphere. And with those 3 things, you can perform a correction to your differential atmospheric refraction, and you can get the absolute position of your star, your object you're observing, and instead of its apparent position. But just those 3 simple things to do the correction.
What about the size?
What do you mean the size? If it's a star, it's a point source of light. If it's a resolved object like the moon, for example, you can still perform. There's different things you can do. You could perform this correction at the 4 limbs of the moon or just at the center of the moon or something. But I use the correction for just point sources.
So when you say absolute position, you just mean in terms of your field of view, not the actual position.
No, you have your elevation angle that you're whatever star or object you're observing. That's very easy to get. That's your angle above the horizon, for example. Then you have a parallactic angle. That's the direction to the zenith.
Mm-hmm.
So yeah, the direction from your observation to the zenith. That's 2 different values. And
You're
then
talking
you
about
use
a
some
co-altitude angle then? Is that what you're talking about?
No, what I mean is
Not exactly,
what you're
no.
doing is you're getting the 2 dimensions, x, y. You're not getting how far away it is from you. So you don't have.
No, you don't need to know how far away it is from you.
I know for what you're doing, you don't. But when you said absolute position, it made it seem like you know exactly where the star is.
We're going from the premise
position with respect to the zenith, not
this is all with the premise that I think we all agree that the stars and the moon, the lights in the sky and stuff that we see are in apparent position. I think we're all on the same page there. It's an apparent location, apparent position. So
I don't agree with that.
You think it's
That's what Stellarium says, right? And here's the thing: if I take Stellarium, I put myself anywhere. I put myself anywhere in North America or Canada, and I go to Polaris. If I go to Polaris with Stellarium and I use a right angle triangle, in other words, I get my elevation angle like you suggested. I take 90 minus my elevation angle, and I times it by 11131. I get the distance in kilometers to
that's
the
not
GP.
a right triangle data.
It is a right angle triangle because I take a 90 degree. I subtract it from my elevation angle, then I multiply it by 111.31 to get the distance.
Why don't you multiply times 60? Wouldn't that give you the distance as well?
Gio, you don't agree that the star appears to be right there where I'm pointing to with my finger? It appears to be right there. In other words, that's the apparent location of it.
Yeah, I didn't understand.
I wanted to get on the same page vertical with Gio. Or no.
Well, appear and apparent are different, slightly different words.
Oh no,
not quite the same. But
would you like me to post the right angle triangle that's used in this calculation, guys?
All right.
Sure.
If you must.
Is it going to obey trigonometry?
Well,
yeah.
You'd have to define what you mean. Well, if it follows what I just posted, it doesn't revolve around trigonometry or geometry whatsoever. And this is what most flat earthers think. Go ahead and talk about it.
Is that flat
The
soils?
hypotenuse is straight
Flat
line.
soil, yeah. It's a flat soil summary slide of his 5-minute video of what a co-altitude angle, which he gets right on.
So
how to figure out a co-altitude angle, but the problem is his idea that it follows this arc is complete utter bollocks.
Yeah, it's not consistent with reality. Yeah.
No, it not in any way, shape, or form.
Gio, I have 30 seconds left, but so sorry. The apparent. So where I point to something in the sky, that's its apparent location. That's where it appears on the sky. What's wrong with that again?
Well, from one angle, I would agree with that. Yeah, that it is the apparent if you're using it in terms of that definition. But I was thinking
is that a metaphorical angle, or is that a real angle?
That you were talking about the idea that the actual position of it is different than what you're seeing.
Maybe I kind of see what you're thinking.
Me too,
All I'm strictly saying, I'm staying very confined in this box of my words, is the apparent position, the apparent location of where this source of light appears to be in the sky, not physically where it actually exists in the universe, on the dome, in the wherever. It's just,
and so from that perspective, my understanding of it is that the kind of radius of our field of view would be that what you're describing, like the extent of the radius of the field of view of the range that we can see would create that.
I think he's just saying it's a trivially true thing that's its apparent position.
Yeah,
the trivial.
I think maybe you're digging a little deeper than I'm trying to be.
It's apparent within the radial sphere essentially of your field of view. Like, let's call it a hemisphere because it's not going under the Earth. Let's say so. Let's say from the Earth up.
Okay.
Basically, this is how I understand.
That limit, the limit of that is going to create a field for you, like your actual field of view. So then all the stars are going to appear in a particular declination and a particular coordinate position from your position.
I understand what you're saying, Gio. You're basically saying that it could be understood in one and two ways. It could be understood as that's where we see it, and it could be understood as like the reason they're saying apparent image or what have you is because they're implying that the actual image or actual position, apparent position versus actual position, they're implying that the actual position is somewhere else, you know? So I understand you like, you know, kind of listing that caveat.
Maybe I'm still confused about why. I don't know.
If you say apparent, if you say like, you know, apparently, like as if it's in actuality, it's not. It just seems like that, right? So there could be an implication that when you say apparent image, that the actual image is not there.
So okay, I get it. So maybe the word
apparent position. Perhaps we could use apparent position and apparent image.
Okay, or maybe the word I should have used was we can both look up and we see this object, this star, this point of light, and it appears to be right here where I'm pointing. How about that? It appears to be right
angle.
Sure.
When you emphasize appears, it's the same thing.
But that's different than apparent. Apparently, apparently that's different than using apparent position. Anyway, the main point is Zanek put it in the chat.
For example, in the globe model, you've heard for Selenelian eclipses. What you guys have to say is that the light is bending in that scenario.
Sure. Yeah.
So in that case, the actual position of where it's actually showing up in your field of view is dropped because by the time it gets to you, it's curved.
Sure, because its actual position and its apparent position are not the same. Yeah.
Right. So it's sort of like you could point at what you guys might say, oh, that's where it really is if you were to draw a straight line geometrically. However, you're seeing it over there.
Yeah, I see nothing wrong with that.
Somewhere else.
Yeah. I don't see anything wrong with that.
We see this every day with the reason the sun, when it starts to set, it'll start slowing down. The angular velocity of that sun or moon will slow down as it gets to the horizon. That's
it's just parallax as it moves farther.
Yeah.
That's not true.
Percentage.
Yeah. You dug yourself into a hole there, Zanek.
Over a plane, and it's all going down to a point.
It's not a hole at all. That's a reason. That's an explanation.
Anyway, I got to get out.
Yeah, what was the thing though? Okay, so yes, apparently that. Let's just use the word.
Well, Zanek put it in the chat. It's three simple things you need to correct for that.
What's the actual like? You gotta give your mic drop moment here. We didn't even get through it.
Well, I did kind of say it. Zanek backed it up.
On appears, so okay, we're all in agreement. It appears there. Let's go.
Sure, Zanek. So yeah, it appears to be there. Zanek put the 3 points that I already made earlier. You need 3 simple things to calculate how much differential atmospheric refraction is at that point, that apparent point where the star appears to be at, and you get that value and you can correct for it. And you can get the actual location, not the apparent. You can get the absolute position of where that star is. This has been worked out and done for I don't even know how long, 100 years, maybe even longer. It's a very.
Where'd you get the formula from? Just out of curiosity, because a lot of the formulas that I get are from the sextant manuals. When it comes to refraction, I'm not asking you if I'm asking the other guy.
Oh boy,
I know how to drive them all.
manual.
Yeah, they're
not asking you to drive them for me.
There's many different sources that go over this. I mean. More than I could
name me one, because the only calculation I can come to is always a square root calculation. They're always square
Which is the one
things.
inside the sextant?
Not for celestial refraction data.
Yeah, you're talking about different. You're conflating 2 different things.
Like
celestial refraction. So differential atmospheric refraction when observing, nighttime objects with
celestial
your
celestial body versus terrestrial. Yeah, okay.
Whatever. Yeah,
celestial stuff. Yeah.
Conflating a little bit.
Okay.
But anyways, in my
what
opinion,
it is,
it's
refraction. Refraction is
things.
refraction, right? In
why in the
terrestrial,
celestial? Why in the sextant manual do they say instead of using the drop for the horizon to be 1.2, why do they do it 1.7?
They use multiple. They use 0.96. They use 1.17. There's multiple.
So the value
ones.
in the sextant manual would say 1.7.
There's dude. There's 0.962, which is there's the 0.96 comes from the 1 arc minute to the 1 nautical
Can you just
mile,
answer the
which is
question? Why do you have to throw
6,000
other
feet.
numbers in there?
Because
do you not agree that there is in print 1.7 degree drop times the square?
No, there is
you don't
not
think that's in any of the model, any of the structure manuals for it?
So again, Zanuck, I'm going to repeat
it's
myself
a simple
clearly.
question. You can either
There's
disagree or not agree.
multiple
Don't talk about other things.
formulas.
This is your
There's
technique.
multiple formulas.
I'm gonna let you guys devolve back down to elementary. So I gotta get out there. It's great talking to you guys.
Zanuck for you, dude.
Great talking to you guys. I'll catch you guys later.
Good night, Crown. It was a lot of fun.
Catch you later.
He's funny.
Yeah, the 0.96 is for celestial refraction, and that's not a square root of the height. The 0.97 is usually the dip angle.
You jokers. You big fudgy jokers.
Okay.
Well, do you have any response to it or just that? I mean, that's just an add-on. Like what?
Look, man, at the end of the day, all the sextant manuals have a square root of the observer site multiplied by 1.17 or 0.96. It is all in apparent position due to refraction.
The celestial refraction does not have a square root in it.
Not saying that it did. It was more of a question. I'm talking about all terrestrial calculations using the sextant uses a refraction calculation, which is the square root of the observer site times 0.96 or 1.17.
Right,
what if you don't have a C section?
Yeah, it's due to refraction. Just remember,
then there's no
boys,
refraction.
due to refraction.
You directly derive your altitude angle without any refraction or anything horizontal.
Hang on. The 0.97 times the square root of observer height is dip correction, and it is derived from the Earth being a globe. Go.
Yeah, it's not. It's a refraction calculation.
Well,
if you go look at
I've derived it in a video, Data.
It's
I've derived it in a video.
You can derive it all you're wrong. I fly plane, buddy. There's no dip drop for the guy on the ground.
You're a student pilot.
You just sound like an idiot trying to convince somebody there's curvature on the ground. You guys.
Well,
please.
show me how you get 0.97.
You can fool some of them, but what you're doing is just beyond retarded for me. You talk about crazy. You guys are just the epitome of crazy, man. Telling somebody who flies a plane you can measure dip and drop on the ground is just fucking retarded.
Of course, you go up and you measure. You can go up in your plane.
Panic, smile ear to ear, dude.
Go find an airport.
Dude, smile ear to ear. It's you that's being deceptive. It's you that tells one person that it's negligible.
Tough guy.
You don't account for it, and then you try so hard to convince somebody.
I was flying when you were shitting your diapers. Okay.
All right, Zanuck, move on from the ad-homs, but go ahead, dude.
That wasn't an ad-hom. That was just an insult.
Well, I had to
anyway, Data.
One of you because you were talking over each other.
Oh, yeah, right. So anyway, you can do this test yourself, Data, and you can see a green and white flashing light at an airport 100, 200 miles away at as high altitude you fly your little Cessna 172 or 9, and you can see a dip angle from level, and you can multitude of techniques to be able to find out what how far it is below level, and it'll be close to 3 degrees or so. Now, if you are on a flat surface, that would be half the distance away that airport is to you, roughly. So you can do this yourself.
Dip angle today,
and that means the surface is flat. I mean, the surface isn't flat. Sorry.
I could be guessing where you've been dipping angles, Ruben.
Yeah, I measured some dip angles today.
I bet you did.
Let me post it. Hold on.
What'd you measure?
I went up to a place called Beacon Hill, which is 155 meters above sea level, and measured the dip to the horizon.
Did you get some nice planar geometry?
We're using Euclidean geometry to work out angles. Yes.
Some nice XYZ horizontal level.
How does that work on a geodesic model? How does that work on a geodesic model?
Yeah, you understand that we can transform between Euclidean and non-Euclidean
Wow,
fields, right?
you can transform. Yeah,
Yes.
why don't you throw the transformation equations? Show me what you've done, and then transform them back from flat to
God,
planar,
going from a
or
circle
flat
to
to
flat.
spherical. Yeah, and then show me your first order measurements and tell me how you got that on a geodesic one.
Yeah, I'll show you a measurement in a minute when I upload the photos.
Using Euclidean on a large flat ball, right?
I'm using Euclidean on a sphere.
That has no curvature, hence why you're using Euclidean.
So Ruhif, what you're about to show us is in your description of it something that you think you're measuring the globe right here. Is this what you're claiming?
Yep.
Okay. I will take a look at it.
It's just a dip angle to the horizon. Like, it's nothing special.
And what is involved in your interpretation that leads you to the idea that it's a sphere?
That it's consistent with a sphere. It's what I expect on a sphere.
All right, we'll await the photos. Why don't you describe it? Like, what'd you do?
I'll find the location I went to and stick it in the chat.
Do you expect this sphere that you live on to oscillate, slow down, and speed up?
What? Why do you want to just
Went to
change the?
Solarium and actually did some measurement or some analysis of
expect
the
the globe-
program
do you
that
expect-
showed that the sun actually gets smaller and then stops getting smaller, bigger, and he thinks that's his evidence for the fact that the sun is.
There's more than that, dude. Stellarium has it all over, dude. You want to look at retrograde motion of the stars. You want to look at how a rotation's going back, but then you have
there
all
we
the
go.
stars doing something else, different degrees. It's crazy, dude.
All right, there is the measurement through my theodolite, and that was
What's the length of the observation there, Ruhif? 5 miles,
mean the
10 miles.
length? However far the horizon is.
Well, yeah, but that's based on your height, right? You have an angular limit to the horizon. The ground rise up to a neutral point of your eye. You have a limitation. So the higher you go, the more the land stretches out, right? That would be
Point
what
the
you'd find.
theodolite
That's what
at
you'd find
the
on a flat
horizon
surface.
and read
Sure.
off the number.
Sir, you're pointing your theodolite at a horizon over the surface of the Earth. Is that surface of the Earth pointed towards the ocean, Ruhif?
I don't even know what that means, Data. I pointed at
So
the
you're
horizon
at one.
and
You're
measured
at
an
one
angle.
location. Yeah, you're at one location. You're looking off to that horizon. Is that towards the ocean? The direction you're looking
Yes.
off into the.
It
It
looks
is.
like there's
Hey,
water
check it
out
out.
there.
Check it out,
So-
Ruhif. Is it
And
possible that the
how far is
land
that, by the way?
is the land sloping underneath you towards the ocean?
No,
because that's
I
how
have a picture above it that shows the sun below level.
Yeah.
So
how does that work?
What is the extent of your proof?
Digging yourself a hole.
Just a picture of a
No,
digital
dude.
screen?
Again, you're the one getting paid to
Is
fight
it?
against flat Earth. I'm here just to write a book, hopefully to sell it for documentary purposes, man.
All right, so let me
You're not gonna
find
sell
Beacon
any
Hill.
copies of your silly book. Stop being delusional.
Beacon Hill. Hold on. I'll,
Definitely will sell. I'll definitely sell at least
I'll buy
10
it because I want to see my name. I want to see my name in it. I want to see my name.
I'll definitely at least sell 10 because I have 10 orders already. Man, if you know, if I worked harder, I could peddle my book too. But again, it's just not ready yet.
All right, let's put.
The devil's really clever, right? Because he plays both sides perfectly. But not only that, the way he tries to win an argument is he'll present truth in it, but not hide away the duality of that truth, knowing that he's using the actual truthful argument, but you end up believing the lie. That's the crazy part about psychopaths, is that we end up believing the lie while they tell us the truth right in front of our face.
Find a lat long.
Well, there's a picture of
Ruhif,
47,000
basically
feet.
let me ask you,
47,000
Ruhif, do you
feet.
feel like this is in the category of a measurement when you
Yes.
are setting up a device that you didn't build and then just looking at a screen?
Yes.
I'm just asking you. I'm not trying to
Yes,
I'm
I
not
do.
trying to debate it or put it down. I'm just asking, do you when you're doing that, does that feel like a definitive measurement?
Yes. It's an angle measurement.
And you're not using any secondary or tertiary methods to validate this. You're only going off of that equipment.
That
This
equipment wouldn't
device
work unless it
accurately
worked.
measures angles. It's what it does.
At what distance? And what
It doesn't
distance?
matter. There's a line there.
Any distance.
Any distance. So light years to a star?
Yeah. Yes.
Oh,
If I point it at the star,
Yes.
I'm measuring the angle to that star. How difficult is that to comprehend?
I'm glad I'm reminded of that.
I don't understand why that's so difficult. All right, so I'll post the Control Shift C.
And then your whole thing depends on this equipment as well, right?
Say again?
The whole conclusion to what you're presenting here depends on the equipment as well, right?
The equipment measures an angle, right? Very simple.
Right, but your entire result depends on this equipment. That's all I'm stating, which is the
I
obvious.
measured it with this equipment, yes. Anyway, let's get to the actual measurement. So one of those things that I posted gave the height, so 155 meters, and we'll add like 1.5 meters for my observer height. And if I calculate what the angle down to the horizon should be for about 156.5 meters, it should be 0.372 degrees. Copy. So that's what it should be, and that includes standard refraction. I measured.
Oh, there we have it. Ruin.
Do we not have an atmosphere, Geo?
God.
Do we not have an atmosphere?
That's just classic. I love it, dude. That's hilarious.
Okay.
All right. I mean, there you go. You're just starting to calculate, plugging in some radiuses. Basically what you're doing is you're just getting the number you want because it's at a distance that the device is not meant to be used. We all know that a horizon at a very far distance, especially over water and land and all of that, you're not going to even get something close to precise. It's such a often blurred and distant line, and that even looks like kind of a cloudy day. So that to claim that you're getting some kind of accuracy over that distance with this device, all you're doing is you're adjusting it in the way that you need to cook the books. And then
Do you understand that the distance is irrelevant?
To push the narrative.
Do you understand that the distance it's looking is irrelevant?
It absolutely is relevant because that's where your margin of error would come in.
No, I'm just pointing it at something that I see. That's it. I don't know how far away it is. I'm just pointing it at something that I can see. And the theodolite works out how much have I rotated to see that. Anyway, I'm off by like 1/100th of a degree.
With the standard refraction as well, right? The radius, you're plugging it all in. So you're begging the question at the foundation.
That's not a begging the question fallacy, Geo. It's not a fallacy to say if the Earth is this, this is what I expect. That's not a fallacy.
But you're plugging in refractive values that equate for the lacking curvature.
No, I plug in refractive values that are measurable in the atmosphere. Measurable in the atmosphere. You keep saying the same shit all the time, and I keep telling you no. It's like you got a fucking 15-second memory.
Why don't you go measure a body of water, Rui? Do something practical with it.
You did not.
Set up a few stakes.
Oh, I measured the Sydney Tower, by the way. I'll try and find the video for that.
But why don't you do something like more practical with it? Go create a nice horizontal line next to some water.
Yeah, I mean, I was foundationally challenging your assertion, and then you just ended in an ad hom, and we didn't even get to the actual.
You keep coming back with the same response.
Conclusion of it.
Yeah, it matches the calculations for a globe.
Right, so you're using a piece of equipment at way beyond the distance that it's designed to be used.
It doesn't have a distance limit, Gio.
And way
again,
beyond
you keep saying, and I keep saying no.
Margin
it doesn't.
of error that would be required and then you're adjusting it in the way that you want to get that right number.
No.
Then you're adding
Again, refraction is measurable in the atmosphere. It has been measured.
Your quote-unquote prediction is something you're just plugging into it.
Plugging into the device?
No,
What?
plugging into the calculation to
Right.
get your result.
That's my prediction. Yes, that's my prediction.
So you're just that's why it's begging the question. You're predicting.
No, it's not begging the question.
That you're assuming based on data that isn't even linked to that, because once you calculate and add in radius values and things, now you're just adding in a totally new assertion.
The prediction is what would I expect if the Earth has a radius of 6,371 kilometers and has an atmosphere. I get a prediction, and then I go and test reality. If reality matches, that's fantastic.
So you're saying these tools have no limit, Rui?
Correct.
Okay.
Correct.
Okay. Interesting. So then, so then, why then don't these people that use these tools all the time just like put the tool in point A, right, and shoot something that's 5 miles away, and then just calculate everything in, and then put their little marker in there? Now, why do they keep on shooting over such short distances?
Right, because they're trying to carry an elevation. So they're not misusing the tool, they're using the tool for a different purpose. Right? So that's why they say, with an auto level, you should only do, 100-meter shots, right? Because once you get past 100 meters, the error due to curvature and refraction is greater than the accuracy of the instrument.
Oh, really?
Yes.
Really? So these professionals that are doing these things are using them over when they're surveying are using them over 5, 6, 7, 8, 9, 10 mile constantly all the time, are they?
No. They're trying to carry an elevation, right? They're trying to carry an elevation. There is a method to use that instrument to do that properly. It involves short shots, because if you take long shots, then you've got curvature to deal with. In fact, I've got a little, let me find a little citation. Hold on.
If you take long shots, you've got curvature to take into consideration, but when you take short shots, you don't have curvature to take into consideration.
The amount of curvature is insignificant. It's less than the error in the instrument.
Well, you'd always have to take curvature into consideration. It's always there. It's never not been there. It's always there. So you'd always have to calculate for every single time to be accurate.
If you take a 100-meter shot, right? How accurately do you think you can read the rod at 100 meters? Not more than not less than a millimeter. You're not going to be more accurate than a millimeter.
They're not using these tools over vast distances and then signing their life.
Yeah, because they're carrying an elevation. They're using it for a different purpose.
Just not doing it.
Anyway, let me read what I just posted in the chat. It says, automatic level compensators seek a horizontal line of sight through the telescope. There is no way for the compensator to correct for Earth curvature and atmospheric refraction. The best procedure is to simply limit your observations to approximately 100 meters so that the errors are relatively insignificant. That's why they don't shoot any more than 100 meters.
I would say I would say that's your mic drop moment, but I think you're going to want to keep your mic because there's more to be said here.
Okay.
Symbolic.
It's time actually 6:45. Yeah.
All right, so that's you believe that.
That's the fact, right? There's no functional difference in the telescope of an auto level versus the theodolite. They're both just magnifying lenses looking through with a crosshair. They're the same, right? So why is an auto level limited and a theodolite not limited when they're functionally the same thing? They're telescopes, with crosshairs. Harry's in the house.
Wouldn't quite define it as that. an auto level is more than a telescope. It's not even the right thing, not even the right word for it. But I mean, it has a
What they
sight.
are.
It has a sight.
Yeah.
But it's not a telescope.
Yeah, it is. It magnifies things. Even less. Gee.
So Ruhif, I mean, if you didn't add in all the calculations and you just got what you got in the world, what are you getting when you're doing just that without any? That doesn't require going home and taking a notebook and adding things in and doing some chemistry, just on what you got directly. Give us a feedback on that. Exactly what you actually think you did in the physical world.
I have no idea what you're asking. No idea. I took a measurement, right? I want to compare that measurement to my prediction.
So your measurement is claimed to be from horizontal to the horizon.
Yes. And it is 1/100th of a degree off my prediction. Who the fuck's calling a quarter
So
seven?
you're just
Hold on.
basing this off of the distance that
Hang
the
on, one sec.
horizon appears, because that happens on a planar surface. That's what a dip angle is. It's the difference between the height, the horizon, and your feet, essentially, or the ground beneath you. What do you think, Bandsaw? Do you think he is measuring the sphere right here?
No, not at all.
What do you?
Not at all. I'm surprised that someone. Well, I'm not surprised that someone probably has this sort of money just hanging around in the console of his car, just to spend willy nilly. Doesn't actually take the tool out and go create a horizontal line next to a, you know, a nice static body of water and just go, here we go. Here's my horizontal line and here's me 8-inch drop over that mile, guys. Don't have to calculate anything, just directly measure it. Boom. But we want to use these things over, you know, 6 miles, point at something that is just so far in apparent positions and say, oh yeah, my dip correction, I'm 155 meters above this and above that and all that sort of stuff, and it kind of all my calculations work out. Rui loves his calculations. Like, he doesn't want to do anything practical, but he'll do it mathematically. He has said that conclusively. I'm not interested in doing anything practical. I just want to do things mathematically. That's lazy, Rui. That's lazy. You can have a little family project out there. Then you won't have to worry about your daughter coming home one day and go, oh, Dad, it's flat. You won't have to disown her. Because you can both come to the same conclusion. You'll have to say to your daughter, oh my God, I was wrong. No.
Yeah, no, he's gonna get.
riding.
It's gonna be all right. I think he's gonna find it easier. It's kind of like a slide, you know. Once you start sliding down, you know,
Yeah.
you just let go, and the baby's born.
Yeah. It'll be a very humbling experience, I must say. But yeah, no, I'm not suggesting that at all.
Well, he's basically taking an angle, and I mean, I guess like he's not claiming that's the geometric curve of the Earth, is he? I mean, that's kind of what he's going after with this. So
yeah, that's what it sounds like.
Right. So now, is this the refracted horizon? Is it the pseudo horizon number 1, 2, 3, or 4 in their model?
Did he correlate that with all the weather balloon data too between him and the object? I'm kind of
Yeah,
curious.
he's gonna have to add that to his chart ASAP.
Yeah.
We gotta add it to the charts. Maybe get some new colors in there, some new 2.0 version 2.0.
Yeah.
Yeah, and I mean that dip angle will occur just based upon the way that everything meets at the horizontal place of your vision and the way the ground and the sky meet as it goes out. And remember that one presentation Brandon did on this? Were you there for that show? Where he actually, it was one of those times where he was doing kind of like a, like a half-hour presentation type thing, and he was showing these slides and going through it. But he had some good slides. Like he made them himself, I think. Like he actually, and it showed it really well.
But look, when it comes to the dip angle and whatnot, which seems to be something that you have to work in for marine navigation, social navigation, and because your horizon is probably a lot closer to you, the apparent horizon is a lot closer to you. That dip correction that you're allowing for, which is what? That's the height above the surface, the water surface. That's the dip correction, yeah? Joe? That's what that is?
Sorry, I was mostly listening, but I kind of missed the last part.
Yeah. Your dip angle mainly is used in navigation, marine navigation, and that's the distance basically that you are above the water. So if you're standing on your yacht or your ship, you've got that 10-foot distance between you and your
yeah, exactly. And that increases as you go up.
Yeah, exactly right. But the horizon that you're pointing towards is also too far closer. If you're roughly, I don't know, 6 or 10 foot above the water, what's your horizon at 6 foot? About 3 mile thereabouts. Whereas Rui's little thing where he's 200 meters or whatever it was above the surface there. I don't know. It doesn't seem too practical to me. There seems the error would be far higher. Firstly.
Yeah. Well, that's why I think who was it? Data was saying that he had it over water too. It was like way out there. Like when the last part is water, when you have land and then water.
Yeah.
It can be all kinds of refractive effects.
Exactly.
Yeah. How is he? Yeah. I guess now I want to ask him how he even thinks this is even valid at all.
And
to me, this is kind of like wandering a laser into the air and trying to it's not solid. But yeah, go ahead.
Yeah, like you won't get a surveyor to confidently measure anything over a body of water. Having them to sign off on it, I think would be very, very difficult. They tend to work around bodies of water because of the inaccuracies that entails. I know when we were working on a big dam project that we worked on years ago, and it was a very big dam, Geo. Even we did the initial very rough surveying, so we get start the groundworks and all that sort of stuff, like the initial rough in, and start the moving of all the earth and stuff like that. But when it came to the final surveying and whatnot, the surveying was done all around the edges, and then when it came to putting in pipe work and all that sort of stuff, they once again worked around the edges. They wouldn't shoot from one side of the dam to the other. They would shoot along one edge, along the other edge, and back along the next edge. They wouldn't shoot directly across the dam when it was filling up because of the inaccuracy, because they needed to be spot on, because of the pumping systems and stuff that we were installing. Everything had to be all within the allowable tolerances to get everything to work within its maximum capabilities. Shooting these things over bodies of water, it just leaves huge inaccuracies, and I don't know why Rui's taking this shot and this picture and going, ha, here we go, see, I calculated it.
Here we go. I'll just add a little radius value in here.
Exactly.
Maybe you should. Done.
Yeah.
Ready for sale.
That's right. Now go measure the radius first before you add it into your calculation. That'd be a good place to start.
That would be a much fresher start right there.
Wouldn't it?
Yeah. That would be a nice boost.
Like let's start at the beginning, not at the end. Not after the equal sign. Let's start before the equal sign.
Right. I want it to equal the globe, and I want to predict a globe. So I'm going to insert a radius value in these calculations that presume a globe, and then I'm going to get a globe result, and then I'm going to think that I proved the original globe theory.
Look, I'd actually be prepared to go out with Rui and measure something, go up to Lake Air or something like that, and let's measure it, buddy.
Just get some equipment and just have some sword fights.
It could be a pretty cool weekend. We could take a tent, be in the middle of nowhere, battling the snakes and the spiders and stuff in between, shooting a few.
I think if you and Ruhif are in the woods somewhere, one of you guys is ending up with a pillow over your mouth, and you're not leaving. I'm just kidding, of course. That's funny. Definitely kidding, but yeah, you guys would probably strangle each other. But no, I'm just kidding. No, Ruhif might just be like, all right, this is my chance. I can take him out.
Take him out now.
You're going to be drinking, and you're going to, at the end of the night, you're going to pass out. Ruhif's going to come in your tent with a pillow and just come taking out the flat earth. They can't go on without bandsaw, so this will do it.
He got his story straight. He could say the dingoes took me or something.
Yeah.
God. The
well, hello, Bandy.
I've returned.
Hey, Blue, how you going, buddy?
Yeah, pretty good.
Good to hear.
Oh, did Data go? Data's gone.
Hey, there's Ruhif.
Hello.
I had a nice little break.
I was talking to Geo, sorry. I was talking to Geo, wasn't I? Where were we, Geo?
Went away for a dirty weekend, or a dirty 4 days, Blue.
Oh, yeah.
Yeah. So, what do you got, Rui?
I think we were talking about angles down to the horizon, Geo.
Oh.
Excuse me.
Something's wrong with those angles down to the horizon.
They dangle. That's the problem.
Are they getting curvy?
Curve is implied in the measurement.
I can't figure it out, honestly. If you're at a 10-foot observer, if you use the corrections out of the nautical almanac, it just doesn't work.
What do you mean?
If you're at a 10-foot observer height using their correction, your horizon's only 2 miles away. Something's wrong.
Oh.
Interesting.
Or angles down to the horizon the other day as well. What was the height of that? I think it was 102 meters, I think.
So you're saying the almanac is wrong, Blue?
Gotta be. If the Earth's flat.
Oh, right. There you go.
Well, but you were saying it's wrong. I guess you were just being sarcastic and pretending like it was the opposite.
Yeah, I'm being sarcastic.
I guess I somewhat took it seriously. I thought you were actually saying that was the case.
I took some other measurements from here the other day.
So what angles do you think you're getting that don't fit a planar geometry? And what are you assuming
What's the prediction for planar geometry?
What are you assuming the horizon is, and how are you claiming to have measured such horizon?
I simply point my theodolite at it and read off the angle that it measures. It's not any more complicated than that.
Is that where you did it from?
No, that's one the other day. That was on 11th of August, a week ago.
You went up on that little thing?
That's where the survey mark is, yeah.
Nice.
So the survey mark is that. 12.6 meg, really? For a photo? Really? Big photo. Anyway, that's the survey mark up on that little lookout thing.
Do not disturb.
Yes. Don't dig it up. Probably should get the data for that one as well. I'm pretty sure it was 102 meters or something. So
Ruhif, when you're claiming you're measuring this angle to this set horizon with this set
don't say claiming, Geo. I am measuring an angle. Right? That's what the device does.
Okay, cool. So once you're doing that, what are you assuming that horizon is, and how are you assuming that horizon fits your idea of a globe?
Okay. I'm measuring to a thing I can see. That is the extent of the measurement. Okay. When it comes to what my prediction is, I'm predicting using the idea that the Earth is a globe, it has a radius, and we have an atmosphere. But the measurement itself, there's no...
Well, an atmosphere wouldn't necessarily be an assumption, but the first two would be your assumptions.
Sure.
Okay, then what? Okay, you've assumed the sphere. Now what? So now what's the next step?
Calculate what that angle should be, given those assumptions.
Now, what are you assuming the horizon is? Is that the physical edge of the ball?
Yes, it's the last drop of water that we can see.
Okay.
Okay, wow. This is interesting.
A metric horizon.
No, I did not say geometric horizon. Whenever I have Tourette's about the phrase geometric horizon, right? And my Tourette's is that whenever anyone says it, whenever anyone says geometric horizon, I say, when you say geometric horizon, do you mean the horizon that we would see if there was no atmosphere? Is that what you mean?
Well,
what do you mean when you say geometric horizon?
I think in general, geometric horizon would be known as the point. Like if you were to have a basketball with an ant on it, and it's only a couple inches, there's a quite defined line where the edge of the ball meets the sky or whatever's beyond the. So that geometric meaning that it has geometric features of a spherical nature to it, and that is what's making up the horizon, which is kind of the general globe thing. You're looking out, there's the horizon, the edge of the Earth, basically, and space.
Yeah, but does it assume no atmosphere?
The edge of the ball.
Yeah,
Well, that's
but
not.
does it assume no
Yeah,
atmosphere?
that's the thing. Well, yours. So that's what you're saying. This thing is that you're pointing it at, and that's what you're using for your calculations. You're saying this is the actual tip of the ball, like the way like an ant on a basketball. It actually is that the end of the globe.
Yeah, but with an atmosphere or without an atmosphere?
I don't think anyone has ever said there's not an atmosphere that I've ever heard.
Okay. So what do you mean when you say geometric horizon?
I think I just explained it. The physical point
Right.
of the edge, the furthest edge of the sphere that you can see, and where
Right.
that meets with basically outer space in that model.
Right, but looking through an atmosphere, yes?
Of course.
Okay, so your geometric horizon is also the refracted horizon, correct?
I'm not claiming that. No, I don't claim
No.
there is a geometric horizon at all. The
Put
horizon
yourself
is
in
not made
globe
up.
shoes.
Geometry is a part of how horizons are made up, but they're not. They're not what they are.
Okay. The horizon we see is in its refracted position.
That's what you're saying.
Okay. Yes.
Right. So
Right,
how
the
are
thing
you
I'm
using
pointing
it?
at.
How are you using it as a refractive position that you're adding in standard refraction and radius values and all that? How are you using it that and saying that it's the actual curve, the tip of the ball, to where now you're claiming that you're making a calculation that fits that quote unquote prediction, as you're calling it?
Right. I do geometry with curved light and a Earth with a radius.
So you just curve the light into a sphere.
No, I don't curve the light into a sphere. I have a curved path of light, and I account for that, as well as the Earth being a sphere.
So you assume the sphere, and then add the bending to fit the model, even though in reality we're just
No, not to fit the model.
But in
The model
reality,
doesn't-
we're just seeing the extended planar geometry and dip angles.
Well, if you think it's extended planar geometry, please show me your prediction for the angle down to the horizon. How do you get a prediction on your model?
Well, I don't think it's possible to with atmospheric conditions. I mean, in my understanding,
I do it.
To go a little bit philosophical, like the Earth is like a work of art to me in that viewpoint, to where every moment is unique. So the atmospheric conditions at every moment that have ever existed are unique. However, there's similarities certainly in certain areas, as we know. There's certain things that happen regularly and all that, hurricane areas and all the rest of it. So there are certain areas where there's consistencies, but it's unique. So the idea of a prediction, you could get close with certain predict. I mean, we've talked about
that's all I'm asking for.
We've talked about making like a huge scale model, and then we could recreate some atmospheric conditions. That would be interesting, and then see how that matches up. But I mean, to get a perfect prediction is not going to be possible.
No, I agree. It's not perfect.
What we can do is observe the geometry and the refractive effects.
If I go up to this place every couple of days, I will measure the same value within like an arc minute or so. All right, so there is a typical atmosphere. Right, my results won't stray too far outside of some bounds.
Most areas have a consistency, but they vary between each other in terms of how far you can see, and like sometimes
of course,
you
if
can
it's a
see
foggy day, right? You got to see a nice.
Other times,
you got to see a nice crisp horizon, right? We're not going to fucking do this in fog. You've got to have reasonable.
Right, but back to the
visibility.
question. Okay, I'm just trying to go with you on this. So, if you're saying that where you're pointing that device is where you're kind of saying both. It's a refracted horizon and it's the edge of the ball. How can it be both?
Yep. What do you
How
mean?
can it be the end of a physical, actual geometric ball and then also be refracted and therefore in a different position than that edge of the ball? How could it be both?
I don't see a conflict with that. There is a path that the light takes where it just skims the water, right? That path exists. That's what I'm looking at with the theodolite. I don't see the conflict between refraction and a horizon.
Well, the whole thing depends on what that thing is actually pointed at.
Yeah,
In
that
terms of
line,
what you're-
the dark blue
plugging in.
line.
Like that's what you're claiming is the root of this quote unquote prediction. So
Yeah, what's the conflict?
Okay.
There is a
Let me
drop
ask
of
you this.
water
You would agree
somewhere.
that-
Hang on.
An ant on a basketball has a point that you could literally take a string and you could go from the ant to the edge of the ball, or you could put a
Okay.
camera in the eyeballs of the ant. So there is
Hang on. No. You've done two different things there. You've said piece of string and then a camera. Right? The string doesn't give a shit about the atmosphere. The camera does.
Okay, so just explain to us. I'm not even like trying to refute your thing. I'm just explain what you want to about the horizons and refractions and how it's all working. Go ahead.
Okay. There is a drop of water somewhere out there, which is the last drop of water that we can see. Once you go further than that, you can't see that water again. All right. So that drop of water exists, and the light coming to our eye takes a curved path to get there. The end.
Okay, so we got curvy light. Where does the curving
Yep.
Earth come in?
In the prediction as well.
Just because you've implanted it, or because it actually is showing that?
That's my model. My model is that the Earth is a sphere of radius 6371.
So you're just bending light to fit a sphere in a model?
No, I'm not bending light to fit a sphere.
Come on, man. What's going on?
The density gradient in the atmosphere is measurable. I'm not fitting it to predictions. Or, sorry, fitting it to observations.
Well, that's a whole
It's
other
measurable.
model in and of itself, what you're calling density and how you're claiming to have factored all that in. That's a whole nother. Now you're just adding another ad hoc kind of.
That's not ad hoc. The
But
density
original
gradient
thing
in
you
the
did-
atmosphere
The original
is
thing you
measurable.
did, you said you were looking at a horizon that you think is bended light. You then have the calculations for said bended light, and then you're using a model that you're adding a radius to assert a globe quote unquote prediction. But you haven't
That is
actually
my
predicted
prediction.
something in the physical world. You've used something from the physical world and put it into an alternative model and have only verified that external model. That isn't actually verifying the root of that.
My measurements match the prediction of the model. That's what it comes
Can
down
I-
to.
If my mic's going to work for a second, if my connection's going to hold up for a
Yeah,
second.
go ahead. I'll be listening, but I gotta mute for a bit. But yeah, go ahead.
All right.
Let's interject it so you guys can go back to talking. When you say you're adding in bendy light, if you didn't bend the light, you'd still get a ball. You'd just get one that's 7/6R bigger. Is that correct, Rui?
Yeah, but yes, you would, but that's not how we get the radius. I mean, the whole Alberoni thing is not. Yeah, but yes, I see what you mean. Yeah.
For the sake of what Gio's asking, it sounds like what Gio's alluding to is you see a planar thing with zero dip, and then by doing fancy maths afterwards, you end up going from from flat to curve. And what I'm trying to make clear is if you didn't do any math, you'd still end up with curve, just a different rate.
You would if you implied a radius from these measurements, you would get if you implied it without incorporating refraction, you would get 7,500 kilometer radius. Yes.
So that's, but the point I was not making was so much about the radius, just that like,
But there is a radius.
people
Yeah.
without raw calculation, then flat earthers could really be big earthers.
Yes. Anyway, I've got to do some stuff as well. I'll be back in like 10 minutes or so. Talk amongst
What do you
yourselves. Huh?
What do you measure from that altitude? Just out of curiosity, Rue.
What did I measure?
Dip. How much dip do you get? You said you're 102 meters.
102 meters. Let me find the actual measurements. 1 second. I've just uploaded a bunch of shit from my phone. Where are we? I've got to check the actual marker first as well. So so that
get it where you got to get it, Ruhif, but I am definitely not buying it.
Okay. Anyway, that survey mark is 101
Although I'll listen,
meters.
and I will respectfully appreciate you.
Okay.
I mean, it is an interesting way of putting logic together.
The predictions match reality?
No, that you can be measuring something from reality and then creating an alternative system that you feel as though you've verified or have shown predictions for.
Right. Predictions match reality.
Even if you didn't apply
there you
any
go, Blue.
manipulation, you'll end up with a ball.
Only if you add a 3959 radius, you end up with a ball. Yeah.
But it matches, right?
That's what you have to add.
No. What I'm saying is, if you didn't do anything to the numbers Ruhiv's getting, you would still.
If I didn't incorporate refraction, if I didn't add refraction.
No, I'm not claiming that he's not measuring. I mean, I've said many times the 3959 radius is the sphere of our field of view. So he's using similar geometry to get that. He's measuring a position within his own hemispherical field of view.
So we can
happens
see
to be where the ground meets the, where he's claiming the ground meets the water, or sky meets the water. Sorry, go ahead.
Anyway, Blue, I put the measurement. Hang on, Harry. I already got a sec. Blue, I put that measurement in. So 17 and 48.
Yeah.
17 plus 48. Oops. Yeah.
Yeah, I mean, they've reverse engineered the spherical Earth model, in my understanding, from the optics and the spherical field of view that we see within, and how that situates within the larger system of Earth.
All right. So I measured
those
0.
elevations and declinations are all within your field of view. But you have to actually measure the Earth curving to really have that be a thing.
I measured 0.297 degrees, and the prediction is 0.301. So 0.004 degrees off. Not bad. 4 1,000ths of a degree off. Is that okay? That was on a different day as well.
Not much.
Yeah. Anyway, I'll be back in about 10 minutes.
Yeah.
If you had a grid on a piece of paper, and you like an artist, you have your perspective focal point at the end. I don't know what you call that, like the convergence point, is it? And if you had a simple grid worked out, and based on that number, you could adjust it and remove a zero every time you get a shorter or a longer. Like if you had the horizon in the center of the paper, exactly in the center, then you could work out a grid sort of like ascending and descending, and base it on perspective. It's kind of like if you have a light shining over the water, like the moonlight. The closer you get to that convergence point, the light seems to get more condensed and brighter. And I could see where they're getting mistaken, that the light looks like it's bending, but it's just all coming to a point. It's like that congestion of light, and the thickness of the line of the horizon when it's at the horizon, the thickness of that line, the distance of the horizon itself is so condensed, it's actually taking up miles and miles, that horizon line, but it's all condensed into one little point. So you're mistakenly looking at that line thinking that's the last drop of water, but in that last drop of water is condensed into miles. Yeah, you think about an airplane flying over your head from behind you and flying away into the horizon. It's flying at fucking 30,000 feet or whatever, but it flies directly towards the horizon where you're looking, and it almost gets down to your eye level, but it's still at 38,000 feet. That's a real condensed horizon that you have in the distance. You can't say that there's a last drop of water that you're measuring, because that last drop of water is so condensed into a thick horizon line of miles. it's all perspective. That you can't just say it's refraction. It has to be perspective has to be taken into account. Do they ever take perspective into account, Geo? Have you ever heard them mention perspective as it being a thing?
Is it your opinion that people aren't taking perspective into account?
Because it's not in the calculation, is it? Anywhere in Ruhip's calculation does perspective come into play?
Does it not? Like perspective, what is perspective? Just define what you mean by perspective.
So your angle of view, where you're looking at the horizon, which is a condensed line on a surface. If you're just above the ground and you're looking at the horizon 3 miles away, that horizon line is not just a 1 millimeter line from left to right view of that last drop of water. It's a very
I just mean if you define perspective as your angle of view, which sounded like what the words he used, he's measuring an angle measuring. He's using an angle measuring device from his views. So he's definitionally doing exactly what you're saying. Perspective.
Yeah, but he's measuring it in a straight line. He's measuring it in a straight line, but perspective works from top to bottom, left to right as well. It's all converging from all angles coming into one point. That line where he's looking at the vanishing point.
Okay, so what would taking perspective into account look like?
It would look like an equation. It would look like an equation that he is using with his refraction. So I'm not sure if there's some like a artist's perspective program, like if you were wanting to be like on a CAD program or something like that, that would be able to have this mathematical equation. I suppose there must be, otherwise they wouldn't be able to come up with a program like CAD.
It's just trigonometry. If you're saying the rate at things at which things get smaller as they go away from you, it's just a right angle triangle where
they get smaller.
The base of the distance from your eye is the base of the triangle, and the height of the object is the far side, the short side of the triangle. But that's what you're doing. If you're using an angle measuring device, you're just doing trig. So would that be a good enough equation to trig?
I don't think so, because you have all of the left, right, up and down condensed layers all coming into that convergence point where it's going to be a very condensed, just like the airplane analogy I was saying, it's 38,000 feet, but it looks like it's straight. You're looking straight ahead, but you're looking at 38,000 feet above you at the same time.
So what's the equation then? It's not a trigonometric.
I'm not claiming that I can come up with an equation, but I'm saying that that this isn't taken into account in his equation. He's not taking perspective into account.
Please show me how to do that, because I don't think anything needs to change. What I've done is correct. Please point out the error. Don't just say, oh, you need to do this. Show how it should be done differently.
From an artist's perspective, you would need to take perspective into account.
Okay. Show me how to correct my prediction. Don't just say it's wrong, right? Fix it.
Okay, to correct your prediction, you'd have to take out the assumption that light is bending towards down.
Why would I take that out when that's exactly what it does?
Because that hasn't been proven. It's still an assumption.
We have a measurable density gradient, right? Do you accept Snell's law?
I do, but at the same time, I also think that needs to take perspective into account, which it doesn't.
Snell's law? Holy shit! Again, if you want to fix Snell's law, I mean, do you think Snell's law gives the wrong result?
I'd say I'd put my hand on my heart and say that if he's a baller, then yeah, there must be something wrong.
What? I thought the question was, does Snell's law work as is?
My question to you was that you're claiming that there's refraction involved in your measurements.
Yep.
But you haven't taken perspective into account. Why not?
Okay. I will tell you that my calculations are correct. You're saying they're wrong. Please correct my calculations to, quote unquote, take perspective into account. Please give me the correct formula.
I would say that it's kind of like you have already figured out a way to manipulate what your understanding of perspective is, and you've hijacked it in such a way that you are using this refraction and your calculations when in fact it's kind of like a reverse engineering of your actual understanding of perspective, which you're not admitting this is where you're getting your calculation from.
If you think you understand perspective better than me, then you should be able to give me the correct, quote unquote, correct formula, right? You can't do that because you're talking shit.
Well, you can say whatever you like, but you know, at the end of the day, you still have quite a few assumptions, and
that's fine. Right? I assume a sphere, and everything in reality matches that assumption. So I'm fairly confident that assumption's actually correct.
You could use many other assumptions and still come up with the same result and the same numbers that you've come up with same amount of errors.
Yeah, I mean, I think that term right there, you just said fairly confident. I mean, that sounds a little like, 60, 70%. I mean,
I was underplaying it, Gio.
Well,
I have 0% doubt
it's a
that the Earth's a
Freudian
globe.
slip. It's a Freudian tone.
0% doubt.
Freudian tone. Well, before you were saying that, like, if you realized the Earth was not a globe, that you would be insane. I don't think you would be insane. I just think that you would have to look at a scenario like this and be like, oh, okay, I just took those assumptions and ran with it, and that's what was faulty.
If every observation matches the globe and nothing matches flat Earth, like what the hell?
Well,
It's not.
My understanding is that it's completely the opposite. It's all planar geometry.
Then show it to us. What's your prediction for the dip angle to the horizon?
But Gio, how?
It's all fun and games just to say it's planar geometry. Show us the geometry.
Right, that does as
you're
many
cutting out,
actual raw measurements as.
Someone was trying to ask a question. Who was that?
That was riding.
Roddy, you try again, but you were kind of cutting in and out.
He's on a motorbike.
Yeah, maybe he's
screaming through Timor, running for his life.
Harry's 100%. Nobody has done as many raw measurements as me.
Really?
And he's texting in the chat. He's poning flat Earth left and right.
I think you do secretly understand exactly how perspective works, and you've hijacked it. And
I don't secretly understand it.
You do, and you've secretly got a formula, like I was saying, on a piece of paper with your vanishing line in the middle, and you've worked out sort of like an approximate to get these numbers quickly, as if you were, and you know that the average distance to the horizon from a certain altitude is going to be a certain amount. I think you know how to fudge the numbers, yeah.
But how can you make that claim if you don't know how to account for perspective?
Yep.
I think he does. He's more clever than he makes out.
No, how can you, Carlos, how can you make the claim that he's doing that if you can't do the same? How do you know what method he's employing if you have no method?
Oh,
I've
Doofus,
just,
how you going?
I've just posted the dip correction angle, like the dip correction formula and the derivation in the chat. It's not difficult. It's really not difficult.
Very simple trig.
What did I say it was going to be? Did I say it was going to be trig?
Well, you can do it with Pythagoras. It's a bit less accurate, but yes.
Did you know, Harry, that self-praise is no praise at all?
It's like if you are actually the best, can you even call that arrogance?
Yeah.
Well, I'm the only person excellent enough to assess my excellence.
It's not bragging when you're the best, eh?
Yeah, Carlos, if you can't actually, derive any kind of formula for flat Earth dip angle, like,
You have
why
to
are we having
talk
this
to
conversation?
wisdom. I'm not the mathematician in the family. I'm just saying that I assume that you have a deeper understanding of what you're actually looking at.
Right. Or the Earth's a globe, and that's just the very simple geometry of it. That's your other possibility.
Yeah, you could say that, but there are too many holes in the argument, and we wouldn't be here talking about it today if it had been settled already.
No, we wouldn't be here if you guys would actually be rational, honestly. Like I've
if
always
you're
said.
talking about holes, every single one that comes up, we discuss at length, and then we have to change the topic because we never can finish discussing the fact that it's not a hole.
Yeah.
Because
like I've said,
because the conversation never comes to an end. Because when you get to the end of the rope on one part of the conversation, you have no choice but to move on to the next step, and it's just a continuous spinning cycle and never ending because there is no definite answer. There's always an argument at the end of the argument. That's what I'm trying to say. It's never ending because you don't have definite proof.
It's never ending because you don't listen to the answers. Like I've said to Geo probably 20 times that we don't, fiddle with refraction to match observations. Refraction is it's a measurable density gradient in the atmosphere. I don't know how many times I've told Geo that, but he keeps coming back and saying you're just fitting it to observations. We just repeat the same shit all the time, and you guys don't listen. That's why the argument keeps going on.
I mean, I guess that's your interpretation of it, but that's not, in my understanding, what's happening.
Okay.
What we're discussing with it. I think we've gone through it multiple times. I've been pretty clear in what I actually have said.
Right. How many times did you tell him that he has to make the observations fit a ball? And that's not what he's actually doing.
That's not what I said.
It absolutely
make
is.
the sphere model
Not
fit.
use that combination of words. What he just said.
You did say you have to make the sphere model fit.
I don't think I said those words in that order either, but I did talk about plugging in certain values, such as said radius, in order to create a model that you then are, yes, a secondary system that you're then claiming that the original observation and assumptions based upon that is then plugged into.
Or it would be much easier to say the observations fit the model.
Yes. Blue.
So
So
you can just
you
could
Is
just
it a model of what? Your field of view?
the model fits the observation.
No, it's not a model of the observation. You're modeling what you
It is
should
more like
expect
that,
to
actually, what
see.
Carlos just said. It is more like that. Yeah, the model fits. Yeah, the model is basically programmed to receive the input they're putting into it, and it's just spitting that out. And then they're just linking a physical correlation with assumptive bendy light to then calculate this model of a globe, but not actually verifying it in the physical world.
That statement literally belies your ignorance of programming.
Hang on a sec. 24 miles.
If you can program yourself exactly what the model says, a spherical Earth with a certain radius, and if you choose to include refraction as well, there's no way in that program that you've defined for the observation to go in and for it to spit out the expected thing on the observation. It literally cannot do that because you've programmed it some other way.
I think Geo's sort of denigrating the sort of reverse engineering aspect of creating a model. I've got no issues whatsoever. Like, we take observations in reality and we go, what model could explain those? That's reverse engineering. That's literally how you make models.
There's a lady
this is going to be kind of a little bit of a crude correlation the way I'm going to say this, but let's just say that there's wind currents, in a certain area. So, little wind around an area. If you then built a model and said, okay, my theory, I'm going to come up with a theory. These are, plug in whatever mythical, okay, invisible alien elves, whatever you want to call, these are invisible alien elves, and they run over here and they run over there, and it causes the wind to move in this way. So now I have this invisible elves theory. I have the actual observation in the physical world. So I do have, oh, look, that little burst of air went over there, that little burst of air. So you can say, look, I'm verifying this prediction, but I'm plugging it into this model of how the invisible alien elves, or whatever I call them, are running around creating that wind. Now I could then do that. And you guys are also kind of plugging in there's a radius value. So that would sort of be like plugging in like the speed that the elves run or something, like the average speed. Maybe that would be a correlation to the radius value, because you're plugging that in. And then you're using that data to claim that it's confirming the original model said, alien elves that are causing the wind to blow. Now, that doesn't mean that you've actually proven that it is the alien elves that are causing that. You're just plugging in particular values into a preferred model and getting that to compute.
Well, then let's bring it down to what we're actually talking about instead of invisible alien elves. The radius of the Earth being plugged into a model that shows, or that tells us what the horizon dip we expect should be, had its radius value come from other observations that didn't necessarily require using the horizon. For instance, using celestial observations with respect to various positions on Earth, or using objects dropping in the distance, dropping with respect to distance. Both of those things don't involve the horizon, yet the information we gained from those observations could be used to predict where we expect the horizon to be. And lo and behold, it matches.
Lo and behold.
Now, Carlos, why do these conversations keep going? Why do you think, if we come down to this point in the conversation, why does the conversation continue? Sounds like somebody's breaking up.
He's also on mute, according to me as well.
I mean, I'm deeply interested as to why the conversation continues when we reach this point, especially considering, like, earlier the conversation involved there's some maximum distance for theodolites. And I, just made an offhand comment in the text chat. I bet you there's never going to be a citation for this. And there never is a citation for it. The claim always comes out that there's some maximum range for theodolite, and nobody fucking posts a citation. but the conversation continues.
I have a citation. Let me post it again. Where is it? There it is. I read this out like half an hour ago, this one. It's nice. The second half of it. Do you want to read it out, Lucas?
Read it out? Oh, okay.
Yeah, the second half.
Curvature and refraction. Automatic level compensators seek a horizontal line of sight through the telescope. There is no way for the compensator to correct for Earth curvature and atmospheric refraction. The best procedure is to simply limit your observations to approximately 100 meters so that the errors are relatively insignificant.
I wonder if that's why you shouldn't look any further than 100 meters with an auto level, because the Earth's curved.
Could very well be.
Should go feed dogs in a minute, I think. Oh, I know.
So where are you, Doofus, on this conversation that's been happening? I've been hearing over the last few days on the ether.
Well, I mean, I heard QE was trying to rip into it. I haven't really had too much involvement in the conversation. It was interesting, actually. It was interesting hearing Witsit describing light having better transmission properties through less air or a rarefied medium. And for some reason, some flat earthers giving him blowback on that very real observation. I thought it was strange. It was weird that I was trying to take Witsit's side on that particular issue.
Yeah, well, that would be probably a strange feeling for yourself. I would agree there, but yeah, whether or not you call it ether, or say for argument's sake, dark matter, do you agree maybe that there seems the need to be a placeholder for stuff that we don't know about, whether or not you want to call that ether or say dark matter?
I would say ether and dark matter are totally not synonymous. Dark matter is something that has a varying density across regions of space, and ether supposedly wouldn't have such a property. And in addition, if you guys want to call the various fields that stuff propagates in the ether, that's fine. People can do that. I'm totally not against that. But when somebody says the ether can, and then they list an effect the ether should be able to have on something, that's where I take issue. Like when they say the ether can cause this inertial effect in this rotating object, but not cause that effect on an object that's not rotating, that's where it gets really weird. It's a claim totally without evidence, just made up.
Right. So you think there's a distinct difference between the two, whether it's ether or dark matter? You think there's a very clear distinction between the two of them?
Yeah, I'm not sure where the connection's supposed to be for ether and dark matter. They're not stated to be replacements for one another.
Oh, I just see whether or not it is ether or dark matter. Me personally, myself, it seems to be this this placeholder between the stuff that we know of, for that empty nothing, for that empty nothingness. Right. So we know the stuff that we know. We can quantify the stuff that we know. But what's between the stuff that we know, we can't seem to quantify it or measure it yet. So it's kind of a placeholder. We can see some effects of stuff that we can't quite quantify yet. And so, whether or not we want to call it ether or dark matter, that's kind of how I see the two of those things. For me, they're kind of in the same bucket.
Nobody else would agree, I don't think, with the dark matter replacement for ether, because dark matter is not stated to be the stuff that's in between everything, because, as I mentioned earlier, it has varying densities in various regions of space. So it's more correct to say, if you're going to take maybe a mainstream science terminology as opposition to ether, it would be fields or regions of space-time or anything but dark matter, essentially. Dark matter doesn't really fit in this conversation.
Right, okay then. Fair enough. Fair enough. Interesting. Yeah, I've got to go back and watch a couple of those. I think there was an episode on, I think it was Nathan's. People seem to be talking about where, I think it was Dyslow got shredded by QE. I've heard.
Oh, yeah, Nathan was definitely very vocal. I saw a very brief video clip of it, though. I didn't see the show where it came from, and yeah, it was quite loud.
So they're obviously anti the ether, from what I can gather by the stance that they're taking. Are they, to your knowledge, are they replacing it with anything? Do they have to have a substitute? Are they taking on board space-time or dark matter or these sorts of things? Are they taking on any of these things?
I don't know what their actual position is, but I would say that it would be against their usual character to take an affirmative position in opposition to ether. I think they would prefer to not make a positive claim there.
Right.
Oh, and I think their biggest issue is with the way that it's been described by Ken Wheeler and his various people that like to listen to what he says. The particular words that are chosen to be used in their particular order and relationship with other words, they don't like the way that it's being described. That's really as far as deep as it really needs to be, I think.
Yeah. Have you got any time for anything that Ken Wheeler himself views? Because I don't know, they put him up on as what the magnetism man. Do you totally disagree with everything that he says? He's completely wacky, or do you get on board with some of the stuff that he proposes?
Yeah, I can't really say I agree with too much of it. He goes on to things about the dielectric in opposition to, or in counter space, in opposition to. It gets really complicated because he's just throwing out words, and none of it really has a good predictive model. That's the really key point, is that there's no model with this to tell us what his version of reality can be used for. There's no descriptive nature that gives us new knowledge that tells us we can do things that we haven't already been able to do.
So the way he views it, the way he can predict anything, and I don't know what he can and can't do, just to be quite honest with you, because when I watch any of his videos, I kind of get lost in the verbiage that is used and stuff. But he has no predictive applications for anything that he says in reality, like here on Earth. I'm not talking about the stuff that's far away. Like here on Earth, there's nothing that he says that is useful.
Right. If he's got a better understanding, then surely he's released some devices that make use of this new understanding of magnetism or anything else, really reality in general. And we use that to do something that we couldn't do with our previous understanding. That would be great if he would release something like that, but it never has materialized.
Well, when it comes to practical applications with what he seems to know about magnetism, he seems to have put that practically. And I haven't done a great deal of research into it, and I may have mentioned it to you once before in regards to the recovery of gold in sleuth boxes when it comes to the flour gold, the very, very fine stuff, with his application of magnets, and specifically very specific strength magnets in a particular array, seems to have been successful in the recovery of flour gold in the sleuth boxes. So that seems to be like a practical application that he has used with what he tends to understand about how the field, the magnetic field works, and how he can slow down the flour gold to such a speed that it has time to then settle in the sleuth box and be recovered rather successfully. So I would say that would be a practical demonstration from what I can gather.
Well, we're already aware of paramagnetism and diamagnetism and ferromagnetism. There's more, but there's that. All of that is stuff that we're already aware of. We already know that this happens, where various materials respond to electromagnetic field in different ways. It's not really new.
Okay.
Yeah, like copper and lead and steel, they all respond a little differently. The thing that is more interesting to me is the whole anti-electron thing. he's very against the idea of an electron. When we got these things called TVs, or at least when we were younger, they were all, when they were still working, CRT TVs.
Oh yeah, I've still got one actually.
Yeah, the big old tubes that are firing
Yeah.
electrons all the time, and they're being redirected by electromagnets around the yolks around the outside, changing the direction of the electrons. When they hit the phosphors, they fluoresce, and there we go. We got fucking. We have everything we need in regards to electrons, and he still has an issue with that. That also gets me.
Yeah, and I've still got one of those doofus, and it still works with a
hook a PS2 up to it.
Well, no. I've got a desktop box which converts analog to digital, digital to analog signals actually.
Oh.
Yeah, and it's the thing. Actually, I actually tested it about 12 months ago because I don't use it, but it's still kind of there in the garage, probably for memory's sake. There, but it still sits there. But and the thing actually still does work, surprisingly. Very surprising.
You might be able to find a retro gamer or somewhere that's streaming them playing old games like Super Nintendo games or Genesis games or whatever, who might actually pay good money for that. Maybe, like, I mean, good in this case would be like $60 or $70 maybe.
Oh yeah.
If it's in great working condition. And if it happens to be like a particularly sought after thing, like if it's a Trinitron, you might get a pretty good bit of money out of it.
Yeah. Oh, look, I'm not really interested in selling it, to be honest with you. It's like an old fridge that I've still got. That it's an old Westinghouse fridge that, God, it's nearly as old as what I am. Doofus, and it still goes strong. It still goes strong.
Yeah, I've got what I don't remember the brand name on it, but there is a fridge I have in the basement that has been unplugged when we moved in. It's probably been unplugged for years because it probably used to be what's up in the spot where the current fridge is, and we moved in furnished, so we were super happy. But we had to power that thing up because we were stocking up at 2020 for a thing that is a topic that we probably shouldn't discuss.
Yeah.
But I had that. The thing still works. Of course, it collects condensation like a motherfucker, though. So it's got a leak in the seal somewhere, and whatever.
It was so funny because got married. We decided to because of the age of the fridge, because before I got married and all that sort of stuff, and it was getting old anyway at that stage when I got married. It's just like it's got to pack up any day now. So let's get ourselves a new fridge type of thing. And anyway, we got the new fridge, and that one went into the garage and became the beer fridge, and it kept on going. And the new fridge that we bought had X amount of life, and then that packed up beyond repair, and it was ended up being cheaper to buy another one. And anyway, since we've been married, I think we're on our third fridge now. Since we've been married, but the one that I brought in to the marriage is still going strong, like it hasn't packed up. It's funny.
Yeah, if you can measure a length of time by the number of fridges, that's actually pretty good.
Yeah.
That's long term right there.
Oh yeah. Well, they don't make stuff like they used to, do they? Do it's really they don't make it for that longevity.
Oh, fucking washing machines? Of course not. No.
Oh.
We still got our one that was made in the late 80s. Still trying to figure out whether we can stockpile certain parts for it. Because we don't want to let that thing go. It's been running since we moved in flawlessly. And I have so many friends who have these, either they're side loaded or top loaded. It doesn't matter. Anything past 2007 or so is absolute garbage.
It is, yeah. Oh, most definitely. The inferior parts, the bearings or bushes or whatever they use, just seem to be inferior. They have these electronic components now attached to them, which tend to go astray and cost you an arm or leg to
Yeah,
replace.
costs more to fix one anymore than it does to buy a new one.
It does, Blue. Like, it's incredible. Like, this little part that's as big as a matchbox.
Yeah, I know.
Like, you're like, oh.
My father used to measure how long he and Mom had been married by how many bottles of Tabasco sauce they'd gone through.
Oh, there you go.
Yeah, Pop would say, "Yeah, we're already on our third bottle of Tabasco sauce, and this is after they've been married for like 40 fucking years."
And the worst thing with the U, like the spin in the tub in the washing machines now are made of plastic, right? Which are just useless because I've got 2 fire pits that are made out of the old tubs from washing machines. I've just welded some legs on the bottom of them. They're great outside fire pits, those things.
Yeah, well, I got holes in them and everything.
Oh yeah.
They're all set to go.
What's your I don't know if you were listening, Blue, but what's your take on this ether topic over the last 4 or 5 days? It seems to be getting quite animated, I should say.
Well, like every other topic. That won't be the first animated topic we deal with.
No.
I really haven't paid very much attention to it. I hear the word ether and my brain shuts off immediately.
Really?
Yeah, ether doesn't exist. I'm not even going to talk about it. The hell with it.
Well, like I was telling Doofus before, me, ether, and I know, Doofus did make a distinction, like how I was thinking. To me, the ether, dark matter, to me, it's all kind of like in the same bucket, really. Even though, Doofus did make that the distinction, between them. But anyway,
Right,
that's kind of.
Yeah, and we don't have to go into too much detail on precisely what it is really in order to make, like, you don't have to pin it down in order to make other kinds of observations. And it's sufficient to say, well, if you're pulling a vacuum in a vacuum chamber, there's more distance between those molecules of air. So it's really just fine to say there's less molecules of air in the same volume. Whatever that other stuff is or is not doesn't really matter.
But we think there's something there, regardless, between those molecules. Yeah, Doofus?
Something gets into a really weird bunch of weeds, because if you define it to mean something that is material, then it has to be matter, or if it isn't, then you're describing something as a field, and it's complicated. There's just less molecules in that given volume is all.
Yeah. Look, whether it's a field or whether it's actually matter, I do, and it kind of starts to get in. It gets messy, I suppose, there. But nonetheless, whether it's a field or whether it is matter of some stuff, the general consensus there is something. What that something is exactly is still kind of being worked out a little bit, but a something. I should just call it something and get completely out of ether and dark matter altogether. I'll just call it something and sit on the fence.
Yep. The region between the molecules, there's more distance between the molecules. I'm like, okay, sure. You don't have to say what it is or what it isn't. It doesn't really matter.
No.
Matter.
Yeah, we have a way of measuring that, of course. We call it pressure.
Yep.
We can also weigh it. Curious thing, you can actually weigh it. Those little molecules all going randomly in every direction, yet they have weight. How does that happen?
Well, we catch them, we put them in the container, and then we weigh them, Blue. That's what we
Yeah.
do.
Yeah, but why are the ones hitting the bottom of it seemingly hitting it harder than the ones hitting the top of it?
Because they're excited. They're having a
Okay.
party in there. That's why.
They just like down, and somehow inside that steel tank, they know which way down is. Amazing.
Oh, they got arrows painted on the inside, letting
I
them know.
had never thought about that.
Yeah, exactly. Exactly. So what's your next big project, Blue? That you
Don't have one planned right now.
Oh, okay. The last one took it out of you?
Yeah, that one did. I would dearly love to do a Foucault pendulum one day, but the problem is trying to find something with a ceiling height of about 200 feet.
Mm-hmm.
And these little short-ass things that people try are just ridiculous.
There's a huge one in the Melbourne Museum.
Mm-hmm.
And I presume it is a Foucault's pendulum. I was only a little tacker when I saw it. But the Melbourne Museum is, several stories high. Anyway, it's obviously attached to. Well, I'm going to presume up near the ceiling height stairwell, and as a kid, I can just remember walking up the stairwell and looking down and looking at this. Well, and there must have been something on it actually, but it kind of looked like a parquetry floor. That's the vague memory I've got. I probably should have taken more notice of it because it was probably something very distinct there. Written, but yeah, apparently this thing just keeps on pendulating for 24/7. But yeah, it's a huge one.
Yeah.
Why are you up so early, Blue? What the hell?
Oh. 6 a.m. already.
Oh, okay. Well, you were up a lot earlier than 6 a.m.
Yeah,
that's
that's
for
true.
sure.
That's the I don't know. I get up early anyway.
Yeah.
Pretty much always have. About 3:30, 4 o'clock in the morning is my favorite time to go down to the gym. Nobody's there.
Yeah. Oh, there you go. Yeah,
I don't have to put up with the idiots.
I definitely have allergic reactions when it comes to gyms myself, Blue. have to take an EpiPen anywhere, anytime I walk past it. I feel everything blowing up, my throat getting tighter.
Well, the later the day goes on, the less interested I am. That's for sure.
Yeah.
I can quite enjoy it early, but
do a lot of walking though, which is quite enjoyable.
yeah, it doesn't necessarily help very much, but it's is enjoyable. Yeah, my wife will say, I think I'll start exercising. I'm going to start walking. You're right. If you walk, if you want to exercise, go exercise. Don't say I'm going to exercise by going walking. Yeah, but I need to lose some weight. Yeah, right. I'll tell you what, walk from here to Milwaukee and you'll use up about the equivalent of a Big Mac. Okay.
I know. God, I find it so funny. There was a huge craze here for so long, and it may still be around, but it seems to have died down a bit with the what do you call it? The little things that count your steps.
Pedometer thing. Yeah.
Yeah, I think yes. And there was a craze around here for
Fitbits.
So long, and everyone would wear them. People at work would wear them, and they have competitions. Who'd have the most amount of steps, in one day and whatnot. And they would brag, I had 3,000, 6,000 sort of thing. And anyway, my wife, she got one, she was given one through her work. It was part of a pack that she was given. And anyway, I pinned it to my belt one day and just went about what I kind of normally did. And I'm not active, but I'm not inactive either. And I was kind of surprised myself that I got up to just over 3,000 steps in one day, and that was doing what I normally do. Nothing extraordinary whatsoever. And people were just bragging about normal kind of activity that they do during the day anyway. It's quite extraordinary. And all those fit watches and stuff that they have around. Tracking your activity and your heart rates and all that sort of stuff. How fit you are. Probably fortunate where I am. I've got lots of hills to walk up. And unfortunately, many of them are uphill. It'd be handy if you could walk downhill all the time. It'd be so tiring.
These kids, I walk to school both ways, uphill.
You've heard me say that, haven't you? Too. Tell me, kids. uphill 17 mile, both directions, in the rain, in the snow, broken glass everywhere. With, they don't know how good they've got it.
Yeah, no, I walked. I had it easy. I had to only walk a quarter mile to the bus stop, but then my kids came along and they had to walk half of a block, just half of a block, and they just complained and complained.
And I bet you they were still late for the bus.
Oh no, we weren't going to let them do that.
No. Yeah, how late it was.
I don't even remember what the third claim, false claim was. What you need.
Then how would I know if you left if I didn't join?
You might have just been watching who's in VC, you know, like a creep.
Like a creep.
Like a creep.
How you going, mate? Good?
What about you?
Yeah, good, mate. Good. Yeah. Had a beautiful 4 days away. It was
Where'd you go?
good. Oh, we just went up into the hills, have a bit of a country change, so to speak, and went to some wineries and a couple of restaurants, and it was really really nice just to get out and do something a little bit different. Relax in a different environment, because we pretty much just relax where we are at the moment. But it was just relaxing in a different environment. Yeah.
So was it like a camping trip, or you guys stayed in hotels, or?
Oh, it was 5-star, my friend. It was 5-star. Yeah, the boss wants all the mod cons. So
Then what's the point? It's like being at home, isn't it?
well, where we were was actually beautiful. They were like little villas, I suppose, separate, and just plotted, here, there, and everywhere. But you kind of had a place to yourself, and beautiful little verandas and balconies and stuff like that, and then just looking out, over the hills and state parks and stuff. Yeah, it was really, it was quite nice, just listening to nature and stuff, and filling in our time the best and dirtiest way we could, pretty much. How's how's daddyhood treating you?
It's going okay, man. You know.
Yeah.
Little girl's getting big. She's only 2 weeks tomorrow, so she's still, like, you know, the mother's still stuck at home with her. But I think starting from next week, we're gonna start trying to take her out.
Right. Yeah.
Because we do have a pediatrician appointment, so she has to go through that. Yeah. But no, so far so good, man. It's just been working from home mainly, man.
Okay. Well, you're a bit cautious to take her out, are you?
Her mother is, you know. Yeah.
Right. Is that what, because of what's been going on for the last couple of years, or that's just her general sort of?
Yeah.
Fair enough.
And I guess, and like her mother. So not really my mother-in-law, but basically my mother-in-law also feels we should only start taking out, like, you know, after a month. Like when she's at least like a month old. She just feels she's a bit too young right now. If we take her to like a mall or something, the lights might be a bit too bright, and her eyes are still adjusting. Stuff
Right.
like that.
Yeah. I can definitely understand that, because you know, when they do pop out, they look very, very fragile when they when they pop out. But it's surprising though, Nate. They do bounce. So if you do drop them, they do bounce. Right, so you don't have to worry about
they bounce. What? How can you say that?
Well, because it's a true story, my friend, right? This is a true story, right? Yeah. When my our youngest two came along, and like I said, I was building a home at the time, and we were living in a garage, and anyway, our middle one, Bobby, she one day when Jeff was only about, I don't know, would have been maybe 5 or 6 weeks old, unbeknownst to us, right, went over to the little crib and pulled Jeff out of the crib, right, because she wanted to nurse him, and then drops him on the concrete floor.
Oh my God.
Shit you not. And you know, like how you have those moments in your life when you see something happening, but everything's kind of like in slow motion. Have you ever had one of those moments? Yes. That's exactly like what it was. And it's like, no. And anyway, Jeff has just hit the floor, and his head's hit the floor, and he's literally bounced. Bounced. And he ended up he did actually fracture his skull. He got like what they call it, a green fracture on his skull. But because everything is so new, you know, because it's all very soft and very pliable and whatnot, it was a green fracture, which, you know, didn't cause him any it is actually joked about that it did cause him long-term harm, because it's kind of the in-family joke that he was dropped on his head as a kid. But they are very resilient, I must say. Like, but I do definitely get the whole you know, being cautious, and like you said, you know, being exposed to everything that's out there at the moment. You want to make sure everything gets its isn't gonna be negative at all.
Yeah, I mean, you know, her mom always gets like this, you know, like even with our first daughter, she was very protective and didn't want to go out much, even though there was nothing like what we've had recently happening, you know? Yeah. I guess it's like a mother thing, right?
Oh, look, mums are definitely like, they've got that protective lioness quality about them. What a lot do, right? But you know, well, I notice they're kind of like from your very, I can understand it with your very first, but then as you have more, it kind of isn't so extreme.
Yeah.
Because you've had that experience, like I suppose maybe just because you're used to handling them, throwing them
Yeah.
about, and stuff, you're not quite as frightened, I suppose, of hurting them or putting them in harm's way of anything. Those
Yeah.
barriers are broken down a little bit, but yeah, no, she'll be right. Like I said, mate, the boss and I think she's absolutely gorgeous, which is surprising with what you look like, but
Wow. Fancy.
wow.
Wow.
But she is absolutely gorgeous.
Thank you, man. I appreciate it. Yeah. But it's been quiet around here.
Yeah, look,
What's been
like I said,
happening?
I've only been back on board for the last 24 hours or so.
Oh, okay.
Yeah, like I said, been away, but
Mm.
I have noticed.
Did you take any pictures of like scenery and stuff?
Oh, look, the boss has some on her phone. I could
Okay.
get some of those, but I have to transfer them. Yeah, I'll share some later on with you in DMs. But I definitely have noticed that, which isn't really surprising, Nate, that the ballers haven't still come up with any direct measurements of any curvature or anything like that, which is really not surprising. So, I thought I'd come back to have these these amazing revelation that you guys would have something, but alas, I'm still here. Alas, yeah, alas.
Yeah. I don't know. I mean, I just feel it's a bit of an unrealistic expectation to expect someone on Discord to have a direct measurement, unless they're a geodetic surveyor or they work with satellites or something of that nature. Maybe you should ask those guys, like I know there's that dude.
Well, I don't know. We have all these people. We've got people like, we've got Rui in the chat. We've got B-Ball. We've got Bev.
Do they work with satellites?
We've got Rakia. No, but they could all do these direct measurements because they've all gone out and bought these tools that do these direct measurements.
But so what you want is a direct measurement of the whole thing, not just over like 2 miles, right?
Oh no, I'm happy with just a small lake myself, Nate. I'm happy.
And no one's giving you that?
No, not yet. No one's done it.
I find that so hard to believe.
Yeah, I think Rui went out and bought himself a I don't know what he bought himself. Was it an auto level? Bought himself a theodolite. I can't remember. But anyway, and he bought this thing and he kind of does what B-Ball does with it. He looks at things that are like 32 kilometers away. It's just like, well, you've got these tools. Why not go use them for what they've been made for? You should have like a little get together, have like a little meet up. They should all have a little meet up. They should plan to meet up and go measure something. That'd be cool. That'd be cool.
But what do they do with it then when they have it?
I don't know. Well, they seem to take a lot of. They seem to take photos. A lot of people seem to take photos with.
Maybe they don't know how to use it properly. Then I don't know.
Well, they kind of reckon they do. Oh, people, what's he tagged me with? There we go. See another photo. There we go. Shout out, people.
Taken with it's photos.
There we go. We've got photos and we've got cartoons all rolled up into one. Damn. But I suppose, what, if someone did go and take direct measurements, there'd be nothing to talk about. Probably.
Really? You think so? Like, do you think if someone took a direct measurement, or if we took a flat earther up to space, the whole flat earth argument would end?
Oh,
You
you
really
and I
think
would
that,
have
Jason?
plenty to talk about, Nate. At the end of the day.
Yeah, but I mean, like if we took a prominent flat earther up to space and he recorded everything, you know, one long shot, no cuts, and he brought that back, do you think every single flat earther would just disappear? I don't think so.
I don't know. I reckon I don't know, you might get labelled a traitor
Sure.
or a
Yeah.
shill, maybe,
I think,
possibly,
yeah.
possibly,
I think
but
that's what would happen, most likely.
maybe, but
So,
you know that wouldn't even happen anyway. At the end of the day, because you have to like sign all these confidentiality clauses to say that when we reveal to you that the Earth is flat, that you're not allowed to tell anyone that. You have to tell them it's a globe. Like these are the contracts that you have to sign before you go up there.
yeah,
Unfortunately,
maybe.
yeah.
That's not true, asshole.
Come on, people.
He's obviously joking, man.
Well, I wouldn't be surprised that you'd probably have to sign that contract in blood as well, right? Just
Blood, sweat, and tears. Yeah. And then you gotta join the Illuminati or something and sacrifice a baby.
Well, you know, Jeremy and I are open to joining the Illuminati, even though that created much discomfort in the chat that Jeremy and I would join.
Yeah, I remember you guys were pretty open to selling your souls. Yeah.
That caused a real row, didn't it?
People were shocked. They were a bit put it back, you know. But I think most flat earthers would actually be open to joining the Illuminati. You know, like if they came and told them, "Yo, you'll join and we'll make you the new owner of Google." Like, how many flat earthers would actually say no?
If I was to become the new owner of Google, what do I have to do to become that?
You gotta sacrifice your best friend.
I could quite easily sacrifice you, Nate.
Am I your best friend, Jason?
There's a lot of people probably scared of being wrong.
Sorry, people. What was that, mate?
I said, you know, taking a flat earther up to space. I think a lot of them wouldn't want to do it because maybe a lot of them were. I'm not saying they would, but they'd probably be scared of being wrong or being incorrect. Like, you know, they've been wrong all these years.
Already gone through that. They already believed it was a globe and already were wrong and already had to come out of that.
So would you, Gio? Would you go?
Been there, done that. Not outer space, but I'm saying been there, done that with realizing you were wrong about the Earth and then coming out of that. That's already been done. So why would you think that somebody who's already gone through that and has already gone through that rite of passage, as it were, why would you think that they'd be quote unquote scared to do it again? Wouldn't it be perhaps you projecting that because you haven't gone through it yet?
You're missing the question, Gio. If you had the chance to go to space, would you go?
Maybe.
Okay, and yeah, that was the question. Would you go? That's it.
How high would I get to go?
Depends on a lot of factors. That's of course assuming that it's real and that it's all that. So would I like to go to Narnia if it was real? Yeah, for sure.
Well, we know Narnia is not real, right? But we do know that there is a claim that people go to space and they go all the time. So, you know, if you had the chance and someone said, "Hey, I have a free ticket for you to go in low Earth orbit to see the Earth," would you go? Just a yes or no question.
Yeah, but I can't just give it a yes or no because it depends. Is it safe? Is it?
Of course, it's safe because many people have already done it.
So, are you talking about like the William Shatners of the world that have gone up X amount, X height, like that sort of height, or you're talking higher than that?
Like low Earth orbit, you know?
Well, is
Um,
low Earth orbit, is that like ISS height?
yeah, you can go to ISS, or what's the other thing?
Well, see, even ISS height would not give you
Virgin Galactic.
the full dimensions of anything, apparently.
Well,
Because apparently,
I'm sorry, go ahead.
I was just going to say, well, because I don't know, but apparently from the ISS height above the Earth, to quote someone that's got a little bit more knowledge than me, that shit looks flat at the ISS height.
But see, you're just assuming that that's what you would see. The thing is, would you go or not?
Oh, look, if I could go, I would definitely go. But if it's going to look, if it's not going to, if it's not going to do what you would like it to do for me, right? Because that shit looks flat, right? It's just going to confirm what I know already.
Hey, Bandsaw, I hate to tell you this, but if you went up there,
yeah,
if you said you went up there, because I wouldn't even believe you could go up there, but if you said you went up there and you said it was a ball, I wouldn't believe you.
What?
I'm sorry. It's the flat earthers. If flat earthers were going to believe somebody that it's a ball, they wouldn't be flat earthers. If we could actually suspend our like common sense and in a way that would allow us to just believe it's a ball again, we would have done that. Nobody wants to be a flat earther. Are these guys really in here saying we took a flat earther? Did they trust the flat earther if it's a ball? All we have to do is get a prominent flat earther money and tell them to say it's a ball.
Question.
Like the hypothetical is. Sorry, people.
The entire question was, would you go? I'm not saying what what you would see and what you wouldn't see. The question was, would you go if you had the choice?
They're scared they're going to see it's a ball because they'd be believing it's a ball if they saw it was a ball. I mean, we got all these pictures that we've been showing them, and for some reason, those aren't good enough. They have to see it with their own eyes.
No, that wasn't the question. The question is, would you go if you had the choice?
I'd laugh at the idea of going.
Okay, so you wouldn't go.
You'd even think that people could go. I mean, the idea that you could go up there is just laughable at this point. It's not like about someone trusted somebody else.
So if someone gave you the opportunity, you wouldn't even jump at it, would you?
All right, you know what? I'll go if you can answer one question for me. Actually, I'd like either you or Nate or a combination of the two of you to explain something to me. All I'm asking for is an explanation. Doesn't matter if you're right or wrong. I just want how you can describe it without just like some calculation that you're relying on that makes it seem like it works for you, right? Just explain it in like common sense language how this is possible. We know that when we do
Explain how what is possible.
When you do time-elapse photography, right? You get those perfect concentric circles, right? And then it's often said that, oh, to be fair, I guess it could either be that we're spinning or the sky is moving, right? That's always put out there as if it's just one or the other, like they're equally viable, whichever one that is, right? But when you really think about it, they're not equally viable, at least in the way I see it. Maybe you could have an explanation that'll totally make sense to me, okay? So that camera that you used when you make a concentric circle time-elapse photography of the stars, if you bump that camera just a little bit, just a nudge, your whole thing's you can see that you can't move the camera. It has to be stationary in one spot. It cannot move at all for those concentric stars.
Can I ask you a question, Dave?
The only way you can get that. Now, how are we going? All these different vectors, 67,000 miles per hour around the sun. The sun's moving 500,000 miles per hour in another direction. We're spinning on our axis at 1,000 miles per hour. All of that is going on. What you can say it's just because the stars are so far away, but is that really good enough for you? I don't care how far away those stars are. You got to explain to me in some common sense language how it's possible we're going all those different vectors, thousands of miles in an 8-hour time elapse to make no difference of the way it would work on a flat Earth compared to a moving vector, multiple direction Wall Earth.
So,
Just
Dave,
explain.
before B-Ball gives you his answer, I just want to ask you a question that for you to ponder on while B-Ball's giving his explanation. These concentric circles that we see when we take time-lapse footage of star trails, right? I'm sure you know that the direction in which these circles move changes depending where you are. How is that possible on a flat Earth? Then yeah, B-Ball can go ahead and answer your question.
Because the stars are closer, different angle.
What do you mean?
If the stars are much closer, then they would change in relative to where you are on the surface of the Earth. A lot.
Explain it to me though. If I'm right above,
you have to give me an exact example of what you're talking about, I guess.
all right. So if I'm right above the equator, I see the stars go what? They go clockwise, right?
Yeah.
Yeah. But the moment I step beneath the equator and I move away from it on the flat Earth, all of a sudden the stars start moving the other direction. Why would that happen on the flat
It's vice versa. It's counterclockwise.
Because they're actually moving the other
counterclockwise
direction.
from the north and clockwise in the south.
Okay.
Yeah, because
Thank you, Joe.
No way. It's just like it seems. Even the stars are just like they seem. No way.
What?
You mean the stars are actually moving in two different directions and there's two sets of stars? No, couldn't be.
You're what? Yeah. It's different stars. I'm looking at. I totally agree.
Yeah,
but
different
I'm
stars.
looking at different
The
stars
southern
on
stars
the same
are a
sky,
real
right?
thing.
So
Flat
if I'm
earthers that think it's just a reflection, I don't agree with.
okay, so we'll be looking at different stars on the same sky. So if I'm right, like imagine your flat pizza Earth. I'm right above where your equator line is, right?
Yeah, just look at the 3 pics I put it in the live stream right now. That explains it.
Okay, hang on. Let me look at them.
Works just like magnetism or thermodynamics.
It works just like what? Magnetism and what?
Thermodynamics. I'll put a
wasn't
video
sure.
in that explains how it. I'll put a video in the chat also that explains how stars
Okay,
probably move.
the middle picture I don't get it because it's a magnet and I'm seeing Ken Wheeler stuff. The first picture looks interesting. The issue is that looks like you were saying there is a South Pole. If you agree
Yeah.
with that first image, so you do
Yeah.
believe that there's a South Pole. Okay.
Well, I think that makes sense that there's two sets of stars that are adjacent to each other over a stationary plane, and a pole, you could call it a dipole. Maybe there's like a positive and negative. I can't say if I believe one way or another, but I think if I had to guess, that seems to make the most sense at this point.
So North and South Pole, right? Positive, negative, North,
Yeah, it
South.
seems like, yeah.
We're saying the
Two
same.
sets of star, but I wouldn't say north and south. I'd say
I've never heard that from a
positive,
flat earther.
negative, maybe.
I've
Yeah,
never
that's
heard
what
a
it
flat
seems like.
earther say there's two poles. Oh, then that changes everything, Dave. Because I was thinking you would, imagining the old flat Earth
typical
model where
person.
there's only one central
Now,
pole.
monopole makes no sense.
I agree.
It's not what we observe either. It's not. But the idea that southern stars seem to be going in the opposite, counterclockwise as opposed to clockwise direction. The idea that it's because you're upside down in a ball, and that's just the way you're perceiving it, and all the stars go in one direction. That seems very silly to me.
Okay. So just a follow-up question now. If that is the case as to what's happening, these stars must be pretty close and pretty small then, right? Like the
I would
Earth
say they're
must be
much.
way
I would say they're
bigger
much closer. Yeah,
all
for
of,
sure.
all of these stars, and much smaller, right? Because if they're much
I don't know.
closer, then they're
Oh yeah,
not
much
as big
smaller.
as
For sure. Yeah, they're not
as
the
we
big,
think.
huge
Yeah.
giant. Yeah.
Okay. So
Inverse square law
sun,
works.
the sun included. The sun is way smaller and way closer
Way
than we
smaller.
think.
Yeah, it's like it looks.
So the
Most
Earth
likely.
is huge.
Earth is big
compared to
compared to all those things, probably. Yeah, just like it seems.
Okay. Interesting, Dave.
The
Interesting.
sun and moon seem the same size, so they're about the same size.
Most likely.
They seem the same size, so they are
You don't
the
have
same
to put
size.
math.
Interesting.
You don't have to use math.
Very
Just
interesting.
observation.
Wait, I came in with a question. I want to hear one of you guys, unless B-Ball is still here. He wants to do it. How do you explain all these different vectors? Moving all these different vectors several thousand miles per hour out of your original position, but you get these perfect concentric circles. But yet
because
you bump the
everything
camera
because
on a
everything is
stationary Earth.
everything is
Yeah,
all right,
so far away is not good enough, Nate.
about
I'm
to
not going
give
to
you
take
an
that as
answer,
one
dude.
answer. You can't just say so far away. It doesn't make a difference. You have to
I
explain.
wasn't going to say that. Yeah, I'm
Okay.
going to give you an answer. The reason is because everything is moving within these vectors together. It's not to say the Earth is going around the sun and moving through the Milky Way on its own. Everything is moving with the Earth. The sun, the Earth, and all the planets are moving together through the Milky Way, you know? That's why things seem to stay intact, even though everything is moving at these crazy velocities with these constantly change at these crazy accelerations with constantly changing velocities and directions of orbit and whatnot. Everything is moving with everything else. We're not drifting away from the Milky Way. We're moving with our Milky Way, with our galaxy. So we wouldn't see, these stars move away from us because we're moving so fast. Whatever it is you were trying to insinuate.
Well, it's got to be pretty. It's got to be all moving pretty uniformly together to have no difference.
It is. That's exactly what I'm trying to say.
That's just like
but
very.
hang on though. It's not to say there isn't a difference. There isn't changes. The changes take a very long time to happen, right? For us, average human lives 60 years. You're never gonna see a change in these things. You would need to live over 3, 4, 5,000 years to even see a noticeable change or drift in the movement of a luminary.
So you can't tell.
Yeah, but the thing is, Nate, you could say that. Okay, I could say that. Okay, first of all, it's stretching your limits of acceptance just in what you said, that it's all moving so uniformly together, and we're talking trillions of miles, trillions of light years away. I mean, like, it's just like all of it moves away, but it's so distant. But relatively speaking, you could say that there's something even bigger than that that's relatively close, because we got a whole universe, and our galaxy is very small compared to the rest of the universe. So it's all relativity idea, but it doesn't work still, Nate, because you're talking about spinning on the axis, the rotation. You got the rotation plus going around your own sun, plus the sun itself is going along with it. So what's really moving in uniform motion if we've got 3 different vectors right there? That would mess up the concentric circles just right there at a local level. Doesn't matter how far the stars are away.
Why would it?
Because then those stars would also have to be moving in all those different vectors along with you.
But they are. That's exactly what I'm saying.
You're spinning away from them.
Dave, hang on. What I'm trying to say is everything is moving together. The sun, the earth, the moon, and the planets are all rotating around the same barycenter. So as long as we all rotate around the same barycenter, we're all going to be locked and fixed to each other.
All right, here's the challenge. Just draw me a little sketch, a little doodle of how that makes sense to you, with little pictures and arrows. That makes it. I know it's going to be hard to do, but if you could draw a little picture of arrows,
it's not hard. It's not hard to do at all.
and then which direction stars are moving with it from different galaxies, suns from different galaxies moving along with their own planets that happen to be
Are you high, Dave?
A little bit, but I'm just saying, dude, it's a little bit strange that you just totally accept that. A little bit strange.
I don't just accept it though. I've had to.
He said you can draw it, but you wouldn't understand it.
No, I that's not what I said. What I said is I can draw it, but will you understand it? But
of course,
they've never heard
not
the
about
question.
understanding.
Okay, cool. Then I'll draw it for you. A bit
All right,
later.
cool.
No,
Oh, you're just asking if I'll be able to understand it? Is that what you're actually asking?
Yeah, Dave. I mean, there's nothing wrong with that question.
You guys are
You
still like
say a lot of things.
they
You
don't
say a
understand.
lot of things I don't
If
understand.
they understood what we were saying, they wouldn't be flat earthers.
So this,
But Dave, I just want to make sure, because you do say things I don't understand. So I just want to make sure that I say things or show you things you will understand.
Yeah, but you're saying that as if I don't understand. You're such a smooth Asian, dude. It's so funny. I don't understand what you're saying because you make no sense and you're crazy. But you don't understand what I'm saying because you're not good at science.
this notion, Nate, that you said that the stars are moving, but we're not going to notice it for say 5,000 years. right? So we're never going to notice it, but you know, take our word for it. They are actually, you know, moving, and things, I will agree, do go.
Whoa, hang on, Vepso. Hang on.
What?
Not once have I said take my word for it or believe what I'm saying. You guys ask a question, I give you an explanation. If you don't like
Yeah,
the
no,
explanation,
Yeah, no, hold on,
to
Nate.
look into it.
Don't get your knickers in
Okay.
a knot. Don't get your knickers in a knot, buddy. All right, all right.
Watch out,
I'm
Nate.
fairly.
He's gonna sacrifice you to get in the Illuminati.
Yeah, exactly. Right. And when I say take my word for it, I'm not saying like you. It's like the general consensus of the astrophysicists. All right. Okay. When so it's like, here, take our word for it. You know, these stars or this star here, it isn't actually fixed. It is actually moving, but it's going to take 5,000, 10,000, 20,000 years. You know, 22 million generations for you to actually see it. So kind of take our word for it. This kind of theory, this kind of idea that they are moving ever so slightly, right? How recent is this idea? Like, does this date back to, I don't know, Aristotle, Copernicus, like all these apparent great minds that lived once before thousands of years ago? Like, did they have these sorts of theories, or is this a very recent thing that has been proposed?
No, this is a pretty age-old idea. I would say
It's
it's
an
only
age.
recently. It's only recently that we've been able to put really accurate figures to back the concept and the idea. But I think it's a pretty age-old idea that these things are really far away from us, and they all moving. And these movements do change over time, right? So they change over cycles. You know, like you'll hear there's all these weird cycles. You'll see this type of thing in the sky every 12,000 years, yada yada yada. You know, that speaks to the idea that people knew things are very far away, and it takes a while for things to repeat themselves, and there are chances where things won't ever repeat themselves
Yeah.
again. Yeah.
Okay, well, when we look at, say, a star like Polaris, for argument's sake, and that seems to have a little bit of a cycle to it. It kind of like makes like an eye shape with it, like the eye of Ra or whatever you want to call it. But it seems to have this little shape to it. You're hot micing, Dave, by the way. Sounds like you're exercising, buddy. But we're told that in X amount of years that Polaris isn't going to be Polaris anymore. It's going to be taken over by another star. I can't remember. I have heard the name of it, but it's going to be taken over by another star, and then another star is now going to be Polaris, even though it'll have a different name. So I don't know. I would put to you that, you know, people that have observed Polaris way back when thought that this was a fixed star and that it never moves and doesn't move. It may make like some little circle shape in the sky, but I'm pretty sure that Polaris has been the fixed star, and it's going to be Polaris forever, and nothing will take its
I
place.
hear you. So, we did know things were very far away, but we didn't have an accurate understanding of orbital mechanics till round about, I would say, the 1500s. You know, Copernicus, Kepler, Tycho Brahe. Before that, we were using the model of Ptolemy, but it wasn't accurate at all. You know, there were a lot of assumptions involved. It was geocentric. Things weren't really.
Hold on, Nate. You're right close to your mic. It's really popping. Sorry, mate.
We didn't really have an accurate description of the sky above us. That's why we weren't able to predict the movement of things that accurately, right? But now, as we know where Polaris is in relation to Earth, we know its movement, and we can predict its movement. We can predict, for example, based on where Polaris is now, and its momentum and direction of movement based on current conditions today. We can extrapolate the past and into the future as far as we want to go. We can predict where Polaris is going to be 3,000 years from now or 30 years from now. We have that ability now because we have a proper understanding of orbital mechanics. In the past, we didn't have that ability. And because, we didn't know how to do these things, what most people would do is they would just assume Polaris doesn't move. It'll always be our North Star.
Okay. So when
of people in the past referring to different North Stars. So it has been documented by people in the past, the North Star being something else.
Okay, so how far ago was it documented that Polaris wasn't going to be Polaris anymore? Who was the first to go, you know what, it's moving and it's not staying exactly where it is. It's going to be taken over by another star. Who was the first person? How long ago did that go?
I don't know. Off the top of my head, that is not something I know, Ben. So I don't know who the individuals. I don't really focus on individuals. I know it seemed to be a thing within these discussions that the individuals are discussed more than the ideas, and I think that is something that shouldn't be happening. We shouldn't care about whether or not Aristotle or Aristophanes exist.
No.
What we focus on is the ideas associated with the name. So I have no idea.
Well, I think he's asking that because it's like, how did they figure out that where Polaris was 2,000 years ago, or how they know? What's the method they're using there, mate?
Orbital mechanics. I just explained it to you guys. Using orbital mechanics, if you understand the current conditions today, you can extrapolate into the past or the future. Ooh, you have a phone call, Vanessa. And you really need to
Yeah, but like within our lifetime, Polaris hasn't moved. It does its little orbit, this little tiny, elliptical orbit. Within that one little area. Within our lifetimes, we don't know of it moving out of that position.
Like I said, Dave, if you understand the Polaris's current conditions today, you can extrapolate into the past or the future.
But what conditions are they using to base that assumption on? What conditions?
I'm not. There are certain current characteristics of that object that you need to know. Its size, its orbital path, its momentum, this, that, and the third. But if you have that information, then using the idea of orbital mechanics, you can predict where it's going to be, or where it's going to go, or where it was.
So wait, do you know how far away they say that Polaris is, right? Or they've changed it recently, but you know the distance, right?
I don't remember.
It's if you times how long a light year is, right? A light year, you know what that is?
A light year?
Yeah. And
so it takes to travel in one Earth year.
Right, but in miles, you know what it is?
Light year in miles? I think it's 1 AU. So Earth's orbit around the sun?
Yeah.
Like the distance of orbit on either side of the sun, right?
Well, I'm just asking, you know how it's trillions of miles, right?
Yeah, trillions of miles is really far.
An accurate read is trillions of miles away. Right? They need to know all those other characteristics, as if that could be known. You really think they're
like you're breaking up
millions of miles away? You trillions of miles away, you think they're accurate about the size and all those characteristics that determine where it's going to be in 3,000 years? I mean, are you confident they really have figured that out?
I haven't done the calculation myself, but from the things I have done, knowing that I use the same methods and methodology and the same sort of mathematics and physics, and they use that same sort of mathematics and physics to determine where Polaris is going to be, I feel pretty certain, yeah. If it's worked for me, I don't see why it wouldn't work for them. Hello? You there?
It's 323 light years, right?
Okay.
And it's 6 trillion miles. So 33 times 6. All right. Try that. Well, if it's 6 trillion miles, right, for a light year, and it's 323 light years, so 323 times 6 trillion. What's that? Could you read that number off? Just do some math for me, because this worked for you before. So you must know that they've got it. Can you write the number that this actually equals? 6 trillion times 323. Can you even say what that number is? Or write the zeros?
Million, a billion. Oh,
How many zeros are in that number?
Hang on. You said 6 trillion.
6 trillion times 323.
Okay, that's a billion. A billion is a trillion is 1,000 billions. To add 3 more. 1, 2, 3. Okay. Times 3, right?
Right. Times 323. 6 trillion times 323.
323. It's a really big number.
Yeah, that's all I could say about it. I don't know if you can get more exact than that.
Like 12 zeros. It's a really big number. I don't even remember what you call that number. But yeah.
Yeah, that would be pretty hard to figure out. Just the number that they give us, to how far away it is. How big do they say Polaris is? What's the size? You know that?
I don't know. I don't remember these things off the top of my
What's
head.
the size of Polaris?
But where are you going with all of this? Like you know.
Well, I'm just saying these are the characteristics that make us sure that 3,000 years from now it's going to be in a certain place compared to where it is now. These are pretty big assumptions that we're letting them just like say that they know. So Polaris is around 50 times bigger than our sun, and our sun. What's the size of our sun?
No one is just letting them, say these things. If they make
they're
these
saying it regardless if anyone's letting.
This is the thing. When they make these claims, they provide you with the tools needed to falsify them. You can go out and see if their claim is true or false. You can read.
Oh yeah. If we could do that, we wouldn't be having this discussion, Nate. Come on. Okay, wait. Do some more math for me. Once you get that number, this number is 430. This is how big our sun is. It's 432,690 miles. That's what they're saying our sun is. 432,690. And then if Polaris is supposed to be 50 times that big, can you even give me that number? At 50?
Have you ever
times 50 times 432,690.
30 years?
I'll do the math on that. I can't even imagine how big that thing is. All right, so this is crazy that's how big it supposedly is. And that it's that far away. You can't even give me the number. You can't even put the number of zeros that number would be. You can't even reasonably explain that number to me, or how we could have something so big and that we know the accurate size of it from that far away. And when you look at that thing, you know what you see, right?
No, I don't even know what you kind of rambling, Dave. Like you're throwing out all these numbers, and I don't know what, but the point is you're trying to get to.
Well, the point is when you look at like this GIF I just put in the live stream. That's a P900